Hi, everyone, and welcome to this chapter. In this chapter, we're going to talk about Bloc, but we're also going to touch upon Cubit for a very short example. Um, a lot of you have asked me to cover Bloc, and I've waited with Bloc for a while because it really took a lot of preparation. I've been working on preparing the material for this chapter for about 2 weeks, maybe even more. We're in this chapter. I just want to really make sure that we go through every detail of Bloc. So this is going to be a very long chapter. And I actually mentioned it on social media, on Twitter and LinkedIn, that this particular video should ideally be its own course. And you should view it really as its own course into Bloc, because we're going to touch upon every detail of Bloc, and we're even going to go into testing. So keep that in mind while watching this video, in that it is lengthy for a reason. There are so many topics also to discuss, and I will show you 8 examples in this chapter on how to work with Cubit and how to work with Bloc in order to create your applications. And at the end of this chapter, we're also going to create a real live example of using Bloc together with Firebase storage. We're going to create at the end of this chapter an application that has authentication, has registration, and is going to allow users who are authenticated and logged into the application to upload their upload their photos into Firebase storage or bucket. So this is a lengthy chapter, but it's for a good reason, in that we're going to go through a lot of details of Bloc library. So before we get into Bloc, we need to also know about qubits. Now, in this chapter, I'm not going to go into details about qubits, because qubits are what Bloc is actually built upon. And a lot of you may be using qubits, but I prefer not to use qubits, because qubits are so simple that you can actually create your own streams and stream controllers. So you don't really need qubits, or at least I don't need qubits. However, when it comes to Bloc, since it has its own pattern built on top of Qubit, it is a lot more useful for me, at least. But however, since Bloc is built on top of qubits, I thought to address qubits and kind of shortly have a look at what qubits are, what they're useful for, and also we're going to have a look at a simple example of how to use qubits inside an application, just so that we can later go on and talk about Bloc. So qubits are really just like a level on top of streams and stream controllers. If you have watched some of my videos, I've talked about streams and stream controllers before. But if you don't know what they are, they're just simple way of creating like a reactive application, kind of like a pipe of information that keeps producing data. That's your stream. And also you have a stream controller, as its name indicates, is a way of controlling that pipe so that you can add values to it, or you can, for instance, do other operations with your stream using that controller. And a qubit is an interface that sits on top of streams and stream controllers. Internally, a qubit has a stream controller, you can say, and it keeps like a stream in the qubit itself, as you'll soon see. So there is just a one level higher than a stream, and a stream controller is at one level of abstraction on top of the stream and stream controller. So what we're going to do now is just have a look at a very simple example, in that we're going to create an application, a simple application that picks a random name out of an array of names, and we're going to use Qubit for this. And I don't want to, as I mentioned, I don't want to spend too much time talking about qubits. I just want us to go through creating the simple application, so you at least see what qubits are for and how they're used. So I won't at all go into like the testings of qubits, etc. If you're interested in qubits, if you think it's so important, please do let me know in the comments below, and I may be able to create a separate chapter for only qubits. So now enough talking, let's go and create our application in here. I'm just going to do some reshuffling here on the screen, and adjust my microphone here as well so that I can see my screen down there. So let's go ahead and bring up terminal, and it's time to update as well, I can see, but that's okay. The updating goes really fast. So what I'm going to do in here is to go ahead and create our sample application. So let's go to our projects, or wherever you try to keep your projects. And I'll say Flutter State Management. I think I have my projects actually in CD dev projects courses, I believe, Flutter State. management. And in here, then we're going to go ahead and create a simple project. And remember, instead of creating different projects for every example, what we're going to do in this chapter is just to create one project, and we're just going to structure it for every example. And as you'll soon see in most of these examples, actually, when we've created a project and we finish the example and we commit our code, then we're in almost all of these examples, we're just going to completely like delete every file in that project except for main Dart, and then continue working on that empty project for the next example. So it's completely up to you. I mean, how you want to manage it. If you want to create different projects, it's completely fine by me. Go ahead and do that. But if you want to follow along with the examples that I give you in this chapter, it's probably best to follow along as I'm doing. So create one example, one project, and we're going to create our examples on top of that. Okay. So let's go ahead and say Flutter. If I can type here, Flutter create, and we're going to say testing block course. So that's the name I'm going to give it. And I have the habit of giving it an organization of SE pixelity here as well. I think it's actually like this. So for me, it's important to specify the organization for the project from the absolute beginning. For you, it may not be the case. So what you can do is just to say Flutter create testing block course, and that should be enough. So let's go to cd testing block course in here, and I'm going to open up Visual Studio Code, as you can see in here, and make it full screen, and we're done with the project creation. I'm going to make this a little bit bigger as well. Great, so you can see the code better. All right. So what we're going to do in this first example is to, first of all, add our dependencies. As I mentioned, we're going to use Bloc, and we're also going to use Flutter Bloc. And I mean, maybe for this particular example, in the beginning, we don't actually need Flutter Bloc, and I'll explain to you what the difference is. So Bloc is the third-party package created by Felix Angelov, I think is his last name, if I'm not mistaken. And he has created this package called Bloc, which you can download from PubDev and bring into your dependencies. Bloc package is the core of the Bloc paradigm, or the Bloc library, let's say. So it includes all the basic building blocks of qubits and Bloc. However, when you come to Flutter, which is the application that we've created, Flutter, it needs to be able to interact with streams and stream controllers and display things on the screen, for instance, based on the output of those things. So for those UI components that hook themselves into the core of the Bloc package, then you need the Flutter Bloc library or package. But for this particular example, we don't need it, but I think it's actually good to bring it in from the absolute beginning. So as you can see at the bottom of the screen, we're going to go ahead and add these packages to our application. So we begin by going and saying in here, Flutter pub add Bloc. So that's going to be the first dependency brought into our application. And then we're going to say Flutter pub add Flutter Bloc as well here. Okay. So that's going to bring in Flutter Bloc and Bloc. So if we open up our PubSpec YAML in here, we should have both of those packages added to our application. As you can see here, we have Bloc, and then we have Flutter Bloc added to our PubSpec. So let's go ahead and create a very simple scaffold application in here. I'm going to go to main Dart and remove everything and use an FSA, a Flutter scaffold application in here. And this is a code snippet that I've created in Visual Studio Code that allows me to paste in pretty much a material application, as you can see in here. And also it gives me a home page with an app bar. So I use this so much that I've created a snippet for it in Visual Studio Code. And I actually have a video about creating custom snippets, and specifically this Flutter scaffold application snippet in Visual Studio Code on YouTube. So if you search in my channel in my videos, you'll see that there is a video available that teaches you exactly how to create this FSA. As you saw in here, FSA, you can see FSA, Flutter scaffold application. So go ahead if you want to watch that video. Otherwise, just go ahead and create a simple material app in here in your main function, and also a home page, which is a stateless widget. Okay. So let's go ahead and import our dependencies in here. So we need a block to begin with. So let's say package block Dart. And also, since we're gonna, as I mentioned in this example, we're gonna use a Cubit, and we're gonna pick a random name from an iterable or from a list of names. And to pick a random name, we need the math package. So because math has the randomizer in it. So let's go ahead and import Dart math, I believe, just like that. Okay. After we've done that, we're going to go ahead and define a list of names. Okay. So actually, in this Dart math, maybe we should go ahead and say as math show random. Okay, because this basically allows us to prefix the random function or the random class with the math prefix, so we are explicit about where random class is coming from, as you'll soon see. So we have Dart math as math show random, and we also have the import of block Dart in here. So what we need to do is to go ahead and define our names. So I'm just going to say const names is, let's say we have foo, or with a capital F maybe, and then we have bar and baz. All right, and put a semicolon, a colon there. So what we've done now is to define our names, but we also need to be able to pick a random name out of this iterable or list of names. So let's go ahead and do that. So we're going to do it in style, and we're not just going to like have a function that's inside our homepage widget that extracts a random name, but we're actually going to go ahead and create an extension on iterable of anything, a generic iterable that gives us a random element from that iterable. Okay, so let's go ahead and say extension get, or say random element t on iterable of t, and in here we want to get a random element from this iterable. So let's say get random element like this. Okay. And then in here we say element at, this is a function on iterable and it needs an index. So what we're going to do is to say math random next int, and we're going to provide the length of the iterable itself to this function. So take a look at this extension that we created. It simply allows us to call two iterable functions, one element at, and the other one is called next, element at. And that's pretty much it, actually, just one function on the iterable. And the other one function is called on the random class, as you can see here, next int with the length. So it picks a number between 0 to that length. So it's a very simple function, basically. So here's the exciting part. Now we're going to go ahead and create our qubits. So as I mentioned in the beginning of this chapter, qubits are simple, one level higher abstraction layer on top of streams and stream controllers. So they allow you to abstract away some of the maybe dirty parts of creating streams and stream controllers because they're not so fun. So let's go ahead and create our qubit here. So we're going to call it names qubit, as you can see in here, and then we're going to say it extends qubit. Okay, and now in here, when you're extending qubit, if you look at the source code for qubit, you'll see that it says, okay, what is the state that I'm managing? And this is a generic. Okay, so generic type. It's not really hooked into or not constrained into any specific data type, but it just says, okay, if I'm a qubit, what am I managing? Now, our qubit is going to manage a string, so it's going to return a string. But what you also need to remember about qubits and blocks is that they need an initial state. So when later we start talking about block, you'll also see that a block also needs an initial state. And the reason really behind that is that if you look at a qubit at the abstract class qubit, you'll see that it has a constructor in here that says qubit, and it always has to have an initial state. So that's the reason. So the reason that we define this as an optional string is that we don't know what value this guy is going to have to start with. What we want to do is to expose a function on this qubit that will generate a random name, but initially it has no random name. So it's just going to wait for us to ask for a random name. I mean, it doesn't have to be like this. We could go ahead and say qubit a string, and then when we go ahead in here and we say names qubit, so our constructor, for instance, then we could just say super foo bar. So we just picked a random name. However, this doesn't come from our list of random names, which we define in here. So we could go ahead and say this is a qubit of string, but for this particular example, I just want to go ahead with a qubit string like that, and then say we don't initially have a value to produce, just so you get both of the worlds. So you know that you can provide an initial state, but you can also go ahead and say, I don't have an initial state. And that's by providing null to super. Okay, so that's the constructor of our qubit. And what we need to do is to go ahead and pick a random name in here. So let's go ahead and create a function in here. So let's say void pick random name. Okay, and in here what you want to do is to produce a new state. And what do I actually mean by produce a new state? Every qubit and every block has a special object called state. So if, for instance, we go in here and I type in here state, you'll see state is actually an optional string. Okay, so what you need to know about this is that this state gives you the current state of your qubit. And in this particular case, after the construction of names qubit, as you'll soon see how we're going to construct it, but this qubit has no value in it. It's just null. So this state is going to be null. However, you can produce new states. You're not going to set a new value for this because, as you can see in here, it says state has no setter. State is something that you can get. So if we go in here and get the code for this state, you can see it has only a getter, and internally is reading the value of this underscore state. So this underscore state is a variable, but it's living and residing inside this block base class. Okay, so you can't really reach this underscore state because it's a private variable. So you can only reach state. So here's when you can read a state, but how do you actually produce a new state? And that is through a function called emit. And there is a function here in both Bloc and Cubit called emit. And emit is your way of producing new values, both from your block and from your qubit. So let's say by picking a random name, we want to actually emit a random element from our names list. So what we're going to do is to say emit, okay, like that. And we're going to pick a random name. So let's just say names get random element, just like that. All right, so that's the only code really we have to write for our names qubit. So what we're going to do is now go ahead inside our homepage. We're going to go ahead and create this qubit. And if you remember from the beginning of this chapter, I mentioned that qubits are very similar. I mean, they're kind of like one layer on top of streams and stream controllers. And if you've used stream controllers before, you know that you create them and you also need to dispose of them. So qubit is no different. When you create a qubit, you also need to make sure that you dispose of it. So since we're not using Flutter hooks at this point in time, we're going to go ahead and turn our home page from a stateless widget to a stateful widget so that we can initialize our qubit and we also can dispose of it when dispose is called on our stateful widget. Okay, so let's go ahead and turn our home page into a stateful widget. And I'm going to say convert to stateful widget here in Visual Studio Code. And it creates the state object for me. And also I have my homepage stateful widget. Okay. So let's go ahead and first define then our qubit in this homepage state. So I'm just going to go ahead and say late final, and we're going to call it names qubit here. And we're just going to say qubit. Okay. So now that we have this late final, what late final really means is that it's a variable that we will for sure initialize before it is being before it gets used for the first time. So what we need now is to go ahead and in our init state to initialize this variable. So let's say init state like that, and then I'm just going to say qubit is and names qubit just like this. All right, so that's a simple init state for us. And what we're going to do is to go ahead and close our qubit on dispose. So let's say dispose, and in here we're just going to say qubit close. All right, so close is really just gonna, you can see it's going to do some cleanup on the internal variables inside this the Cubit itself, kind of like a stream controller dispose or text editing controller dispose in Flutter. Okay, so what we need now is, as this Cubit's value changes, as I mentioned quite a few times, Cubit is kind of like a stream. As the Cubit's internal state changes, we need to update our home page's state as well. So let's go for the body of our scaffold and use a stream builder. Okay, so we're just going to go ahead in here and say body. And in here, we're just going to say a stream builder like that. Okay, and put a comma there. And we're going to say this stream builder is actually managing a value of optional stream, just like our Cubit. Okay. So what we're going to do then for its stream, we're going to say Cubit stream. You see, the Cubit is actually exposing a stream of its state, which is that streams of string. So here we're saying the stream is the Cubit stream. And then for the builder, we're going to go ahead in here and say this is a context and then a snapshot like that. All right. Great stuff. So what we're going to do then is to create a button in here, which will then be able to, upon pressing it, it will call the pick random name on our Cubit, and it will ask the Cubit to produce a new value, upon which the stream of the Cubit will produce a new value, and it will come to our builder again. All right. So, okay, let's go ahead in here and say final button is a text button, just like that. Okay, and on it's pressed, and for the child, we're also gonna provide a text in here. So let's say text pick a random name like that. Okay, semicolon, and in here on the pressed, we're gonna go ahead to the Cubit and say, hey, pick a random name. All right. So let's go ahead and actually, I wonder if we should define the button like this. Perhaps, yeah, that's okay. So let's go ahead in here and say Cubit. And we're gonna say unpressed is the Cubit pick random name, just like that. And to be honest with you, we could make this function a little bit shorter by doing it like an arrow function like this. Wait a minute. I have to get this Cubit from here. Sorry about that. And then paste it right here. Okay, so that's our button now. The button is created. Okay. So now that we have the button, we should go ahead and handle the various states of the snapshot. All right. So I'm just going to say switch snapshot dot connection state. And then I'm going to get help from Visual Studio Code to complete all the missing cases in here for us. So in the case of none, we have no data yet. So we're just going to return the button. In the case of waiting, we're just also going to say return the button. And in the case of active, we're going to return a column. So in the case of done, we're also going to say return const sized box or something. It should really never get here because the stream of our Cubit shouldn't complete and shouldn't be done until the our home page stateful widget has actually been disposed. All right. So we're just putting a size box in here. In the case that our Cubit is active and is like actively producing values, or is at least ready to produce new values, we're gonna create a column in here that displays our both button and the text that is produced by the Cubit. So let's in here say return a column, and for children, we're just gonna say, okay, the first child of this guy is gonna be text of our snapshot dot data, which is the string of our Cubit string, or an empty string, and the button. So you can see in here, while the Cubit is active, we're going to display a column with a text of the Cubit string, and also we're going to display our pick a random name button as well. So I'm going to save this. Let's put a trailing column there, so we get the excuse me, so we get the formatting correct. Then I'm going to say in here select device. I don't even know where my select device is. Select device. Oh, it's not really cooperating with me so much. So I'm just going to see if I can run this on let's see, Flutter run maybe it will give us more luck here in terminal. So, okay, it says, which one do I want to run it on? And I'm going to say run it on the third option in here, which is my iPhone 13 Pro. And so we're going to now test this out and see when the, I'll bring this up as well. So you see it's now running the Xcode build. And Xcode has kind of like its own life. It lives its own life. You never know how long a build is going to take. So now we see it says compiling, linking, and signing, and we should only wait for this to be done. And I can see now it says Xcode build done. And let's go to our application now and see how it looks like. Okay, so you can see in here we got our button, and if I press it, then we see a random name being generated here, Baz. And if I tap it again, then there is a random name being generated here. So really, qubits are pretty much just streams and stream controllers. You have full control over like what values they produce, and I mean when they produce that value. And if you look at our qubit at this point, you'll see that it's pretty much just very like the simplest qubit ever created. Let's see if we can actually find it. It's right here, names qubit. So for this particular reason that qubits are usually so simple, and that the fact that they're just sitting on top of streams and stream controllers, I personally try not to use them because they're just too simple and I can do the job myself with built-in tools. But they're important to know because Bloc is kind of based upon qubits. So, and that's why we actually had a look at qubits to begin with. But what I suggest for you to do is to have a look at the source code for a qubit as well, and see that it's internally using something called a block base. And you need to basically really go into block base to understand how qubits are actually working. And you can see as soon as we come in here, we're talking about streams and stream controllers. So it's not a huge surprise that we had to use a stream builder when we were talking or working with qubits. So as is tradition in the other examples that we're going to provide also in this chapter, and as is tradition in this course, we go ahead and commit our code. So let's see if I can bring up terminal in here. So here, terminal, and let's stop this application here, and let's just say git status. Oh, we are not a repository, so git's init. Okay, and let's go ahead and commit our code. So I'm just going to say git add all, and then I'm just going to say git commit m step 1. Okay, and then git log, we have step 1. And I also really like to tag my code so I can git checkout without having to check out the actual SHA-1 or to know the actual commit number. So I'm going to say step 1. Great. So if you say git log and then git tag as well, step 1 is tagged. So that really concludes the example for Qubit for now. Okay, now that we're done with this example, let's go ahead and have a look at starting basically working with Bloc instead of qubits. So what we're going to do in this particular example is to create an application that is going to load person instances from 2 JSON objects that we're going to serve over localhost. And we're going to also have some caching implemented in this application so that there's going to be 2 JSONs, each of which is, for instance, going to contain 2 or 3 objects. And those objects are all going to be the same person object, which probably just includes name and age. We're going to create our data class for a person, and we're also going to load those instances of person from JSON into our Bloc. And you'll also see how we're going to use Flutter Bloc and our Bloc builder to render that content on the screen. So there's going to be quite a lot of stuff happening that has to do with Bloc. If you're not familiar with Bloc from before, a lot of these things will probably be completely new. Or if you're familiar with Bloc, you may also learn something in this particular example. So for those of you who are not familiar with Bloc, you may be asking, so what is Bloc actually? So if you've watched the previous examples in this course, we talked about Redux, and we saw how Redux works. And just to just if you're not familiar with Redux, you should know that Redux isn't just some sort of a magical pattern. What it does really is that, excuse me, there's events coming into some sort of a bubble. This bubble processes those events and produces a new state. So given a previous state and a new event, then you are supposed to produce a new state. And this is really what Bloc also does. So the difference here is that in Redux, you can produce one new state per event. However, with Bloc, you can produce many, and we'll talk about that soon. So a Bloc works with actions and results. So the actions are what your application produces. For instance, if the user presses a button, and that button will then be its own action, for instance, let's say a button for loading a JSON file, then you send this action to your Bloc, and then subsequently, then your Bloc is going to process that action and produce a new state, as you'll soon see. So when we define blocks in our applications, there are going to be instances of a block class. When we looked at here at Cubit, for instance, we saw that it extends a class called a block base. Now here, block base. And we'll similarly have a look at using block. If we go in here and find our Cubit, let's see if we can go here to Cubit and instead say block. And this is also a class that extends block base. So in that case, I mean, they're very similar basically to each other. Okay, so what we're going to do is to simply have a scaffold now in our application. We've committed our code. We've also tagged our code. So there's really no reason that we have to keep this code running or having it hanging around. So what I'm going to do is I'm going to select everything in here and just replace the entire thing with a Flutter scaffold application the way we had it before. So no traces of a Bloc or Cubit, nothing in here. Okay. So let's go ahead and define our JSONs. And what we need really is to be able to serve two JSON files locally. And for that, there is a really good extension in Visual Studio Code called Live Server. So if you go to extensions, excuse me, Live Server, you can see that there is an extension that you can install, and it's completely free in the marketplace. You can install it, and it will allow you to serve the contents of your project on a local web server. So it's very, very useful. So let's go and define our JSONs then. So in here, what we're going to do is to define our JSONs. Let's see if we can find a good place for them. Let's just define them inside API. Okay, I think I pressed the wrong button in here by saying profile as well. So let's actually do a hot reload in here, or if things are going to work, let me just try to run the application again. And let's go to our output in here and see debug console perhaps. And I can see that there's nothing in here really running. So I think there's something perhaps wrong with Visual Studio Code in here that is not allowing me to run my applications. It could simply be that it requires a restart. So I'm going to do that, but I'm not going to show the entire process for you. So let me just go ahead and do that. Okay, now I've restarted Visual Studio Code. So let's go ahead and see if the select device and the other commands are going to go any better. So iPhone 13 Pro, which is my simulator here. And if I can have a look here, I can see now launching is working a lot better. So Visual Studio Code really just needed a restart, a complete restart. Okay, so let's go ahead and define our JSONs in here. So I'm going to go and create a folder. Let's say new folder. And actually, instead of saying folder, we could do a new file, as you can see in here, which is this one. I'm just going to say API/persons1JSON. This creates the API folder for us. So if you prefer to create a folder first, just create the API folder first, please, and then create a persons1JSON file in here. Okay, so that's that. And I can see our application is running here. We don't need that right now. But let's go to this persons1 and let's go and define our persons in here. So I'm just going to say this is an array, and the first object has a name parameter here, and we say foo1, and then we have an age of 20. Okay, and we're going to go ahead and copy paste this. So let's just say foo, and we have bar with age of 30, and then we're going to say baz here with the age of 40. So this is our persons1 JSON file. All right. I'm going to copy this and create another file in here, and I'm going to call it persons2 JSON. And in here, I'm just going to paste that foo2, and let's just say bar2 and baz2. Okay, maybe we can have as many JSONs as we want to be honest with you. But just to start with, we're going to go with 2 JSONs to demonstrate the concept of caching as well. Okay, now we have our JSON files. So let's go ahead and define our first action. So an action really is a packet or an instance of a class that you send or you will send to your block in order to dictate to the block what to do. An action is an input to a block. It is your intent telling the block to perform an operation. So when you're doing block programming, what you need to really do is not just to think about, okay, what is the block going to do, but also how you're going to interact with the block. And the interaction, what goes in the block, are defined using actions. So what we're going to do in here is to go ahead and define our first action in our application for our block, even though we haven't really written our block in here, okay? But we know that we want to somehow tell the block to load something, to load, for instance, a person JSON. And what we're going to do in here is to basically define an abstract class called a load action. And I will explain to you what this load action actually is and why it is an abstract class. Okay, so let's go ahead first and define it. Let's say an immutable abstract class, load action. All right, and let's create a constant constructor for it as well. So constant constructor, just like this. All right, so I told you that I'm going to explain to you why this is an abstract class, and I'm going to do that right now. So when you define a block, if we go ahead and in here, for instance, if I go and say, let's just import block first. So let's just say import a package block, okay? And we're going to also need Flutter block. So let's import that as well. Flutter block, just like that. If we go ahead, for instance, anywhere in our application, let's say in the build function right here, let's just say we have a late final block, my block. Okay, let's go into the source code for a block, and you'll see that a block, any block instance, will require 2 generic types. One is an event, which is what we're defining, and the other one is a state. So when you're interacting with your block, then you need to always know that, okay, what kind of an event does this block accept, and what kind of a state does it produce? Most blocks, I would say almost all blocks, don't just have one event, except they can have multiple events, and they probably actually have multiple events coming into them, and they're producing multiple different states. So given the fact that events and states are multiple, since we don't have enumerations with associated values, unlike Rust and Swift in Dart, we have to define different classes for these events and these actions. Sorry, these events and these states. So let's say that you define different events. Let's say you, or an action. Let's say that you want to post an action to your block and say load a JSON file, and then another action that says load an image, and another action that says load a video. And all these actions, of course, how are you going to go to your block and say that my block accepts these 3 separate class actions? As you saw in the definition of the block's generic type that expects one event type or one action type. And so that is the reason we have this abstract class in here that defines the action or the event as a whole that can be sent to the block. So when we define our block later, you'll see that we say that this is a block that whose events are of type load action, meaning that any class that subclasses load action is a proper event that can be sent to our block. And the reason that this class is abstract is because abstract classes in Dart and many other languages, of course, I think almost every language that has a concept of an abstract classes cannot be initialized, meaning that you cannot make a mistake of initializing an instance of load action and sending it unintentionally to your block. So that's the reason we have the abstract class load action at all, and the reason for it being abstract as well. Now you know. So let's go ahead now. Now that we have this abstract, we're going to go ahead and define a list of the URLs for our JSONs. So what we need is to, we're going to do it in a very nice object-oriented way in here. Let's just say an enum of person URL, and let's say we say persons 1 and then persons 2. Okay. So these are like, this is the definition of our person URL in here. And we're also going to go ahead and now actually return the real URL for these enumeration values. Excuse me. So how we're going to do it is by creating an extension in here. And we're going to say extension URL string on person URL. Okay. And let's say string get URL string. So this is our function. And then we're going to switch on this because we're at this point is an instance of our enumeration, a person URL. So we can ask Visual Studio Code to complete this for us. In the case of a person URL persons 1, we have to return a URL valid for persons 1, and persons 2 also has to have a valid URL. So before doing that, let's go ahead and start live server for our application. So I'm just going to say open with live server. And it opens it in a window here for me. As you can see, it's really just listing the entire contents of this application's root folder. And we created an API folder, and here's the persons 1 JSON, and I can see here's the URL for it. So I'm just going to copy that, and I'm going to bring it in here and say we return an instance of that. And for persons 2, we already know that the URL is persons 2, just like that. So now we've defined our persons 1 and persons 2 enumeration for the URLs, and then we also create an extension on that enumeration, which then returns the URL string for us. And as I said before, in languages like Rust, where we have enumerations with associated data, enumerations are a lot more useful in that they can actually carry a URL with them. So we don't have that yet in Dart, so this is how we should live with it. And so that's really it for defining the URLs. So what we need now that we have the URLs, we also have to define an action for loading an actual person's JSON. As I mentioned, this is the like the umbrella action or event for the entire block. Any events dispatched to our block later will have to be of this load action type. But we haven't actually implemented any concrete implementation of this abstract class, and that's what we're going to do right now. So let's say immutable class load person's action, okay? And this guy extends load action, just like that. All right. So what we're going to have in here is just to say final person URL, like this URL. So here we're basically saying that whenever this action is dispatched to our block, this action actually requires a URL to be loaded. So we tell the block that, hey, we want you to load like a list of persons, but in that action, we're going to tell the block which URL that person's JSON needs to be downloaded from, and that's indicated by this person URL property in here. Okay, so let's go ahead and create a constructor for this guy. So we're just going to say create a constructor. I'm just going to say const in here, and then in here you could just call super as well. Okay, and let's make this required parameter here. All right, we could also say implements, I believe, in here, because we're not really extending anything, so we're just implementing it. So that's going to work as well. Fantastic. Now that you've done that, what we need to do is to go and program our person class. So as you saw in persons 1 JSON, every person object had a name and an age. So what we're going to have to do in here is just to go ahead and define these inside a person class. And then we're going to allow that person class to also be initialized from a JSON object, which is usually a map of string dynamic. So let's go ahead and do that right now. So I'm going to remove this block thing from here. We don't need that. That was just a test. So I'm going to go ahead and create a class in here, immutable class person. Okay. So what do we say? A name which is a property here. And then we're also going to say final int age, just like that. Let's get Visual Studio Code to create the constructor for this guy for us. And what I really like to do is just to make this a const, put a comma in here. Then I'm going to do it like this. Oops, if I can. And I'm just going to say required like this. And I'm going to put curly brackets right there. So now we have two required parameters in our person class. Okay. Then the next thing we're going to do, we're going to have to create a constructor for our person class that can create an instance of this person class given a JSON. So let's go ahead and say person from JSON. And in here, we're going to take in a map of string dynamic, and let's just call it JSON. Okay. In this constructor, we're going to say the name property of this person class is equal to JSON name as string. And also we're going to say age is JSON age as int, just like that. So now we have a person class with two properties, name and age, a constructor, and also a from JSON, as you can see in here. I wonder actually if we can remove that. We could remove that, to be honest. We could probably live without that, because this is going to be like the default constructor. I mean, some people may want to keep this, and to be honest with you, we could keep it. It's not really harming anyone. So let's keep the default constructor so that you can create instances of this person class manually as well. But just know that in this example, we're not going to create instances of this person class manually. We're actually just going to use the from JSON constructor of this person class. Okay. Fantastic. So let's go ahead now and take care of downloading instances of this JSON of, like, as you saw, our persons1 and persons2 JSONs. They have their start as a list, and in that list, there's only instances of this person class. So we need some sort of a function, a helper function that can help us achieve that goal, so that we can basically give that function a URL, and that function is then going to be able to give us a future of iterable person, meaning that is going to be able to download the contents of that URL, parse it as JSON, and then parse that JSON as a list or iterable of person instances. So that's exactly what we're going to do next. Great, then let's get started with that. So I'm going to go ahead here and start creating the function signature in here. We're calling the function actually get persons. And this guy just takes a URL, okay? And since this is a function that's going to return something in the future, we're just going to say that it returns a future. And we know that for every URL, we're going to download a series of person objects. That means that we're either going to return a list of persons like this, or better yet, we could just say iterable. So we actually return the list lazily, all right? So that's our function signature in here. And the way that we're going to go ahead and do this is to use HTTP client. I really don't like to use like any third-party packages unless I really have to. And HTTP clients in Dart.io package already includes all the utilities that we're going to need to achieve this particular goal, which is hitting a backend, or in this case, which is on localhost, and retrieving the content with a get HTTP call and parsing the content as JSON. So let's go ahead and say HTTP client. And this isn't really defined, and it's just going to auto import it from Dart.io. So let's go ahead and say HTTP client. We create a new instance, and then we're going to say get URL. And this needs a URI. So I'm just going to say URI parse. Okay. And let's say we need the URL in here. Okay, so this, if you have a look at it, this gives us the request. It actually gives us HTTP client request as mentioned in here. Then what we need to do is to close that request in order to get the response. So I'm just going to say request in here, and then I'm going to say request close. This gives us a future of the response. And since we're using then, it's kind of like flat map latest in RX, if you're familiar with that. Otherwise, it's basically chaining together two futures. So this future ends, its result will go in here, and it will kick off another future, which in turn then returns the actual response in the next then clause. All right. So let's go in here, and then we say then, and in here we get the response, which I'm just going to call resp like this. And then we're going to transform the response in order to get a string from it. So let's say we want a UTF-8. It's going to auto import it for us from Dart convert. And we're going to use its decoder. and then we're going to say join. And as you can see, it actually gives us a future of string. So the result of this entire thing at the moment is going to be a future of string. Now, this is a string. It's not really a JSON yet. It's just a string representation of that data, okay? So let's say we write then, if I can spell. So we're going to say str, and we're going to say JSON in here. And let's see. If you have to actually import, I think, JSON in here. We have Dart convert, so that should be fine. So I'm just going to say JSON.decode like that, and we get the string in here, right? So that's our JSON decode, and we're going to take this and say as list of dynamic. So this gives us the list, and then we're going to take this list. So let's say in here, and we're going to map it. So we're going to say we take every item in here. So let's just say E, and then we're going to say person from JSON like this, E. And then we close the whole statement. So this is a simple implementation of get persons for us. So it's not so magical. Just to go through it again, this gives us a request. The request goes in here and becomes a response. Response goes in here and becomes a string. String goes in here and becomes a list. And list goes here and becomes an iterable of persons. And the result is a future. So it's really just, we're not doing anything special. We're literally just converting data. That's all we're doing. It just looks a little bit scary, but really it's nothing special. Okay, now that we have that, let's go ahead and define the result of our block. Because if you remember from what we talked about before, when you look at block has its input and it has its output. So we've defined the input, which is this action that we define in here. If you remember, let's go in here, load person's action. Now we have to specify the state of this block, which is the object that it actually holds on to. Remember from Cubit, we could say this dot state, or just omit this, and we could just say state. Block has the same thing. It has a state. So now we should go ahead and define a class that holds on to that state. So you could think of this as our application state. So what is our application state? It's kind of like a fetch result. We're going to call it in here. So let's go ahead and define this application state, and we're going to call it immutable class fetch result. Okay. So what this fetch result actually includes is an iterable of person, because if we fetched the data from the backend correctly, then this fetch result is actually going to include an iterable of persons that we parse from that URL. So let's go ahead and say final iterable of person, and we're going to say persons, just like this. And also in this chapter, as I mentioned in the beginning, what we're going to do is we're going to build some caching into our block, meaning that if we've already fetched the first person's URL, we're not going to fetch it the next time again. If we already have the results parsed and fetched and parsed, then we're going to store them in some sort of a cache inside our block. And once you ask for that same data again, then we're going to fetch that result from the cache. So it's important now to go ahead and add a property to this fetch result to indicate whether this result was cached or not. And that's exactly what we're going to do. So let's go ahead and say final bool is retrieved from cache, just like that. I want to get Visual Studio Code to create the constructor for me. So I'm going to put a curly bracket here. I'm just going to say required for both of these parameters and a colon there. And let's make this guy a const constructor. Okay, so it's also important to implement the toString property of this particular class, because we're going to log it out to the console to have a look at whether something was actually fetched from the cache or not. So let's go ahead and implement toString in here. So I'm just going to say toString, a simple string, which is going to say fetch result, and its property is retrieved from cache is equal to $ is retrieved from cache, just like that. And I don't think it's necessary actually to go and write the persons, but maybe we could just do that as well while we're here. So let's say persons is $persons, just like that. All right, so it's a little bit of a long string, but that's also okay. It's less than 80 characters long, so it's completely fine. I actually think it's less than 80 characters. I'm not sure. So that's that. So now that we have the input to the block and also the output, which is the fetch result itself, what we're going to do is to go ahead and define the block header itself. So we're going to call this guy a persons block. Okay, so I'm going to go ahead and just say, as you can see at the bottom of the screen, we're going to say class persons block extends block. And if you remember from block, it first needs its event and then it needs its state. So events, we define them as action. So let's just say load action. All right. That's our abstract class. You remember, we don't actually allow any load action to be sent to us because load action is an abstract class and it cannot be initialized. Remember that it cannot be constructed. However, since we said that our block accepts load action as its event, any subclass, any class that conforms to load action can be sent to our block as an input. And the only class that does at the moment is the load persons action. All right. So that's really this parameter in here, this generic parameter. And also we have to specify our state. Remember, in block, it also needs a state. And for state, we're just going to say an optional fetch result, because initially, if you remember also from Cubit, you have to specify an initial state for your block. And since we don't have an initial state, we're just going to say a fetch result optional, just like that. All right. Now it's complaining because we don't have a constructor. So let's go ahead in our persons block and add the constructor. So I'm just going to say constant here. And in here, I'm going to remove this guy and say initially the data is null and we can't be const because that's not going to work. So that's our constructor. Okay. So what we need also in here is some sort of a caching mechanism. So in here, what we're going to do is to say we have a local cache for every person URL in here. Let's go ahead and see if we can find it. For every person URL that is requested of us, we're going to cache a list of persons, an iterable of persons. So let's go ahead and define that. So we're going to go ahead and say final map of a person URL. For every person URL, we can cache an iterable of person in here. And we're going to call this guy cache, and it's initially empty. All right. So this is coming a little bit late because we already created the block constructor. But if you haven't done that, go ahead and do the constructor in here as well. Okay, now it's the juicy part. It's the important part. How do we handle the event that comes in here? You remember this action in here, load person's action? And the way to do that with Bloc is if you go ahead in your constructor and create an actual implementation for your constructor, then there is a function inside this constructor that you could say on. This on function, if you go in there, you can see that it takes an event. So it says, okay, what event do you actually want to handle? And in here, what we're going to do is to go ahead and say on load, let's see, on load person action. And so so here we've defined the function. We say here's a function and it's the generic parameter is this, but this function actually has two parameters. Actually, it's the handler and a transformer, but we're not going to use a transformer. And the handler itself, it has two parameters. So if you open this parenthesis in here, you can see Visual Studio Code is helping you out, say, okay, this handler has an event and an emit. So let's go ahead and do that. So this is like the simplest this is the simplest implementation of handling the load person's action in your block. So you get the event. As you can see, this event is now going to be typed. It's going to be a load person's action because we specified it here. And it also gives you an emitter. As you can see, it says it's an emitter of fetch result optional, which is something that you define in here. So event is the input to your block, whereas emit is the output of your block. So given this event, what do you want to do and what do you want to produce? All right, so let's go ahead and first grab the URL that has to be loaded. So we're going to say URL is event URL, because remember, load person's action has a URL, which is of type person URL. And what we're going to do in here is to say, okay, given this URL, we're going to go and see if this URL exists in our map. Okay, because if it does exist in the map, we already have that iterable of persons cached, so we can return that. So let's say if our map contains, it's called cache, contains a key of URL. So we know that we have the value in the cache. So we are now going to go ahead and grab that value from our cache. So if you say cache and then we give it the URL in here, we can say final cached persons. Okay. And this cached persons now you can see in here is going to be an iterable of person. So let's go ahead and create a result out of this. So we're going to say this is a fetch result. The person is cached persons, and is retrieved from cache is true, and a colon at the end and a semicolon at the end of the entire statement. Now that we have our result, we kind of want to give it back. Whoever is invoking, whoever's sending that, I mean, we haven't really gotten to that point yet. I understand, maybe a little bit like confusing. You may be thinking, what is whoever? And that's why I'm saying whoever, because we don't really know how this whole thing is going to work yet. But just imagine this action comes into your block. Now you want to produce some sort of a state. And the way to do that is with your emit. So in here, you say emit, and then you would say a result. So by this, you're telling whoever's listening to changes in your block, which you're going to soon see how we're going to do that. You're telling that person, hey, here is a new event for you to consume. Okay. So if that's the case, then we get the cached value. Otherwise, we don't have the value cached. So let's go ahead in here and say final persons. Now we need to go and call our get persons based on the URL. So we need to do an await in here. And the way to do that is to make your first parameter in here an async function. So then we're going to say await get persons. And the URL is, of course, coming from, as you remember here, we have the URL. Okay, so let's say URL string, just like that, because remember, URL is not an actual string. URL is a person URL, and then we implemented an extension. Do you remember this extension, URL string on person URL? So that's what we're using in here. Okay, so here, as you can see, this person is going to be an iterable of person, and then we're going to do the same code in here. So let's say we first put this into our cache. So we say cache of URL is equal to persons. Okay, and then we're going to construct a new result with those persons. And we say this result is not cached, and then we emit the entire thing, as you can see in here. Very easy. So it's kind of like a copy paste operation. One of them, it retrieves data from the cache. The other one just grabs the data afresh and then saves it to the cache. All right. All right, that's fantastic. So that part should be done. So what we're going to do now that we have a block, we have to somehow provide this block to our application. So this is a part that may be new for you. And for a lot of you, if you're watching this video and you haven't worked with block before, you may be thinking, okay, but how do I create an instance of this block that kind of manages my application state? And the answer to that is with a provider. And a provider is something that is provided inside Flutter Bloc, and it is simply called it's called Bloc Provider. So you need to use Bloc Provider to basically give your application an instance of your block. And the way to do that, we're going to go ahead inside this home. As you can see in here, it has a home page, but we're going to wrap this guy inside a block provider. So I'm going to go in here, and as you can see here, it says block provider. And let's go ahead in here. We're going to say this guy's, you see, it has a create parameter. It gives us a context. And I'm just going to ignore the context, and I'm just going to say we want a person's block, as you can see in here. Okay. And also then we say the child is home page. So what this really did is that what it does is it wraps the home page inside a build context who has access to the block that you create inside the create parameter of your block provider. So if your run app was here before, and then material app was here before, and widgets, your home page was here. Now what's happening is that run app is here, material app is here, block provider is here, and then your home page. And that's kind of obvious from the structure. You can see run app, material app, block provider, and then your homepage. So your homepage is one level deeper now, one level lower, simply because block provider is one level higher so that it can provide, as its name indicates, so that it can provide your block to whoever widget is sitting under it, okay? So any widget that homepage also creates is going to have access to this person's block using the build context, as you'll soon see how we're going to do that, okay? So what we're going to do then is to go ahead and create a little bit of an extension to our code, and that is going to be a subscript extension. And we're going to use this extension actually a little bit further down the road. So I'm going to show you how we're going to do that. But what you need to know about this extension is just that given an index on an iterable is going to be able to give us an optional value in the iterable. So you may be thinking, okay, but what is that? What does that even mean? So let's put it to test. Let me go ahead in here and say const iterable string and names, and let's say foo and bar like this. Okay, and let's say void test it, which is something that I usually do when I'm testing functionality in Dart. And let's say final baz is equal to names 2. And remember, this guy basically it actually isn't defined, as we can see. So we can't even access like names 2 at this. Sorry, we can't even access the third parameter of names iterable because this subscript isn't really defined for iterable. But if we change this to list, you can see now all of a sudden we can access that value. And then baz is, as you can see, is a string. I kind of don't like the way that Dart has done this. I mean, no offense at all to the Dart team. This is just a personal preference. But what I want is for this subscript, this functionality in here to be done on iterable, not on list, because list itself is on iterable. If you go in here, there we go, extends iterable. So I kind of expected this functionality to also be on iterable because we were having an iterable of person, and I kind of want to be able to access persons at specific indexes. And I also don't want this to return a string. I want it to return an optional string, because if I say, give me the 11th item at the index of 10, then it may not exist. So I expect this guy to actually be an optional string. That's why we're going to create this little extension on iterable now, so that we can kind of rely more on getting proper data from iterables given an index. So let's go ahead and say extension subscript t, and we're going to generate that on iterable of t. And then we're going to say, okay, if the iterable is of type t, then we optionally return a value at the given index. So we say it's an operator, okay, and the operator's name is this. The parameter to the operator is an index in here. So we're just going to say if the current length is more than the index, then return element at index. Otherwise, return null. So that's the definition of this subscript extension. All right. So if the elements, if the length of the iterable, let's say we have 3 elements in the iterable, if the length, which is 3, is more than the index, so let's say the index of 2, which is the 3rd item, then this condition is true, then it's going to retrieve the correct object for us. Otherwise, let's say we have a length of 3, and then you ask for index of 3, meaning that the 4th item, but length is 3, so you can't retrieve the 4th item from 3 items, then we're going to return null. All right? So that's that function. I hope that it makes sense. So we're going to go ahead now and add a column to the body of our scaffold in here. So let's go ahead and say body is a column in here. And let's create children in here as well. And we don't have any children in that at the moment, but we're going to take care of that soon. Okay, so let's go ahead in this column now and add 2 buttons in here with their actions. First is going to be load JSON 1, and the other one is going to be load JSON 2. So we're going to have 2 buttons. The first one is going to load the first JSON, and the second one is going to load the second JSON. So let's go ahead in here and add 2 text buttons. Okay, so let's say text button 1 on pressed is an empty function, and its child is a const text load JSON number 1, like this. All right. I'm gonna put that in there, and then I'm gonna copy this text button and then literally just gonna place it in here and say load JSON 2. All right. And I've actually added this text button and this text button to the column, but the goal was really to add these two inside their own row. So let me see if I can take both of them and kind of wrap them with a row. There we go. So if you go to simulator, it kind of looks like this, load JSON 1 and 2. Then what we need to do in here is to actually, when this button is pressed, we're going to send a command for the first time to our block. You see, at the moment, you may be like, okay, we're in homepage, but where's the block? We have no access to it. But remember, homepage itself is wrapped inside a block provider, and the block provider is injecting this block, this guy, person's block, in the build context. So the block is in the build context. It's hiding in there. It's ready for us to extract the block from the build context. But how? There are some functions, really good functions that you can use on build context, and one of those functions is called read. It takes a snapshot of your current given block from the build context if it's present, and this function is going to traverse all the way up the build of the layer hierarchy and the widget hierarchy in all the build context hierarchy, and it's going to extract the given block from any of those build contexts, first comes, first served, kind of. Okay, so let's go ahead and say context read, and we're looking for our app or person's block, right? So that's the function. So if you go in here and say final foo, you can see now the foo's database is actually person's block. So this is how you get access to your block, okay? But how do you send a command to your block? How do you send an event? And that's with add in here. You see, it actually knows that person's block requires a load action. So how do we send a load action? And we had a load person's action in here, and the URL is person's URL or person URL person1, just like that, okay? So let's go ahead and make this entire thing a const as well, and a colon in there. And have a look at this code, please. So context read, grab a hold of your person's block, and then send an action to it. And the action actually has its own properties. And we know that the person's block is actually waiting for this action in here. You can see in here, load person's action. All right. So that's the first button. It's sending the person's one URL to the block. Let's go and copy paste this thing and put it in the second text button in here as well and say person's two, just like that. All right. So that's going to take care of loading the second JSON for us. And then what we're going to do is we kind of want to grab the data that comes here. I mean, we're sending data to the block, but how do we get hold of the result that comes back from the block? And there is a great component in Flutter Bloc, and it's called Block Builder. As its name indicates, it's kind of like a stream builder or future builder. And what it does is that it listens for changes in a block that you ask it to listen to, and then it rebuilds its child component, or it actually calls its builder function, and it says, okay, now that this block has changed, give me a new widget. So it's listening for changes in the block, and it's like rebuilding its widget dependent on the changes in the block. So it's perfect for this case. So this is our row, ends here, okay? So let's go ahead right after this row and create a block builder in here, okay? And if you look at the signature of block builder, you can see it says, okay, what is the block itself, right? First, I want the block, and we're going to provide that. And then next is its state. So we're going to say we have the person's block. And then we know that person's block has the fetch result as an optional. Okay, so we're going to provide that right there. And then we get the builder. So there is an important, let's go to builder, and then in here we say context and state. Let's just return a container for now, okay? So we can make Visual Studio Code or Flutter happy. But I want to talk about a function in here, a parameter in here called build when, which is this one. So what happens in here is that block builder, if you don't provide build when to it, what it's going to do is that whenever any state changes in your block, is gonna call the builder function, and it's gonna expect you to return a new widget to be rendered on the screen. But if you provide a build when to your block builder, what is going to happen is it's going to call the build when function, is going to give you the previous fetch result in this case and the current fetch result, and it's going to say, okay, given these two values, give me a Boolean, and then based on that, I'm going to make a decision whether it has to be the widget has to be rebuilt or not. And if you read the documentation for this, it says, let's see, blog is blah blah simple. Please refer to block listener if you want to do anything. Okay, return widget here based on block A, and then let's go see if they have an example. Return true or false to determine whether or not to rebuild the widget. So we have to return true in here if we want our widget to be rebuilt. So here's the question. Given a fetch result, an optional fetch result, how do we know that we want the our widget to be rebuilt? And we can do a simple comparison in here, to be honest with you. So we can just go ahead and say just a dummy comparison in here. Let's say we take the previous result, previous here. We could call the previous result actually, and current result. So that's similar to the fetch result. It's a little bit easier. Previous result, okay, optional persons is not equal to current results persons, like this. Okay, and we just return it. All right. So if they're not equal to each other, if they're not exactly the same, then we're going to return true, meaning that this builder is going to be rebuilding. But remember, there's some great collection methods out there for Flutter developers that you can just bring in. It's not third party, but in the collection package, there's like unordered iterable comparison, which you could use if you want to take this example to the next level. And in my Flutter and Dart tips and tricks GitHub repository, I actually recently uploaded a tip on how to do that. So if you go and search for tips and tricks, Flutter tips and tricks here, and I did a unordered, if you look here. So there's deep collection equality unordered and equals. So you can actually use this deep collection equality to search for, so basically do a comparison of this previous results persons, but we're not going to do that right now. I mean, it doesn't need to be scientifically done. Okay, not for this example at least. So great, now that we have that, let's go ahead in here and, excuse me. So let's call the state a fetch result, okay? And if you look at it, it's actually a fetch result. So what we're going to do in here is going to say final persons is fetch result persons, okay? But we're going to say if persons is null if we don't have any persons to display to the screen. So we're just going to say return size box, just like that, okay? So we don't have anything really to display. All right. Otherwise, what we're going to do is to display a list of our of persons. So let's say return list view, a builder, okay? And we have our item count in here. We're going to say persons length, and then we have an item builder. And let's see if Visual Studio Code can help with that, but it can't. We say context and index in here and open square brackets in there. So and a semicolon at the end. Perfect. So now that we're putting list view builder inside a column, we need to make sure that is inside and expanded. Otherwise, it's not going to work so well. So let's go ahead in here and wrap it with expanded. All right. So great. What we need to do in here really is just to grab the person at the given index. So I'm just going to say final person is persons at index. And remember, this is the cool thing. This is now using, I believe, our own let's see if it finds it. Oh, it's going to persons, but I want to find this guy's definition. But anyways, it's using our own subscript here, this guy. Okay. So now that, because if you didn't have our subscript in here, if you did this wouldn't work because there is no subscript on iTribble, remember? So we put it back. And in here, we're going to say unwrap that, force unwrap that, okay? And then we say return list tile. And for its title, we're going to say we have a text of the person name. All right, so this is
this is fine, I would say. So that's really all we had to do. And I'm just going to do a hot restart. And I'm going to do a hot restart simply because we haven't really been bothered to go ahead and extract our material app into its own widget, meaning that any changes that we're making now to the main function are not going to be recompiled, and they're not going to be there if you do a hot reload only. So you need to do a hot restart. So hot restart in there, and then let's go ahead and bring our simulator to the screen. So what I'm going to do is I'm going to press the load JSON number 1, and you can see our foo1, bar1, and baz1 are loaded to the screen. And to be honest with you, it would be really fun if we actually did some logging and we could actually see the fetch results and if it's cached or not. So I'm going to do a hot restart to remove the cache. Let's add some logging to our application. So I'm going to import Dart developer, and I have this handy extension on object that can log any object out to the developer console. So let's go out here to our block builder, to the builder right here, and I'm just going to say fetch result like this and log. All right, perfect. So now that we have that, let's go ahead and bring up the developer console here. So you see, we don't have, the block builder isn't really building anything at the moment because there are no persons in here, and the result of this thing is false. So if we do this, you can see that it says it's retrieved from cache false, and it's actually retrieved our persons. Let's do load JSON number 2, and you can see it's still saying that it was retrieved from cache not. Now, if we hit load JSON number 1 again, it should retrieve the data from cache. So this time I expect to see is retrieved from cache to be true. So let's test it out. Boom. And you can see now it says retrieved from cache true. And it's going to do the same thing for this because they're both now cached, and none of them is going to produce false anymore because they're both cached. So we've now put it to test. We know that it works, but if you want to also be a little bit better at this, you would go ahead and implement toString on person. So you'd say toString. Let's go ahead and implement that. So I'm going to say person, and let's say name in here is equal to $name, and age is, let's just say name equal to name and age equal to $age, just like that. All right, so save this, and let's do a hot restart, and let's go to our developer console and see how it looks like. Load JSON number 1, we can see it says foo1 age 20, bar1 age 30, baz1 age 40, and then we go to load JSON number 2, and we get foo2 age 20, and the rest is history. Then we press load JSON number 1, and it says it's retrieved from cache, and it's the same result as this guy. So, and it's the same, to be honest with you, with load JSON number 2. So there's no surprises there. Great. Okay. So now that we've done that, let's go ahead as is tradition and commit this code because we're ready with this example. So we're done with it. Let's go to the terminal, and I'm going to say git add all, and let's commit it. We're going to say this is step 2, just like that. And if we look at our commits, we have step 1 and step 2. And then I'm going to say git tag it as well as step 2. And if you look at our tags, we have step 1 and step 2. So that's really it for this particular example of this chapter.
Great stuff. We've come far, to be honest with you. We've done 2 examples. The first one we've done Cubit, and in the next example we've used Bloc. And a lot of developers out there may actually think that, well, this is all there is to Bloc. We just send stuff to Bloc and we retrieve stuff from Bloc. But there's a lot more to it. And if you're really trying to learn Bloc, and one of the reasons that this chapter of the Flutter state management course on YouTube is so long is that I don't want you to think that Bloc is all really about streams and that you send values to it and you retrieve values from it. But Bloc is kind of like a way of thinking, is a way of structuring your project, is a way of structuring your files and your actions and states in your application. So in order for this chapter to be doing a good job at representing Bloc and what it means to use Bloc in a typical Flutter application, we need to also touch upon tests. And
we're not going to do tests only right now, but we're also going to add tests to more examples in this chapter. So I'm going to show you examples, then we're going to write tests for them. So you get used to writing tests for your Bloc applications. And that's exactly what we're going to go and do right now. So the Bloc library, if you go ahead and read the documentation of the Bloc library, it's very well documented online, by the way. It allows you, it gives you high flexibility of testing. But we have a little bit of a problem right now because our code isn't really mockable. And what mocking means, you may be familiar with mocking, but if you're not familiar with it, I'll just quickly explain what it means. Mocking, the ability of a function or a piece of code to be mocked, or for it to be mockable, means that it is free of dependencies that are tightly coupled to that piece of code. Let's have a look, for instance, in our application right now. At the moment, if you have a look in here, this load person's action, it is coupled to the person URL that it can load, and then person URL has persons1 and persons2, and those two enum values are tightly coupled to specific URLs. So if you start to write some tests, for instance, in our application, then these tests, if they're using URL string on this person URL, then we need to always ensure that while our tests are running, these two particular URLs are available. Now, keep in mind, you may think, okay, that's not so bad. If I'm running my test, I'll just ensure to make sure that I have a local web server, as we have with the live server extension in Visual Studio Code, and I'll just run my tests. You'd be right. If you're running it on your computer, that's going to work, but it is not the right thing to do. And I'll explain it to you what that actually means. If you're becoming a better software developer and you're becoming like a software engineer and you're trying to do things more correctly, then you have to always think of, okay, not only about yourself, but you're also going to have to think about like the different people that you're going to work with and what makes sense to them as well, and what makes sense in terms of a whole team working together on a Flutter application. Even though the code here might work for you, it surely won't work for other people if you're working inside a team. So if you're becoming a good software developer, you also need to ensure that you're doing proper engineering practices, making your code mockable, making sure that if anyone else also runs your tests, they don't have to necessarily have to have a web server in order for the tests to succeed or fail. Even though if you're doing particular integration tests, you may need to, for instance, spin up a local web server and host some files and mock all of that as well. So it really depends on the type of testing you're going to do. In this particular example, in this part of this chapter, we're not going to do any integration tests. We're actually going to do unit testing, and we're going to use block tests for this. So don't worry about it. This is all just a lot of big words that I'm throwing out there. I understand maybe a little bit intimidating, but we're going to go through it, and like I'm going to break it down into small manageable chunks of code that we can digest together. So we need to make our code more mockable, meaning that we should make sure that it's not tied to these like hard-coded strings, such as these URLs. And we're going to have a look at how we're going to do that. But before we do that, let's go ahead and add a little bit of analysis into our analysis options and ensure that we're only using single quotes, as you can see in here. So I'm going to say prefer single quotes inside this file. As you can see, analysis options, and we're going to save that. It's just something that I'm used to, which I forgot to add in the previous examples. But thank God I don't think we have any problems at the moment in our application, or we have two. Okay, we have one problem in our tests in here, and then we have an unused import in here as well, which is again in the test. So both problems are in the test. So we don't have any problems related to a double quote being used in our application, which is pretty good. Okay. So what we're going to do is to go ahead and add a package to our application, which is called block test. And we've already added block. We've already added Flutter block. Now we're going to go ahead and add a block test package to our application. As you can see at the bottom of the screen, I've indicated that we're going to add this as a development dependency, meaning that this dependency is not going to be shipped with our application. If you add a dependency to your application, normally, let's say, for instance, if you go to our pop spec, we have at the moment Bloc and Flutter Bloc. These two dependencies are going to be shipped with our application, meaning that when you release your application, for instance, to the App Store or Windows Store or Google's Play Store, for instance, then those dependencies are actually going to be shipped with your application. They're going to be compiled in the same binary, and they're going to be shipped and packaged. However, if you have a dev dependency, those dependencies are only going to be available on your computer while you're developing this application, meaning that they're not going to be shipped with your application. And since testing is something that you don't have to, you never should actually ship with your product, then we're going to add the --dev option to our pub add. So that to make sure that the testing package is only going to be available on our computer while we're developing this application. Okay, so let's go ahead in terminal in here. I'm going to bring it up, and let's go, as you can see at the bottom of the screen, Flutter pub add. We're going to say --dev and block test in here. All right, so this is going to go do its job. It's going to drag in block test. So if you look at your pop spec in here, we have block test added here, version 9.03 at the moment, under the dev dependency section of your pop spec YAML file. Okay, so what we're going to do is we're going to first do some cleanup. At the moment, if you look at our main Dart, we put everything in here, like literally the entire code is in here. Everything is here. Okay, so we're going to clean this up. Let's go ahead and create a little folder in here in our application. And let's just call it, this folder is going to be called lib block. Okay, so this folder is block right here. Okay, so we're going to go ahead and move our person Dart class in here. So if you go and have a look at it here, person. All right, so let's go there and take it there and put a file in here. We're going to say person Dart. Okay. And I'm going to go and have a look at my code in here just to make sure that I've done everything correctly as well there. Yeah, okay. And then we're going to paste it in there. And now it says that immutable is a modifier that I can't find. I'm going to bring it from foundation. I'm just going to say show immutable. Okay, so this is going to ensure that we're not importing the entire foundation package in here. We're only using the immutable annotation, which is a const immutable, as you can see in here. Okay, so that's compiling fine. And then what we're going to do is to go ahead and ensure that our person class actually is implementing all the functions and properties that it has to. So we have toString from JSON, and it looks fine. Good. All right, so let's go ahead and add our block actions to a new file in here. So I'm going to go ahead and create a file in here under block, and let's say new file block actions. Start. All right. And we're going to get our actions and put them in there. So let's see if we can find them here. We have the load action and we have the load persons action. Let's go grab those and bring them into block actions, Dart. And again, we don't have access to immutable. So let's import foundation and say show immutable. All right. And in here, it says that it needs person URL, but person URL, we haven't really placed it anywhere yet. I don't even know where person URL really is going to be honest with you. So maybe person URL is actually going to be, let's see if we can find where person URL is going to be. Let's put it in block actions then, in here in block actions. Let's go and take person URL. And we could actually put person URL in there with this extension as well, right there. Okay, let's put it in block actions. Great stuff. Fantastic. Okay, so we put it there, and it's and let's see, classes can't be declared inside other, and I think we are missing a curly bracket in here. Fantastic. Okay, and let's remove this extra curly bracket maybe that we've left somewhere. Have we left it? No, we haven't. So in block actions, now we have person URL, and we also have load action and load persons action. All right. So what we're going to also do is, as I mentioned before, this is not really a sustainable way of doing coding because person URL at the moment is hard coded. Enum, there's no way for us to inject any other URL in here, and it has like this person URL extension. So we're pretty much kind of gonna get rid of this person URL, to be honest, and we're not gonna use person URL anymore. So let's kill this person URL as it stands right here. So let's kill it all, okay, like this. So after getting rid of person URL, we have to start thinking of, okay, how do we actually parse URLs? How do we make sure that this person's action can actually send some sort of an action to the block that the block can actually understand? So what we're going to do is to grab this URL that we had in here, at least the first one, okay? Let's go ahead and define first two constants in here. So we're going to say person's one URL, and that's that one. And then copy paste this and say we're going to say person's two URL. And instead of passing a person URL in here, which was an enumeration, we're going to say this guy is a string. Okay, so it actually takes a string, a raw string in here. Fantastic. Now, imagine this guy carries with it a URL. Great, a URL is fine. But what happens when this URL goes into the block? Well, then you would say, okay, well, then the block is going to download that URL. But we have a problem there, because what happens if the block then tries to download this URL? Then we have the same problem. We're back to square one. You have the problem that a block is going to download a specific URL, meaning that it is, even if we're doing tests, for instance, even when we're doing our tests, we could say, when we're doing tests, let's just load another URL. But we still have the problem. We're loading a URL, meaning that we have to have some sort of a web server running. So this solution of loading a URL isn't really going to work, wherever you put the URL loading. However, if we kind of could inject some sort of a URL loader into this action and say, here you get a URL and you get a URL loader, then based on those two properties, then the block can say, hey, I'm going to first go to, I know I got this action. I know it has a URL. And it has a URL loader. I'm going to pass this URL to the URL loader injected into this action. If it returns data, fine. Otherwise, I'm going to download the URL myself as the block. That is dependency injection. That is a way for you to dictate how your application should work and how you're making it more testable. I know it may sound a little bit abstract right now, but let me show you in actuality how this is going to work. So let's go and define a type definition in here. We're going to say person's loader. Okay, so this guy should actually load and give us an iterable of persons. So it returns a future of iterable of person. And let's call this, it's called person's loader. And it is a function, but what does it actually take? Well, it takes a URL. So we say it takes a URL, just like that. And it doesn't have access to person. So let's import person. So this is the type definition of a function that you can see. It takes a URL and it returns a future of an iterable of person. So what we're going to do in here is going to say we have a new parameter in here. It's called person's loader. We're going to call this guy loader. Okay. And then let's say required this dot loader, just like that. So now the person's action is going to be able to carry with it a loader. So this is great stuff, because then we can inject any loader into this guy and mock that. So in our tests later, as you'll see, we will actually create a loader that, independent of what URL you send to it, it will give you a specific set of or iterable of persons. This makes this load person's action testable. You're basically injecting dependencies into it. So this is dependency injection. All right. Fantastic. What we're going to do in here, we're going to go ahead and define our person's block, as you can see at the bottom of the screen, in this block folder in here. So let's go create a new file. We say person's block.dart. And we're going to go to our main file and take this person's block exactly as it is and chuck it in here. Okay, so into if I can find that person's block right there. Okay, so I just chucked it in there. We have a lot of errors, but we're going to fix them soon. So what we're going to do now is to go ahead and define equality on iterable. So we need this because, I mean, as you'll soon see when we go into, I mean, just before I get into all of this, I know there's lots of errors on the screen. You may be like freaking out, but don't worry, we have all the tools available so we can fix all these errors and go ahead and make our test. So we know there's lots of errors. I'm completely aware of it, but we're going to fix them soon. So let's focus on what we have to do here. When you go and mock this action in here, block action, and when we mock this person's loader, it's going to, in our tests, return a specific iterable of person, okay? However, remember, iterables are not guaranteed to hold their ordering, meaning that if you try to test something and you tell your test that, hey, here is a person's loader that returns an iterable of this particular person and then this particular person, then what you need to do is also kind of make sure that the ordering is correct, because if you then compare these, what you send to this loader and what the loader actually returns, the ordering might be different, meaning that then your test will start to fail, or they might fail because ordering is not guaranteed. So what you have to do is kind of like compare iterables independent of their ordering, of their elements ordering, if that makes any sense. So what we're going to do is to kind of like code some functionality here, and we're going to create an extension in our person's block in here that is going to help us with that. So let's go and code that right now. So let's go in here, and don't look at all these errors. I'm actually going to shift them down so you don't see them. So let's say extension is equal ignoring ordering on of type T on iterable of T. Okay, iterable. Okay, just like that. And we're going to call it is equal to. Okay, and I'm going to copy that, and this is a Boolean function, and it looks like this. And we're going to compare the current instance to another iterable of T, and let's just call it other. Okay, so what this guy is going to do is going to say, first of all, these guys have to have the same length. All right, so their length should be first of all equal, so other length. And also, if we create a set out of these two and intersect these sets together, then their intersection should be the same as this. I know this is, I mean, it's a little bit unfortunate that then we have to go into mathematics and talk about intersection, but intersection is really where two sets collide. So if you have an iterable of A, B, C here, and then you have another iterable that's B, C, and D, their intersection is going to be and C, because that's the two elements that they have in common, so that they intersect there, B and C. Okay, so what we're saying here, for two iterables to be equal, ignoring their ordering, what you could do is to first compare their lengths. If they have the same length, then there is a chance that they could be equal. But if they don't have the same length, this function is immediately going to return and say false, because they're not equal. Okay, once you've gone through the length part, if they have the same length, what you could do is to take the elements from the first iterable, take the elements from the second iterable, put them into two sets, and then take the intersection between these two sets. If the intersection has the same length as the current length of this iterable, then you could say that these two iterables are equal. And I want you to pause this video if this is too much for you to understand, or sorry, too much for you to maybe grasp at the moment, because it's going to mathematics. You could go ahead and read a little bit about sets, perhaps. To be honest with you, I'm not a math whiz. I mean, this has made sense to me, so it's just something that I understood, but it doesn't mean that I'm good at mathematics. So if you didn't understand this part, you could go ahead and pause this video and maybe even do some experiments yourself as well. So let's put this into a set in here. And then we're going to say intersection of this guy should with another should have the same length as our length. So that's the implementation of this function. And remember, I'm just trying to show you different ways of doing things, because you must know that there is a built-in function in Dart that you can, I think, is a package collections that kind of does the same thing for you. But I just want you to explore different ways of doing the same thing. All right. So that's our function. Okay. So what we're going to do here is to go ahead to our fetch result. And if you can find that guy, fetch result is somewhere. Let's see if you can find it. Fetch result, where are you? Here, it's still in main Dart. And we could go ahead and actually grab this fetch result and bring it into our persons block here. Okay. Immutable, we're going to fix. We're going to add foundation in here. Great. And then show immutable. Great. And we don't have access to person in this file, so let's import that. Okay. Fantastic. Now that we have that, now we're going to go ahead and actually implement equality on this fetch result. So because this is going to be very important in our tests, when we take an instance of fetch result from before and compare it to a new instance of fetch result, we kind of need to understand, are they the same or not? So the way to implement that is that by going to override the equality operator. So let's say override operator, bool operator, equal, and then we say covariant, and this is a fetch result other, like that. Okay. So what defines equality between two fetch results? First of all, their persons have to be the same. So we say persons equal ignoring other persons. Okay, so that's the first condition. And also is retrieved from cache should be the other retrieved from cache. So as long as these two properties are equal, then we could say that the fetch results are equal. Then as you implement equality, you also have to implement hash code. So let's go and do that. So override int get hash code. And in here, there is a function on object. So you can say object hash, and we're going to take our persons, and we're going to take is retrieved from cache in here. So that implements and completes the implementation of fetch results. Okay. All right. So we need to now go ahead and update our persons block in here. So if you look at our application, we just have the get persons. We have the subscript in there. And really, I think that's all there has to be in the main Dart file. So let's go ahead and fix this file. Now we have a lot of errors in our persons block. The first thing is that we have no access to block as a class. So I'm going to bring in Flutter block. We have no access to load action. Let's go ahead and import block actions. We have no access to person URL. And the reason behind that is that we aren't working with person URL anymore, actually. We're going to work with string. We're going to work with actual URLs in this cache. So given a URL string, we're going to cache an IEEE person, okay? So here we get a URL, we go into the cache, then we say cached persons, blah, blah, and return it. So this part is done. So the caching is absolutely fine, okay? The problem is where we actually doing the loading. You can see in here, it's still going to the get persons function. We said that we shouldn't do this anymore. Get persons is just something that our application is going to inject into instances of our action, which is here, block actions, load persons action as a loader. Okay. So what we need kind of is to take away the dependency of our block on this get persons function. The get persons function makes our block not testable. We need to make it testable. And as long as we have a hard-coded dependency on get persons, our block isn't testable. So the good thing is that every action, you see this action that comes in here, this event of type load persons action, it has a URL loader. Okay, so remember that we added that here, URL loader. So let's go ahead in here and say final loader is event.loader. And then in here, we're going to await that loader and getting that URL. And then the rest of the code is going to be the same. So there's no changes in here. Okay. Fantastic. So what we need to do is now go ahead and fix some of the problems also that we have in here in our main Dart file. So we could take care of that right now. So let's see one at a time. It can't find person's block. Let's import person's block. So that part is fine now. We have get persons, so that's also fine now. The subscript staying the same. And now we have this problem in here that we're initializing the load person's action in here, but there are new parameters in here that we haven't provided yet. So let's go ahead and do that. So the URL is going to be hard-coded for the main application, not for our tests. So the hard-coded URLs, I believe, were implemented here. Persons one URL. So let's bring it here. So we say persons one URL, and as the loader in our main application, we're actually going to hook in this get persons. So it just fits in like butter. It's just fantastic. So, and then we copy this code that we have here and we paste it for our second button. And then we say persons two URL. So if we now go to the problem section of our application, we shouldn't ideally have any problems. You can see it's in the main Dart file. Okay, we can remove this import. We don't need it. And the actual only problem that is in our application is in the tests file, which we're going to soon fix. So no problem. So let's save this file and do a hot restart. And if we go back to our application, it should work exactly as it did before. Actually, this person's two isn't working so fine, and that's probably because let's see what we probably missed here. So persons two URL, okay. And if we go to the action, we have that. And if we look at our actual block, let's see how that guy is working. It's taking the event loader, and then it's taking the URL. Fantastic. And here, what do we have? Persons two URL, and we have persons one URL. And the problem here, to be honest with you, could be with how we're comparing our persons and how like persons comparison actually looking like. But to me, this looks fine actually. So I don't really see where the problem is. Let's have a look. Get persons, persons two. So if we tap on this guy, it doesn't do anything. Let's have a look at our logs. So if we do a hot restart, I can see here it says it actually retrieved foo1. So it's a little bit strange. And it could be because we've missed something in here. As you can see, persons one, and it should be persons two. So let's do a hot restart, load JSON2, and now they're working fine. So if you did everything correctly, your application should work exactly as it did before. So no changes to the way the application actually displays its content to the user. But what we did really was a huge work, a huge undertaking to make our block and our entire application, for that matter, more testable. And that's what we're going to do right now. Okay, fantastic. Now that we have set up our application so that we can test it, let's go ahead and do the actual testing for our block. So the first thing that we're going to do is to go ahead and delete the existing file in here under test. As you can see, it is marked as red in here because there are just so many errors. And it is, for me at least, it's an opinion, but it's always easier just to completely remove this file than to try to fix it, because almost nothing in here is reusable for us except for the actual void main function. So let's go ahead in here and just say delete, and we deleted that test. And what we're going to do in here is to go ahead and create a new test file in here. We're going to create a persons block test. And this is something important for you to remember, that your files have to be prefixed, not actually prefixed, they have to be suffixed with test.dart. So you can't call your test files tests as in plural test. They have to have the word test at the end, and their extension needs to be Dart. So let's go ahead in here and create a new file, and we're going to call it, let's see, we're going to call it, as you can see at the bottom of the screen, persons block test, persons block test.dart. Great stuff. Okay. And we need 5 different imports in here.
the first one is going to be Flutter test that we have to import in here. So let's go ahead and say import package Flutter test. Okay, so this is the underlying test structure of this test file. It's not going to be a Dart test file. It's going to be a Flutter test file. Then we need also block test, because block test, as you remember, we added it as a developer dependency, as a development dependency. This development dependency allows us then to write tests specifically for block. So let's go ahead in here and say import package block test. So we import that. We also need access to our person's block, and block actions. So let's go ahead in here and say package, and then we're going to write person. It seems like we can't, so that's okay. We're going to auto import them soon. Okay, so we can just leave these two for now. Great stuff. So what we need here is to go ahead and create two iterables of person, which are mocked. So we're not, or do you remember we had these person loaders? If you go back to our, I believe, not in here, they were here in block actions. We had these persons loader, and the idea behind this is that given a URL, then a person's loader is going to be able to give you back a future of iterable person. So what we need in here is to first define these two iterables, and then create some sort of a mock loader that always returns those iterables. Okay, so we're basically mocking right now here. So let's go ahead and create these mock values. And I have both of these ready, so I'm just gonna copy paste them in here, because it's just so much easier to paste this value in here than to actually have to write it. But it is very simple. As you can see in here, it's saying mock persons one, and it has basically reference to person, and it says age 20, name is Fu, and the next value is with the age of 30, and the name is Bar. And since we don't have reference to, since we don't have access to person, I'm just going to auto import that here. There we go. It's so much easier to auto import with Visual Studio Code than having to write this entire path. So this is our mocked persons one, and we're also going to go ahead and create a mocked persons two. So I have that data available in here. It's very similar to mocked persons one. So I'm not going to go ahead and type this manually. It's just so much easier to paste it while we have it in here. Let me see if I can actually grab that. And let's paste it right here. So as you can see, we have mocked persons one, and we also have mocked persons two in here. The ages are the same. As you can see in here, it says 20 and 30, and then we have foobar. And the same is true in here, age 20, 30 foobar. Now you may be thinking, okay, but why aren't the values any different in here? So why is it foobar and age 20 and 30 in both of these? Well, I mean, they don't necessarily have to be like this, but if you remember, when we actually did the JSON files for our main application, we made sure that the values are a little bit different. So we said foo1, bar1, baz1, and in the second JSON file, we said foo2, bar2, baz2. And the reason behind that number system that we added was to be able to visually identify whether we've loaded the JSON correctly or not. However, in this application, or sorry, in this test, we are not going to do anything visual. We're not going to actually spin up a whole Flutter environment and display like a UI to the user. But what we're going to do is just to compare some data. So what you put in here, the point of this is kind of moot. So it's not that important what you put in here. What's important is that the data that you give to your block, excuse me, should be the data that you get back from that block when you load that JSON. So you could go ahead and experiment with adding different values in here. It won't make any difference if you write your tests correctly. That's what I'm trying to say. Okay, so we've added our two mock persons in here. You can see mock person one and mock person two. So I was a little bit slow in bringing up the title at the bottom of the screen. Then what we need to do is to define two mock functions. And these two mock functions, they need to comply to this particular person's loader implementation, or the declaration of this type definition needs to be followed in here. So what we need to do is to create two functions, and they take in a URL, but they're completely going to ignore that URL. And what they're going to do is to return a future of iterable person. The first function is always going to return mock persons1, and the second function is always going to return mock persons2, regardless of the URL. And that's the idea of mocking. That means that whatever URL you get, you're going to completely ignore it, and you're just going to return mock results. So that allows our block to be tested or that allows the block to be testable, as you'll soon see. So let's go ahead and do that. So we're going to write the first function. We're going to say the first function is going to return a future of iterable of person. So, and we're going to call this mock get persons1 in here, and it takes a URL. And what this guy is going to do is just going to say future value mocked persons1. So you can see this this is very simple, and it's still complying to the structure or to the declaration of persons loader, which returns a future. It is a function and it takes a URL as a string, but we're completely ignoring the URL in here. And to be honest with you, if you're ignoring the URL, we could also name this guy with an underscore, just to kind of indicate to whoever is looking at this code that we don't care about that incoming value. Okay, so let's go and copy that guy and say persons2 as well in here, and don't forget to return mocked persons2 in future iterable person here. Okay, so those are our two functions which are going to mock the results of loading the load action. Okay, so the first thing that we need to take care of in here is actually set up our test structure. So the first thing we need to do is to create the void main function. And as soon as you do that, you can see that there is a run and a debug function available, functionality available here in Visual Studio Code, because it recognizes that this is the entry point to our tests. And then what we're going to do is to go ahead and create a test group. So when you're working with a Flutter tests, there's this concept of a test group, meaning that if you believe that logically few of your unit tests, for instance, or integration tests or whatever, are connected to each other in that they're kind of testing similar things related to each other, you could go ahead and, or actually instead of could, is you should go ahead and create a group. So let's go in here and say we're creating a group, and this is a function. And in this group, we're going to say testing block. Okay. And the second parameter to this guy is just a simple function, as you can see in here. Actually, sorry, it's a function in here and goes like this. Okay. So now here, write our tests. Okay. So when you're inside a group, there is a function in there is a functionality in here that you can go ahead and set up this group. So what it really means is that since you're inside a test group, you can have different tests inside this group. So let's say one of the tests is going to test the initial state of the block. The other test is going to test, for instance, what happens when you load persons1. The other test is going to test the ability of loading persons1 twice, meaning that the first one shouldn't be cached and the second one should be cached. So we're going to have quite a lot of tests, and these are kind of like their own blocks of code. However, if you really look at it from like Flutter's perspective, all of these tests have something in common in that they all need our app block, or I think we called it persons block. Right? So they all need an instance of this persons block. So you could either go ahead and set up a persons block for every test that you're writing, or ideally you would go and say there is one test persons block. All these tests will have an instance of that when they're run. So there is a great functionality in Flutter tests that is going to give you the ability to construct an object before any of your tests are run. So in here, we're going to say, okay, we're going to test, for instance, the initial state of the block, and we need a block for that. Then Flutter is going to give you the ability to create an instance of your persons block right before that particular test is run, and right before any of the tests in this group are run. So it's kind of like a setup stage. So what we're going to do first is to say we have a variable in here called actually called block, and it's of type persons block, and it's going to auto import this now for us, as you can see here, so we didn't have to import it ourselves. Okay, Excuse me. So we're saying that we have this variable in here, but how do we set it up? Because we're saying that this is a late variable, so it's going to be set up somehow, but we don't really know when. And that's why we have this setup function in here. So setup function, it takes a function in itself, and the goal of the setup function really is to do the setup that all the tests require. So in here, we're just going to say block is persons block, as you can see in here. So now that we've done this, any tests that we write in this group, they're going to have access to a fresh copy of persons block. So that's also something that you need to keep in mind. When we're doing testing, every time any of our tests run, this persons block is going to be created afresh. It means it's going to be created as a new instance because setup is going to be run before any test and every test. So remember that. So setup is not for the entire group only once. It is once per test in the group. So, and this is really good because it allows you to make sure that the block is created afresh, it's created as a new instance right before any of the tests in this group are run, so that you have a clean slate to work with. Okay. Fantastic. Now that we have our block, it's time to go ahead and write our first test. So in this first test, what we want to do, if you go back, let me actually bring our test to the left and the block to the right. So let's go back to our persons block here. Okay, and I'm going to remove the block actions. So if we look at our persons block, which is here, do you remember this line of code that we wrote that we said whenever persons block starts its functionality, its work, it by default has a state of null. So as a software developer, what you want to do is really to hit as many of these lines of code that you've written as possible in your tests. And by that, I mean that your test needs to cover as many lines of code that you've written. Your tests have to test these logic. So you've written this piece of logic, or we've written this piece of logic that says persons block super null. And what happens that if in the future someone goes and changes this data type in here and adds another value in here, or just say, oh, the default fetch result is this. Let's say they add this code, say empty, and then in here they say false. And this is a completely okay piece of code. There's nothing wrong with it. As you can see, it also works. However, someone has gone in there and changed the initial state of your block. Now, all of a sudden, your application may not work as expected. So since this is a piece of code that we've written, we kind of expect it to be null to start with. It makes complete sense to go and cover that piece of code. And I keep saying cover because that's where the word test coverage comes from. So you may have heard that a lot of people say, yeah, my code base has 60% test coverage. And what that means is that 60% of the entire runnable and executable code in the application has gone through testing. It doesn't necessarily mean that is a sign of quality. Tests could also be problematic. They could not really basically give so much value in terms of quality to a project. They may be defensive codes in that they make sure that you don't accidentally go and change something in the code, if you understand what I mean. And that doesn't necessarily give any value to the quality of the product per se, not necessarily. So I just want to mention that test coverage means how much percentage of the entire code base has gone through some sort of testing. Okay. So what we want to do now is to have test coverage for this particular logic. So how do we test that? Now we have the setup. We know we have an instance of block, but how do we go ahead and create a test for it? So there's a function called block test, as you can see in here. So, and block test comes from this package, block test package that we imported, if you remember here, which we imported as a developer dependency. Do you remember in our pop spec? Here, a block test is under development dependencies. So this function is going to allow us to do some testing with our block. So let's see what we can do in here. So let's say we want to have a block test, and let's give it some parameters, because if you have a look at the source code for block test, it needs two generic parameters. One is the block type itself, and the other one is the state of the block. So the first parameter should be the person's block in here. So let's say persons block. And the second parameter is the state of that block. So if you go to persons block, you can see its state is fetch result as an optional. So let's go ahead and do that right now. So we say it's got a fetch result and as an optional. So now that is happy. And let's go ahead for the description. Let's say that test initial state. So this is just a string that you need to provide. Okay. Now the build is, if you look at the parameter build in here in our block test, let's have a look at it. You see, its output should be the block. So this build parameter is actually required, and it should always give a block back to this block test so that we can test it. So you may be wondering, but wait a minute, we've already created a block and it's right here. And you'd be right, we've created a block, but this block test guy has no way of knowing that. So what you need to do in here is just to say, okay, here's an empty function. We don't care about what it's actually doing, but what it really needs to return is our block. And that's it. So now you said that we have the build function, but we're not going to create a new instance of our block, but except we're going to go ahead and use that block that we've already created. Okay. So let's go in here in build. After build, what we need to do really is to basically test the initial state. So how do we do that? There is a function in here. There is a parameter in here called verify. And this verify guy is it's a parameter that is in itself a function which gives you the block, and it expects you to return true or false. If you go to verify, let's see if we can find it. Verify. Here you can see it's a function and it takes in a block, and then it should return something in here. Okay, so our responsibility now is to say block state should actually be null to start with. Okay, and that's it really. So let's say that we've written this block test now, and let's have a look at it. It has a description. Its build parameter returns the block, and in verify, we're just verifying the state of the block to be null to start with. All right. Okay, that's great stuff. So now that we've tested the initial state of our block, it's time to go ahead and test basically loading some mock data. So what we're going to do is to go ahead, let's put some comments in here. We're going to say fetch. I'm actually going to copy the comments because it's just too long to type for me. All right, so you can see we're going to fetch some mock data in here, persons one, and compare it with the fetch result. So you now know that when we're testing block, we're going to go ahead and create a block test in here. So let's say block test. The description is going to be mock retrieving persons from first iterable. You also know that the build function, the build parameter is a function that just returns a block. All right, so it kind of looks like this. And now what we need to do is to start actually interacting with the block. In the previous test, it was very simple because we didn't really interact with the block. We just tested its initial state. We didn't send it any actions. We didn't send it any events. So you may be wondering, okay, but how do I start sending events to the block? And how do I basically get the state of the block after I've sent these events? And the way to do that is to start by adding this ACT parameter, which is, I believe, for actions. And I'm a little bit confused why Felix didn't actually change this parameter name to be actions, because I mean, we have build, we have many other parameters in here that are like fully spelled out, expect, errors, seed, setup. But when it comes to actions, he decided to call it ACT. Even tear down is a longer word than action. So I don't know, but anyways, that is a parameter that we have to specify in here. And what this parameter looks like, it's if you go to the source code for block, you can see it gives you the block. Okay, so let's go in here and say, okay, we have the block, and let's also go in here and type the the generic parameters in here. So we say we have the persons block and a fetch result. We have the block. Now here we have a function. So how do we go and tell now the block to load some stuff? Okay, if you remember, block had a function called add. Is nothing that we added to the block itself. The block library always gives you an add function on your blocks. Okay, so this is coming from the block library itself. Now what we need to do is to send it some events, and we have the load persons action, if you remember. And we can see in here, if I put some commas to get the code formatting a little bit better, great stuff. So here for the URL, we actually don't care about the URL in our mocked tests. So in here, you could just say dummy URL1. Okay, so it doesn't really matter because our loader, which is our mock loader up here, completely ignores the URL, and it always returns the mock persons one iterable. So let's go in here for the loader. For the first loader, we're going to take mock get persons one. Okay, let's chuck it in there just like that. And then we say this is a constant. All right, so great stuff. So now we're loading persons one. And what we're going to do is to actually retrieve the persons one more time. And the whole point of this exercise is if you copy and paste this event and send it twice to your block, what you're doing, what you're expecting the block to do is to the first time send you the same mocked persons one iterable back, and for the first result to have caching as false, meaning that the block hadn't cached these values given that URL. Remember, this URL is going to be used for caching purposes, dummy URL1, right? So the block is going to cache the mocked persons with that URL. And the next time you send the same action, then the block is going to look this URL up in its cache. Let's go to the block so I can show you that code. So you see here, the cache. So it looks at the URL and says, oh, I already have this URL cached. Then it goes ahead and retrieves the persons from the cache using that URL. So whatever URL you pass in here, you kind of also have to pass it in here. So for caching in the block to actually work. All right. Okay, great stuff. Now that we're sending these values, we're going to go ahead to actually write the testing of this. So now that we've put the actions in here, let's see where that actions actually ends. It ends here, I can see. We need to expect some stuff. So we sent 2 actions. Now we have to expect 2 results from our block. So that's done with expecting here. And it's a function that needs to return an array. Okay, so this array needs to be an array of the results of this block, which in this case is a fetch result. Okay, so we expect by sending this first event, by sending this first action to the block, we expect a fetch result that looks like this. Its persons should be mock persons 1, and its retrieved from cache should be false, right? Just like that, and we say const. Perfect. So now that we have that, we say, okay, we expect first of all for this result to be sent, and then we expect the same result to be sent, but this time caching should be true, meaning that the first one was basically there was no cache for the first one. After sending that event to the block should have cached the first result, and given the same URL, it should give us back cached response, meaning that the first time caching is false and the second time caching is true. Okay. All right, great stuff. I think we can put a comment here as well to get the formatting a little bit nicer. And that's really the second test that we added, okay? So what we need to do now is to, now that we've added the first mocks in here, basically expecting mock persons 1, what we're going to do is to copy this same thing and now start loading with this mock get persons 2. Okay, so I'm going to go ahead and copy this code that we wrote in here from here, block test mock retrieving persons from first iterable. I'm going to copy that code. Let's go here. And up until this, I believe, where is it here? And let's go ahead and do mocking for the second one. So I'm actually going to copy even its comments in here. I think it's very important to copy the comments as well. Okay, so let's go ahead and paste it in here. And this time, let's go say fetch mock data persons 2 and compare it with fetch results. And then in here, we're saying mock retrieving persons from second iterable. And then we say here, dummy URL 2. Remember, this is only used for caching purposes. And don't forget to change the loader as well to mock get persons 2 in here, like that. Because get persons 2 returns, if you remember, the mocked persons 2 from our binary mock persons 2. Great stuff. Now that we have that, don't forget to go and change the expectations as well. So you're expecting mock persons 2 to be returned from here. And that's really it. So now that we've written our tests, it's time to go ahead and run these. And one thing that you may run into is if you read the documentation, for instance, for Bloc, which you should, if you're trying to learn Bloc, I highly recommend that you even have Bloc's documentations open on the side so you can have a look at, compare the things that I'm telling you with what the documentation says, and also complete what I'm telling you with what the documentation says. So if you look at that, when you go to the testing part, it tells you to run your tests with another command that compared to what I'm telling you now. And if you run that command, which is in the documentation, you most probably will run into a lot of errors. And the reason behind that is that the person who's written the documentation for Bloc didn't really write it for Flutter testing. They've written it for Dart testing. So they ask you basically to do some Dart testing. And if you do that, you will run into a lot of problems with linking of this test target with material libraries. So you're going to run into a lot of issues. So what you need to do now is to go ahead and follow the instructions that I'm going to give you here. So let's go and go to the terminal in here. Now that we're almost ready with this, we're going to have to go and run our tests with Flutter test. And it is not that, I mean, if you look at the documentation for Bloc, you'll see that it states that you need to run your test with Flutter pub run test. However, the persons who've written the documentation for Bloc testing, they thought that they're writing it for a generic type of like Dart Bloc tests, because you can also have a Dart project, not necessarily a Flutter project, and have Bloc in your Dart project and have your Bloc tests as well in a pure Dart project, not Flutter. And for that, you need to run your Dart tests, as I've mentioned here, Flutter pub run tests. So, but if you're running tests for Flutter application and Bloc, then you need to run your tests with Flutter test. It's very important. Otherwise, you'll get a lot of errors. So let's go ahead in here and say Flutter test. You'll see that we will have 3 passing tests in here. However, I've kind of hidden a little bit of a problem in our tests, and I just wanted to demonstrate that simply because you have tests in your application, it doesn't necessarily mean that you're testing the right things and that your tests are indeed adding value to your adding value to the quality of your application. So let's go ahead and here you can see that, for instance, we're saying that we're verifying the block state to be null. Okay, let's actually change this. Let's say that the block state shouldn't be null. And then we do know that the block state is in fact null to begin with. However, now we're saying that we're contradicting ourselves, saying that we think that the block state shouldn't be null. And then you run your test and you expect the test to fail, but in fact, they're not. The tests are still going to succeed, meaning that these tests, I mean, at least this particular test that I designed here isn't really testing the right thing. So you may be wondering, okay, but what is the problem? And the problem is this verify parameter in here. You can see that this is a dynamic function. So you can return whatever you want from here. So, but what we're returning from this parameter is a function that it itself returns true or false, because this is a true or false statement. However, simply because you're returning true or false doesn't mean that the block test function in itself is actually testing this true or false, and that is exactly the case. Whatever value you return from this verify isn't really going to be tested against anything. So what we need to do in here is actually expect the block state to be null. So this is in fact then going to run the expectation against the block state. So let's go ahead and see if we can run now this test. If I can see my keyboard, which is kind of like blocked behind my microphone. So let's say Flutter test. Okay. This is going to succeed, but just to demonstrate that now our expect statement's working as expected, let's go ahead and say that we expect the initial state to be a fetch result of an empty person in here, empty iTerminal person, and for this to be false, kind of like this. All right. So now if we run our tests, you'll see that they're going to fail simply because the initial state of the block is in fact being tested with expect. You can see it says actual is null,
and the expected result is what you specified in here. So let's go back, keep it as expecting here, and let's say that it should be null. All right. So what I really want to say in here is that simply because you have tests, it doesn't necessarily mean that they're testing the right thing. And also simply because you have tests, it doesn't mean that you've done your tests correctly. So I suggest that you go through these pieces of code that we've written for our tests and kind of have a look through them just to ensure that we've done things correctly and that we're testing everything that we were supposed to test. Okay. Now let's go ahead, as is tradition, we're going to go ahead and commit and tag this code that we have here. So we're going to say git add all and git commit, and let's say step 3. Okay, and we're going to tag it as step 3 as well. So if you look at our tags now, we have 3 tags in here, step 1, 2, 3. Okay, and the same with our commits as well. So we have step 3, 2, and 1. Fantastic. So with that, we're done with the third example in this chapter. Well then, great. Now that we're done with this third example, let's go ahead and focus on what we're going to do next. So in this example, we're going to create a more complex block, and we're going to create some sort of like a login system into our application, and then we're going to create a service that retrieves some notes. Let me show you how this actually is going to work. So let's say that this is our simulator, and I've already written the code for this, and that's why it is running right now in the simulator. So I'm just going to show you so that it becomes easier for you to understand what we're actually going to work on. A demo that has already been prepared for you. So here we have a login screen in the application we're going to develop, and in here you can write an email and a password. So if you write some text in here and press the login button, then you'll have an overlay that does a loading, and then here you can see it says login error. However, if you provide specifically foo@bar.com, and then for the password, if you say foobar, and I think foobar baz actually, if I'm not missing, or if it's maybe just foobar, like this, then you're going to be taken into a screen that displays some of the stored notes, for instance, for you. But what we're going to do in this application is we're literally faking all of this. So we're going to have a login service that will attempt to log you in with a dummy API. There are really no APIs in this application. We're not even hitting any backend for this application. And then we will have a notes service that is going to, given that you're logged into the application already, is going to retrieve some of your notes, for instance, for you. And these notes are also, they're objects, they're real objects in the application, like they're real classes. However, they're completely faked. So what we're going to learn in this example is how can we create a block that it has multiple states, like it's gonna hold on to a variable, knowing whether you're logged into the application or not, and it's also gonna allow you to fetch some notes given that you're already logged in. So it's going to be a little bit of a more complex example, and we're going to do some dependency injection in this block as well, so that it is not hard-coded which services the block is working on, since we're going to want to test this later. So let's go ahead and clean up the code that we've written so far. So as you can see at the bottom of the screen, let's go and delete all the tests first. So we're going to say just delete here. And we're going to delete the entire code that we've written for this block in here. So I'm just going to say delete the entire folder. And let's go to our main Dart file in here. And what I'm going to do is I'm just going to get rid of all these imports that aren't working anymore, just like that. And I'm going to bring our scaffold application in here. As you can see, materials already imported, so that's not a problem. We can just get rid of that. And as you can see, the rest of the application is just a void main run app, material app, and then as normal, we have our home page, which is a stateless widget. So nothing special really in here. So I'm going to just say select device, 13 Pro, which is my simulator in here. And I'm just going to run and compile and run the application so that it is ready for us to start adding our code. Great. So if you haven't already done this, please go ahead in your analysis options in here and require trailing commas. And in here, we can see that we need to add require trailing commas. Let's say true.
So this is just an analysis option that allows the Dart formatter and the Dart analyzer to give you warnings if you're missing any of your required trailing commas. And this is really good for formatting, to be honest with you. It's not a requirement, but it is just good practice. And if you enable it in your analysis options, then your Dart formatter is going to give you warnings if you're missing those trailing commas, okay? So what we're going to do in here, because in this application, as you saw, we have two text editing controllers, one for the username or the email address and the other one for the password. We're going to have to create some text editing controllers. And one of the videos in this Flutter state management course on YouTube, as you can see, I've talked about Flutter hooks. And Flutter hooks is, I mean, you could say it's kind of like a state management solution. It is going to make the creation of text editing controllers a lot easier for us. So if you're not familiar with Flutter hooks, I really suggest that you go ahead now and watch that particular video in this playlist. And there is a link at the bottom of this video in the description section that I've linked to the entire playlist. So if you click on that link and have a look at the video for Flutter hooks, then you should be able to watch through that, learn how Flutter hooks works, and then come back to this video. And for those of you who can't really be bothered going and learning about Flutter hooks, I'm going to do my best to explain what's happening in this example, because we're not heavily dependent on Flutter hooks. All we're doing in here really is just to use some text editing controllers, okay? So you could skip watching Flutter hooks, but for the curious, I really suggest that you go and watch that video first. Okay, so with that being said, let's go ahead and add Flutter hooks to our application here. So let's say Flutter pop add Flutter hooks like this. And this is going to bring in Flutter hooks into our pop spec YAML. So let me go ahead and open our pop spec YAML and have a look in here. And we can see Flutter hooks version 0.18.2 has been added to our application. Fantastic. So let's go ahead and start working on our models. And as you can see at the bottom of the screen, we need to create our models Dart file in here. So for that, we have the lib folder. Let's say we need a new file in here and we call it models Dart. Great stuff. So how this application is going to work is that we're going to have a login service, as you'll soon see, and it's just going to really mock logging into the application. But what this login service is then going to provide us is an object of that I'm calling in here a login handle. Imagine it's just a token. It's some sort of a string. Okay, it's just going to indicate whether the user has been logged into the application or not. And I just happen to have called it login handle. It can be anything else. It doesn't necessarily have to be called login handle, but in this application, we're calling it login handle. So it's just a token indicating whether a user has been logged in or not. And we're going to use this login handle in our block, telling the entire application whether the current user is logged in or not. Okay. So as you can see at the bottom of the screen, we're going to go ahead and create an immutable class in here. So let's say immutable class, login handle, just like this. And as you can see, immutable hasn't really been noticed in here as a valid modifier. So let's say import foundation, and we're going to say show immutable like that. Okay. Great stuff. So now we have the login handle. Let's go ahead and add some stuff in here. So what this login handle is really going to do is just going to create some sort of a token. All right. So let's just say a token final string token. And then let's go ahead and create a constructor for this guy and make it a constant and make this guy a required parameter. Okay. Just like that. And put a trailing comma in there as well. All right, now what we're going to do is, I mean, you don't know about this. I'm just going to explain it to you how this is going to work. And when we log into our application, then with that fake account that we have foo@bar.com with the password of foobar, then what we're going to do in here is we create the login handle, and then we, in our login service, the login service is actually going to check, oh, is the email foo@bar.com and is the password foobar? If it is going to create a new login handle and set the token to foobar. That's it, really. And then when the application is trying to load your notes, the notes service, which we're going to create, is going to have a look at the login handle, and it says as long as the login handle is equal to foobar, then I'm going to load that person's notes. Otherwise, I'm not going to load anything. So this foobar concept in this application is a little bit important, and we're going to build it into the login handle. So we're going to have a specific foobar login handle. All right, both the login service, both the block and our note service are going to use this particular login handle. Okay, so let's go ahead and say we have a new constructor in here, which is called login handle foobar, just like that. And in this case, we're going to say the token is foobar, just like this. Okay, it's not very important when you set it to. It's just an indication that, yeah, this is the foobar login handle. Okay. So since we're going to do some comparison in our node service later to determine whether you've logged in with that particular account or not, and to retrieve your notes based on that, let's go ahead and implement equality and hash code for login handles so that we can simply compare two instances of our login handle. So let's say we want to implement override bool operator equal covariant login handle author. Okay, so now we have to return a boolean indicating whether the current instance is equal to this incoming instance, which is this other instance here. Okay, so let's say in here we say as long as the token is equal to the other token, then these two instances are equal to each other. And here we're getting this issue about having no hash code. So let's go ahead and implement hash code in here as well. I've written a good post about this on my Twitter account and also on LinkedIn for those of you who are not so familiar with how come it is that we have to implement equality like this, or why is it that whenever we implement equality we also have to implement hash code. I've explained this in a lot of detail, so it's I think it's like a 1.5 pages long. So if you're not familiar with this, I really suggest that you go and follow me on Twitter or LinkedIn or both, whichever you're comfortable with, and have a look at my recent posts where I've actually explained this in full details. All right. And to be honest with you, I can actually also link to that post, perhaps at in the description section at the bottom of the screen. So let's go ahead and implement hash code. In here, we're simply just going to take our tokens, tokens hash code as return. Also, let's go ahead and implement toString in here, so that if you're logging out, if you're logging, for instance, an instance of this login handle to the debug console, we're going to see clearly exactly which login handle this is. All right. So let's say in here, we say this is a login handle like this, and we say token is equal to $token. All right. Great stuff. Seems like we're kind of done with the login handle. There's not much more to see in here. And that should really conclude the login handle part, at least. So what we're going to do next is to go ahead and work with our login errors. If I go back to this application that we had in here, if I manage to do a little bit of a hot restart, let's see in here. So let's say, actually, it's not that one, was it? Yes, it is. Let's go in here and say foo at bar.com and then an incorrect password. If I say login in here, you'll see that there's an error in here that says login error, invalid email password combination. Please try again with valid login credentials. So we need to somehow define an error, some sort of an object that some service is going to throw, and then we're going to catch that error and display an appropriate error message to the user. So let's go ahead as you can see at the bottom of the screen, create an enumeration that is going to hold on to all the possible errors that this application can throw. However, we're only going to have one error for this particular application, but still doesn't hurt to define it in a proper way. So let's say enum login errors, okay? And let's say in here we have invalid handle, just like that. And great. Now that we have our login errors with the invalid handle, it is time to actually go ahead and create a model object for the notes that we were displaying to the user. If you remember from the application when we logged in here, so if I say the password, let's say the password is foobar, as it is expected. if we go to the application, you'll see that there's 3 instances of something rendered to the screen, and these things are going to be represented in our application with a specific class that we're going to call note. Okay, so as you can see at the bottom of the screen, we're going to go ahead and create that. So let's just say immutable class. I just hope that nothing special was imported because I misspelled immutable, but that was fine. So immutable class note. Okay. And in this guy, we're just going to have a title. So final string title. I'm going to get Visual Studio Code to complete the constructor. And this is a constant constructor. Okay, just like this. And let's go ahead and make this a required parameter, as you can see in here. All right, great stuff. So now that we have that, let's go ahead and also create a toString, override the toString in here. So if you're logging something to the debug console, then you're going to see it clearly what this guy's actually doing. So they say that this is a note and title is equal to $title. All right, so that concludes the implementation of the note immutable class. So now that we have that, as you saw in the application, when you logged in successfully, then you had 3 nodes in here, and these are kind of mocked. So there's nothing stored anywhere in any type of like a remote server. So what we're going to do is to create these mock nodes as well, as you can see at the bottom of the screen. So let's use iterable to create this. So we're going to say mock nodes, and we're going to say iterable generate. Okay, so we're going to create 3 mock nodes in here. And we're going to then take this index provided by iterable generate. So when you say create 3 values, then it's going to go from 0, 1, 2, and it's going to pass those numbers to you in here. And then it's going to expect you to create an object based on that. So it's kind of like generating and also mapping at the same time. So let's say for this, we take a note and its title is going to be note $i+1. Okay, so I'm going to explain what happened in here. So let's say the first time around, iterable generate creates its first index, which is 0. 0 comes in here, and then iterable generate says, okay, for the 0 that I gave you, give me an object back, okay? And then we're saying, okay, I give you a note back whose title is 0 plus 1, which is 1, because we don't want to display note 0, note 1, note 2 in here. Instead, we want to say note 1, note 2, note 3, okay? So that's great. Now we have our mock notes, and if we hover our mouse over it, you can see it says iterable of note. Fantastic. We're going to create a few dialogues and overlays on the screen. We had this. If you go back to this application, if I get rid of it and then open it again, we have this foo@bar.com and then foobar. So you can see in here it says please wait, and then we have the please wait again. And if I kill it again and open the application and write something that doesn't work, it's going to display this thing in here. So we have a few strings to display in our application, and it kind of makes us to go and collect them in their own files so that they're not spread around everywhere in our application. And this is a good practice also if you're doing Flutter development also in any type of company, constellation, or if you're doing it for your own as well, is to have like your related strings kind of collected inside one file, hopefully, or at least somewhere that it's visually indicative of that they're like related to each other, so not spread around in multiple files that are not related to each other. That's what I'm trying to say. So let's go ahead and in here and create a file, and we're going to call it strings.dart. Okay. And our strings.dart, we're going to have a few strings in here. And I'm going to paste all these strings in here simply because this is really not going to contribute anything to your journey of learning about Bloc. It's very boring for us to go ahead and define constants in here. I'm sure you already know how to do that. So this is not going to be a huge surprise to you how we have a few constants and how we have some values in here. So if you want, go ahead and pause the video. I'm going to scroll around in here. I'm going to actually remove this title at the bottom. Pause the video in here if you want to, and go ahead and add these strings also to your project. So I'm going to bring the title back now that you don't have to, now that you were able to pause the video. So here's all the strings that we're going to display in our application, all collected inside one file. Okay. So now we're going to go ahead and create a testable API, a login API. As you saw, we're gonna have foo@bar.com and then foobar as the password, and then we're gonna pass this to some sort of an API and a fake API, and this API is gonna go ahead and like fake logging the user in as long as the credentials are foo@bar.com and the password's foobar. So let's go ahead and create this little guy in here. As you can see at the bottom of the screen, it's lib APIs login API. So I'm going to go ahead in here to lib and say new file, and we're going to say APIs/login API.dart. Okay, so we have the file ready now. So what we need in here is to create a login protocol for our login API. Let me just explain what this actually means. You see, the login API is going to be something like the concrete implementation of our login is going to reside in our application. So this particular login API that is implemented in our application is going to have some very like hard-coded logic in there. It's going to literally look for the email foo@bar.com, and then it's going to also look for the password of foobar, and then if that is the case, then it's going to allow you to log in and it's going to give you a login handle. So that's going to be the implementation of this login service inside, or this login API in our application. But wait a minute, if that is so hard coded to be foo@bar.com and foobar, how are we going to test that? And that is a very good question, because we can't really. The only thing we can do is just to test the hard codedness of that string. So when later we go and write some tests for this block that we're going to create, which uses the login API, we're really constrained to foo@bar.com and foobar as the password. But you can't then change that login credential without actually going and changing the code inside your application. So what we're going to do is to break that chain, break that hard codedness, and create a protocol, which is going to be kind of like an interface for any API that shadows as the login API. Then later in our block, when we create the block, we're not going to take the concrete implementation of this login protocol, but we're only going to take this interface of login API. That allows us then later in our block tests to pass a new login API that we inject into our block later during our testing. So I know it's a lot of big words. Don't worry about it. If this is making you a little bit nervous, I completely understand, but just know and focus on the fact right now that we are going to go ahead and create an interface for the login service or the login API. Any object that conforms to this interface is going to be a login service or a login API. Okay. So now that we have the file in there, we're going to go and create the actual protocol or the interface. Okay. So let's say immutable, if I can spell, immutable abstract class, login API protocol, and immutable is in foundation. So let's go and import that. So show immutable. Great, so this is the protocol. So what does this protocol actually contain? Let's go ahead and say that this protocol has a constant constructor. And the only thing important in this protocol or interface is really that it needs a future, it returns a future of login handle. And Visual Studio also imported login handle for me from here, as you can see, okay? We say it returns, ideally it returns a login handle, but it's optional because it may not. And the function inside this guy is actually, so this function takes two required parameters, excuse me, required string email. I have to drink some coffee, I think. I apologize for that. So let's just say required string password, okay? Now we have this function that says, okay, whoever wants to be a login API has to implement this particular function that has a required string email and a required string password. So it's very simple to understand. It has no concrete implementation right now, but we're going to go ahead and add that. Okay. So now is the time to actually implement a concrete implementation of this login API protocol, and we're going to call this guy just a login API. So let's go ahead and say an immutable class login API implements our login API protocol, just like this. And then we're going to get help from Visual Studio Code to create one missing override. All right. So I'm going to put a colon in there. Great stuff. So what we're going to do then in our application, this login API guy is going to just be is going to be a singleton. Okay, so we're going to go ahead and create a singleton out of this guy. So let's say a const. We have a constant here, login API, and share an instance. So this is like the initializer, kind of like a constructor. Okay. And then we're going to say static const login API, and we're going to call this shared. It is equal to login API that's shared instance like that. And then we're going to go ahead and say factory login API, and this is going to return our shared instance like this. Okay. So, and to be honest with you, this could also be called like instance or something. So this also works. So wherever you go and say login API.instance, then you're going to get this shared instance in here. So these three lines are really just to create your singleton. Okay, so in some other languages like Rust and Swift, creating singletons is a lot easier. Like if you have in Swift, you could just say struct login API, and you could just say static let shared is login API. And this in itself creates a shared instance for you, a singleton. So anywhere in your code, then you could say login API.shared, and that goes into your singleton. However, in Dart, it's a little bit more like rusty. I don't know how to say it. It's a little bit like tricky to create a shared instance, but this is the way to do it. So now our login API is a singleton. So let's just say a singleton pattern. Okay. Now we have a singleton in here, login API. And that part really is done. So, but we have to also handle the logging process. So how are we going to do this? So if you saw in the application, so if you go back in here, let me see if I can bring it up. If you have a look at foobar.com and say foobar, if you look here, it creates like a delay. So it's faking logging you in, because what would be really good is if this API could fake that is actually doing some API calls. If we did a login immediately, then you wouldn't be able to see any type of like a login overlay or anything like that. So what we're going to do in this implementation, we're going to start by saying this guy is an error function and it's a future delayed. And for the delay, we're going to say a const duration seconds 2. Okay. So that's that. And then what this future is going to create is we're going to say if the email is foo@bar.com and the password is equal to foobar. Okay. So let's see there. Okay. So this basically is creating a future Boolean at this point. Like if we created this as a function, now I know I'm changing a lot of code. I apologize for this. Let's go ahead in here and put the parentheses in here and say final foo is equal to this. This guy is going to be a future of bool. So what's happening in here really, let me go back, is this future delayed. Let's see where the parenthesis ends. So I myself am getting a little bit confusing here. Okay, so the parenthesis ends here in this particular case. So this is a future of bool simply because this future just waits 2 seconds and then calls this function, and whatever you return in this function will be the result of this future. So if you look at the signature of future delayed, you can see there's a parameter here called computation. And in here, if you return a t, then the entire future delayed will then be your future of t. You can see in here, the result is future t. So sometimes it really helps if you go into the source code for Flutter and Dart to actually see how these functions are implemented internally. Okay, so we have a future of bool now. So this Boolean will indicate if your credentials are correct according to our standards. Okay, so what do we do in here? Then we say, okay, we chain this with a then, and then we say is logged in. So what we want to say is if you're logged in, return a login handle of foobar, otherwise return null. So we say is logged in, return const login handle dot foobar, otherwise return null, just like that. All right. So, and I think let's see what's happening. Missing a required trailing comma. So let's put a trailing comma in here, and yeah,
that looks fine to me now. So now we've implemented the login function in here. So you can pause the video and have a look at it, but I'll explain it again. A 2 seconds delay produces a true or false based on your credentials. If it's foo@bar.com and the password's foobar, it produces true. Otherwise, it produces false. If the previous value was true, or if the generated value from future delayed was true, then we create a login handle foobar and return it from the login function. Otherwise, we return null. Okay, and that's why we're basically having this foobar in the login handle, if you remember from before. Okay, here. Okay, so in the same way that we created this login API with its protocol, we also need some sort of a notes API. So this notes API is going to be exactly like this login API in that it's going to have its own protocol, then it's going to have its own concrete implementation. And then we're going to go ahead and kind of do the same pattern in the notes API. So let's close this file and go to our APIs in here. As you can see at the bottom of the screen, we're going to go ahead and create a notes API. So notes API.dart. And in here, now that we've created it, we should go ahead and add our protocol. So let's go ahead and say immutable. You can see at the bottom of the screen, let me bring the caption. So let's say immutable class, abstract class. And this is going to be our notes API protocol, as you can see in here. Let's import immutable as well. Immutable, like this with double M, foundation, and then we say show immutable. Immutable, great stuff. Now that we have that, we need to define the actual protocol itself. So this is going to be a little bit different from the login API protocol because, well, this isn't really working with any login handles. But what's expected from any notes API implementation is for it to be able to return an iterable of notes. Okay, so let's go ahead first, create a constant constructor for this guy. Const like this, and then we're going to go ahead and say this guy should, anyone who implements this protocol or interface should return an iterable of note optionally, and then let's just call it get notes. All right, and this guy then accepts a required login handle, auto imported login handle like this. All right, so this isn't really any surprise in here. So all we're saying is that this interface expects anyone who's implementing it to be able to have a function called getNotes, which returns a future of optional iterable, meaning that if you say getNotes with an incorrect login handle, for instance, then this protocol or the concrete implementation of this protocol is free to return null, a future of null to you. All right, or a future of iterable of note optionally equal to null. Okay, that's a little bit more scientifically correct. Okay, now that we have the protocol, let's go ahead and create the concrete implementation for that guy. So since this is very similar to the login API, I'm going to copy paste it in here so that we don't have to type the same code in order to save some time. And then I'm going to explain to you what's happening in here. Okay, so you can see we created a Notes API, a concrete implementation, which implements the Notes API protocol in here. Then we said that, okay, we're implementing that required function called getNotes. Let's put a comma in here to get the formatting a little bit nicer. Then we're in the same way in our login API, we have a future delayed, which delays the computation by 2 seconds. And since we have a login handle coming into this function, we're saying if the login handle is equal to foobar, then return our mock notes. You see, mock notes we define in our models. Otherwise, return null. So it's very simple. It's really just comparing the login handle with foobar and making sure it is that one and returning mock notes. Otherwise, it's returning null. All right. So that's done. We're done with our services. So that's really good. Let's go ahead and start focusing on what I think is very juicy, and that's the block part. So let's go ahead, as you can see at the bottom of the screen, create our actions, which is lib block actions. So I'm going to create a new file in here, and let's just say block/actions.dart in here. Okay. So in these actions, let's go ahead. Let me bring the caption. As you remember from the previous examples, when we're working with Bloc and we're creating our actions or events, or the inputs to the block, it's always a good practice to create an immutable abstract class that defines the entirety of all the different actions that you can send to your block. And then you create concrete implementation of that abstract class to define your specific actions that are able to be constructed or initialized and sent to the block. So let's go ahead and say we have an immutable class in here, and it's an abstract class, and we're going to say app action. Okay, just like that. And let's import immutable. By this point, you should know how to do this. Immutable. All right, and let's create a constant constructor for this guy. Const like this. Okay, so we have two actions really in this application. If you remember, when we added foo@bar.com and then foobar as the password, then you could press the login button. That's one action. That's the login action. And also, after logging in, we're going to send a load notes action to our block. So we're going to say, hey, here's you haven't logged in before. Here's the first action, and the second action is I want you to load some notes. Okay, so let's go ahead and define the first action in here, which is our login action. So it's going to be an immutable class login action, and this also implements our app action in here. Okay. And so what does this login action actually need to contain? Well, from the UI perspective, when you press the login button, you should really think of these actions as things being sent from your UI to your block, at least in this application currently. Okay. So how do we do that? If you think of what the UI is expected to send to your block, really is so simple. It is just a username, or sorry, is the email and the password. So let's put those in here. Say final string email and then final string password. Okay. And let's get Visual Studio Code to complete the constructor for this guy. And then we're going to say this is a constant. And I like to put a comma in there. And then I'm going to say required. And let's put curly brackets in here and end the curly brackets right there. So now that we have our login action, basically, so it's as simple as that. It doesn't contain any kind of state or anything like that. It's just a pure struct kind of sent to our login to our app block, as we'll write it later. Okay, that's that. And then we're going to create an action in here. And this action is going to be for loading notes. So when we log in into the application, then after the login handle is received, then we're going to send another action to our block, which we're going to write soon. And then we're going to tell the block to, hey, start loading some notes. So let's create an immutable class in here, immutable class, and then we're going to call it load notes action, and this implements the app action as well. And the only thing this guy has is a const load notes action. So it's important now for you to have a look at this and kind of think about like the login handle in here. Okay, this guy, we understand. This guy just says, hey, go ahead and log the user in with these credentials. However, this load notes action, you can see that it doesn't contain any credentials. It doesn't really say, hey, go load the notes for this credential. What's going to happen is that our app block that we're going to write soon is going to internally contain the credentials. So as you'll soon see, when we talk about the states of the application, then this state is actually going to hold on to the login credentials. And if you then send a load notes action to the block, then the block is going to say, let me see if I have login handle in my state. And if I do, I'm going to go to the going to go to the note service and download the notes for that login handle. So it's all going to be like in three parts. So you have the inputs, actions, and then you have the state, which kind of is going to hold on to your login handle. And then you have the block, which is like delegating its tasks to these two things that are coming and then going out. So, but don't worry, this is all just a lot of abstract words I'm saying right now. We're going to have a look at all these things in detail. So as I mentioned, we're going to need an app state, which is going to kind of hold on to our login handle as well. So let's go ahead and create that. As you can see at the bottom of the screen, it's going to be in lit block app state. So new file. Sometimes I get this bug in Visual Studio Code, block, new file app state.dart. So what we need in here really is just to define one class that internally defines then our application state. So I'm going to go ahead in here and start defining our app state. So let's say immutable class app state. Okay. And let's go ahead and import immutable and say show immutable as I show you in here. So one of the things that our app state needs is a property to indicate to the user, to the UI, that the application is actually loading something at the moment. If we go back to the app here, and if I write anything in here and anything in here, and then say login, you can see that we have this little overlay in here, and then it displays a dialog. So we have this loading indication that we need to tell the UI that, hey, you're at the moment loading something. So display some sort of a loading indicator. So let's go ahead and say final bool is loading. Okay. So that's one of the properties of the app state, which the UI is going to be interested in knowing about. And if we have an error logging into the application, then we need to kind of tell the UI about that as well. Say, hey, we tried to load something, but now we got an error. So display this error to the user. So if you remember from our models, we had this error, login errors in here. As you can see, let's put a trailing comma in there as well. So what we are going to do is to define this guy in here and say final login errors. Okay, let's auto import that, optional, and we're going to say login error. Okay, so you can see it's an optional, meaning that the app state could optionally carry with it a valid instance of login errors. And if the app state does that, then it's the UI's responsibility to display an error to the user. All right, so that's why it is optional, because it doesn't necessarily have to contain any type of a login error. All right. And what we need to do is to carry with us also a login handle. So let's say we have a login handle optional. And I believe Visual Studio Code, yeah, it was in models. So we didn't have to import anything specifically yet. Login handle. Great stuff. So that's login handle in here, and it's optional as well because, well, yeah, the user could be logged out of the application or not logged in yet. That's why it's optional. And also, we're going to have an iterable of notes in here, optional, and we're going to say fetched notes. All right. So, I mean, the optionality of all these parameters, it does make sense if you think about it. You don't necessarily have to have an error. You don't necessarily have to be logged in, and you don't necessarily have to have any notes fetched yet, right? So that's why these three properties are optional. However, loading is a state that is black or white. It's true or false. So that's why it is here. A Boolean is loading optional won't make so much sense, right? So now that we have these, one of the things I really like to do is to go ahead and always create a toString implementation for my app state, so that if I sometimes am doing poor man debugging and I'm logging the app state to the console to see if it's correct or not, then I can actually get some valid data. So let's go ahead and implement toString. And when you have a lot of data like here, we have like 4 properties in here, and some of them could be optional. So what I like to do here is to create a map and then use the maps toString function. And this is going to create a beautiful dictionary of key and values for us, and we don't have to implement toString manually. So let me show you how I like to do that. So let's say the properties are the keys, so is loading, and then the properties value themselves are the values of these keys. So, and then in here we say login handle is login error, and then we say this login handle is the actual value of login handle, and then fetch notes as the key. Fetched notes as the key has its value of fetch notes, and then we're going to say toString at the end. Okay, so that's the implementation of toString for our app state. So very, I mean, I would call it clever. I think it is a nice way of implementing toString for classes that have quite a lot of properties. We're getting all these errors in here because we don't have a constructor yet. So let's go ahead and create a constructor. I'm just going to say this is a constant constructor. And this is a trick I like to do. If I want to make all these properties required properties, what I usually like to do is to go ahead and do a trick in here and put a trailing comma after the last parameter, press Command S or Control S in Windows and Linux. Then I like to do multi-line editing in here and say required. So I add required to all of them at the same time, and then curly brackets. So that's the constructor for our app state. And also, if you remember when we talked, because we've already talked about block in the previous example as well, every block, when it's initialized, it has to have an state. So what is our state when, you could say, okay, we know the state of the application is app state, but is our block going to contain a null app state? Like when you start the application, is the app state null, really? In some way, you could say maybe it could be null, but in our application, we shouldn't null wouldn't make so much sense, except because we have these nullable properties in here, we could say an app state whose is loading is false and all the other properties are null is our null app state. So let's go ahead and create an app state that we're just going to call empty. Okay, so it's like the initial app state. So let's go ahead and create a constructor in here, and we're going to say const app state dot empty, and our job in here is to set the default properties in here. So let's say is loading is false, login error is null. We're going to say login handle is null, and also fetched notes is null. Okay, so that makes Visual Studio Code and Dart happy as well. So we're going to start with the app state.empty as our initial app state. With the app state ready, it is time to actually go and create our app block. And this is, for me at least, is like the most fun part of creating a block application, when you put the input and output of the block together into the app block itself. So this is where all the fun comes together, at least for me. Let's go ahead and here in our block folder, as let me bring it up, actually, the title at the bottom of the screen. Lib block and app block in here, say new file, and I got that bug again, new file. Let's see if I should say new file in here and then say app block.dart. So go ahead and please create that file as well. So what we're going to do is to go ahead and define our app block with two actions in here. So let's say in here we have a class app block, and this one extends a block. So let's see if you can auto import block in here. Great stuff. And if you remember from block, I love going into source code for packages, because then you can actually see how they're implemented. You don't have to go and look into Stack Overflow to see what you have to pass the block as generic parameters. It's really enough if you just go into its own source code. You can see it says the event and the state. Read this as input, output. So what do we have for events? We've defined them in here, actions, right? And so let's go in here, and then we say the events are app action. So these are the inputs, and I can see that this was imported automatically. And then the outputs were the app state. So app state also auto imported in here. We can see in here. All right. So let's close that. So then what we're going to do in here for our app block really is to, first of all, we're going to need two properties. Well, if you remember, our app block is going to use two particular services. One is that a login service, and the other one was the node service. But we're not going to bring in their concrete implementations. If you look at our APIs, the login API, this is the concrete implementation of this login API protocol. Instead, we're just going to bring in the interface, okay, so that we're not bound to any particular concrete implementation of those interfaces. So let's say final. And then we're going to say login API protocol, and this is going to be auto imported. So if you're using a text editor that doesn't have, or a code editor that doesn't have auto import, then you're going to have to import login API manually. So we have login API in here, and in the same way, we're going to bring in an abstract implementation, or sorry, an abstract class for our nodes API as well. So let's go ahead in here and say nodes API protocol, and we call it nodes API. Great stuff. So, and this is not so happy at the moment because we don't have a constructor. So I created a constructor in here. And sorry, this can't be a constant. So these two properties are required. So let's go ahead and say required in here. Okay, required like this. a colon, and then we're getting this little error in here because it says the super class doesn't have a 0 argument constructor. And that's completely correct, because by default in Dart, when you create a constructor like this, it's going to call the super class's default constructor with no arguments. But in this case, it's annoyed at us, saying that, well, I'm trying to do that, but Bloc class doesn't have a 0 argument constructor. Again, let's go to source code. Here's the constructor. It's super easy to find. You can see in here, it says Bloc, and then it says, well, I need an initial state. And remember, this is our app state. So do you remember app state empty? That's going to be our initial state. So let's call super and say the initial state of our app block is app state.empty. All right. So let's put a constant here as well. Perfect. So at least is not angry at us at the moment, though our app block really isn't doing anything. So it's not really implementing anything. It doesn't have any type of a logic in here. Okay. So let's go ahead and implement the first action. So if you go to app action in here, the first one is login action. So let's go ahead and open the curly braces here in our app blocks initializer or constructor. And let's go ahead, let's just go ahead and handle on login action. Okay, and then in here we had the event and emit, if you remember, okay, like this. So now the event is this login action, right? And the emit is, if you remember, we could emit a new state. So we could just say emit, and we could say app state, blah, blah. All right. So now that event came in, we need to start loading something. So we need to start going to our login API and say log the user in. But before we do that, we should actually tell the user interface that we've started loading something. And we can do that by modifying this particular property of is loading. All right. So let's say start loading. So let's emit a new app state in here to the UI or whoever is consuming this block and say, yes, we are loading. We have no errors at the moment. We don't have a login handle yet. And we also don't have any notes that we fetched yet. All right. So let's put a colon in there and emit this as a constant app state. So this is the first step into logging the user into our application by simply starting to load. Okay. So let's go ahead now and log the user in. If you remember the login process, like if we have a look at our login API, this returns a future, meaning that this is not synchronous at all. It is actually an asynchronous process. So for that, we should go ahead and turn this on login action to an async function. All right. Great stuff. So right after this emit, we're going to say log the user in. And then you'd be like, okay, but how do we log the user in? We don't have a concrete implementation of our login API. And we don't need a concrete implementation of login API, because if you remember in our constructor, we actually took in an instance of this login API protocol abstract class. Abstract classes cannot themselves be initialized or constructed in Dart. So whoever's using our app block, whoever's initializing our app block has to actually give us a valid instance of a concrete implementation of this login API protocol. So by simply referring to login API in our app block, we are sure to have access to a concrete implementation instance of this login API protocol. So let's go to our login API in here. So we're going to say final login handle is login await login API dot login. And then you'd be like, okay, but the username and the email and password are in the UI. How do we get them? Well, that's why we have this event in here. If you remember, the login action in itself includes the email and password, and it is the UI's responsibility to construct an instance of login action and send it to our block. So we're not talking with the UI in here, we're talking with the action in here, okay? So in here, the email comes from the action.email. I thought we had the action. Let's see here. Sorry, it's the event.email. And in here, we have the event.password. Okay, so you can see now login handle is going to be an optional login handle in here. Okay, So let's go ahead now. As soon as we get this login handle, we're going to say we emit a new app state. So I'm just going to copy this emit code so I don't have to type it manually again. And in here, we're going to say is loading is false. And then login error is going to be interesting, because how do we actually produce a login error? Because if you look at the implementation of our login API, it doesn't do any, it doesn't produce any errors. So what we're going to do in here, we're going to say if the login handle is not foobar, then that indicates an error. Otherwise, there is no errors. So let's go in here and say if the login handle is null, actually. So yeah, it means it's not foobar. Then we produce a login error, which is, actually we have to auto import this, I believe, invalid handle. Yeah. Otherwise, we produce null. Okay. And yeah, we can't have this as a constant in here. So that's for the login error. So as long as we got a valid login handle, then we have no problem, meaning that we produce a login error of null. If the login handle is null, however, then we say there is a login error of invalid handle. All right. Then we pass the login handle, which we received in here in the app state. And then we say, yeah, we just logged the user in and we have no fetched notes. All right. So that's that part. Now, right after handling the login action, we're going to go ahead and handle our load notes action. So let's just say on load notes action, and then we have event and emit in here, and then open the curly braces in here. And in the same way, I mean, when our user interface, it's telling our block that, hey, I understand I got the login handle, but now I want to load the notes for that login handle. So how do we do that? Again, the first thing that we have to tell our UI is that, hey, we are starting to load something. So let's go in here and say we emit the loading state. All right, so put it in here just like that. So we're just saying is loading. However, let's say that your block had previously logged the user in, meaning that your block had already had a login handle. All right, so it produced an app state in here with a valid login handle. All right, so that's the state of the block at the moment. Now you tell the block to load nodes. And if you look what we're emitting here, let's put a comment here as well. We're literally saying that we're starting to load, but all of a sudden, login handle is gone. So what happened in here? Well, yeah, we lost the login handle because we're just saying we're loading. We're not telling the application that we actually have a login handle. So this is a little bit of an intricacy that we have to be careful with, that when you're emitting new states in your app block or in your block generally, you need to make sure that you're not losing state. So let's in here in our login handle, go to our state and get its login handle. Okay, so login handle. So we're saying invalid const. Yeah, we have to get rid of this const as well. So we're saying we're producing or emitting a new app state whose is loading is true. The login error is null because yeah, we're loading now something. We have no fetch nodes, and we carry with us the previous login handle. So this state in here is this. It's no property that is defined in here, but it is the state that any block holds onto. So this is actually a property of the block class itself. You can see in here. Okay, so we're going to our current state and digging out the login handle and placing it in this newly emitted app state. All right, so that's the start loading. So let's get our login handle now. So let's say get the login handle in here. So we're going to say final login handle is state login handle. All right. And then we're going to say if this login handle is not equal to foobar, is not equal to const login handle dot foobar, then we're going to produce an error. Okay, so we're going to say, okay, if you're asking us to load the nodes for any login handle that is not foobar, then we're not going to be able to give you any fetched nodes. So let's go ahead and emit a new state in here. So I'm just going to say emit. Okay, and in the app state, then we're not loading anymore because remember, we're not producing kind of an error. The login error is going to be login errors invalid handle. And we're in here just going to say login handle. Okay, so have a look at this again. We're saying that invalid login handle cannot fetch notes. Okay, so if the login handle is not foobar, then we're saying, yeah, we're not loading anymore. Stop the loading process, produce an error, keep the login handle as it was, and then we have no notes to fetch. It kind of makes sense, right? And then in here, we could just return. So we don't have anything to do after this. However, if the login handle is foobar in here, then we're going to fetch some notes. All right. So let's go in here and say this is a valid login handle like that. And to be honest with you, we could actually remove this return as well, like this. So otherwise, what we could do, we could just say if login handle is not foobar, then do this and return, and then we could just remove the else. I mean, it kind of depends on how you like to think logically. This could make sense for some. It may not make sense for some other people. But in here, what we're basically doing is kind of like guarding ourselves. So we're saying as long as the login handle is not foobar, do this thing and then return. And anything else after this is for a valid login handle. So let's put a comment here and say we have a valid login handle and want to fetch notes. All right. How do we fetch notes now? In the same way that we did login with our login API, we have a dependency injection here for the notes API. So since notes loading is also an async process, so we're going to put async in load notes action in here. And then we're going to go ahead and say final notes is notes API in here. And then we're going to say get notes. And then the login handle we have as well in here. And what is it complaining about? It is saying, oh, because we haven't really checked, because login handle could be an optional in here, okay? So that's done, and we have to also say await and put a colon at the end. All right, now we have the notes. All we have to do really is to emit a new state. So after grabbing our notes from the notes API, we have to emit a new state in here. We're not loading anymore. We don't have any login errors in here, so we're just going to say null. And login handle is login handle, which we retrieved from here, as you can see. All right. And now we have fetch notes as well. So let's put notes in here, as you can see in there. So we shouldn't have any warnings or any problems in this file at the moment. So it's looking fine, to be honest with you. I don't think we have to modify anything, and we could just use it as it is. Okay, after the creation of our app block, we can go ahead and start implementing the generic dialog that I mentioned in the beginning of this example. If you remember, when we logged into the application from the example that I'd already prepared for you, then you could see that if you enter the incorrect login details or login credentials, then we received a little dialog on the screen. Now, this dialog, I've already created some code like that, and I made it very generic, meaning that it allows you to create a dialog whose result can be controlled by the outside or by the creator of that dialog. And you'll now, I mean, soon you'll see how we're going to implement this, because we're going to go and do it together. But what you need to know about this generic dialog is that we're not only going to use it in this example, but we're also going to use the same dialog in some coming examples, because we're going to have actually 8 examples in this chapter. So what we create now is in fact going to then be used in other examples in this chapter. And that's why it's so important that we put some time into it and learn actually how this generic dialog works. So let's go ahead and create the file for that. So I'm going to go ahead in here, as you can see at the bottom of the screen, we're going to create a file called generic-dialog.dart, and we're going to put it inside a folder called dialog. So let's just go ahead and lib in here and just right click on it and say new file. Then I'm going to say dialogs, generic dialog.dart. Okay. Great stuff. So what we're going to do in here is to create a function called show generic dialog. And we're going to use alert dialog for this generic dialog, but we're not going to hard code this alert to contain specific values or specific title
or any specific content or even buttons. So the purpose of this generic dialog should really be to display an alert dialog whose title, contents, and even buttons and the actions of those buttons or the values that those buttons return can be generic and configurable. So what we're going to do to start with is to go ahead and create some sort of a type definition for the options of this dialog. But now that I'm thinking about it, maybe it's actually better to first go ahead and create the type signature of this dialog. So I'm going to go ahead and do that. So let's just say future and T. What this really means is that a dialog, for instance, on Android can be dismissed without having to actually tap any of the buttons on the dialog. So you have this physical back button on Android that you can press and it kind of dismisses the dialog, meaning that the dialog itself won't really return anything. So the user doesn't necessarily have to tap any of the buttons on the dialog. That's what I'm trying to say. That's why this thing is returning an optional value, okay? Then we're gonna say show generic dialog in here. And for a generic dialog, we need 4 properties. So the first thing that this generic dialog really needs, this function for displaying a generic dialog needs, is a build context to display the dialog on. So let's say required build context, and let's just call this guy context. We're going to take in a title as a string. So let's say required string title, and then we're going to have a required string, if I can spell, of its content. All right. And now in here, we kind of want to be able to generate the options or the buttons for this particular dialog. So if you think about the buttons inside a dialog, what properties do they actually have? Usually, when we create these buttons, they're going to be text buttons, meaning that a text button has an onPressed and it also has a title. So let's say that for every button that this dialog should contain, we need a title, and also we need some sort of an onPressed action. But we don't really want to expose any like onPress as a function, because then that function could possibly do any side effects. What we want is to have some sort of a way to configure not only the number of text buttons, but we also want to configure every button's title plus that button's return value, meaning that if the user taps on that button, then what value should that button return for the dialog to be dismissed? So let's go ahead and do a type definition in here, as you'll soon see how we're going to do that. Let's say type def, and we're going to call this dialog option builder, okay, like this. And this is equal to, so let's make this generic, and this is actually equal to a map of string and an optional t, and it's a function. So let's see if it works like this. Great. So what we're basically saying in here is that the option builder is just a map whose keys are strings and its values are some sort of a value, which we don't actually know about. And the reason this is generic is that it will just plug and play right into this function, which is also using generics. So let's go ahead in here and just say required dialog option builder, and we're just going to say options builder. All right. And as you can see in here, it really plugged and played really well in here, simply because T is a parameter that is brought in here, and it will just plug into this, which also requires T, not just because the name is equal, but because it is actually generic. And we also have a generic function in here. Okay. Great stuff. So let's first build our options in here, because this, remember, this is a function that returns a map. So in order to get the map, we actually need to call that function. So let's go ahead and say final options. Options is equal to options builder. So we're calling that function. And if you look here, now this options is going to be a map of string and dynamic. All right. Because this is something that is dynamic, it's generic at the moment. We don't know what it is. Okay. Then what we're going to do is to actually say return show dialog, because this is actually going to display the dialog for us. The context is fine. All right. And then we have to work on the builder. So let's see if Visual Studio Code can help us with the builder. It can't, and the builder is a context in here. And what we need to do is to return an alert dialog in here. Okay, so let's go ahead and say we return an alert dialog. Okay, just like that. And the alert dialog has a few properties. It has, for instance, a title. So we have the title as a string right there. Let's just plug it in. So we're going to say title is title. Okay. Or sorry, it needs to be actually a text of that title, because this title that we're taking in as a parameter is a string, but the title of an alert dialog has to be a text widget. Similarly, the content, it needs to be a text of the content. Remember, we're taking in content as a string as well. That's great. Now we have the content. And now my favorite part, which is the actions of that dialog. So what should happen, or what actions do we actually need to display to the user? So in here, we have our options, and we know that every key in this options map is in fact the title of an action. So let's go ahead in here and let's just say that the options, or sorry, our actions are going to be the options. Let's take their keys. Okay, so we take the keys, which are the titles of every button, and then we map that. So we say that in here, option title. Okay, and we have a function then in here. Great. So, and then we have to make this to list at the end, I believe. So let's see, here's the map, and then we say to list. Okay, what we need to do in this map then is to create instances of text button and return those text buttons so that they go into the actions iterable. Okay, so let's go in here and say first final, and our value, I mean the value that the button has to return, and in order to complete this dialog, in order to dismiss this dialog, and the value would be inside our options, and we use the option title as the key. Okay, so that we get the value. And now you can see this value is actually dynamic because it's a generic value at the moment. All right, then what we'll do, we say return a text button in here for every action. So return a text button. Okay, there are two properties that a text button has to contain. One is unpressed, like this, and then we say child. The child of the text button has to be like the text that we want to display for the button. So let's say we have a text in here, and the text itself needs to be the option title, right? Great stuff. So now you see all those errors are kind of disappearing. We just have one warning in here because we're not using the value. So what should this value be used for? We said that every button on that alert dialog needs to dismiss the dialog and return a value to the build context or to the presenter. And we have the value in here, which is pretty much the value of the map for that particular key. So let's go ahead in here and we just say if value is not null, okay, then we say navigator of context, and then we pop, okay, we pop with the value. Otherwise, we say navigator of context, then we just pop it. Okay, so basically what we're saying in here, since this option builder said that for every key you don't necessarily have to provide a value, it could actually be null, then what we're saying in here, we're saying, okay, if it's not null, then actually return it to the build context or to the presenter. But if it is null, then just pop the current context. All right, great stuff. So that's really good. We have T in there, and then what this is basically complaining about is what we need to do in show dialog. We should actually say that we're using T in here, okay? And let's go ahead and use T in here as well. And I wonder actually if we should say an optional T in here. Yeah, this is probably better because sometimes we may not return a value, okay? Great stuff. So we have that now. We have our generic dialog, which we can put to use soon. So let me put a comma in here as well to get the formatting better. All right, so as you can see, there is a comma in here. Good stuff. That's our generic dialog. So we can move on to the next screen. So if we go back to the application that we created in here, if you remember this, if I press the login button, you can see that there's an overlay on the screen, and then there's a little loading indicator. Now, this guy in itself is a loading dialog, which I use in a lot of my Flutter projects, and it is for me, it's a very valuable piece of code that is so reusable that I can just throw it into any other project and it just works without problem because it has no dependencies to any third-party components. All it does, it covers the entire screen and then puts in a loading indicator and some text, and then you can dismiss it whenever you want. But also, one of its capabilities is that if it is already displayed on the screen and then you try to display it again, then it also works, meaning that it holds onto its own state and knows, oh, I'm already displayed on the screen. If you want me to be displayed again with, for instance, new text, all I'm going to do is I'm going to change my text. So what we need to do in here is to go ahead and create some sort of a loading screen and a loading screen controller, which holds on to the state of this loading screen. And normally I would just copy paste code in here, but I believe this piece of code is so important. And we're also going to use it, for instance, in the eighth example of this particular video. And we're kind of going to like drag and drop this piece of code into almost all of these projects that we're going to develop. So I think it's important that we put some time in it now and create a reusable code so that we can copy and paste it into our upcoming examples as well. All right. So let's go ahead and create the file, as you can see at the bottom of the screen. So we're going to go into libdialogs, and then we're going to create a loading screen controller. So let's say loading screen controller.dart. Okay. I'm going to open it up here as well, our loading screen controller. Okay. So, so let's go ahead in here in this loading screen controller and just create the definition for this controller, and you'll soon see how this actually works. So what this loading screen controller really is going to contain is, it is an object, but what it does is it internally contains two functions, or mainly two function pointers. So what this does is that we create this loading screen controller so that our loading screen itself can contain a copy of this loading screen controller. And if we've already displayed the loading screen to the user, then the loading screen is going to contain a copy of this loading screen controller. And that is the way that our loading screen will know that it is already displayed on the screen. And once this loading screen controller copy is obtained by our loading screen, then our loading screen is just going to say, aha, I'm displayed already on the screen. So what I'm going to do is I'm going to update my text. Or for instance, I'm going to now close the dialog if it's time to hide that dialog. So this loading screen controller is kind of like a token or a gateway into our loading screen for updating it or closing it. So with that said, let's go ahead and start developing this loading screen controller. So let's go ahead and do two type definitions first. I mean, to be honest with you, we don't really have to do type definitions, but what this loading screen controller is going to take as arguments are two functions. And I always find it easier if I define my functions before I actually use them. A lot of people go ahead and maybe just put the function definition right inside the parameters. I kind of prefer to do it this way just because I feel like it makes the code more reusable. It makes the code also a little bit more indicative of what the user or what the developer of this particular class, for instance, expects. So let's go ahead and do our type definitions in here. So let's say close loading screen is an actual function, which our loading screen then is going to be able to call if we, for instance, as programmers, as callers to the loading screen, tell the loading screen, hey, close the loading screen now or hide it. So let's go ahead in here and we say this is a function that just returns a Boolean to indicate, for instance, if it was successful or not. And then, so that's for the closing, but we're also going to have another function for updating the loading screen's text, for instance. Okay, so let's say update loading screen in here. And this guy is a Boolean function that also indicates whether the updating was successful or not. And then we're going to take a string here as the text to be updated on the loading screen. Okay. So let's create an immutable class in here and say immutable class loading screen controller. Okay. Controller, if I can spell it. Let's import immutable as well in here from foundation. So show immutable. Okay. So we have that immutable. Immutable like this. Now that we have these, let's go ahead and basically add the closing and also the updating in here as functions. So we're going to say final close loading screen, okay, and we're going to say close, and then we're going to have final update loading screen as update. Let's go ahead and then create the constructor for this guy. So we're going to say const constructor, and we're going to make both these parameters required named parameters, in fact, and put a comma there. We're done with the loading screen controller. And again, remember, the loading screen controller is not an actual controller that has any logic in it. It's really just a token. It is a token that will be returned by the loading screen component itself internally when we from outside call show or hide methods on it. So let me give you an example. Let's say that your loading screen is not displayed at the moment. Then you say loading screen show, and then you provide text to it. You say hello world. Then before you hide the loading screen, you say loading screen show, and this time you say goodbye world. Well, that's a little bit sad, but let's just say you say hello. Now, the loading screen internally is going to have a look at itself, and it's going to say, oh, I'm already displayed, and I have the text of hello world. So instead of hiding myself and showing myself again with new text, all I'm going to do is just to update my text. And the updating is then going to be done through this little guy, because the loading screen is going to contain internally an optional instance of this loading screen controller. When you show the loading screen the first time, the loading screen is then going to create an instance of loading screen controller internally and hold on to it. Then the next time you tell the loading screen to show, but with a different text, all that loading screen is going to do is just to call this update function internally on its loading screen controller instance, which it also holds internally. And this update function will then update the loading screen overlay. It is a little bit abstract. I'm completely aware of it, but this is a typical, this is a pattern that you should be familiar with, or you should become familiar with, because there's lots of places that this kind of pattern is used, even inside Flutter. So let's go ahead now that we've done the controller, let's go ahead and start implementing our loading screen, okay? So in the previous step, we actually forgot to create the loading screen file in the dialogues. So let's go ahead and do that right now. So inside dialogues, we're just going to click on dialogues and say new file, and then we're going to say loading screen.dart. Now is the time to actually implement our loading screen. It's not that difficult to implement our loading screen, to be honest with you. It just takes a little bit of a patience. All right. So let's go in here and say we have a class loading screen in here. Okay. And let's just go ahead and create a singleton for this guy. So we're just going to say loading screen dot underscore shared instance. So this is its internal constructor. And we're going to say static late final loading screen. Okay, just like this. And we're going to call this guy shared. And internally, this guy is going to call that function. And then we're going to have an instance, a shared instance. So let's just go ahead and say factory loading screen. And then we're going to call this guy, actually, we could just say loading screen dot instance or something, maybe. And this guy is going to return shared. Okay. Maybe something like this would be fine. I sometimes also do it like this, just so that whoever calls loading screen, they get an instance of the loading screen as a shared instance, but this is also fine. We can roll with this and see how it works, okay? So this is really our singleton pattern. All right. So we have a singleton loading screen, and the reason it is singleton is more a political kind of statement. A loading screen doesn't, I mean, there should absolutely be no way for you to be able to create another loading screen in your Flutter application, because loading screen is a loading screen. It can only be displayed on the screen one time. I mean, there can only be one instance of loading screen at any possible time in the duration of your application. So it is more a political statement that that it has anything to do with the internals of the loading screen, because even if you remove the singleton nature of a loading screen, it will still work, but you may run into a problem where you accidentally display two instances of your loading screen, and this is to prevent that particular issue. So let's go ahead and say loading screen controller in here, and this is an optional controller, so we're just going to say here is a controller. Okay, so the reason again for having this controller is that loading screen internally can manage its own state. All right, so what we need in here is to go ahead and first do the show overlay function of our loading screen, because it is the absolute most important part of the loading screen. So let's go ahead in here and create a function, and this guy really is just going to create a loading screen controller for us, and it is in fact going to also create the loading screen itself. All right, so not that only it's returning the controller, but it's also going to take care of creating the loading screen's UI. So let's say this function actually creates a loading screen controller, and we call it show overlay, just like this. All right, and it has two required parameters. So let's go ahead and say that it needs a build context. So let's say required build context, and we're going to call it context. And it also requires text. So let's say text in here. Okay. Well, it's not so happy because build context isn't available. So let's just say import material in here. And I'm just going to say, yeah, let's just import entire material, because we're going to use some overlay functionality from material, which is not then going to be available if we just say show build context. Okay, so let's import whole material package in here. Great stuff. It is not so happy about what we're doing in here because, yeah, the whole syntax is kind of broken. We're not returning anything. So what we're going to do in this show overlay really is just to create a stream controller of type string, and then anytime the updating of this loading screen controller is called, we're going to update this stream controller. So as I said, it is a little bit of like a mind shift to think about it this way, but it makes sense when we actually implement it. And the first component that we have to work on in here is our stream controller. So let's go ahead and add the stream controller in here. So I'm just going to say final text is a stream controller. Okay. And it is a stream controller of strings. So stream controller is a part of Dart async. So we have to import Dart async library in here. And now we're good to go on that front, at least. And then the first thing we're going to do is to make sure that this text guy in here, the stream controller, has actually the current text that this function is taking in as a parameter. So, and I think, yeah, let's put it there. Okay, the argument type stream controller can't be assigned to the parameter type string. Oh, yes. Well, we can't call both of these texts, so this is getting a little bit confusing here. So let's call this guy underscore text, just like that. Okay. So our stream controller to begin with then has text as its string to begin with. So let's go ahead and create some like 3 required things in here, or variables in here, that we need for our overlay. So if you haven't worked with overlays in Flutter, they're a little bit special in that overlays, they have their own like lifetime on the screen. Like widgets, they're kind of like in a widget hierarchy, but overlays are kind of like free souls. They kind of can float on top of everything, and they're not really part of like the widget tree in the sense that other widgets are. So they have their own lifetime, and they have kind of they're living a free life. So what we're going to do in here is to get our state, which is our overlay of context. And you'll see soon that this state, as you can see in here, is an overlay state object. And we're going to use this state to display this overlay on the screen basically soon. So we also need somehow to understand how big the screen is and how big we need to make our overlay. And we do that by our render object. So let's create a render box in here, and we're going to say context find render object as render box. Okay, so that's our render box. And again, these things are a little bit like outside the scope of this particular chapter because we're talking about state management here. So it is very important that we don't get sidetracked and go into like teaching Flutter, because this is going to then become like 40 hours long video. And I already have a Flutter course available for which is about 37 hours. So I've been through that. I know how long it can take to explain everything. So in here, we're going to use the render box to understand the sizing of our overlay. Let's just say that, okay? So let's just say final size is our render box dot size in here. So we got the size, okay? So let's in here say get the size. All right, just a little bit of a comment. And then what we're going to do is to actually create our overlay entry, which is going to be an overlay entry. Its name is kind of indicative of what it does. Is going to create our overlay on the screen, or it is actually just going to create our overlay, the thing that we're going to put on the screen. But then we're going to use overlay in here to actually display that overlay, as you'll soon see. Okay, so let's just say final overlay is an overlay entry in here. Okay, so we have that. Let's just go ahead and add the builder in here. You can see it's a function that should return a widget, and it takes a build context. So let's go in here and we say we get the context in there. Okay, so we have the builder. And there's no other parameters, to be honest with you here. So we just have to program the builder and we should be good to go in there. Okay. So for the builder, let's just go ahead and return a material component in here. Okay, material, just like that. And inside our material, we're just going to say color is colors black with alpha. And let's just say 150 in here. Okay. And really, this color is what is going to be covering the entire screen. Let's go back to our example in here. This is that black color. You see, it is containing, like it's covering the entire screen. And it has an alpha of 150 out of 255, I believe so. If you look at the documentation, 255. So it's kind of like half transparent, kind of. And it is the black color. You could just experiment with different colors in here if you want to, like green, yellow, whatever you want to. But this is like a typical color if you just go with black, because you can see it kind of like dims the screen. Okay, it's kind of typical of overlays or any dialogues to have the same behavior. And you can see in here, here's a dialogue. It has no, I mean, this is a system dialogue. It's a material dialogue. It is actually kind of like an overlay. Internally, you can see it has this kind of dark background. This is not our overlay, it's the system overlay. But our overlay, which is this one, blends in so nicely with that dialogue. You can see it kind of has the same alpha, has the same kind of dark background. You can see here is ours. Here is the systems. So I kind of recommend you go with something like this so that your overlay blends in well with material components. All right. And for the child, what we want in here, if you look in here, it's in the center. So we're going to go ahead and say child center. So we begin by that with that. Okay, so that's our child. And then in here, we're going to create a container. So let's say we return a container like that. And then we're going to create some constraints in here. So sorry, oh, not return container. And the center has a child, which is a container like this. All right. So this container is going to have some constraints. We're going to actually size this container, okay, so that it has some minimum width and maximum width, and also a max height, because we don't want this container to become so big. You can see at the moment, if you look here, it has this minimum width, you see, even though the text is very short, but the box is kind of like stretching itself a little bit more than the text actually requires. So that's the minimum width. And also it has a minimum height because we don't want it, sorry, it has a maximum height because we don't want it to be stretched like all the way. So let's go ahead and add these constraints in here. So I've already prepared these constraints. Let me just copy paste them so we can save a little bit of time at least. So these are constraints, okay? And I'm just going to paste them in here. You can have a look how they're implemented. You can see the maximum width of our
material component here for our overlay is the width of our render box, which is the entire screen in this case, times 0.8, meaning that the maximum width of our overlay is going to be, I mean, not the overlay itself, but the contents of the overlay, which is this part, is going to be 80% of the entire width of the screen, meaning that you will always have a little bit of a margin to the right and left, okay? The maximum height is going to be following the same rule, 80% of the entire height of the render box, which is our screen. And also there's a minimum width, which is half of the width of the render box, which is the screen. So if we didn't have this in here, and if you have very short text, then the contents of your overlay would be so little that it's just not so nice to look at. So these are that's why we have these constraints in here. So let's go ahead and add some decoration to this guy, and we say decoration, and this is a box decoration, okay? We add a color, and we say color is white, because if you remember this, you see this content, this container is white in its background. So that's what this color is for. And then we're going to add a border radius in here. So let's just say border radius, all right? And we're going to say border radius dot circular radius dot circular, if I can spell it. And let's just add a radius of 10 in here. Great stuff. Okay, missing required. Okay, so that's because we want the edges to be rounded, as you can see in here. Because you can see also material like alert dialogues. Do you see? They have rounded corners. I can make this bigger so you see. So we're kind of really trying to follow what the system look and feel is kind of. And I think 10 is a little bit too much as well, but we could go with 10 for now. You can change that value whenever you want to. Good. Now that we have that, let's go ahead and add the child to this container. And the child you can see in here is going to be a column, and we're going to add the contents of that. Actually, we're going to add the column itself into a single child scroll view. And the reason we're going to do that is our overlay is going to allow you to add as much text as you want. There is no limit to the text you can display in this overlay. However, if you remember our max height and max width, they kind of dictate how much real estate you have on the screen. So what if you actually add the entire lorem ipsum to this overlay? Should it not be able to display it? It could be an opinion based. Maybe you could just say, well, it's just excessive text. We don't have to take care of it. It's an edge case. But if you're creating like a reusable component, you shouldn't leave surprises to the color of your functions. So you should kind of like make sure that your overlay can accommodate any text that is provided by the user, and it can size itself correctly. This is how you would write good APIs, in my opinion, at least. So let's go for the child of the container. We are going to create here. We're just going to say we have some padding, and I'm kind of just going to paste the padding part because it's not that important. Okay, so here's the padding part. We have a padding of 16 inside that container in here, as you can see. Okay, so we have some padding on top as well, as you can see, and that's that. For the child of this padding, we're going to say single child scroll view. And this guy also needs a child in here. Okay, so let's put a comma in there. And for the child of this one, we're just going to say colon for now. All right, so this is our opportunity now to display the contents of our overlay. So this column then is going to have a main axis size, and it's going to be a main axis. Let's see if it can bring it in. Main axis size of minimum. And the reason behind it is that if you look in this example, you see this column isn't taking the entire screen. However, if you don't change this parameter to minimum, what column always tries to do then without that parameter being set to minimum is the column will always try to, in its main axis, which is the vertical axis, it will always try to take as much space as possible, not as much space as it needs, but only as much space as there is available on the entire screen. So
if you look then up the chain of the column, it's inside a scroll view, and the scroll view is inside a padding, and padding is inside a container, which is inside center, which is inside material. Material takes the entire screen. By default, that's what material does. So if you don't change this parameter in here to minimum, when you display your column, this white box is going to be super long vertically. It's just going to go all the way to the top of the screen and all the way to the bottom of the screen. So that's why we have this main axis size set to minimum in here. Okay. So let's go ahead and its main axis alignment as well, change that to center. Okay, so because the content of this always has to be in the center, you can see in here. Okay, it's not to the right or left, it's actually in the center. Then for its children, let's go in here and say for children, like this, we're going to add some sized box on top. All right, so I'm just going to copy paste the size box, and these 3 children, I'm going to copy paste them in the interest of saving time. So we have 10 points to the top of the container, and then we have a circular progress indicator in the middle here that is just rotating, and then we have another size box of 20, and this is to just create some spacing between the loading indicator, which is a circular progress indicator, and the text that we're going to display on the screen. Okay, great stuff. Now, how do we do that? I mean, if you remember, we can't really just go in here and say text of text. You may be like, yeah, this looks fine, but really it's not so fine, because this text, I mean, what is going to happen soon is, as you'll soon see, we have the stream controller in here, right? And the stream controller is really supposed to be used by our overlay so that it can update its text whenever we call this function with new text. All right, so let's go ahead in here and actually, instead of having text like this, let's go create a stream builder. So we're going to say stream builder like this. And let's just say stream builder. And we could just say this stream builder is actually a string like this. And its stream is text.stream like this. All right. And we need a builder, of course. And the builder of a stream builder takes a context and a snapshot like this. And then we should return a widget right here. Okay. So what we need then is to look at our snapshot and see if it has data. And if it doesn't, we're just return a container. So let's say if snapshot has data, then we're going to say return a text widget. And we're going to take the snapshot's data in here. And I think that should be fine, actually, snapshot data. And then we're going to add a text alignment, and we're going to say text alignment, text align center. Okay. And in here, we're just going to force unwrap that. Otherwise, we're just going to say return a container. So if you don't have any text, we're just going to return a container, and that's completely fine as well. Okay. Great stuff. Now that we have that, we have created our overlay entry in here. What we need to do is kind of insert that overlay on the screen. We need to display it to the user. So let's go ahead and say state.insert. And remember, we created that overlay state on top. Let's go and have a look at it. Here's our state overlay. It's an overlay state, okay? Now we're going to insert our overlay. So here's the overlay. This is how we insert it on the screen. But how do we do this now? I mean, how do we then go ahead and create this loading screen controller in here? So if we go ahead and say the return function of the return value of this function is it's called a loading screen controller. Loading screen controller, as you can see in here. Then we have to define 2 functions in here. One is for closing, and the other one is for updating. So in this guy, we can see in here, we need to return a function. And in this guy also, we need to return a function. So this is the text. All right. So how do we implement these functions? Whoever calls these functions is going to have full control over our overlay. So the first thing we need to do is to close this stream controller for our text. So that's the first step. Then we have access to our overlay in here. So we're gonna actually remove this overlay from the screen. Okay, so whoever tells our overlay to close, we have to do these things first, okay? And then we return true. So we say, yeah, we were successful. All right. In the case of updating, all we really need to do is just to say text
dot add text. So this is really, I mean, now you're probably getting why we had a stream controller, because we return a loading screen controller, and then in this controller we have the ability to call, close, and update. Okay, so this is great stuff. Now we have that functionality. Good. So that's for showing the overlay. Now let's go ahead and create the API for the outside world. And to be honest with you, we could actually make this function private, because no one from the outside should actually call this guy. So let's make it private. Okay, great stuff. Now that we have that, let's go. I said that we're going to do the closing thing first, but let's just do the showing thing first. Okay, so let's go in here and just say void show. And remember, this is for the outside world. Whoever wants to display our overlay is going to call this function, but we're going to internally call the show overlay function. All right. So this guy has two required properties, parameters. We're going to say required, and we're going to say build context. So we need the build context, and I'm going to say context, and let's just take then the string that needs to be displayed. So we're going to say required string, and we're going to call this guy text. All right. So just like that. Now, show doesn't need, I mean, it should not go to show overlay function if it already is displayed on the screen. How do we know that? How do we know that this overlay is actually displayed on the screen? Well, we're going to go to this controller guy. We're going to say if controller here, if controller update, let's see if, oh, we don't have it. If controller dot update, you see, this is an optional. If we can update with this text or false, then we were successful. You see, I mean, this may be a little bit of a mind bend for some, but this is like we're going to an optional controller if it exists and calling an update function on it. We know that update returns true if it was successful. However, what happens if controller doesn't exist? Well, then this guy is null. And that's why we have this operator in here saying that either take the left side, or if the left side is nil or null, take the right side. So if we have no controller, false is producing here. Okay, that means we don't actually come here. Okay, but if controller was available, update is going to be called on it, and we know that update always returns true when it's available. In here you can see, therefore we're going to return from our function. And to be honest with you, this is just like some big words to say that if we have an overlay, update it. Otherwise, okay, otherwise we're going to create a controller. So we're going to say controller is show overlay. So we're internally calling show overlay. Okay, so easy. So what you need to understand is that show overlay is going to be called only once until the overlay is removed. Okay, so if there is a controller from the previous step, then we're going to update the controller's text, and then it goes into this update function. So this function really is going to be called once at a time until the overlay is removed from the screen. And once that happens, then this controller is, as you can see in here, we're creating it. And then during hiding it, as we're going to soon create that function as well, we're going to nil this controller out, meaning that the next time we come into show, controller is going to be null, update is going to return null, false is going to be picked, and we will end up in the else statement. So let's go ahead and do the hide function. So let's just say void hide in here. Okay. When we do hide, we're going to say controller, if it's available, if we have a controller, then close the controller. And remember, in controller close, what we're going to do in here is just we're closing the text stream, and we're also removing the overlay from the screen. Great stuff. So that's for hiding. And we also have to null this guy out. So we're going to say this controller doesn't exist anymore. So simple. I mean, the whole like code may look a little bit cryptic, but if you go through it and really think about how the loading and showing and hiding and all that stuff is working, it will eventually make sense. I'm sure of that. Great stuff. So we have now our loading screen controller and loading screen, and we have our generic dialog. So we have like the building blocks of our application. We even have our block. That means we can start actually working with the UI of our application, okay? So let's go ahead and create this email text field. Do you remember this guy? You see it has a little bit of a custom logic in here in that it allows, let me see if I can make this simulator bigger. You see this character in here? So it has its own custom character for hiding the password that the user enters on the screen. And this is a widget that we're going to go and create now. So now that we know the password text field has to work this way, let's go ahead and create that in our application. So as you can see at the bottom of the screen, we're going to create a file called, here we're going to create the email text field, but soon we're going to create the password text field as well. I just explained the password text field a little bit earlier than I was supposed to, but that's kind of okay as well. Let's go ahead and create the libviews email text field. So let's go ahead and say new file. In lib, right click, and let's just say views email text field dot dart. All right. So we're going to now go ahead and program our email text field in here, and it's going to be a stateless widget. So I'm going to say stl flutter stateless widget, and let's just call it email text field. All right. We're getting all these errors in here. They look very scary, but simply is because we're not importing material right now. So let's go ahead and do that. We're importing material now. And our email text field is going to have a text editing controller, because it internally is not going to create a text editing controller. That's really not a good idea. But we're going to pass it a text editing controller so that we can then extract its text when we press the login button. All right. So let's go in here and say that we need a text editing controller. So final text editing controller, and we're going to call it email controller. Okay. Now let's go ahead and pass that in here. So we're going to say required. And I'm going to go here to my do not disturb as well. And let's just say this email controller. Okay, so we have the text editing controller being passed into our email text field. Then what we're going to create in here is to create a text field. As you can see in here, text field. The first parameter that we're going to pass to it is going to be the controller. So let's say controller is the text controller, I think we call it, or what do we call it in here? Email controller. So email controller. And then the keyboard type is going to be a text input type, and this is going to be email address. Kind of important to actually do that, because if your user is typing their email in here, it's very important that they have this @ sign in here. Otherwise, very boring process and lengthy process to go ahead in the symbols and then find the @ sign. So if you're creating a text field for users entering their email address, it's very important that you set the keyboard type as well to email address. Okay. So let's go ahead and say autocorrect as well should be set to false. And this I beg you to set to false, because having having autocorrect on an email field could be very frustrating for users, especially if they don't have, like, for instance, names or emails that conform to the current language. For instance, if I have an Iranian name and my phone's language is US, then autocorrect is always going to try to autocorrect my email address, which could be very frustrating for me. So, and let's go ahead and add a decoration in here. So what we're going to say is to say const input decoration. Okay. And in here, we need a hint. As you can see in here, if we go and remove this, then there is a little bit of a hint in here that says enter your email here. And we have that text already in strings file. Okay, and it says enter your email here. So let's go ahead and just add this in there. So we're going to say it is equal to enter your email here, and this file strings is going to be auto imported, as you can see in here. Great. I think we can also say show enter your email here. So we're not importing the entire strings file. We just need enter your email here as a symbol. Great stuff. That's for our email text field. So that part is done. Now we're going to go ahead and create a text field also for password. I'm going to close this file. Let's go to views and let's say new file, and let's then create password text field Dart, as you can see at the bottom of the screen. So that part is done. The creation of the file is done, at least, and we're going to go ahead and create the password text field, which is going to be very similar to our email text field. So I'm going to copy the entire email text field's contents, and I'm going to paste it inside password text field.dart file. Okay, let's go ahead and call this guy password text field. So I'm going to do refactoring in here. I'm going to say password text field, and that part is done as well. And then in here, we're going to say enter your password here. So this is the hint that we're importing, and then let's put it in here. Great stuff. So what we needed to do in here, the controller is fine. Then we're not changing the keyboard type. But instead of autocorrect setting to false, we're going to say obscure text is equal to true. And then we're going to say obscuring character, and I'm going to put a custom bullet point, kind of like obscuring text in here. Okay, you don't have to do this part. For me, it makes sense, and I know that bringing up the emoji like window is very easy on Mac, but it may not be as easy on Linux or Windows. I know when I'm using GNOME on my Ubuntu machine, it is kind of like difficult to bring the emoji window. I can bring it up in a text editor, but I can't bring it up in Visual Studio Code as easily. So you don't have to do this part. That's what I'm trying to say. So you can omit this and your application will work perfectly without a problem. Okay. So this part's also done. Let's go ahead and change this email controller's name as well to password controller. So I'm going to say password controller. Great stuff. Now we have our password text field with the password controller in here, and it's building itself as a text field. So that part's also done. So let's go ahead and what we need in here, as you can see in our application, when we log in with foo@bar.com, and then we go and enter like the correct password, which is foobar. If we log in with it, you will see that we will have a list of notes in here. So what we want to do is to create some sort of an extension that allows us to turn an iterable of notes into a list view. And you don't have to do this, but this is just something nice that we can add to our application so we can easily turn an iterable into a list view. Okay. So let's go ahead and create a new file in libviews iterable list view. Okay. So views, new file, iterable list view.dart. So iterable list view, what this guy is going to take is just going to take an iterable. And we're going to just create the iterable list view widget first, and then we're going to create an extension on iterable that can create an instance of this iterable list view for us. Okay, so let's say that this guy is a stateless widget, and we're going to call it iterable list view, and it can take any values in here as t. Okay, so let's import material as well. Let's see if we can import material. Great stuff. Excuse me. And then what we're going to do in here is to take an iterable. So we're going to say final iterable t, and this is our iterable, and let's take this as a parameter. So we're going to say required this iterable. So our job in the build function is to create a list view that goes through this iterable, and for every iterable inside this, it creates a list tile with the text of the list tile being equal to that object's toString value. So it turns any object to its string representation and displays it inside a list tile. So let's go ahead and say return in here, and we're going to say list view builder, and then we're going to say item, and we're going to say item count in here. It's equal to iterable length. Okay. And then let's go say item builder. And in here we have a context, and we also have an index. Okay, so like that. And we're gonna return a list tile in here, list tile, as you can see. Our list tile is gonna have a title equal to a text in here, as you can see. Okay, and the text of that, let's put some commas in here to get the formatting better. The text is going to be our item. So let's say iterable element at index of index, and we're going to call toString on it. Okay, so you can see now it's a very simple implementation of a widget. And then what we're going to do is to go ahead and create an extension on any iterable that can turn that iterable to a list view. So let's go ahead and say extension to list view. It can be T on iterable T. Okay. And let's say widget to list view in here. And then this is going to create an iterable list view. And its iterable is, in fact, this instance. All right. So anytime you have an iterable, even if it's an iterable integers, you can say to list view, and it just goes ahead and creates a list view for you. So it's very, very handy. This is actually one of my favorite extensions together with its iterable list view widget in Flutter, to be honest. Okay, what we need to do is to go ahead and create our little login button as well. Okay, so let's go ahead and take care of that. We have our login button, and this guy is going to have a callback, and it's also going to take in 2 text editing controllers. Okay, so let's save this file. And as you can see at the bottom of the screen, we're going to go ahead and create libviews login button. So on views, new file, login button .dart. Okay, and this guy is going to be a stateless widget, so STL in Visual Studio Code, and we're going to call this guy login button. We have some problems with this stateless widget because we haven't imported material, so let's do that now. Great stuff. And this guy is going to take, when you press this button, what we need to we need to pass 2 text editing controllers to this login button. And when this login button is tapped, what it's going to do is just going to grab the text of the email text field, and then it's going to grab the text of the password text field, and then it's going to pass that back to whoever created this login button. All right. So let's go ahead in here and create a type def, and we're going to say on login tapped. It is in fact a void function. Okay, and it passes 2 parameters to its callback. So it says email and string password. Okay, just like that. Great. So what this login button then needs to do is to accept a callback, which is on login tab, and it also needs to accept 2 text editing controllers, one for the email field and the other one for the password field. So let's go ahead and add those as requirements in here. So let's say final text editing controller, and this is going to be our email controller. Okay, I'm going to paste this in here and call it password controller as well. And we also need a callback. So let's say final on login tab, and we're going to call it on login tab, just like that. All right, let's take these in as formal parameters as well. So I'm going to put a little comma in here, and let's make all of these 3 parameters in here required parameters. So let's say required. Great stuff. So we have all these 3 parameters as required. Fantastic. So now that we have those, let's go ahead and build our widgets in here. So what this guy needs to do is it needs to be a text button. All right. And text button has to have a child and an onPressed. So let's just start with onPressed, and then we add a child in here as well. And the child is going to be a const text, and we need the login text. All right. So this is going to be auto imported from strings. If you look in here, we have strings auto imported. So let's say show login. And if you look at it, this button simply just says login, nothing more. Okay. Great stuff. So that's the child, but we haven't really done the onPressed part. So the onPressed part, what it's going to do is, if you look in here, if we forget, for instance, let me kill this application and bring it back up. If you don't enter anything in here, when you press this button, what it's going to do, as you can see, it says, please fill in both email and password fields. And then it displays some information in the dialog as well. So we have this dialog. So what we need to do in here is to have a look at the text inside the email controller and the password controller. And if any of those is empty, then we're going to display a generic dialog to the user. Okay, so let's go ahead and say final. Email is email controller.text, and then we're going to say password is password controller.text, and we're going to say if email is empty or password is empty, password is empty, then we're going to display a generic dialog to the user. So we're going to say show generic dialog. That's going to be auto imported. The context is already there. And for these parameters, let's go ahead and say title show generic dialog. And this is a generic dialog, a Boolean. Okay. And we have a few things in here. Oh, this is going to our show generic dialog. I mean, it's using the materials show generic dialog, but we're not actually using this function. You see, this function is actually imported from widgets. We don't want this function. We actually want our own function. So let's say show generic dialog, which is this one. And you can see it's auto importing it now. So let's use that function. All right. And we're going to say this is a show generic dialog of Boolean. Okay. So to be honest with you, the bool part doesn't make any difference because we're not actually using the return value. Context is already available to us. The title of this guy is going to be email or password empty dialog title. And remember, this is defined inside our strings. So here, so let's remove this show login because we need more strings. And this is that title. You see it says, please fill in both email and password fields. Okay. The content of this guy is going to be very similar to this. Is not going to be title, but is actually going to be its description. Okay. And for options builder, remember, this guy is a function that needs to return a map of string and value. So we're going to say this is equal to this, and the title of the button is going to be OK. OK is something that we've defined in our strings. You see, it's a string, OK equal to OK, and it's inside strings.dart file. And its value is true, like that. Okay, so we have our options builder. And this function is async because it's a future. I mean, this function isn't actually async. It just returns a future, but we're not awaiting on that future because we don't need its result. We're just calling it, and we're just completely ignoring the result. Okay, great stuff. If that's not the case, if neither email or password are empty, we're going to say else in here. And then what we're going to do is to say on login tapped. And then we're going to send the email and password as parameters to the callback on login tapped. Great stuff. We're now done with this login button. So we don't have to do anything more, to be honest with it. So now that we have the login button, we have our block, pretty much everything's like in place we also have our loading overlay. Everything is ready for us to start actually implementing our login view. So let's go ahead and at least create that view first, and then we're going to do the implementation right after. So inside views, as you can see, we're going to go ahead and create a new view, and we're going to call it login view.dart. And inside this login view, then we're going to go and do the implementation of the login view itself. So in this login view, we have two text editing controllers. And when it comes to text editing controllers and many other things that are kind of like difficult to create and manage their life cycle because you have to dispose of them as well, I prefer to use Flutter hooks. And I think I mentioned this at the beginning of this chapter, but I usually use Flutter hooks like I blend in Flutter hooks in state management whenever I'm creating Flutter applications. So I have a video actually in the current playlist of Flutter state management playlist on YouTube, which you can have a look at. It's a few videos before this video, but I may change the ordering. But if you tap on the link at the bottom of the screen that I've linked to the entire playlist, there is a specific video that talks only about Flutter hooks. So I really suggest that you pause this video and watch that Flutter hooks video to get a better understanding of how Flutter hooks actually work. So with that said, if you look at our pop spec YAML as well, we've already imported Flutter hooks into our application, so we don't have to do anything special in here. We can just use it. So I'm going to go in here and just say we have a stateless widget. Actually, maybe we can create a stateless hook consumer. No, let's say we create a stateless widget, and we're going to call this guy login view. And let's import material so we get rid of all those errors. Okay. So let's then go ahead and create our hook widgets in here. Hook widget. Okay, so we have our hook widget, and let's then import Flutter hooks in here. Great stuff. So what we need on this login view really is to go ahead and create that login callback as well, because we know this login view is going to display the login button. And when the user presses this button, we actually need to take the user then, if everything is correct, with the login handle, we're going to take the user to the list of notes, for instance. Okay. So let's go ahead in here and say we have a final on login tabbed, which is going to be auto importing in here from login button. And we're going to call it on login tab, just like that. And let's bring it in as a required parameter as well. So let's say bring it here in the curly brackets. And we're going to make this required parameter. And then let's put a comment here to make the formatting a little bit nicer. Okay, now that this guy is a hook widget, it can use any of the Flutter hooks available in the Flutter hooks library or package. So let's create an email text editing controller hook. We're going to say email controller is use text editing controller. And then we're going to copy paste this, and we're going to call this one password controller. Okay. So what we're going to do in here is to first say create, and we're going to return a column. Okay, and then I like to put it in some sort of a padding in here, just like that. And our column, if you look at the implementation, it's going to have a text field, and then a login button. And if you remember, we have two text fields, one the email text field and the password text field. So let's go ahead and say email text field. Sorry, this is going to be inside children like this. Email text field is going to be auto imported now, and its email controller is actually this email controller. Then we're going to have a password text field. So password text field auto imported, and its password controller is in fact password controller as well. So they plug and play very nicely. Okay. So we have these two properties. Then we're going to have a login button. So login button is also going to be auto imported, and things just plug and play nicely. You see, we don't even have to type anything. All the parameters are already there. So because the email controller and password controller are already there, and on login tab is also there as a parameter to this widget. Great stuff. So now that that is done, we have to go ahead and put things together. So we have our login view, but what we're going to do now is to go and put it all together and display the login view if the user is not logged in, and then we're going to display the notes if the user is logged in. All right. So let's close the login view, and then we're going to go into our main Dart file and put things together. So let's go ahead and just say main Dart, and then we're going to start implementing our main Dart file to put the whole thing together. To be honest, this is actually my favorite part of the entire example, because we've been now working with so much abstract stuff. We've been working with stuff that we haven't even seen displayed on the screen, but now we're going to put it all inside one implementation and bring it together. So let's start doing that. If we look at our application in the main file, we have the material app, and then we have our home page in here, and that's completely fine. But what we need to do in here, instead of returning a scaffold inside build, what we're going to do is to wrap that whole thing inside a block provider. Okay, so let's go ahead and wrap it with block provider. So now we have a block provider in here, and you can see it says create, and then we have the context in here. So let's go ahead and create our app block. Okay. So app block needs to then be imported. I'm going to import it right there. So we have no problem with that. And let's say block provider. And as you can see, block provider needs a generic object in here, but it's going to be derived from this app block. So we don't have to put any parameters in here, any generic parameters. App block, if you remember correctly, it needs two instances, one for the login API and the other one for notes API. So let's say login API is actually an instance of login API, because we have a concrete implementation of login API, and let's auto import that in here as well. And it says it doesn't have a unnamed constructor. So let's go to our login API and see what we've done. If you can find it, login API. And we can see that we have an instance in here. So instead of saying login API in here, let's just say instance, okay? And then let's go to our notes API as well. So we have notes API. Let's say notes API.instance as well, but it doesn't seem like we can. Let's just import notes API, and let's see if we have something similar. which we don't. So let's go to our Notes API in here. We can see that we actually don't seem to really have anything. I mean, if you look at our login API, we have a singleton, but for Notes API, we don't seem to really have done something like this. So let's have a look at our Notes API. Maybe we could just generate an instance of this Notes API. So if we do this, so it seems like just login API has a singleton, and I'm, to be honest with you, not sure why this guy actually needs to have a singleton. And we may just be able to remove this. So let's just comment this guy out. We don't need it to be a singleton because it just has a simple function in here. Okay, so let's just remove that completely. And in here, we just create a login API just like normal. So we create an instance of it. Okay, so less singletons, the better. Great stuff. Now that we have those instances, in the child of this block provider, at the moment, we're returning a scaffold, and that's completely fine. But what we're going to do in here, we're going to say the text is actually the home page text. And this is a string inside our strings file. Let's have a look at it. If we've auto imported it, you can see in here, because home page is a string at the bottom of the strings file that just says home page, so that we don't have any hard-coded strings inside our scaffold. Okay. Now that we have that, the body of this guy is going to now be a block consumer. Now, what the block consumer does is that it combines two very important aspects of block library inside your application, and Flutter Bloc actually. A consumer is both a builder and a listener. So, I mean, we need to think about why we need a consumer. If you remember from the application, if we have a look here, when you enter something in here, this guy has the ability to display texts to the user. So it means it is actually doing side effects. So by pressing this button, the widget on the screen isn't changing. The widget is still login view. However, there is an error produced by our block. So if we go to our app block, which is in here, do you remember that it has an app state? And an app state can actually have a login error. Okay, so this login error could be an invalid handle, for instance. So what we're going to do in here is, if we go back to our main Dart, we're going to use a block consumer, which can have side effects in form of a listener, and it can also display stuff on the screen as the main widget, which is the builder part. So let's go ahead in here as the body of scaffold. Let's say that we have a block consumer, which has our app block, and then it also has the app state in here. Okay, so it's not so happy because block consumer is not known yet. I think the type can't be assigned. Okay, but that's fine. So then we're going to go in here and open parentheses right there. So we have a listener. Let's see if we can add the listener parameter in here, listener, and it has the context and the state, okay, which is our app block. And then we're going to have also a builder in here. So let's go ahead and add builder, right? And our builder also text context and app state like this. And then let's just return container for now from this guy, okay, so that we don't have so many problems. And in here, let's call this function also app state. So it's not so happy because app state is not a known parameter. So let's import app state. So have a look at this. What is going to happen inside listener is that we're going to issue side effects such as displaying our loading screen, which is the overlay. But the builder is going to dictate what needs to be displayed on the screen inside the widget tree, such as our login view or the list view. So they're two completely separate things. This is a side effect part, and this is what is displayed as a widget in the widget tree. Okay, and our overlay, which is a loading screen, is not part of the widget tree. Great stuff. So inside the login consumer, now our task is to first take care of the loading screen. So let's say take care of loading screen, or just say loading screen. Also, I like short comments, okay? And what we're going to say if app state is loading, then go and say loading screen. It's going to be auto imported instance, and let's just say show, okay? So the context is going to be provided here, And then the text is just going to say, please wait, which is inside our strings file. All right, and a comma to get the formatting right. And you can see now how this API is so clean from the caller's perspective, because the caller doesn't have to hide or show or have a look at the state of the loading screen. All it's really doing is just saying, hey, loading screen, get the shared instance and show yourself. And loading screen internally inside the show function is going to be like, am I already displayed on the screen? If yes, update the text only. So it's, to me, this is just beautiful, to be honest with you. And then we go to the else statement, which means that the app state is not loading. Then we just say loading screen, loading screen dot instance dot hide. Okay. And you can see in here, hide is simply just optionally calling the close function on controller and then setting it to null. And if you call hide many times without having shown the loading screen, is not going to have any effects, because controller's already been set to null in the previous execution of the hide function, and then we're just setting it to null again. So it makes no, I mean, it's not a bad practice, to be honest with you. So and we now have to have a look at displaying errors. So display possible errors in app state. Just let's leave it as display possible errors. Okay. So we're going to say final, and we're going to say login error, and that is equal to app state dot login error, and we're going to say if login error is not null, then we're going to display that error to the user. So we're just going to say show generic dialog is auto imported. Yes, let's use that, and then put a comma in here to get the formatting correct in the application here. For the title, we're going to say login error dialog title, and that's inside our strings, and it's just going to say login error. Okay. For the content, we're just going to say login error dialog content. And if you have a look at it, it's this string. It says invalid email password combination. Okay. And for the options builder, it's a function. And for the title of the button, we're just going to say OK. And the value of this guy is just going to be true, just like that. Okay. So we're not going to wait on it because we don't have to. The dialog is just displayed. Okay. So we're going to go ahead in here as a side effect. We're going to say if we are logged in, but we have no fetched notes, fetch them now. All right, so here we're going to issue a side effect, and we're going to go to our app state and say, hey, app state, we know your state has changed and you got like a login handle, but if there are no fetched notes, then we're going to tell the block to actually go and fetch them. So we're going to say if app state is loading is false, and false, and these in separate lines, so it's a little bit cleaner. We're going to say app state login error is null, and then we're going to be saying app state login handle is equal to const login handle dot foobar. Okay, and our app state fetched notes is null. So this is literally saying that, yeah, we seem to have logged in. We have a login handle of foobar. We have no login errors. We're not loading anything at the moment, and we have no notes fetched. So here we have to fetch the notes. So let's say context dot read. So let's get our block in here. Okay, so we're going to say app block. Then we're going to add an event to this guy, and the event is going to be load next. What do we call it? Load notes action. All right. So you can pause the video and have a look in here. So all we're saying is that if we haven't fetched notes and we're logged in as foobar, then send this action to the app block and tell it to start loading. Okay. And that's that really for the listener part. And for the builder, what we're going to do in here is just we're going to say final notes is app state fetched notes, and we're going to say if notes is null. If we don't have any notes yet, then we're going to display our login view. So let's say return login view in here. And when you tap on the login button, we get the email and the password. Do you remember this was a callback? Okay. And then else if the notes are not null, we're going to say return notes dot to list view. Okay, and let's import iTribble, which is this one, iTribble list view, which we created. So you see how beautiful this is. If we don't have any notes, it means that we haven't really fetched any notes. So we're just going to display the login view. And once this login button is tapped, then we're going to send an action to our block and say, hey, start logging the user in. So, however, if we do have notes, we're just going to display the notes as a list view, not the login view anymore. Okay. So in here, let's say context, context.read, and we're going to get our app block in here. And then we're going to add an event in here, okay, which is our login action. The login action takes the email and password, which are actually passed in here as the callback of our login button being tapped. So it just plugs in so beautifully. I mean, it's really nice. I don't know. To me, this looks really nice. So good stuff. And really, that's that for this example. I don't think we have so much more to have a look at. Let's just have a look at our problems as well and see if we have a lot of problems and we can clean them up. Let's remove these imports that are not used. And also we're importing Dart developer in here. So for you, the problem section in Visual Studio Code or Android Studio, I don't know which one you're using. It could be different. I don't even know if Android Studio has the problems section, but I always suggest that you go inside the problem section if you have it and find any possible issues with your code, which the Dart analyzer can find right before you, for instance, compile your application and fix those issues. So it's always good practice to do that and not let them pile up. Great stuff. Now that we have that, let's go ahead and run our application. I'm just going to do a select device in here, make sure it's running on iPhone Simulator, and then I'm just going to start the application so we can have a look at how it works. And since this is like the first run of our application, excuse me again, we may have made some mistakes. So let's keep our mind open for the possibility of bugs in our application, because we haven't really up to this point tested the application at all. So let's see how it goes, and then we can fix any possible issues that the application might have. So here the app is running. We can see the login screen appear in front of us. I'm going to close the widget inspector. Let's test the scenario that we try to log in with empty text fields in here. So we can see that the dialog is displayed correctly to the user, and then we dismiss it. Great stuff. Let's add some email but no password, and the dialog is still displayed. Let's add the incorrect email and password and then press the login button. You can see loading starts, and then it gives us a login error exactly as expected. But then we say foo@bar.com, and then for the password, we're going to say foobar, which is the correct password. It starts loading, and then it should start loading the notes, and then it displays the notes to us. So this was really it. This was for this example. And I really hope that you actually enjoyed this particular example, because there was a lot of code that we wrote, but also we're going to reuse a lot of this code later as well. All right. So this was the fourth example of this chapter. Let's go ahead and commit this code and also tag it as we usually do in all my example codes, basically. So let's say git status and git add all, and you could say git add all like this as well. And I'm going to commit this then as step 4. And let's just say git tag as step 4 as well. So if you look at our logs, then we have step 3 and 4. And if you look at our tags, we have 1, 2, 3, and 4. And that's really it for this particular example in this chapter. Now that we're done with this particular example in this chapter, it's time to go ahead and write some block tests. As I mentioned in the beginning of this chapter, we're not only going to be focusing on creating blocks and states and actions, but we're also, our goal should be to learn the block library or a package. And in order to be able to fulfill that goal, we shouldn't just learn about how to use it, but how to also test it. So we've written quite a lot of code. Let's go ahead and see if we can write some tests for them. Okay. But we need to first make some changes actually to our app state. If you go and open our app state and have a look at how it looks like right now. So I'm going to close this panel. Let's close the main Dart and let's go to our app state in here. and see how it is implemented. So if you look at our app state, we don't have at the moment any type of equality built into it. So you can see that we have is loading, login error, login handle, and also fetched notes. So equality for these things could be quite easy to implement, especially for these three properties in here. But for fetched notes, since it's an iterable, which means it is an unordered list kind of, or array, it could be a little bit more difficult. And the reason that we have to implement equality for app state is that so that we can write some tests for it. So if we, for instance, go and initialize an instance of our app block inside our tests, then we want to be able to expect certain app states coming out of that app block. And we're going to do that by implementing equality on app state, because that's what internally block tests are going to use in order to compare a given app state with an expected app state. So let's go ahead and implement equality on our app state. All right. But to be able to do that, we actually need to be able to compare two instances of iterable of anything, in this case note, with each other. But we need to do it in an unordered and in a deep manner, meaning that even if our iterable contains other iterables in itself as elements, it should be able to be compared with another iterable. So we saw in the beginning of this chapter that we implemented some like easy iterable with sets like comparison, but we're going to do it in another way this time, because we're going to do a deep comparison between two iterables. And in order to be able to do that, we need to use the collection package. So it isn't something that you have to add to your project with pub add. So what we're going to do in here, we're just going to say pub. Import, and we're going to say package, and then in here we have collection. So this is some header file that you can import into your application without having to actually import any third-party packages or libraries. Okay. In this collection, there is a deep comparison between iterables that we can use. Let's see if you can actually find it here. It's called equality.dart. And in this file, there is an example. Let's see if you can find the deep equality here. You can see it says deep equality on collections. All right. And then there is a file in here that says there is a class in here that is called deep collection equality. Okay. And this guy has a constructor called unordered. So, and then there is a function in here called equals. And you can see it takes in dynamic parameters in here. And then it tests whether it's a set or a map or it's a list or an iterable. So it is very thorough in that you can even compare two simple objects with each other, or you can compare two sets or two lists or iterables. So it does the comparison in an unordered and deep fashion. Unordered meaning that it doesn't care about the order of the items appearing in each iterable, for instance. So an iterable that contains two integers of 1 and 2 would be considered equal to another iterable of integers that contains the values 2 and 1, because the ordering doesn't matter. And also it will do a comparison deeply. It means that if you have an iterable whose elements are also iterables, it will go into each iterable in the first iterable and compare it with each iterable in the second iterable, and does a comparison in an unordered way between these iterables itself. So it's like recursive. It goes deep into every iterable, and it's inside each iterable's elements as well, if they are collections. So what we kind of need in here is to create an extension on object that allows us to do this kind of comparison. So let's go ahead and say extension in here, unordered equality on object. Okay. And then in here, we're going to say bool is equal to other. And this is also a dynamic parameter, so no data type in here. Okay. So then we're going to say const deep collection equality. And don't worry that Visual Studio Code or Android Studio is not going to give you some hints and autocomplete this. That's completely fine. They are in scope. And then we say unordered like this. And then we say equals. We're comparing this with the other. Okay. So this is going to give us the results that we're looking for. Now that we have this extension, it's actually time to go ahead and implement equality between this app state and any other app state. All right, so let's go in here and override the equality in here. So let's just say override. All right, override bool operator equal covariant app state like this, other. Okay, so now our responsibility is to go through every property of our app state and compare it with the other app state that is in here's properties. Okay, so the first property is loading. Let's go ahead and compare our is loading with the others is loading. So we're going to say is loading is equal to other is loading, and the other property is login error, and we're going to say login error should be the other login error. And also we're going to compare the login handle. So let's say login handle should be equal to other login handle. And last but not least in here, we're going to compare our here our iterable of note fetch notes in here. So let's go ahead and compare the two. So we're going to say, and our fetched notes, optionally compare that with, you see we're using our own extension function in here is equal to, and we're optionally invoking it because fetch notes to the left hand side can also be null. All right, we're comparing it with the others fetch notes, and otherwise we're taking the value of true in here. Okay, so if fetch notes, for instance, is null, then we're saying okay is equal to other one or true. But to be honest with you, now that I'm looking at the implementation of this, let's say our fetch notes is null, but the other fetch notes is not null. And the way this is going to work is that it's going to look at our fetch notes and it's like, oops, it's null. So it's not going to execute this command in here, and then it's going to take true. So this is kind of wrong, I would say. So this implementation won't work so well. Let's create this as a function in here, and let's say final other properties are equal, and then we set that to the result of this equation in here. So first we compare, first we compare all the three other properties except for our iterable. Once that is done, we're going to then say if fetched notes is null and the other fetched notes is also null, then we're just going to return other properties are equal. So in the case of our fetch notes being null and the other fetch notes also being null, what we're doing is that we're saying, okay, then we're only taking the equality of the other three properties into consideration. Otherwise, we're going to say return other properties are equal and this particular statement in here. So, and then we're going to take false as the default as well. Great stuff. And then, of course, we're going to remove this and remove all the code that we had in here. Fantastic. So have a look at this code. Now you can see that we have our three properties in here, and they're being compared correctly. And also we're checking for null values in here as well. Great stuff. So that's working fine. So this handling the fetch notes also being null on both sides. As you can see here, we're getting a warning because we haven't implemented hash code. So let's go ahead and do that now. So let's say create method hash code, and this is an override. And in here, we're going to use object. So we're going to say it returns object of hash. And then in here, we're going to enter all the four properties that we have. Okay, so let's say is loading. And then we're going to say login error, login handle. And then we also have fetched notes in here. Okay, so for hash code, the implementation is very simple. We're just taking object hash, which is going to calculate the hash of all these four properties for us. Okay, so that's great. Now we have equality in our app state, which is going to be very useful when we start implementing our tests. All right. So now that is done, let's go to the next step. I'm going to close this file and let's go to our tests file in here, and then let's see if you can find that. So lib. And then we have, I can see that it seems like we've actually completely removed the test folder. So we don't actually have any tests in here, or do we? We don't seem to have tests in here. So let's go ahead and create them. Okay. So let's go ahead and right click in here. I'm going to say new file, and then I'm going to say test / persons block test.dart. Okay. And then in here, Actually, no, we don't need this file anymore. I can see now at the bottom of the screen that we said we don't need this file because apparently we had this file before. So what we need here is instead say app block test. So let's rename this guy to app block test. Oops, I'm typing in an error window. Let's call this guy app block test, app block test. All right. I think I confused myself because I had to remove the test folder, and I don't know why I had done that. So we shouldn't remove the test folder. So now we're going to go into our app block test, and we're going to start writing our test. So there's going to be quite a lot of imports in here. Okay. So I'm not going to write all those imports because there are just so many. I'm going to copy paste them. And then in here, let's go ahead and fix this guy, testing block and underscore course. So have a look at this. We have immutable import. Then we have Flutter test and block test imported, and all the other imports are literally importing our actions, app block, login API, notes API, app state, etc., etc. So these imports are nothing like revolutionary. They're just expected imports that we're going to use inside our test. But I just think it's so much easier to copy paste them over. If you're a little bit confused about this, and if you want to go ahead and type these out yourself, if you're sitting at home or anywhere else following along with this course, go ahead and pause the video and then type these out in your editor so you have all the imports ready. Otherwise, you can also rely on Visual Studio Code to auto import these things for you when you start typing. Okay. Great stuff. Let's go ahead and define our mock notes. So in our application, our block, if you go back to our block in here, let's see if we can find it, lib, and then we have block in here, and then we have our app block in here. You can see that when we try to load our notes, it goes to the, let's see if we can find it here, login handle. Great. Load notes. Good. Login handle foobar. Then it says login handle, return, and then right here, it goes to our notes API and gets the notes. All right. So our plan for our tests is to create an actual mock login API and a notes API. And the mock notes API, what it's going to do is going to conform to this particular, let's actually see if we can find it. Let's go to our APIs in here, APIs. So in the notes API, you can see we have this notes API protocol in here. We're going to create a mock concrete implementation of this notes API protocol. And in there, we're going to return 3 mocked notes. And the reason that they're mocked notes is that we want to be able to then pass these notes to our notes, like mock notes API, and then expect the same notes back. So this is just a simple mocking technique, to be honest with you. So I've already done that mocking, so I'm going to just paste it in our note, in our tests file in here. You can see it's just an iterable of note with mock notes in there, note 1, 2, 3. Okay. Great stuff. Now, what we're going to do is to implement a mock notes API. So this mock notes API, as I mentioned, it's going to conform to our notes API protocol, but all it's going to do is just going to return some mock values, which are here, mock notes. Okay. However, if we have a look at our notes API, I'm going to open it again in here inside our API notes API. So let's just keep this guy open for now. If you look what the notes API is doing, it's comparing the given login handle inside this gets notes function. This one is comparing it with login handle foobar. That's problem number 1. This notes API has a direct connection with login handle foobar. It is returning foobar every time if the login handle, it's returning the mock notes if the login handle is foobar. That's problem number 1, making the notes API not testable or not as easily testable. The other problem is that should the login handle be correct according to the notes API, is always returning this constant in here, which is mock notes, which we've defined in our models. If you remember here, mock notes. So that's problem number 2, makes it not so testable. So what we're going to do is to basically fix that issue and create a mock notes API that is going to allow us to compare the login handle of its get notes function with a given login handle. So we pass it an acceptable or accepted login handle, and then inside the implementation of our mock get notes, we're going to compare the accepted or acceptable login handle with the given login handle. That makes our implementation inside the tests logic, it makes it a lot more testable. Okay. So let's go ahead and create an immutable class in here. I'm going to say immutable class dummy notes API. Excuse me. And this guy implements our notes API protocol. Okay. So we know that we have a missing concrete implementation in here. Excuse me. And that is completely fine. Let's go ahead first and implement the properties that this guy needs. So we're going to say final login handle, and this is an accepted login handle. Okay. And should we then compare the given login handle with the accepted login handle if everything is correct? Then we're going to return some notes, but we're also going to inject the notes that this guy has to return in the get notes function. We're going to inject those into its constructor. So let's go ahead and say final iterable of notes in here, optional, and we're going to say notes to return for accepted login handle. All right. So both those problems that we mentioned with our Notes API, the concrete implementation of Notes API into our applications bundle, are going to be fixed by implementing these two properties. So let's create a constructor in here, and I'm going to say these both properties are required named parameters here, required. Okay, and another required in here, and let's make this guy a const in here. Fantastic. So when we write our first test, as you'll soon see, we're going to create an empty version of this dummy notes API, because in the initial test, all we're going to want to do is to test the initial state of our block. Let's go to our app block in here. If we find it here, you see there is a state that we initialize our app block with, which is our app block is app state empty. Okay, so what we want is to be able to compare this app block's initial state with app state empty. And what we're going to do then is to pass like empty APIs to our app block. Because if you remember, our app block takes two parameters, a login API and notes API. But in the initial test only, it is not important what login API or notes API you pass to your app block. The only thing that's important is that we want to initialize an app block and then test its initial app state. So what goes in these two parameters is not that important. Therefore, we're going to go ahead and create an empty notes API that doesn't do anything really. It's just, it has empty parameters in here. Okay. So let's go ahead and say that in here, in our API, we have an empty state. I'm just going to copy and paste it so I don't have to type all of that again. So you can see here we have dummy notes API empty, and then its accepted login handle is foobar, and its notes to return are set to null. All right. Good. Now that we have that, let's go ahead and do this missing implementation here, which is get notes. And what we're going to do then is inside get notes, we're going to compare this login handle with the accepted login handle in here. If they match, then we're going to return the notes to return for accepted login handle. Otherwise, we're going to return null. Okay, so let's go ahead and say if login handle is equal to accepted login handle in here, then return notes to return. Otherwise, we're going to say return null. And let's make this function async so that we can return values just with the return statement. Okay, so this makes sense. It's just a get notes with a dummy implementation in here. Okay, great stuff. Now that we're done with the notes API, we have to do something similar, but this time for our login API. So I'm going to close this notes API in here. I'm going to close this, and then let's go to our login API. And you can see it conforms to the login API protocol in here. What we're going to do is create another concrete implementation of this login API protocol in here, but inside our test module. And this time we're going to give it two properties, an accepted email and an accepted password. And then in our concrete implementation, we're going to implement this login function, which we have to, because if we're implementing this login API protocol, we have to implement this function. And in that function declaration or implementation, we're going to compare the email and password with those two properties that I just mentioned, the accepted email and accepted password. Okay. This is really, to be honest with you, this is just a lot of talk for mocking things. So these things are not complicated. They're just lots of big words. Okay, don't worry about that. So let's go in here and start implementing our dummy login API. So we're going to say immutable. Dart UI, we don't need. Okay. Okay, let's go in here and then we say immutable class. And this guy is going to be our dummy login API. And this guy implements our login API protocol. Okay. Remember, we need two parameters in here, the accepted email and accepted password. So let's say final string, accepted email, and then an accepted password. Okay, and let's create a constant constructors for these guys, for this guy, and then we're going to say const, and colon in here. Let's make these both required parameters, and then put curly brackets in here. Great stuff. We're getting some resistance from Visual Studio Code simply because we haven't implemented that abstract function. So let's go ahead and say that create the missing override in here, and we have the login function in here. So what we really have to do inside this login is to say this is an async function. Then we're going to compare the incoming email and password with the accepted email and password. So we're just going to say if email is accepted email, and password is accepted password, then we're going to return login handle, login handle.foobar. Okay. Otherwise, we're going to say return null. Let's see what we're getting. A problem here is equal to like this. Excuse me. So this is nothing special. We're just comparing the incoming email and password, the accepted email and password. So there's another peculiarity with this code is that we are returning a login handle foobar every time if email and password are correct. Now, you could argue to say, I don't really like this. I kind of want to be able to control what login handle is actually returned from this. And I completely agree. You could go ahead and do that. You could just create a property in here and say login handle to return upon accepted email and password, something like that. I don't know if you want the property name to be that long, maybe not. You could just say login handle, and then upon the correct email and password, you could just return that. I'm not doing that in this example just to keep it clean, or maybe not necessarily clean. I'm just doing that to save some time and space. But if you want to go ahead and experiment with that, just add a property in here and to your initializer or constructor and return that login handle in here. And that will truly give you full control over the accepted email and password and which login handle to return if the email and password are correct according to this example. Excuse me. Great stuff. So what we're going to do now that we have our services ready, we're going to go and test the initial state of our block. And we're going to basically create some block tests in here inside our void main function. With that in mind, let's go ahead and add our void main function in our test suite here. So let's go ahead and just say void main in here so that we have an entry point into our tests. And I'm going to make the font a little bit bigger because we have quite a lot of real estate in here. So I'm also going to try to find basically the captions to bring up here because we're going to go ahead and start adding some contents to the screen. So what we're going to do in here is to use the verify function of the first block test. So let's go ahead and create a first block test in here. For the description, we're going to say initial state of the block should be app_state.empty. Maybe the font is a little bit too big in here, so I'm going to make it a little bit smaller. Okay. Great stuff. So that's our first block test. Inside the build, it is our responsibility to create our app block that is then going to be used inside our block test. So this build, it is a function which is going to be called by block test. And in here, our responsibility is to create an instance of app block. So let's just say that we create an app block. And for our login API, we don't really care what the login API is going to be, because remember, in the first test, we're just going to test the initial state of our block. And the initial state of our block isn't really dependent at all on neither the login API nor the notes API. So in here, what we're going to say is just to use the const of login API dot. Actually, we created our dummy login API in here, right? And then we said that it has an empty I believe, or we maybe didn't actually. Let's go to our dummy login API in here, and I can see that we didn't create an empty instance of this. So let's do that right now. So let's just say dummy login API.empty. Okay. And this is going to work very similar to the empty notes API, as you can see in here. It's just setting its properties to some default values. Okay. So the login API's default implementation for empty is going to be accepted email is just going to be an empty string, just sending it to any value basically. And then the accepted password is also going to be an empty value in here. So just like this. Okay. So now we have an empty dummy login API and make it a constant as well. Let's go back to our test in here, and let's go and say that we have a dummy login API of empty, all right, for the login API of our app block. And then for the notes API, we're also going to say const dummy notes API empty. All right, fantastic. So we've basically created the build. So what we want to test in here is the initial state of our block, which is our app block. And this is not going to go into the expectations, because remember, the expectations are only going to receive any state that the app block emits after it has been constructed. So it is not going to allow you to test the initial state of your app block. The way to do that is using your in here, let's see, because we're not sending any actions in here, we're going to just do verify. And verify is a simple function, and in here we're just going to do a simple expectation. So we're going to say expect, and we get the app block app state in here. So we're just going to say the app state dot state. Let's see if we can actually get that. We have to type these block tests. So we're saying that we're testing an app block in here and also the app state. Okay, so now it knows that the app state has a state property. We want the app state property to be equal to a const of app state dot empty. Okay, because that's really what our app block does. You can see by initializing an app block, then we're getting an app state empty in here. Okay, so let's go back to our tests and add a comma in here to make all of this happy as well. So then your first test should look like this, okay? And if you're curious, just like me, you want to see how this thing works or whether it works, you could just go ahead and initialize, and run Flutter test in your terminal window, and you should be able to see that your tests should hopefully pass, and that's just one test. Great. So the first test was successful. We didn't have an issue with this one. Let's go ahead then and work on the second test. So what we're going to do in here is to create another block test in here. And this time around, we're just going to create a proper dummy login API and give it some credentials. And then we're going to send a login action to our app block. And then we're going to expect a specific application state with that login handle. All right. So let's copy this piece of code in here, which we've written for the block test. Okay. And then I'm going to paste it in here. This time around, we're just going to say, can we log in with correct credentials? So can we log in with correct credentials? Okay. So in here, what we want to test is really just to give it some sort of hard-coded credentials to our dummy login API. And then later, when we do send the login action to our app block, we expect the same credentials to come out. All right. So let's go in here. Instead of an empty dummy login API, we're going to give it an accepted email. Let's just say bar@baz.com. And then the accepted password should be foo. Okay, so we're changing how the dummy login API actually works by injecting two specific values into it with the email and password. Great stuff. Now that we've done that, we're not going to have verify in here because we're not going to verify the initial state of the block. We've already done that in here, so we don't have to do that again. So let's remove the verify block from our second test. And what we're going to do in here, we're going to go ahead and implement ACT, which is right here, which is for action, okay? In action, we get the app block. And what we're going to do is to send a login action. So if we go to our block actions, or actions, I believe, you remember we have this login action. It expects an email and a password. So let's go in there and say now we send an action to our app block. We say add, and then we say login action in here. So let's go ahead and say const. Let's bring it to another line, const login action. Okay, and then we say the email and the passwords with some commas as well. The email, we're going to say bar@baz.com. So we're giving it an actual correct email and password to log in with, which is then going to be tested against our dummy login API. All right. Then for the password, we're also going to give it the correct password. Great stuff. Now we're sending the correct action. What we have to do is to do the expectation as well. So let's go ahead and add the expectation in here, which is expect. And this guy is a function that has to return an array or a list in here, okay, a list of expectations. So if you remember, when we go into our app block, by sending the login action, the first thing that our app block does is that it emits an app state that says I'm loading, and then it sets everything else to null. So let's just copy this exactly as it is and put it inside our expectations, just like that. So this is what we expect, okay? And since we're expecting to log in with the correct credentials in here with like bar@baz.com and foo, we don't expect our app block. Let's see. Let's go back to the app block. You can see it calls the login API, which in this case is our dummy login API. And then if everything's fine, then it's going to emit this particular state. So let's just copy that state and bring it into our expectations as well right here. Excuse me. So the login error, we expect it to be null, and we expect the login handle to actually be foobar. Because if you remember here inside our dummy login API in here, we said the accepted email and password are actually our parameters foobar, but the result is an actual login handle foobar. Okay, so what you could do, I mean, to be honest with you, to make this a little bit nicer, we could just go ahead in here and say login handle in our dummy login API and say handle to return. Okay, so we are injecting even that, so we're not hard coding anything into our dummy login API. Let's add this parameter in here as well, right there, and we make this required as well. Great stuff. And in here for the empty state, what we're going to do is we can see in here we have an empty. Okay, and let's just say the handle to return is just login handle dot foobar. Okay, for the empty state like this. And we can't have this as a constant anymore because foobar isn't const, or is it? Handle to return foobar, it is a const, but we can't have it invalid constant value. It is a little bit strange that we can't have it as a constant, even though it is a constant. So because if you put const in here, okay, this works. Maybe const here and const here is a little bit strange, but anyways. And then in here, instead of hard coding const login handle foobar, we could just say handle to return. Okay, so now we're not hard coding anything in our dummy API. And in here, we could just say, in the case of can we log in with correct credentials, we're going to say we expect a handle to be returned of login handle with a token of ABC. All right, so we expect a login handle to be returned with a token of ABC. Great stuff. And in here, we expect a login handle. We're going to say login handle with a token of, oh, you can't see the code, so I'm going to bring it up. So you can see login handle of ABC, just like that. Okay. Great. So we can't, let's see, this is also a constant, prefer const. So let's put this as a constant here as well. And then the fetch notes should be null. So really all we're doing in here is sending some data and getting some data. And we're just confirming that that data matches. Nothing special in here, okay? So app state, this upon the login API doing its job is checking against foobar baz. And we're sending bar@baz.com and then a password of foo. Everything matches what the login API expects, and the login API is going to say, okay, email and password match what was expected for me, and I'm just going to return this login handle of ABC. And here we're just checking against the login handle of ABC as well. So that's our second test. Let's go ahead and run it just to see whether it works correctly or not. Great stuff. So 2 tests have passed, and this is some good progress. So we could just make sure that this actually works by changing this token to ABCC as the expectation, and now our test should actually fail. So let's have a look and see if they fail. Yes, and they do. And we can see in here, the C is extra C that shouldn't be there. So it did a diff for us as well. So that's really good. Okay. Then what we're going to do is to try to log in with invalid credentials. All right. So let's copy this guy, this code that we've written for valid credentials, and just paste it down there. So we're going to say here, this entire code should be copied. And then I'm just going to paste it right here. Okay. So we say we should not be able to log in with invalid credentials. Okay, so let's say that the login API expects foo@bar.com and the password to be Baz, and it should return upon the correct logging in, it should return ABC as the login handle. However, for the email and password, we're going to send invalid values in there. So we're just going to say, instead, we're sending bar@baz.com and a password of foo. So this is not going to work. So in the case of trying to log in with invalid credentials, what do we expect from our app block? Yeah, it should first start loading. That's the first thing that we expect from it. However, as soon as it gets this action of login action with incorrect credentials, then it should produce an error. And the error should be a login error of invalid handle. And the login handle itself should actually be null, and there should be no fetched notes in here. Okay, so let's save that as well, so we don't expect any notes to be returned. So let's run our code now, run our tests. So let's say Flutter test. So to test the invalid state, basically. Great, all 3 tests pass. So that's fantastic. And the third note that we're going to do, which is, the third test that we're going to do, or is it the 4th test? I think it's actually the 4th test. Yes, it is. In this test, what we're going to do is to not only log in, but also log in with valid credentials. And we're going to send another action to our app block, which is the load notes here, load notes action. Okay. So let's go ahead and do that. So I'm going to copy the block test that we wrote in here. So I'm just going to copy that and paste it because it's just too much work to type this all again. And in its description, we're going to say load some notes with a valid login handle. Okay, so we're expecting foo@bar.com with the password of Baz, and then we're returning this token in here. And then for our login action, we're also going to say foo@bar.com with the password of Baz. Okay. That's really good. And then our dummy notes API in here, we're not going to do an empty variant of it this time. We're actually going to initialize it with proper data. And we're going to say the accepted login handle should be this login handle with a token of ABC. Okay. So we're going to put it there like that. And this can't be a constant anymore. And then the second parameter, which is the notes to return, are going to be these notes that we define in here, which is mock notes. So let's go ahead and put mock notes in here as well. Okay, and maybe this is a constant. All right, great stuff. So we're basically telling AppBlock that we're injecting you with a dummy login API, which has these credentials as acceptable and has this login handle. And then this guy has an acceptable login handle of ABC as well. And then in case the login handle is ABC, it's going to return mock notes. Okay, great. Now that we have that, right after logging in with foo, bar, and Baz, we're going to send another action in here. We're going to say load notes. Okay, so we're going to say load notes action. All right. So let's see if this is successful. So we can't add twice. So let's turn this into a proper function. Okay. So app block right there, let's grab that and a curly bracket in here. So first we send this action like this, okay? And after sending that action, we're gonna send a load notes action. So let's go in here and say load notes action. Great stuff. So we're now sending those 2 actions. In this case, we expect loading to happen, and then we're expecting loading to not happen. No errors expected, and the login handle, we expect it to be a login handle with a token of ABC. Okay, so that's for the logging in. However, when you try to actually issue this load notes action to your block, you can also see in here that we're emitting an app state, which starts loading, and then it grabs the login handle from the previous state, which kind of makes sense because let's say you tell your app block that, hey, log in, and then it keeps its login handle. And then when you tell your app block that, hey, now that you've logged in successfully, for instance, I want you to load some notes for me. When it loads the notes for you, and if it goes successfully, or even if it doesn't go successfully, it should produce an app state that holds on to your login handle. Because by just not being able to load your notes, or even by being able to load your notes, your login handle shouldn't be erased. You're still a logged in person. So this is what we need to do in here. So upon sending this action load notes, we have to check against this condition in here. So I'm just going to copy that and let's just paste it in here. So we say in here, we expect another login handle of ABC and is loading to be true. Okay. And this is a constant right there. Great stuff. And then after that, since our login handle is already specified, and in here we can actually see our you can see in here, it's looking at the login handle. And if the login handle is not equal to login handle foobar, then it's saying invalid login handle. So this is a little bit dangerous in that our app block is hard coding and checking against foobar in this particular way. This makes our app block not so testable. So we can't actually expect it to look for this kind of login handle. So what we should do really in here is to go into our app block and say, and inject a property in here, a parameter that says acceptable login handle. So let's say final acceptable login handle. All right. And then in here, there should be a login handle. So we're going to say required this this dot login acceptable login handle, or I think in the other ones we call them accepted login handle, right? Accepted login handle. So let's do the same thing in our app block. So we say accepted login handle. Fantastic. So that's our app block, and it has an accepted login handle. And in here, instead of checking against foobar, we should really check against the accepted login handle. So our app block doesn't then have any dependencies on any foobar in here, okay? And I'm searching for foobar in our app block, and I see that there's no other references to an accepted login handle. Now that we've changed that, now that we've added this dependency in our app block, we should actually go ahead and fix our main Dart file in here. So let's go ahead and where we create our app block in here, say accepted login handle is login handle .foobar, okay, for the actual app itself, okay, because in our application itself, we are hard coding that the app only accepts foo@bar.com and a password, foo@bar.com, and I think the password of foobar. That's what's hard coded for this foobar, okay? Great stuff. Now that that error is fixed inside our app block and inside our main Dart file, we should go ahead in our code in here and fix the errors with our app block. So, okay, here we have our app block. It's getting notes API and it's getting login API. And in here, we're just going to go ahead and say accepted login handle, and we're just going to say login handle token of ABC, okay? And this is a constant. And to be honest with you, since we're using this ABC in a lot of places, let's just go ahead and define it as a constant somewhere in here, for instance. So we're going to say accepted login handle is equal to login handle as ABC. All right. So wherever now we have this login handle of ABC, we're just going to chuck this in. So let's see in here, accepted. Let's see, our here, accepted login handle is the accepted login handle. Where else do we have it? Here as well. Let's just check that in. Great stuff. And then I think we need a parenthesis. And where else do we have the problem? We also have the problem in here where we're creating the app block, but we don't have the accepted login handle. So let's check that in. And also, I think one more case, which is the case that we were actually working on before we jumped into this side mission. Now that we have the accepted login handle, we know that also, let's replace this one and this one. And let's see if we have ABC anywhere else and check it here, and maybe one or two more places. So one more place here and one more place in here as well. Fantastic. and here as well. So we had it in quite a few places. That's really good that we've now defined it in one place. So let's just say ABC, it's only defined in one place. Fantastic. So now that we have that, we're saying that, okay, first we're loading, and then we expect an app state with a login handle of accepted login handle. And then we expect loading with accepted login handle. And then what we should be expecting is another app state, which is not loading, and it should give us the accepted login handle. However, this time it should give us the mock nodes, all right, which we've defined up here. So let's do a hot restart on our application. I don't expect any errors in the application's debug console for the application's execution itself. And if we run our test, I don't expect any errors. If there are any errors, we're going to fix them. So let's just say Flutter test and see what happens in here. 4 tests passed. Fantastic. So that was really it. I mean, we've done quite a lot in this example. We've gone ahead and even changed our app block so it's not dependent on app state foobar. Sorry, not on, I believe it was login handle foobar. So our app block is a lot more testable at the moment. So run your tests and see if they succeed. If they don't succeed, go ahead and have a look at the code that I've written, have a look at the code that you've written, and most importantly, have a look at the code, have a look at the output of Flutter test to see if you can detect the problem yourself as well. That's the most important. Great stuff. Now that we have that, we are done with this particular example in this chapter. So as is traditional, let's go ahead and commit our code. So we're just going to say git status, git add all, okay, and then git commit, and let's say step 5. And then we're going to also tag this code as step 5, as you can see in here. And then we're just going to say git, yeah, that's it. No pushing in here. So git tag, it should give us 1, 2, 3, 4, 5. And then also git log should give us the 5th log that we, or the 5th commit that we created in this application. So this was great. And after this, then we can move on to the next example in this chapter.
Now that we're done with this example, let's go ahead and have a look at the next example that we're going to do in this chapter. In this particular example, we're going to go ahead and experiment with something called MultiBlocProvider. Up until this point in this course, we've looked at different types of providers. We've looked at a block provider. We've had a look at how we build a provider. We've also looked at consumers, listeners, etc. But in this particular example, we're going to have a look at a case where you may want to have multiple blocks running at the same time inside your application. If you remember from when we created a block provider, you know that that block that you create in your block provider is going to be available in your build context in the entire widget tree after that point. However, wherever you want to have access to different blocks, then and then you're going to be able to pick that block from your build context, then you need to use something called a multi-block provider. And the other way to actually do that, the other way to create multiple blocks is to create different block providers and chain them together. So you would say, here's a block provider that creates block A, and its child would be another block provider which creates block B. And the child of that one is another block provider which creates block C. And then eventually you will go and say the child of the block C provider would actually be my widget tree. And in the widget tree, you will have access to all those 3 blocks that you created with your block provider. So, sorry, I just want to shake down also in Do Not Disturb. To go around that issue that you have to create multiple blocks and block providers chained together, there is a component in Bloc and Flutter Bloc called MultiBlocProvider. So let's have a look at its documentation a little bit. So let's close this app block test that we have in here, and let's go to our main function, our main Dart file in here. And I'm just going to say late final multi-block provider, and then I'm going to call it provider so that we can go to its source code, okay? And let's have a look at the documentation for multi-block provider. It has a really good example. As you can see in here, it says, in a case where you're creating like a block provider that creates block A, its child is block provider block B, exactly the same thing that I just told you right now, basically. So I didn't make that up. I actually had read the documentation and I thought that is a good example. So here, child A will have access to block C, block B, and block A. However, I've seen a lot of people make a little bit of a mistake in here, thinking that they can have the same block instance provided multiple times inside their application. But that's going to be a little bit difficult because block providers and usually block consumers, listeners, and builders work with specific instance types of a block. So in here, you can't have 3 instances of block A, basically. So you'd have to have 3 separate concrete classes that you will extract from your build context. So keep that in mind because it's quite important actually for this particular example that we're going to go through in this part of the chapter. So instead of doing block providers like this, chain them together, you can just go ahead and create a multi-block provider, as you can see in here. And it says it has an array of providers or list or iterable of providers. And in here, you just create your block providers just like this. So your block providers then wouldn't have children, so they won't have a child widget. So this is what we're going to do in this example. And soon I'm actually going to show you what we're going to develop. So let's get rid of that code. And let's have a look at a little bit of a demo, what we're going to develop in this example. So this is the application that we're going to develop. As you can see, it has 2, let me actually send it to the background, bring it back up so we get rid of that little title up there. So it has 2 images, and these 2 images are hooked to instances of a block. So we have a little bit of a block class, and this block class is able to load an image from a network source. So you give it a URL, and then it will download the contents of that URL, and then it will bring it into itself, ready for consumption. And then our application, it creates 2 instances of that same block. However, it doesn't do it just directly. It subclasses that block into 2 separate concrete implementations, a block A, let's call it, and a block B. But in this example, we're going to call it top block and bottom block. However, as I mentioned, these top blocks and bottom blocks, they're literally just subclasses of that one block that we're going to create, which does the heavy lifting. We're only going to create subclasses to allow our block providers to create concrete instances of that, so then we can later in our application pick these concrete instances. So because these 2 components in here, you can see the one on top and bottom, they're completely separate from each other. So they're not at all related. And the top one goes into the build context and tries to pick the top block provider, the top block. And the bottom image view is going to go into the build context and expect a bottom block to be available there. So one block that does the heavy lifting. From there, we create 2 block concrete instances. One is the top block, the other one is the bottom block. And then we will have 2 views or widgets, which are stateless, I believe, as well. And these 2 widgets will then hook themselves into these 2 blocks and will extract data from them, and they will render the contents on the screen. So this is what we're going to develop in here. As you can see, there's a little bit of a loading period and there's a little bit of a wait. So it creates suspense and it has this loading indicator. So it's a simple example, but you'll actually see when it comes to writing the code for it, there are lots of intricacies and lots of small details that you have to take into consideration before this application actually works. So in this example, we're just going to focus on multi-block provider. Okay, so let's go ahead. As you can see at the bottom of the screen, we're going to remove everything from our application. So don't worry, because we've committed and tagged our code. So I'm just going to literally here select views, APIs, block, and dialogues, and just delete everything from there. And let's keep the main Dart file and then delete the rest here. And I'm also going to delete the test that we've created. Okay, but keep the test folder. Then we're going to go into this main Dart file in here, and I'm just going to create a simple scaffold application. So Flutter scaffold application. You can see we have a material app in here, as we've had before as well. So there's no surprises here. And then we have a home page, which is a stateless widget. All right, with a simple scaffold and an app bar. Okay, so now that it's done, we're going to go ahead and create our app state, which is the first um, step basically in creating our app. So I'm going to go ahead in here. If I can find the keys, I'm going to run our app as well. So let me just stop the other application execution. Then I'm going to run our app while all of this is going on. Let's go and create our app state, as you can see at the bottom of the screen. So it is in libblock. So libblock and app state. Art, okay. Great stuff. So in this app state, what we're going to create is really have a look at what this application actually requires. So if you have a look at the application state in here, I think I actually killed the app. So let's go in here and start it. You can see we have this little loading indicator. So we need some sort of a Boolean flag in the application state to say whether any of these views are loading at the time or not. So let's create an immutable class in here and say app state in here, okay? And then we're going to go ahead and add the is loading flag first to it. So let's say final bool is loading, okay? And immutable is in foundation, remember that? So let's import immutable, and then let's just say show immutable. So we have is loading in here. Then what we need also is two other properties. So if you'll have a look at the application again here, it is able to go and hit a URL and download the contents of that URL and then place the image on the screen. However, it's also able to display an error. Should an error occur during downloading of this image, this application is going to be able to display that as a little text message or something, okay? So two more properties: the data of the image being downloaded or the data of the image that has been downloaded, and a potential error. So let's go in here and say uint8 list, which is for our data, and this has imported Dart type data. You can see in here because uint list is something that is inside type data, and I'm just going to say show uint8 list because we don't need the rest of the symbols. And this is optional, and this is going to be our data, okay? Because if you're in the if you have just started the application, you don't have any data to display, so you're just in the state of loading, and that's why data is optional. After adding the data in here, let's go ahead and just say an optional object that could be our error. Okay, so both error and data are optional. However, is loading is just a state of true or false. An optional Boolean makes absolutely no sense in my idea, at least in this case. Sometimes inside, for instance, an API call, you may have an optional Boolean. For instance, if in a previous version of your API, you didn't have that Boolean, but then the developers are adding that Boolean in the returned JSON. Now they will make it optional because in some older versions of the application, that Boolean may not actually exist, for instance. So it's just a design decision in here. So is Boolean for us is just going to be a black and white flag, okay? Meaning that it's not going to be optional. So let's go ahead and create the constructor for our class in here. So let's just say create constructor, and I just, to make these required parameters, I like to put a comma at the end, and then I'm going to go here in Visual Studio Code and just make all of these required like this. Then I'm going to go here, put the curly bracket and the curly bracket in here as well. Let's make it a const constructor. Great stuff. So as we usually do, if you remember from, because this app state is going to be used inside our app block, which we're soon going to create. So usually when we go ahead and create our app block and then add the app state to, we kind of want like a default app state for the initialization phase or the construction phase of our app block. So it is a little bit of a pain in the neck to go ahead in our block and create an empty app state. That's why I usually go ahead and create an empty app state here in the app state itself. So let's go ahead and say const app state.empty, which is going to be the initial state of our block. In here is loading by default is going to be false. Data is going to be null, and error is also going to be null, just like that. So this is the default app state our app block is going to use upon construction. Excuse me. Now that we've done that, we also want to go ahead and add the toString functionality to our app state, because this is something that I really like. Sometimes when I'm doing poor man debugging, for instance, I like to go ahead and print out the contents of my app state to the debug console. And if you haven't implemented toString, then it's going to be very difficult. You're just going to get a string that says instance of app state, which is not so meaningful. So let's go ahead and override toString on our app state. So toString in here, okay, this is just going to be a simple function, which is going to be a map. And then we're going to say toString, okay? In this map, then what we're going to do is to add all our three properties. Is loading, the key is loading, and then the value is loading, this value itself. Then we have has data, and we're going to say data not null, because we don't want to actually print the contents of our data. Just imagine if you've downloaded an image that's like 2 megabytes, and if you like print out the entire contents of that data to the debug console, is not going to be so pretty. So what we could do is to have kind of like a Boolean key in here that says has data, and its value is whether the data is not null, meaning that if the data is not null, this is going to be true, and has data is just going to say true. Okay, so that's for is loading, has data, and then we're going to just put the error as it is. So that's the implementation of our toString. Very simple. Okay. Great stuff. Now that we're done with our app state, it's actually time to go ahead and create our actions. So, which are our events basically. So let's go ahead. As you can see at the bottom of the screen, we're going to go ahead and app event. I'm going to open it in here as well. Create a file inside lib.bloc, and we're going to call that one block events. So block events.dart. Okay. And usually what we do, you should know this already if you've watched this video from the beginning, that we create an abstract class for our events, and then we create concrete instances of that app event or the event class for any events that can actually be constructed and sent to our app block. So let's go ahead and create an app event class in here, an abstract class app event. And then we create a constant constructor. Excuse me. Let's import foundation for this immutable, and then let's just say show immutable. Okay. So now we're going to go ahead and implement the events, and the only event that our application actually has is this event that gets sent to the block. Let's see. It's an event that tells the block to load the next image. So there's really no other events in here because you can't interact with these images. You can't drag and drop them. You can't click on them. The only thing that's happening is that there's like an internal timer in each one of these views that tells the block to load the next image. So that's the only event that we're going to go and implement right now. So let's say immutable class load next URL event, and this one implements app event. Okay. Undefined class implements, and then let's go and create a constant constructor for this like this, and you could call super as well if you want to, but you don't have to do that. Dart does it for you automatically. Okay, great stuff. So that's load next URL event for us in here. We don't have to do much more on that. Okay, now in this application, as you can see in here, it has like some sort of a database of images to load. And I've already prepared like a list of images that we can hit and return. And I'm not going to go ahead and type all of those because I've also shortened all those URLs with Bitly. And again, this may not be like your favorite URL shortener, but I've just used Bitly because it was convenient. And you're more than welcome to go ahead and prepare other URLs if you're fond of that. So let's go in lib and then create a new file in here, and then let's call it models/constants.dart. Okay. So I'm going to go ahead and grab that list and just paste it inside our constants. And you're free now to go, if you want to pause this video and go type this out. Otherwise, I'm gonna link the repository for this entire video at the bottom of this video on YouTube. And if you want to go ahead and check that code out and go to tag of I think we're going to call this one step 6, right? So if you go ahead and check out step 6, then you're going to be able to find this constant start file. Otherwise, you can pause this video and type that out. Or a third option would be for you to actually put your own favorite image URLs inside this constant start file. Okay, now that we're done, now we're going to go ahead and create the app block itself. So this app block is going to be very easy actually. So let's go ahead and see if we can implement it fast. So we're going to go into lib block, and inside this block, we're going to create our app block, as you can see at the bottom of the screen, app block Dart. Okay, we have our app block Dart now, and what this guy actually is going to do is, you see, we will give this app block a list of images to pick, and then the app block, when we tell it to load the next image, this app block is going to go and pick a random element out of that list and then try to load its contents. So this is something that we're going to do. However, if you think about it, if we tell our app block just to pick any random URL from a list of URLs, how are we going to test that? Because when we then go into our test suite and then we want to, for instance, tell our app block, hey, load a random URL, and then all of a sudden we have to write a test for it, how are we going to assert that the URL that was picked by our app block is actually the correct URL? Or how are we going to test that the app block picked the URL that we wanted? So the idea of an app block having any kind of logic that's not testable is usually not a good idea. And I understand if you're creating like a block for hobby projects and you're not so bothered by writing tests. I completely understand that. I've been in that boat as well. I already am in that boat and will always be in that boat, in that sometimes you have to make a decision not to write tests. It may not make sense all the time. But in this video, since I'm trying to really set a good example of how Bloc should be implemented, I'm going to make our app block testable so that we don't run into an issue later on when we try to test the app block, okay? So let's go ahead in here and start implementing our app block. So let's go ahead and just say class app block. Okay, so we start with that. And then this one extends block, and block needs to be auto imported. So I'm just going to auto import that. You can see in here, block. And to be honest with you, it'd actually be better if we imported it from a Flutter block, because then, yeah, we will get all the functionality of Flutter block. So let's see. Import from Flutter block in here, great. And in here, we have to pass two parameters. Remember, from the source code of Bloc, it needs its events and state. So in here, we're going to say app event. It's going to be auto imported as well. And then we're going to say app state, okay? So that's great. Now, this app block needs its initial state because it doesn't have a constructor. So let's call that. And in here, we're just going to say the default constructor is empty, doesn't take any parameters, and for the state, it has the app state empty, as you can see in here, a constant as well. I can see in here. Okay, so that's the simple implementation of our app block. It has no logic really, but we're going to go ahead and add that logic now. So if you remember, I mentioned that this app block should be able to pick a URL randomly, pick a random URL from a list of predefined URLs. So how do we make that logic testable? If we just pass a list of URLs to the app block and just expect it to pick a random one, then that's not so testable. However, if we can kind of pass a reference to a function that has the ability to pick a random URL from a list of URLs, then it will be testable. So let's say a possible function definition for that would be, let's call this app block random URL picker. That function would return a string, kind of like a URL, and it would be a function, and then it will have an iterable of string, all URLs, as a parameter. So that function would expect a list of your strings as URLs, and it will pick a random one out of that and just return it to us. So this is a function definition for such a function. So what we could do in here is to go ahead in the constructor of our app block and say, okay, give us, let's put this, make it a named parameter, optionally give us a URL picker, okay? So you can see in here, we're taking this as a dependency. So this will be kind of like dependency injection into our app block. We're saying, give us a URL picker. However, our goal is also to not force the main application, not the test suite, but the main application doesn't have to pass a URL picker to us. The main application should just say, hey, app block, go ahead and create yourself. And I'm not going to provide you with a URL picker, just use a default implementation. So our app block is going to have a built-in mechanism for picking URLs out of a list of URLs if this guy is not provided to it. So we need to pick a random item from inside an IEEE. So let's go ahead and create that extension. So let's just say extension and random element on IEEE of T, and let's make this also T in here. Okay, then we're going to create get a random element, and we're going to say get random element. And in here, we're just going to say element at, and now we need math. So let's go import. I think it's Dart math, and I'm just going to say as math. Okay, so that in here I can just say math.random, and then we're going to say next int of length. All right, so this is going to give us a random element out of our IEEE. Great. Now that we have that, let's go ahead in here and create a function that conforms to the same structure or signature as this URL picker. And we're going to put that function inside our app block. And if this URL picker is not provided to us, we're going to go and use our own function. So with the implementation of this get random element, we can go ahead now and do the implementation of actually picking a URL from a list of given URLs in our application, in our app block as well. So let's go and make first create a function in here, a private function, and we're going to call a string, and we're going to call the actual function. Sorry, the return value is going to be a string, and we're going to call the actual function pick random URL. And the goal here is to have this pick random URL conform to the same signature as this function in here. So this return value should be string, and it should actually expect an IEEE of string as its parameter. So let's go ahead and add that in here. And this guy is all it's going to do is going to go to all URLs and say get random elements in here. Okay, so this is basically our own implementation of this URL picker. So if we don't have this URL picker in here, we're going to fall back to our own implementation of URL picker. Okay, for this all to work, we also need a list or an IEEE of string for all our URLs. So let's go and add that as a parameter. I'm just going to copy paste this so I don't have to type that. I'm a little bit lazy in that way, and I still at the same time don't think it really contributes so much if I type everything by hand. So now that we have that, we're also going to add another property to this app block, and we're going to let the app block to wait a little bit before it loads the new image. So if you have a look at this, how this application works at the moment, it displays the image for like 10 seconds, and then it does a little bit of a loading, but also waits a little bit before it loads the image. So this little wait is very useful if you want to actually see the entire process working, because if you don't add this little bit of a wait, then depending on your connection speed, the next image may be loaded so fast that you don't actually see your circle progress indicator. So we're going to add a little bit of like an artificial loading time to our app block so that we can see the loading progress as it's going on. So let's go ahead in here and say duration and optional duration, and we're going to say wait before loading, okay, as a property. So if you provide this duration to us, then we're going to use it. Okay, fantastic. So now that we have all the properties that we need in here, let's go ahead and actually implement the constructor for our app block. So I'm going to create a set of curly brackets in here. So what we do in here, we go ahead and use the on function, and we're going to say app event. I think we have a load next URL event, and I think this needs to be imported as well. And we have block events in here also imported, so we didn't import that. And I think actually that was imported when we wrote here app event. So it's nothing that got imported right now. Good. Now that we have that, let's go ahead and implement the function. So this guy is going to have two properties in here, this function. It's going to have an event, which is the load next URL event, which doesn't really contain any values. And it also has an emit, using which we can emit new states. Okay, so let's see what parentheses and what curly brackets we have to close in here, like this. Good. All right. So now we have that. And in here, we should go ahead and implement our function. This function is going to do some asynchronous work. So let's just mark it as async because it's going to load our image. So the first thing that we're going to do in here is to, as soon as someone asks us to load a new image, what we're going to do is to set our application state as loading. So let's emit a new app state, and we're going to say a const app state is loading is true. There is no data while we're loading. And also we're just going to say there is no error either. Okay, so let's put that there. So you can see in here, we can just put a comment in here as soon as, or just say start loading. Okay, so this is us emitting a new state telling the application that, hey, start loading something. And this is what the application does then visually when the is loading property is set to true. You can see now after a few seconds, it's going to change to a circular progress indicator. And then later on, when the image is downloaded, it's going to be set inside data, and the application understands that. So let's go ahead and now pick the URL that we have to hit. So in here, we're going to say final URL. And the way to do that really is to either pick the given URL picker that is provided in here, or pick random URL. So let's go in here and say we either take the URL picker as a parameter that's provided to our constructor, or pick random URL. Okay, so this is our function that is going to extract a URL out of a list of URLs. And then in here, we're just going to say URLs. Okay, so this URL is then going to be a random URL picked out of the array of URLs in here, or the list of URLs, either by the given URL picker, or if that was absent, then we're going to use our own built-in pick random URL function. Okay, great stuff. Now that we have the URL, let's go ahead and create a try and catch block in here, because we're going to hit some URLs. So it's always good to have a try and catch block. So try, and then I'm going to say catch E. So this is going to be an object error. And upon getting an error, let's just emit an error. So I'm just going to say emit, copy that and go into your catch block, and then say this can't be a constant anymore because E isn't a constant. Stop loading, there is no data, and the error is going to be E. So it's very simple. Just pause the video in here if you want to have a look at this. So upon getting an error, we're just emitting an app state that is not loading, it has no data, and it has the error embedded in it. Okay, so what we're going to do inside try then is, before we start loading this URL, we're also going to wait if the caller to our app block actually expected us to wait. You can see in here, there's an optional duration to wait. Okay, so I'm going to copy this name in here, and let's go in our try block and say if this name is not null, then we're going to say await on a future of delayed for that duration. Okay, so this is going to create that artificial wait, which allows our circular progress indicator to be displayed for a while on the screen as this future is waiting, basically. Great. Now that we have that, let's go ahead and create a network asset bundle. So let's just say bundle. I'm writing Rust code in here. Sorry. So let's say final. And this is something that happens on a daily basis for me. I know this is kind of like a tangent I'm going on the side, but I kind of mix sometimes different languages, and it's a little bit annoying. But I just try to laugh about it. I sometimes mix Python with Rust, or Rust with Swift, and Swift with Dart. It's just, yeah, it's a little bit fun as well. So when we say bundle, let's just go ahead and say network asset bundle is going to be imported from this package in here. Let's have a look from services. So we have a network asset bundle, and we're going to say URI parse our URL. Okay, and then we're going to load the contents of that bundle. So let's just say the data is awaiting on the bundle and load the URL. And by loading it, we're also then in here going to say buffer as UINT 8 list. So this gives us the data. You can see in here is the UINT 8 list, and then we're going to emit a new app state with that data in it. So I'm just going to copy paste that code. So have a look at it in here. We're emitting an app state. The data is set to this data. We're not loading anymore. Let's actually put is loading in here as the first parameter. And then we have the data, and we have no error. Remember, because the error is handled in the catch statement right here. Great stuff. Really, there's not much more to our app block. That's it. So let's just save this file. And let's now talk about creating two concrete subclasses of this app block. I mentioned this before, but I'm just gonna mention it one more time why we're gonna do this. You see, we are gonna have two completely separate views rendered on the screen inside maybe some sort of a column. And these two screens expect this particular app block to be inside the build context because they're going to say context.read. However, if both of these classes try to pick an exact app block class from the context, given that we're going to have two app block instances in our context provided with a multi-block provider, how are these views going to know which one to pick? If both app blocks are of type app block, as you can see in here, if they're both instances are of this type, how are these two completely separate views going to be able to pick the correct app block? Because one of these app blocks is going to be a provider for the top part, and the other one is going to be the provider for the bottom part. So to go around this limitation of picking the correct app block, then we're going to go ahead and create two separate instances or concrete implementations of this app block, and we're going to call them top block and bottom block. Okay. So let's go ahead and start with our top block. So we're going to put that inside lib block in here. So let's go ahead and create a new file. As you can see at the bottom of the screen, we're going to call this top block.dart. Okay. And this top block, really all it's going to do is just going to implement our app block. So let's just call this guy class top block. And this guy extends our app block, which is going to be auto imported. Okay. And this top block needs to have a constructor. So let's go ahead in here and add the constructor. Okay. So it gets the URLs, but we are also going to give it the time to wait before it loads the URLs. Okay. So let's go ahead in here and say duration, wait before loading. And let's just pass this to the super, as you can see here. So that was it, really. Our top block is not more complicated than this. It's just a top block. Okay. And then what we're going to do is just to copy the same code and then go ahead and create a bottom block. So, and again, you can see that these blocks have no logic in them. They're simply there to allow us to pick the correct block class out of our build context. Excuse me. So let's go ahead in here in block and create another file in here and call it bottom block dart. Okay. Now that we have that, I'm going to paste the contents of top block in the bottom block as well. I'm just going to change some names in here, just kind of call it bottom block and bottom block in here as well. So the name of the class is correct, and this one's correct as well. Okay, what we're going to do is to start working with a view that can consume an instance of app block, whether it's top block or bottom block. Okay, so what this view really has to do is going to have the logic for loading, is going to have the logic for displaying an error if the app state contains an error, is going to have the logic for displaying the image itself, and is going to also have the logic of having the app block load a new image after n number of seconds. Okay, so what we're going to do is, I mean, if we kill this application before we actually go ahead and implement this view, let me show you something interesting. If we start the application, you can see as soon as I open the application, it starts loading. So we're going to have a stream in our view that is a periodic stream that fires every 10 seconds. So it starts here, it waits 10 seconds, and then tells the app block to load a new image. However, if we did that, if we created a stream and then it had to wait 10 seconds and then tell the app block to start loading an image, then you would open the application afresh, and then you'd have to wait 10 seconds before the loading even begins, before the loading of the image begins. So in our application, if you look closely, as soon as you open it, it does a little bit of loading, which is like it's kind of like an artificial loading provided by this wait before loading. And then it loads the image immediately, meaning our stream, and that periodic stream that we're going to create in this view, is going to not only be a periodic stream, but it's also going to start immediately by sending a value as soon as the stream is subscribed to. Okay, this goes into a little bit of like reactive program paradigm in here. Like if you're comfortable with Rx Swift or Rx generally, there is an operator on your observable called start with. So this is similar to that. So we're going to create something called start with extension on a stream, which is going to use stream groups, as you'll soon see how we're going to do that. So let's go ahead and create an extension in here. As you can see at the bottom of the screen, we're going to say lib and a new file in here. We're going to call it extensions folder, stream, and then start with Dart. Okay. And we're going to go ahead and implement the start with, but we're going to use a stream group because we're going to merge two streams together. So to do that, you need async. So let's just say import Dart async. Actually, it's in a package of async. So let's say async and then async Dart in here. And then we're going to show stream group, I believe. All right. So let's say an extension called start with on any stream. On stream of t like this, and we're going to say this extension returns the same stream, and we're going to call it start with and a value of that same type, and then this guy is going to create a stream group that does a merging two streams together. What is it going to merge? It's going to merge this stream and also another stream of the same type which contains that value. So I mean, if you're not familiar with reactive programming, this may be a little bit strange to you, but what is really happening in here is, I can just write some documentation in here. Let's say that we have a stream, which is the timer that we're going to create in our view. It starts here, and it waits 10 seconds, and then it produces an element. And then it again waits 10 seconds, so let's just put it here, and produces an element. What we want, though, is not for the user to have to wait initially this long. We want our app block to start immediately producing a value here. So what we're doing is that we're taking this stream, which is going to be our timer, which is this, as we've mentioned here. And then we're saying that, okay, start that stream with this value. So what is going to happen is that we're creating another stream in here, as you can see, that immediately produces a value, and it will look like this. So it will be, so if I say this is that one, and then our value stream, so stream value is going to be this one. What it does is that it starts the stream and immediately produces a value, and then it just continues. Or actually, it dies immediately right here. It dies, okay? So the result of this is going to look like this. So it will be the result of merging. So this is the result of merging them together. It will be this, and then it will continue here, and then it will produce a value, and it will continue here and produce a value. So this is what we want. We want a stream that immediately produces a value and then continues as long as the other stream, which is this, continues. Okay, so it's a little bit strange. I understand it's reactive programming, but I try to explain it this way. If you look at some diagrams, you may understand it better, hopefully. Okay, we're done with that. Let's go ahead and start implementing our app block view. So let's go and close all these windows in here and just dismiss these errors. It's completely fine. And let's go, as you can see at the bottom of the screen, we're going to go into lib and create a new file here, and under the folder views, which we don't have, and we're going to call it app block view.dart. Okay. So in this app block view, it's not going to be any type of a stateful widget. So we're going to create a stateless widget. So STL in Visual Studio Code, create a stateless widget. And we're going to call this guy app block view. All right, we're getting a lot of errors simply because we don't have a material imported. So let's import material. So get rid of all those errors in here. But what's important about this app block view is that it's actually a generic view. Let's go back to this example. Both of these in here, both the image on top and the image on bottom, are two instances of app block view. However, they're going to pick a specific block out of the build context. So a block of type app block. Okay, so how do we tell this app block view to become a generic view that picks a specific class type or a concrete implementation of our app block? Well, we're going to make this guy a generic class. So we're going to say it needs an app block, which extends app block in here. And we have to import app block. Okay. Now, app block view is generic, so it has a constraint called t of type app block. Then later, when we go into our context and try to read this app block, we don't say context.read app block, but we'll say context.read t, which basically the caller, the creator of this app block view is going to provide us with that generic parameter, and we're going to pick that specific app block from the build context. This is basically allowing us to create two instances of this app block view, one of which is going to work with the top block, the other one is going to work with the bottom block. Okay, so that's what this T is for. And since both a top block and the bottom block conform to the app block class structure, then we're good to go. Good stuff. So let's go ahead in here and start implementing our update functionality. Okay. So we're going to create a function in here, maybe before the build function. We're going to call this void start updating block, and this guy needs a build context. Okay, so the purpose of this function really is going to be to create a periodic stream that has that start with, and upon this stream firing an event, we're going to go to that particular app block provided by the T generic parameter and just send an event to it and say load the next image. Okay, so let's go ahead in here and just say that we have a periodic stream. So let's say stream dot periodic. Okay, and this is going to have a duration. We're going to hard code this one to seconds of 10. Okay, so 10 seconds. And then what we're going to do in here is going to provide an event for every tick of the stream. We're going to provide an event. So let's go ahead and say that we don't care about this integer that comes in, but we're going to provide a const load next URL event. Okay, just like that. So if we put this one inside its own stream variable in here, you will see that it will become a stream of app event or stream of load next URL event, which is an app event. So we have the periodic event, but we also have to start it with something. So we say, this is our stream, and we have to say start with, and let's import start with. So we started immediately with an event to load the next URL. Like this, okay? And then when we have this, we go and say for each, and then in here we say, here's the event. Now we have to dispatch this event to our app block. So let's say context.read, okay? And for read, we need our Flutter. Let's see if app block is imported, block events, but I can see that Flutter block isn't imported yet. So let me go ahead and import Flutter block. Because context.read is something that's inside Flutter block. Okay, so import it right there. Now we have to send this event to our app block. So let's just say context.read. And then what do we read? We don't read app block anymore. We read T. Okay, and then we add this event to it, just like this. Okay, so hopefully this makes sense. We're creating a stream that goes, it takes every 10 seconds, but it immediately starts with an event. So event 10 seconds, event 10 seconds event. Okay, and then we're just dispatching those events to our context. So it's not more complex than that. And you can see this is not like an async function because it's just really creating a periodic stream. It's not waiting for anything. It's just say, here's the stream and just do your work. Okay, so great stuff. Now that we have that guy, let's go ahead and implement our build function in here. So the first thing we do in here, we just call our start updating block in here. Okay, so we pass that block. And then what we're going to do in here is to go ahead. The first thing that we're going to do is to kind of create a block builder. Okay, so let's go ahead and say that we have a return a block builder in here. And our block builder, if you remember from the source code of block builder from before, it needs a block. So we know our block is of type T. And then the second parameter that it needs is S in here. Let's see what that S is. Oh, it's the state, basically. So let's go in here. Then we say app state. Okay, and it's auto importing it. Good stuff. So now we go into the builder. Let's see if we can get help from Visual Studio Code. Great stuff. All right, so in this builder, now we have to take the app state. Let's just say app state. Okay. In this builder, now we have to provide the build context with a widget to render, or we have to provide a widget to the block builder, which then itself is provided to the build function to be returned and rendered on the screen. So we're going to say if app_state.error, let's handle the error first. If it's not null, meaning that there is an error in the app state, then we're going to create a return const text, and we're going to say an error occurred. Okay, try again in a moment, something like this. All right, let's put it in here. Good. So we've handled the error now. So if any error is available in the app state, then we display a text message to the user, or a text widget. However, else if app state.data is not null, meaning that we have data. Okay, we have data. Let's put a comment in here and say we have an error. And here we have data. Then what we're going to do is to use that data and display it as an image. So let's say we return an image in here that is coming from memory. And because remember, our app state has the data, app state.data. Okay. And then we're going to say fit is box fit height. Actually, box fit height. Here. Okay. So that basically it's going to stretch the image to fit the height. So then the width will be stretched as much as the height requires to fill the height of the image. Okay. And otherwise, if we don't have an error and we don't have data in here, we're just going to display a circular progress indicator. So I'm just going to copy that and just chuck it in here. So we don't have to type this because this one's very easy code. So loading state. Okay. Loading, just like that. You could also say else if something is loading, if app state is loading. But to be honest with you, in our case, if we don't have the image and we don't have an error, then we are loading. So because we really have only 3 properties in here, is loading, data, and error. Okay. So, but you could go ahead and add an else if you want to. Experiment with that if you want, but I'm just going to leave it like this. Good. We don't have so much more really to do, except that this block builder, since it has no intrinsic size and this image has no intrinsic size, let's add this inside an expanded block. So let's say if we say wrap it with a widget and we say expand it. Okay. Great stuff. I don't think really there's much more to it. It's pretty much this one. So an expanded that wraps this block builder. Okay. Because remember, expanded has this flex. We're going to add 2 of these guys to the same screen. So if they both have the flex of 1, they're going to take each half the size of the available, size, basically. Good. We have the app block view, and it's time to actually go ahead and put it all together inside our home page. So let's go in here and say go to lib views and then create a home page. So if I close, let's see, homepage in here. So what we're going to do is to go inside views. I believe in here we have, and let's right click on it and say home page.dart. Okay. And this guy is also going to be a stateless widget. So let's see, STL. Okay. And let's call this home page. All right. And let's import material in here to get rid of all those errors. Okay, in our homepage, what we're going to do is to actually put things together. Because if you remember, we have this main Dart file in here at the moment that has our homepage, but we're kind of going to get rid of that. Okay, so this homepage Dart is going to replace that homepage, which is right now inside the main Dart file. So in this guy, what we're going to do is to go ahead and import a few things. So I'm just going to put all our imports in here because I think it's a little bit of waste of time, to be honest with you, for us to go ahead and do all the imports. And I'm going to go in here and just say course to fix all these imports. So these are just imports. You don't have to worry about them. The only things you have to think about really is that the material, you know, why we need that, because we need all these stateless widget stuff. Services, system UI overlay style. What we're going to do in this example is, if you have a look in here, there's a status bar on top of the screen, and we're just going to make the status bar a dark color because we don't want that to take so much focus. Otherwise, this would be kind of white. So We just want it to be black and not so visible. All right. So that's what we have this import, as you'll soon see how we're going to use it. Then we have the import of Flutter Bloc, and the rest of the imports are just like the components from within our application that we're going to use. So nothing special. Okay. So, and I hope you understand that I'm not going to go ahead and explain all the imports really. I mean, imports are not so relevant maybe to a block course. Okay, let's go in here in this homepage. Let's go and create a scaffold then. Okay. So let's go ahead and say return in here a scaffold. And let's go ahead inside our scaffold. Let's say that the scaffold has a body in here. And we're going to go ahead and say create an annotated region, I believe, region of a system UI overlay style. Okay. And what we need really in here, let me see if I've written this correctly. Yeah. So annotated region with a system UI overlay style is going to allow us to make the status bar dark. Okay. So let's say the value is system UI overlay is going to be dark. Now the child of this guy is going to be our multi-block provider. So let's say a multi-block provider in here, and we're going to go ahead and say the providers in here. Providers is an array of providers. So let's go ahead and add our providers in here. So let's say a block provider. So this is the first one, and this one creates the top block. Okay. And yeah, it creates the top block. Let's go in there and then create the top block in here. Okay, so let's say for create, we have a function. Sorry, it takes the build context, but we don't need it. And let's go ahead and create our top block. Okay. So the top block is going to have two parameters in here. So wait before loading, we're going to say const duration seconds 3. So wait 3 seconds before loading a random URL, and URLs in here are going to be images. So we have already images defining constants. Remember, constant start. So that's for the first block provider. It's going to create the top block. And then I'm going to copy this guy and put a comma in here and then go ahead and create the bottom block in here. So bottom block, okay. And just change that to bottom block. So great stuff. We're getting a lot of errors and warnings in here, but ignore all of those. It's just because we haven't provided child property to multi-block providers. So let's go ahead in here and provide the child property. So what this child really going to do is to go ahead and create a column, okay? And this column has a property. It's going to say main axis size, and we're going to say main axis size max. So a column is a vertical component by allowing it to grow to its maximum size on the main axis, because remember, a column being a vertical component, its main axis is the vertical axis. So what we're saying is that stretch yourself as much as you can. Take all the available vertical space on the screen, and the height of this column is really going to be taken by our image anyway. So then the children of this guy are going to be 2 instances, which is going to be our app block view, and then we're going to say another app block view. But remember, these guys, let's make this a const. These guys are generic views. So we need to tell the app block view which app block to pick. So we're going to say this one needs the top block and this one needs the bottom block. Okay. So we're going to ask them to load those blocks, because remember, inside app block views, we're using this T, and then we're loading that T from, let's see, from our context here, context read. Good stuff. So let's put a comma in here, make it a little bit happier as well in here maybe. So those are the parts that we had to really put in our scaffold. I really don't think that there's much more to provide in the scaffold, and that's it really. So what we need to do now is to go ahead and clean up our main Dart file. So let's go in here and say main Dart. And we have the home page in here, and we have another home page in here. So let's go ahead and remove the home page in main Dart, because we don't need that. And all of a sudden, this home page isn't found. So we have to import home page. So like that. Okay, great stuff. And I'm just gonna launch the application. I just actually don't want to debug the application, so I'm gonna stop the launch process. So let's go in here, and then I'm gonna run the application without debugging it. So
let's see, because I mean, we're done with this example, but we haven't really seen anything on the screen, and that could be a little bit like scary for some developers if you're really used to like running the application all the time and doing hot reloading and seeing what is happening on the screen. We haven't done that at all in this example. We've just written a lot of code without testing it. So let's go ahead now and put it to practice and see if it works at all. So this is the old application. I can see the running of this application didn't go so well. And sometimes that happens. And that is simply because Visual Studio Code kind of like loses its connection with Xcode in this case. So if it happens again, if this launching doesn't succeed this time either, I'm going to pause the video kind of and quit Visual Studio Code and run it again, but I'm not going to show that process to you. So let's see if this goes successfully. And if not, I'm going to kill Visual Studio Code and run it again. Let's just wait here and see what happens. So I actually had to restart Visual Studio Code for the connection with Xcode to be repaired. So now that our application is running, let's actually have a look at the moment of truth and bring up the simulator. And now we can see this is our application. As you can see, it is displaying the images, and then it's waiting about 10 seconds and then creating an artificial loading state, which goes on for about 3 seconds, I believe. And then it's loading the image, waiting 10 seconds, and then loading again and going on and on. So it seems to be working fine in here. So let's go ahead and do something that we do after every example, and we go and commit our tagger code. So let's go here in terminal and say git status and have a look at the status. We're going to say git add all, and then we say git commit step 6, as you can see at the bottom of the screen. And then we say git tag step 6 as well. So if you have a look at our tags, now we have 1, 2, 3, 4, 5, 6, and have a look at our logs. Also, we have 5 and 6 in here. So great stuff. That was for the 6th example of this chapter. We have 2 more examples to do, and the next one's also going to be exciting. But for me, the most exciting example is actually going to be the last example, which is going to be a huge one. We're actually going to do some integration with Firebase and Firebase storage. So we're done with this one, and let's start with the next example. Good. Now that we're done with this example, let's move on to the next one. So as we've done with pretty much every other example that we've done in this chapter, we first write the example, and then we go ahead and write some tests for it. And this particular example is no different. Now we've written this application, this beautiful application that can load random images on the screen. Let's go ahead and test that block. If you remember, our app block is quite simple, actually. So if we open our app block in here, it really doesn't have so much logic. It only is picking a random URL out of an array of URLs, and it's loading the contents. However, we have kind of like put ourselves in kind of a strange situation in that we're picking a random URL, and that's fine because that's testable since we have a URL picker injected into our app block. However, there is a specific piece in this app block that isn't testable, and it's these 2 lines of code. Because what we're doing in here is like giving a URL to our app block, and then we're asking the app block to load the contents of that URL. So we can't really unit test or block test this piece of code simply because this URL needs to be present at the time of the execution of our tests. So what are we going to do? Are we going to go ahead and like create some sort of a local server and then run our tests? Or what we could do otherwise is to change this logic so that our app block doesn't really go ahead and load the contents, but it delegates that task to some sort of an injectable function that says, hey, here's the URL, go ahead and give me the data for this URL. If we do that, then we're going to make our app block testable. So we kind of need a controlled environment, and that's what I'm mentioning at the bottom of this screen in the caption. So let's go ahead and fix this. So we don't go ahead and use network asset bundle the way we're doing it here, but we're going to make this a controlled environment. So we inject this dependency into our app block, okay? As we've done in here with our app block random URL picker, we're going to go ahead into our app block as well and kind of create a type definition for a URL loader. So go ahead and do that, as you can see at the bottom of the screen. So a type def app block URL loader. okay? And this guy returns a future of uint8 list, okay? So it returns the data. It is a function, and what it takes is a URL, just like this. So it takes a URL and then returns the data for that URL, okay? And so we're going to go and add the implementation for that and add the optional parameters. So let's go in here and copy this and bring it into our parameters that we accept in here. So we have the URL picker, and then we're also going to say a URL loader, okay? And also, we're going to, just like we have the default implementation for pick random URL, we're also going to have the default implementation for loading a URL. So let's go ahead and say future uint8 list. And remember, this URL loader has to conform to the same function signature as this guy. So it needs to return a future uint list, and it needs to take a URL as a parameter. Okay, so let's call this guy load URL, and it takes a parameter of type URL. And then we're going to put this code in there. So we're going to say network asset bundle. Okay, so we're going to return the network asset bundle, and then we're going to say load the URL. So let's bring this to the next line in here. Great stuff. And then we're going to take the data that comes in. We're going to say bytes data, and then we're going to say byte data dot buffer as uint8 list in here. Great stuff. So you can see now this function is conforming to the same function signature as app block URL loader, and it's returning the data just as you would expected. And it says it isn't referenced, and this is what we're getting this morning. Okay. So now that we have the load URL, let's go in here, and instead of saying final bundle and final data like that, we're going to use our URL loader. So let's go ahead and remove that and say final data is, we either take the URL loader that is provided to us as an optional parameter in here, or we use our built-in load URL function. So we say either the incoming parameter or the built-in one, and then we pass the URL to it. So then we get the data in here, and let's see, we have to await on it as well. So really good. That was really all we needed to make this special dependency injection into our app block, okay? So now that we've done this, we need also equality on our app state, because remember, we're going to go ahead and write some tests, and we're going to expect the app state to be like another app state that we're going to insert into our test. So we need equality for app state. So let's go ahead in our app state file in here and start implementing equality, okay? So in order to implement equality, what we really need is to also be able to compare two data properties in here. So let's say you have one app state in here and another app state in here. You want to also compare their is loading property, you want to compare their errors, and you want to compare this data. Now, this data is a uint8 list, and it's kind of like an iterable. So what we're going to have to do is to create a special function that can compare two data buffers, okay? So let's go ahead and first do that. So let's go ahead and create a comparison that byte by byte, it compares two uint8 lists, or any list for that matter. So let's say an extension of comparison in here, and we say it's a comparison of type T on any list that has that T in it. And we're going to say bool is equal to another list. So list T in here, or let's change this to E as an element. Okay. So list E, and then we're going to say other. Then the first thing we have to do in order to make sure that two lists are equal is that their lengths should be equal, or if they're identical, for instance. So there are two things that we have to compare. If identical is a function that is built into a Dart, we say if this is identical with other, then return true. So if they're the same instance, so if you compare the exact same two instances of a list to each other, they should be identical. So we don't have to actually compare their bytes to know that if it's the same memory instance, then it's the same list, okay? And also, if their lengths are not the same, they cannot be the same list. So we say if length of this instance is not the other's length, then we return false immediately. And then we're going to go ahead and do a byte comparison between the two. So I'm going to say for var I equal to 0, and then we're going to say I is less than length, and then we're going to say I++. And I wonder actually if we can say final in here. can't be, yeah, it should be a variable because it's going to be incremented. And we say if this at that place, at that byte, is not equal to the other instance at that same index, then we're going to say return false, okay? Otherwise, at the end, we're going to say return true. And I hope you can see the code in here. So we go byte by byte in both lists, compare the bytes. If any of those bytes at that index are not equal to the other one, then we're going to say return false. But if this goes through and all the bytes are equal, then we're going to return true at the end, okay? Great stuff. So that's the equality on two lists. Now that we have that, we can go and implement equality on our app state. So let's go ahead in here and say override. Override bool operator equal, and then we're going to say covariant app state other. Okay, and let's go ahead and implement this guy then. So for two app states to be equal to each other, is loading property should be equal to each other, is loading. Then we're also going to say that the left-hand side's data, or this data, or an empty list, should be equal to, using our own function, is equal to other data or an empty list. Because you see, we're doing this operating here simply because data is an optional field, okay? If you remember here, right? So if data isn't available there, we're just going to say empty list. And then the error should also be equal to other error, just like that. So now that we've implemented that, we also have to implement hash code. So let's go ahead and implement hash code in here, create method hash code, okay? It's an override, and in here we're going to use object hash as well as we've done in the other example. So we're going to say object hash, okay? And we're going to hash three properties in here, is loading, and we're going to take our data, and then we're going to take our error as well, okay? So this concludes the implementation of hash code. Let's put a put a colon at the end as well, a trailing colon, okay? So that's the implementation of equality in hash code for our app state. Now that we have that in place and we're comparing the bytes as well inside the data, it's time to go ahead and create the test file. Okay, so let's close all these tabs in here and let's go within test folder in here and create an app block test. So we're going to say app block test Dart. This app block test is going to have a few imports, and usually I don't like to write these imports. I either auto import them with Visual Studio Code, or I copy paste these imports. So that's what I'm going to do in here. Let's change these paths. So if you want to pause the video and have a look at the imports, they're not so special. Here we have a uint8 list reference to type data, so we could just say show a uint8 list. Okay. And we have block test import because we're going to do some block tests. And here are imports to app block, app state, and the block events, which are the three components needed to test our app block. Okay. Great stuff. Let's go ahead and test the initial state of our app block. So we're going to go ahead and say void main to start the testing process in here. And we're going to create a block test. Okay. So let's say block test. And the description of this one is going to be initial state of the block should be empty. All right. And let's go and build our block in here. So we're going to say we create an app block. So URLs are going to be empty. We don't need any URLs in here. Let's go and say a URL loader, because we have so many properties in here. We actually don't have to provide any of these, to be honest with you. URL loader, URL picker. I think actually the only property that we have to provide in here really is the, let's see, the URLs. So let's just provide URLs, okay? So that's the only property we have to define in here. So that's the building process. And then in the verify process, what we have to do, we have to verify that our app block dot, let's see, we have to probably in here say this is a block test of app block and app state. So that app block will then be typed correctly, because you see now it says app block, but if you don't provide these generic parameters in here, your block test doesn't know what it's actually testing. So this will be an object. So specify your types in here so you get better type references inside your verify as well. So inside verify, what we want to do is to expect that the app block.state it should actually be the app state.empty. Okay, so let's put a constant here and like that. So that's for our expectations. Let's see, isn't defined. Let's import testing. Oops, here. Flutter test and expect. Okay, so we'd miss one import. But so this is our first test. Let's go ahead and bring a terminal window in here and just say Flutter test. Okay, let's see how this goes. So now we have one test and we expect it to succeed. Great stuff. That test passed. So we've done our first test in here. Good. And that's for the initial state. Now we're going to go ahead and create like our custom URL loader and a string data extension, as you can see in here. So what are we actually going to test? We're going to go to our app block and we're going to say, hey, load a specific, load the next URL. And then we're going to confirm that the data loaded for that URL actually is what we expect it to be. So what we need is to go ahead and create some sort of an extension in here, because we're going to like fake this URL loader to return the data for something that we have control over. So in our main application, our app block loads images, but in the tests, we're kind of going to tell it to load data for a string. Okay, so what we want is having like a controlled environment here in here. So let's go ahead and say that we have an extension to list on string. So we're then going to say it returns a uint8 list, and then we're going to say it to uint8 list. Okay, so we are going to convert a string to its data representation. So we're going to say then uint8 list, and then we're going to say like that, and we're going to say from list, and then we're using our this code units, which is a list of int. Okay, and then we're going to remove this. This extension on string is going to allow us to return the data for any string object. Okay, so now that is done, let's go ahead and define our two strings. So we're going to say, I'm just going to copy paste these guys in here. So you can see we have a text1 data, which is just foo, and then it's converted to two uint8 lists. So this is now a uint8 list data representation of this particular string. And then we have bar as well in here. Good. Now that we have that, let's go ahead and do the testing for this particular example. Okay, so let's go ahead and create a new block test. I'm going to go ahead and copy paste it in here. And let's go and say that this time we're going to load a valid data and compare the states. So load valid data and compare states. And then I'm going to paste that block test right in here. Okay, and remove the verify. Okay, so this time around, we're going to change how we create our app block. So we're not just going to go with like just with URLs in here. We're actually going to insert some URL loading mechanism into our app block as well. So the first thing is going to be the URLs is going to be empty. And then for a URL picker, so which URL I should actually pick, we're going to say, okay, the URL picker is going to take, if you go back to this URL picker parameter, you know, it's of this type, and it takes in an iterable of URLs, and it should return a string. But since in this particular example, our URL loader doesn't care at all which URL has been picked by the URL picker, then the URL picker itself shouldn't really care what URL it picks. So in here, we're just saying ignore all the URLs, which is empty, and just return an empty string in here. The URL doesn't matter, okay? Now, when we go to the URL loader, we're also saying, okay, the URL that comes in here doesn't matter at all. The data that we return is going to be a future value of our text1 data. Okay, so pause the video here if you want to have a look at it. So we're basically saying the app block doesn't care about the URLs. The URL picker doesn't care about the URLs. It just returns an empty string. But the URL loader also doesn't actually care, but it returns the data for text1 data. Okay, so that's the key to this particular testing. So just to reiterate the app block, what it does is it takes this array of URLs, it passes it to the URL picker, and it says pick one of the random URLs out of this array. Okay, in here our list is empty, so empty comes in here, but URL picker doesn't care. It just returns an empty string. This empty string then in turn gets passed to the URL loader, which we still don't care about, and the URL loader's responsibility here is that for that URL, which is empty string, return some data.
So you can see we're just literally ignoring the entire chain, and at the end just returning constant data for text1 data. Okay, this creates a controlled environment for our app block. So we know that when now we go and verify the contents of this app block, the state of the app block, the data in our app state should be equal to text1 data. Okay, got it? Great stuff. Now that we have that, let's go ahead and do an action in here. So we say act, and we have our app block. So let's send an action to our app block. So we're going to say app block.add, and then we're going to say load next URL. Okay, just like that. So that's our action. And then what we're going to do is to do some expectations in here. So we're going to say expect. And in here, we're going to put our expectations. So remember, when we send a load next URL event to our app block, the first thing that it does, let's go in here, is that it emits an app state with is loading equal to true. So let's just copy that guy and put it in our expectations. Okay, boom, just like that. Great stuff. So that's the first expectation. And then the next expectation right after doing this load, excuse me, right after doing this load next URL event is to expect an app state. If you go in here, the URL is going to go through. The waiting is going to be something that is going to be also produced, but there's no state, so we don't have to test this. So in here, then we have to make sure that the app state is equal to this. So let's go in here and put this right there, and the data should be equal to text1 data, okay? And the error should be null. So that's really what we're expecting from our app block in this scenario. So let's go ahead and run our tests and see if our second test also passes. So great stuff. That test also passes, and you can actually test to make sure that your tests are working correctly as well by changing this, for instance, to text2 data, which shouldn't be true. And then you run your tests, and now all of a sudden you should get an error for your second test. Let's see, and here's the error. So there we go. It's basically saying actual is this, and it's, you see, it's saying the exact same thing. So you would, if you had a look at these two, you would be like, but they're equal. This one is this, and the second one is this. Yes, we know that, but if you look at the representation, it's coming from the toString implementation of our app state, and the toString implementation of our app state, if you go back to it, is not really printing the actual data. It's just printing has data. So the data itself is different. So here, you see, if we actually printed the contents of the data, which is usually a bad idea, you would see that the data is completely different, okay? All right, so let's change the code back to text1 data and run our test just to make sure that we didn't mess anything up in here. Let's have a look in here and see. Okay, our test passed. The second test also passed. So let's now go ahead and write the next test for this example. Great stuff then. Now that we are done with this particular example, let's go ahead and actually this particular test, let's go ahead and do the next test. We have two dependencies in our app block at the moment. If you have a look at the construction of the app block, you can see that we have a URL picker, and then we have a URL loader. We already know that our URL picker won't throw an exception, but it could throw an exception. For instance, if the array of URLs is empty, for instance. However, the exception that we're throwing manually is inside the URL loader. So if you have a look in here, we know that we have our own load URL functionality in here. However, when we call that inside this event, as you can see in here, we get the data, and this whole block in here is inside a try and catch. If there is an error, then that error will be thrown right here. So if we could somehow tell the URL loader to throw an explicit error, then we could test receiving that error then on the test side. So if this particular functionality in here, or this particular function throws an error, which because its result is a future, and a future can be forced to throw an error, as I'll show you soon, then we should end up in the catch statement and then be able to catch this particular app state with a valid error inside of our block error. So, inside of our block test. So let's go and test this functionality in here. So I'm just going to go ahead and copy this block test in here and get the action and everything in here. exactly as it is, and then maybe even the expect part, to be honest with you. So let's see if we can grab all of that from our previous test. And then we're going to say test throwing an error from URL loader. Okay. I'm going to paste this code in here. So let's have a look at the description first. Let's just say throw an error in URL loader and catch it. Okay. So that's what we're trying to do in this particular block test. Then we go in our app block, and what we're going to say is that we don't care an array of URLs, and then our URL picker also doesn't care about this empty array. It's just going to return an empty string. However, inside our URL loader, we're going to say future error, okay? And then we're just going to say errors dummy. And then we're going to go ahead and define this error in here, okay? So let's say that we will define an enumeration on top of the test file right here after the definition of our data. And we're going to say enum errors dummy. Let's go back here. As you can see, our URL loader is forced to throw an error, okay? So now that that is the case, what we're going to do is inside the act, we're going to actually send this particular event just like we did in the previous test. So we're going to tell the block, hey, load a URL. And in this particular case, we know that the app state is first going to be is loading, and then there's going to be no data and there's going to be no error while the loading is going on. However, as soon as it comes to the URL loader to load the given URL, our URL loader in here is forced to throw a specific error of type errors.dummy. So we have to go in here and say is loading should be false as the second state, data should be null, and error should be of type errors dummy. Okay, and let's make this guy a const as well in here. Okay, so that's this particular test. Let's see also if I can go to our application testing block. Okay, let's actually do, yeah, we don't actually really need to hot reload or anything because we were not dependent on the application itself. So now that is done, let's go ahead in here and to our terminal, and let's say Flutter test and see if we can test this particular scenario as well. Yes, now we have 3 tests and all 3 are passing, with the third test being the latest test that we just wrote, okay? So what now we're going to do is we've now tested the initial state. We've tested loading one URL. We've tested the URL loader throwing an error and us being able to catch it in our app state. Now let's go ahead and test the ability of our block to run more than one, to be able to load more than one URL at a time. So we're going to go ahead and copy the code that we have for the successful loading of a URL, which is this test. And we're going to copy that and we're going to bring it right at the end. Okay. You can see the successful test was when actually not the initial state of the block. That's not the one I want to test. So I want to grab this particular test, which is in here. I can see in here, we've also forgotten to change the description of our second test. You see the first one said initial state of the block should be empty, but the second test should actually say test the ability to load a URL. Okay. So let's copy this guy, test the ability of loading one URL, and then bring it at the end. And then we're going to go in the description to say test the ability to load more than one URL. Okay, so that's great. Then what we're going to do in here is let's just test the every time the URL loader is called in here, we're going to say this time return text2 data. Okay. And inside our act in here, we're going to send this event twice. Okay, so let's go ahead and make this a normal function in here. Okay, and put a comma. So I'm going to send this event twice. And that's really the only thing we're testing in this particular one, because we just want to make sure that our block is able to handle not just one load next URL event, but also 2 or more. Okay. And again, the design of these tests is completely up to you, which scenarios you want to test. I'm really just putting some ideas here in your head that, hey, you can actually send more than one of the same event to your block and test the state. So don't think that this is the way to go. This is just one way to do it. And then if you're comfortable with it, you go ahead and experiment a little bit and see if you can like send some events, or how many of those events, or sending errors, etc., and test all those scenarios. Okay. So that's great. Now that we know that we are sending two of the same events in here, and that our URL loader is loading or returning the text2 data, we need to expect first, for the first event, excuse me, the app state to start loading, as you can see in here. Then we need the app state to stop loading and return the text2 data. And then we need the exact same two states again, right? Because the next event that is sent to our app block is going to be exactly the same as the first one. And we have a controlled environment here in our app block, in that upon every load next URL event, our URL loader is going to load and return the exact same data, which is for text2 data. So the result of the first event is going to be exactly the same as the result of the second event. So we copy these two states and just paste them in here. Okay, and you can see app state again starts loading, and then app state stops loading in here. Okay. Now that we have these tests, let's just do one round of testing all of these again from the beginning. So let's just say Flutter test. And if you've done everything correctly in here, then we should have 4 tests that pass. And if you don't have these 4 tests that pass, it could be that, excuse me, one of the parameters that you provided to your block test could be incorrect, or that you've written your block or any of its dependencies, such as the app state or the events, incorrectly. So don't worry, don't panic if that's the case. If you're not getting tests that pass, that's completely fine. And I actually trust tests that don't pass more than I trust tests that pass all the time. It's just kind of like a strange scenario where all your tests pass and then you start doubting, like, am I actually testing the right things, or am I testing the things that are right? So don't worry if that's the case. Just have a look at the error logs, and then you should be able to figure out what the problem is. And if you can't figure out what the problems are, you can always reach the Flutter community, or just me myself on Twitter or LinkedIn, wherever you want, so we can have a chat about what could be done for a test. So great stuff. Now that we're done with that part, let's go ahead and commit and tag our code as we usually do. So let's have a look in here, git add all, and then I'm going to say git commit step 7. As we usually do, okay? And then we're going to tag it as step 7 as well. So if you have a look at our logs, then we have 6, 7, and then we have our tags, which are 1, 2, 3, 4, 5, 6, and 7. So great job. We're done with this example. And then we're now going to start looking at a massive example where we're using block and actions and states, and we're going to integrate as well with Firebase and Firebase authentication and Firebase storage. So let's go ahead and do that now. Fantastic. I'm actually really glad that we're done with all the other examples, since we're going to get to my favorite example in this chapter, which is going to use Firebase authentication and Firebase storage. So let's have a look at the more sophisticated app that we're going to develop in this example, and we're going to use, of course, Bloc for that. But I'm going to demonstrate to you first how this application is going to look like, because I believe if we have a look at the application itself first, then we're going to get a better understanding of how to develop it together. So let me bring up the application that I've already developed in here, and we can have a look at it together. So in this application, as you can see, as soon as we start the application, if we are not logged in, and all the login stuff is going to be done with Firebase authentication, which I'm going to show you soon how to do that. So if the application detects that we're not logged in, then it's going to display a login screen to us. So upon having this information ready, so here I've pre-populated these text fields only if I'm running a debug application. So with a username and a password, so my email is my username, and then we are using email and password authentication. So this is not really a username, except it is just an actual email address. So by pressing the login button in here, then our application is going to the backend, which is Firebase authentication, and trying to authenticate this user with those credentials. Now we're getting this given user was not found on the server. So then we should be able to go to the register screen. So apart from the login screen, then we're going to have a register screen as well. And as you can see, the register screen is very, very similar to the login one, except that it does a completely different thing, which is to register that user. So and then I'm going to press the register button in here, which is going to do its thinking. So it registers that user, and also it will then log that user into the application. So here we have the user then, and as soon as we end up on the main application interface, you can see we have a photo gallery, and then we have two buttons in here. So the goal of the application that we're developing is to create the ability for every user to be able to upload their favorite photos, and we're going to store these photos in Firebase storage. So every user, they're going to have their own photo album, which is separate from all the other users. So if I log into the application, I'm only going to see my photos, and if you log into your application, you're going to only see your photos. So I'm greeted with this empty screen at the moment, and then I have an upload button in here, and I also have another button in here. So let's have a look at this one first. So we have a logout button, and then we have a delete account button. So let's try logout first. So pressing logout will display a dialog to the user, and it will say, are you sure you want to log out? And then if I say logout in here, then I'm logged out of the application as I'd expect. Press and log in again, and then it should take me to the photo gallery, since my account still exists on Firebase authentication. Then if I click this one again, and this time say delete account, it says, are you sure you want to delete your account? Cancels that dialog. And if I go and do that again and say delete account this time, it does its loading and sends me back to the login screen. Upon trying to press the login button, then I will see that my user has been completely deleted. So, and if I register, I get registered, and it doesn't tell me that the email address is already in use. So let's say now that we log out, and then I try to register with the same email address and press the register button, then we will get this error in here that says email already in use. So what I want you to know is that we have quite a lot of error handling in this application. So we're talking with Firebase authentication, Firebase storage, and we're having actually a good mapping of all these errors that come back from Firebase authentication, Firebase storage into local error objects that our application is going to be able to display to the user. So if we say register, it says email already in use, and I go back to the login screen and I say login, and then I'm in the application. So we've had a look now at logout and delete account. Let's have a look at also uploading an image. So if I press the upload image, you can see that we will have an image picker. And if I click on any of these images, then it will do a loading dance in here, and it will display that image here inside a grid view. And if I press this button again, I can upload another image, and you will see the contents being then displayed here. So, and all of these are stored inside Firebase. So let me maybe show you how that part actually looks like also, just short. So if I go ahead and perhaps bring a Safari window up. So let's go in here to console, Firebase, google.com. And then I'm going to switch to the account that I've created that project with. And let's have a look at this project. It is called Bloc Photo Library. Okay, so if you go into this Bloc Photo Library at the moment, then we have this Firebase authentication. So if you go to authentication, you can see that there is a user in here. So I'm going to make this a little bit bigger. You can see that we have a user in here whose email address is this, and then this user was created and it's an email provider. Okay, so that's that part. Let's now go to our storage in here. Okay, so tap the storage, and then you can see that there is a folder created inside this storage, and this folder just happens to be having the same name as that user's user identifier. Actually, let's go back now to our authentication in here and have a look at this user ID. You can see it is XSIVZX, and if we take this and copy a part of it and go back to our storage, you will see that this folder is exactly the same as that user ID. So what we're going to do in here is going to have some security rules applied to our storage that will make sure that a user with a given user ID is only able to see his or hers folder and nobody else's folder. So we're going to do some checks in our security rules in here in storage rules, and we make sure that a user with the user ID of X is only able to fetch the contents of a folder called X. So we're going to have different folders per user, and then every folder for that, that folder for that user is then going to include the contents that that user has uploaded, as you can see in here. So if I bring up the simulator, you can see it's this photo, and then we have another photo, which is this one. So we can also add I can just show you in here as well. So if this user says delete account and then deletes their account, let's go ahead. And then if we go back to our storage and refresh this, you will see that if I go back in here, that entire folder is actually gone. So by doing a delete account, what this user is going to do also is not only are we going to delete that user's authentication account. So if you go to authentication in here, you see that user doesn't exist anymore, but we're also doing a check in here to make sure, okay, if the user is deleting their account, we also have to delete the contents that they've stored inside our application. So there's lots of moving parts in here. We have lots of dialogues. We have 3 completely separate screens: the login, the register, and the photo gallery. We also have the ability to log the user out. We have the ability to delete the user account and their contents. And we have the ability to upload photos, and of course, the ability to display the uploaded content. So there's lots and lots of things that are happening in here, and we're managing all of that with Bloc. So in this example, it's going to be a huge example, and I really wanted to display, show you the ability to create a complete application together with Firebase and Bloc, because all the other stuff that we've done to this point, all the other examples we've done in this chapter up to this point have kind of been the preparation to create something this big. So and what I mean is that if you want to go grab a cup of tea or a coffee, because this example is going to be a long one. So let's do it then together. Let's get started. And what we're going to do in here, we're going to go and delete all the code that we've written up to this point, because we've committed all that code, so it doesn't really matter. So let's see if I can go in here and delete all the code that we've written. Okay. So let's go in here. We have views and Bloc extension. So let's just completely delete all these and keep the main Dart file. So let's say delete. Okay. And then all those are deleted. And I'm also going to delete the test that we've created in here. Okay. And let's go to our main application in here. I'm going to decrease the size a little bit so we see a little bit more of the code. And I'm going to say this is a Flutter scaffold application in here. Okay. So this is now running there. I'm going to stop the other application, and let's just see if we can stop this application execution as well. Say select device and run our app on the simulator just to see that we got our Flutter scaffold application. So hopefully this launching is going to go fine, and we're going to see our application running with a simple scaffold. Okay. So while all of this is going on, we're going to go actually to the next stage. So in this app, as you saw, we're heavily dependent on Firebase. So what you need to do is to read about adding Firebase to a Flutter application, because although I really want to be able to tell you all the information necessary to go through with this example, but if I did that, this video would probably be about 30 hours long. And I've already created a video for Flutter, for learning Flutter, which is 37 hours long on YouTube in my channel. And also it's available on Free Code Camp's channel. So unfortunately, I won't be able to go through all the details. I'm going to skim over some of the basic stuff like setting up Firebase. So I really hope that you're familiar enough with setting up Firebase in your Flutter application to be able to go through with all the steps, but I'll also do my best to explain almost everything to you. So have a look at this URL that I provided for you. So if I, for instance, open that URL as well here. So let me just copy that URL and bring it up in my Safari window. So if you open this URL, which is the console Firebase, you can see that there is a documentation in here, and you can always also search for Firebase Flutter, and then you can have a look at Flutter Fire documentation that tells you exactly what to do if you want to add a Firebase to your application. So this is the important part, to be honest with you. This is what you need to go and read more than you have to look at the Firebase console. So I suggest that you have a look at this Firebase Flutter.dev docs overview, which is basically the URL that I provided at the bottom of the screen. Okay. So what you need to do first is to be able to install Firebase tools inside your terminal. So if I go to my terminal in here, I can say Firebase, and this is the utility that you will need in order to be able to continue with this example. So if you haven't done that, go ahead and basically search for Firebase CLI install, and you should go to the Firebase CLI reference in here, and then you will see detailed instructions on how to install Firebase CLI on your host machine. I'm using Mac OS in here, but I also have a Windows and a Linux machine. So I've done the installation of Firebase CLI on all these 3 machines in here, and it's gone perfectly and smoothly. So if you're using Linux like I do, I have an Ubuntu machine. You can also use apt, I believe, standalone npm you have, right? You can also install with npm, so that's really good. Or you can use this as well. So this is going to work well as well. And then you have the Windows installation. And I know from my own experience that the Windows installation for Firebase CLI, it could be improved, to be honest with you. I had to use npm, and when I used a standalone binary, it didn't work so well. I was getting like dependency errors. So if you're on a Windows machine, I suggest that you use the npm variant to install the Firebase CLI. Excuse me. All right. After you've done that, what you need to do is to log into Firebase CLI, and you do that by using Firebase login. So I've already done that. So if I say Firebase login, it should tell me that I've already logged in with this email address. But after installing Firebase CLI, what you need to do is just to issue this command and ensure that you're logged in globally in your system with a Google account under which all your projects are going to be created, okay? Because we're going to use Flutterfire CLI inside the terminal to create our project, and that is then going to use the Firebase CLI in order to understand which user you've logged in with and which user should create the project under. So go ahead and log into your Firebase CLI using Firebase login. And after doing that, what we need to do really is just to follow the instructions that were provided in this documentation. And I'm providing those steps one at a time in here for you. So as you can see at the bottom of the screen, I said run Flutter pop at Firebase core. And that information really should be provided also here, as you can see. So if you want to go ahead, just follow the steps that I'm providing at the bottom of the screen. So what we're going to say in here is to Flutter pop add Firebase core. So we're adding Firebase core library to our Flutter application. And I personally have had some problems with Firebase core installation using Flutter pop add. And there will be a step coming soon, actually, that I will explain. If you're getting some errors with your Firebase installation, then you need to follow these steps that I provide to you in order to fix that error. But let's just say for now that everything is going to go as planned, okay? So now that that is done, we also need Firebase storage. So let's go ahead and add that. Flutter pop add Firebase. Ooh, I can't see anything. So let's close this terminal, open it again. So Flutter pop add Firebase storage, as you can see at the bottom of the screen. So this is also going to go ahead and add Firebase storage to our PopSpec YAML. So let's open PopSpec YAML in here, okay? And we should be able to see Firebase core and Firebase storage in here. Great stuff. So that's another step done. What we also need, if you remember from this example, we had an image picker. So, ooh, did I delete that user? Seems like it. So register and log in. We have this image picker in our application. So this is not something that is built into Flutter, but it is actually a component that we're going to drag into our application. So if you have a look at PopDev and have a look at image picker, like this, you'll see that there is a plugin available that is by the Flutter team, and it is as good as a native plugin, you would say, because it's done by the Flutter team themselves. So we're going to need that plugin as well. So let's go ahead and say Flutter, as you can see at the bottom of the screen, Flutter pop add, and we're going to say image picker. Okay. So that's great stuff. It's going to add image picker to our application. It's going to take some time probably. Okay, that part's also done. And also, we are gonna need some sort of UUID library. So what we're gonna do, you see, when the user picks an image and wants to upload it to Firebase storage, we kind of need a name for that image. We kind of need to know, okay, here's an image, here's a completely random image that you picked from your photo library. We need a name for it in order to be able to upload it to Firebase storage. Firebase storage always needs like a reference. So in order to generate some sort of a reference, we're using the UUID library, and this UUID library just creates a random UUID for us. So, and that's why we need this library. That's what I'm trying to say. So, excuse me. So let's go ahead and say Flutter pub add UUID, which is a third-party package as well. But we need just only a v4 UUID, so we're not using the entire library really, or the entire package. Okay, now that you're done with that, you need to activate a Flutterfire CLI, because we're now going to go set up our Firebase project, and that instruction is really provided right here, so I'm not making that up. It is right here, as you can see. It says Dart pub global activate Flutterfire CLI. So I've already done that, but I'm just going to do it one more time in here. And I can actually see it's downloading some dependencies. Maybe my dependencies were a little bit old. And it's done with its work now. Great. Now that we're done with the activation of our Flutterfire CLI, what we can do is to go and do the fun part, which is to configure our application and basically set it up. So let's go ahead and let me bring up that caption at the bottom of the screen as well. So let's say Flutterfire configure, okay, and see what happens in here. It's fetching available Firebase projects, and it's asking me, okay, am I going to use any of these existing projects, or am I going to create a new one? So let me bring this up a little bit more so you see it better. And I'm just going to say create a new project. Okay. So go ahead and choose create a new project. And now it says, okay, what is the name of this project? So in this one, I'm just going to say I'm using Bloc Photo Library course, because I've, as you know, I've already implemented in this entire example in another project, and I've already taken the name Bloc Photo Library. So in this particular one that I'm showing you, I need to use another name, because remember, these names are kind of like global. So if I've taken that, nobody else can take that. So let's go ahead in here and just say Bloc Photo Library course. I wonder why I can't actually see that entire name in here. So let's go ahead in terminal and try to do the same thing. So let's go ahead into, I mean, I've had this problem before. Sometimes it doesn't show the entire content that I'm typing. So let's go ahead into this folder, and I'm going to say then Flutterfire configure. Okay. So let's go here and see Flutterfire configure, if I'll have more luck in the actual terminal, maybe. And then I'm going to say create a new project, okay? And then let's go ahead and say Bloc Photo Library course. Yeah, I have better luck here in the actual terminal than I had luck in the terminal, which is embedded into Visual Studio Code. So if you have the same problem where you can't see all the characters that you're typing, go ahead and open an actual terminal window. Maybe a bug in Visual Studio Code, I don't really know. So Bloc Photo Library course, I'm just going to enter that, okay? And then it's going to ask us about the target platforms. And, you know, Flutter now supports Windows, it supports Mac OS. We also have like Linux support, kind of. And also we have iOS. I mean, we have everything, iOS, Android, web, everything. So now it's going to ask us which platforms we want. In here, as you can see, web is also pre-selected. I'm going to use the space key to remove that selection in here. So we're just going to go ahead with iOS and Android for now. So I'm going to press the enter button in here. Okay. And then it's going to ask us for a bundle identifier for our iOS application. So for the Android one, it's going to probably set it manually, or it's going to set it automatically. And for iOS, it's asking us now which bundle identifier we want. Now, my company here in Sweden is called Pixology. So I'm going to go ahead, and my domain name is pixology.se, as in Sweden. And the reverse domain style a bundle identifier that I'm going to use for this application should start with SE Pixology, because it's a reverse domain name. Okay, instead of pixology.se, I have to say se.pixology. And then I'm going to set up the name of the actual application here. So Bloc Photo Library. Oh, now I can't see the entire text that I'm typing either. So maybe as soon as it goes off the screen, it can't render the entire thing. So let's see if I can do this configuration again this time so that I can actually see what I'm entering in here. So one more time, Flutterfire configure. To be honest with you, it could be a bug even in Flutterfire configure. I don't know. So here we have the block photo library course. And let's say we don't want the web. And then let's go ahead and do this, fetching registered app identifiers in here. And it's going to ask us for the bundle identifier for iOS app. I'm going to say SE Pixelity, and then I'm going to say block photo library course. But yeah, it was just getting cut off where the terminal was cut off, like on the screen. Okay, now that we've gone through this one, I'm just going to press the enter button. So it's now registering the application for us. Okay. And if everything goes fine in here, then we should have our application set up. Great stuff. Now I can see at the bottom of the screen, it's giving me the Firebase app ID, and it's showing the iOS and Android platform. What I'm going to do is I'm actually going to show you this entire thing, because by the time that you're watching this video, I have gone and deleted this project anyways. So don't worry about any kind of security stuff in here. But if you are developing your application, please don't show this Firebase app ID to anybody, because it is a security risk, and in that some other persons can get access to your Firebase application and wreak havoc maybe on your Firebase authentication or just your Firebase installation as a whole. Okay, now that part is done. Let's go to our actual application in here in the Flutter application, and let's see how it's working. So now we have Firebase installation, and this is one of the things that I mentioned in the beginning of this example, that you may have some compilation errors in here. As you can see, if you go to this Firebase options.dart file, it was marked as red, like a red color in here, meaning that there are some errors in here. And that's exactly what some of you may also encounter. You may encounter that there's errors in initializing this Firebase options. And the problem in here, really, after I've dug deep into this and found out what the problem actually is if you go to your pop spec YAML, you'll see that when we installed Firebase core, this was the version that was handed to us by Flutter pub add. However, if you go to pub dev, and in here you say Firebase core, and if you have a look at the installation example in here, it will tell you to go into your dependencies in PopSpec YAML and add this particular version. You can see it says 1.13.1. However, for me, the Firebase core version is like 0.4.2. It's like a really, really old version of Firebase core. So what you need to do in that case is just to put the new version in here like that and save this file. Okay, so 1.13.1 I can see in here. And then now that we're here, let's just go ahead and look for Firebase storage as well. So I'm just going to say Firebase storage just to make sure that we have the correct version. Let's go to Firebase storage and into installing. And I can see in here it's using Firebase storage 10.2.9. And if we go here, Firebase storage, see in here it says 3.1.6. So this is like really, really old. So let's go in here and say Firebase storage should be 10.2.9 in here. So let's bring it in here. Now that we're at it, let's have a look at image picker as well, because you can't be sure really that we're using the correct version. So let's say image picker, and installing, I can see it's using 0.8.4 and here it's 0.7. So let's pick this version in here and say that's the version we want, and UUID as a 3.0.6. So let's search for UUID, and let's go in here and have a look at the version that we should be using is 3.0.6, which is the correct version in here. Great stuff. Fantastic. Now that we have that, we can see that Flutter pub get running is applied in here, and then we don't have any red errors inside and this Firebase options Dart file, which is placed here. So if you've done that correctly, then you should be really good to go. So what I'm going to do, since we've added a lot of plugins, and these are like actual plugins with binary files that are going to be embedded inside our iOS and Android application, we've been running this code in the iOS simulator before we added all these plugins. So what you need to really do is just to do a whole clean setup now. So let's go in here and go to our application terminal. Let's say, sorry, to Visual Studio Code's terminal. I'm just going to say Flutter clean. Okay, and this is going to clean all the artifacts that have been, all the derived data and stuff. So let's go in there and say Flutter pop get, so to install the dependencies from the beginning. And that's going to do its job. And let's have a look in here and see if we can do a select device and then run our application. Let's see now if this is going to be successful, because if this is successful, then you've successfully installed all your dependencies. So I'm actually glad that we're getting these errors. You can see now we're getting some sort of a pod error. Let me bring the window up so you can see it. So you can see it says, yeah, lots of errors, and this is with CocoaPods for iOS. So what you need to do in this case is to go ahead in your terminal, go to the iOS folder, and just say pod deintegrate first, so to remove all the dependencies from your iOS application, and then say pod install that -- repo update. And this is going to, let's see what CocoaPod could not find compatible versions for Firebase storage. So in pod file, okay, specs satisfying the Firebase storage dependency were found, but they require higher minimum deployment targets. So this is interesting. What we need to do now is to go to our pod file in here and set this platform iOS to maybe 13, just like that, okay? And then we're going to say pod install repo update. Now it's installing all our dependencies, and I can see that it succeeded. So now with that, let's go back to the terminal. I'm going to cd back to the root folder. And yeah, so now that is done, we should be able to run our application. So let me bring up the debug console in here, clean it somehow, and then try to run the application one more time and see what happens. If I can bring this down a little bit like this, and then try to run the application now. So really what happened in here is that we were getting a lot of dependency errors. The dependency versions were incorrect. In here, knowledge about native iOS or Android development could be really potentially like life-saving, kind of. Well, I'm exaggerating a little bit, but you can also Google all these things up and like find the solutions on Stack Overflow. But I know that a lot of Flutter developers could get confused about dependency management, because you don't just have to handle dependencies in your Flutter application, but Flutter itself, when you add dependencies to your pop spec YAML, is going to go ahead and add dependencies to its native platforms, iOS and Android, for instance. And then you need to know the dependency management for those platforms as well. On the iOS side, Flutter is using CocoaPods for dependency management, and we have Gradle than for the Android part. So knowledge of Gradle and then CocoaPods could be really, really important. And it's kind of like outside the scope of this this chapter, or this course in general. But you can go ahead and read about CocoaPods if you're not familiar with it. On the internet, they have their own website with good documentation. Great. So if we did everything correctly, now we're inside our home page in here, as you can see, and our application is running and we don't have any errors. So that would be like the absolute first step of setting up our application for this example of this chapter. So now that we fixed all these dependency errors and we've gone through this nightmare of fixing not only the Flutter dependencies, but also CocoaPods, let's go ahead and get started with the actual implementation of our application. If you have a look at the documentation that I mentioned to you before in here, you'll see that after all the configuration, you need to go ahead and do the initialization of the app. And there's information on how to do that. You'll have to first go and import Firebase core in here. If I just make sure that this is large enough so you can also see it on maybe on a smaller mobile screen, you have to import these two files in here. So let's go ahead and do that right now. And let's go to our, let me see if I can bring up Visual Studio Code. Let's go into our main Dart file, and you should have a material app and a home page, okay? Let's go and do our imports in here. And I can see in here the default importing is done with Firebase options. I really don't like to import my files just like this with relative paths. I want to import them with full paths. So I'm going to remove that part in here. And let's go ahead and have a look at the next step. You have to first make your main function an async function in here, okay? And then after doing that, you have to do this widgets flutter binding ensure initialize to make sure that the Flutter engine is running before the run app is called. And then what we need to do is to do this await Firebase initialize app in here. Okay, so that's the next step. I'm going to copy that code and bring it in here. And now I'm going to get this error, default Firebase options. And then I'm going to import it with its full path, as you can see in here, instead of just importing it with Firebase option start. Okay, so that part's also done. I'm going to do a hot restart of the application. And let's go back to our simulator just to see everything's working as expected. And also there's no errors printed to the debug console in here. That's great. That's fantastic. So let's go ahead and create an app out of our material app in here. As you can see, we have material app right here, and any changes to the main function, as you know, won't be reflected on the screen in our Flutter application by a hot reload. So if you're changing your main function and you want those changes to be affected, then you have to do a hot restart. To get around that problem, let's go ahead and create an actual app, which is a stateless widget, out of this material app. So what we're going to do is to go ahead and say that we're going to take this guy in here, material app, and I'm just going to right click on it and let's just say extract widget. Okay, and I'm just going to call this guy app, as you can see in here. Okay, so then we have an app in here that says stateless widget. So let's go ahead and put it in its own file. So what we could do is just to go to lib, and or maybe we could actually do it later, so it doesn't necessarily have to be in a separate file right now. So now that you've extracted your app, let's make this a const as well. So now what you have in your main Dart is the initialization of Firebase and your main function, and then a run app call, and it shows our app stateless widget, as you can see in here, and our app initializes the home page, which is also available down here. So let's save our main Dart file and just do a hot restart. And if we bring up our simulator, then we should be able to see that it's working as expected and no errors in the debug console. That's fantastic. So this application is going to work a lot with Firebase authentication and Firebase storage. So we need to just jump from Visual Studio Code into Firebase console every now and then to fix stuff or maybe add some security rules. So it's good to have Safari or Chrome or whatever your favorite web browser is, to have that open on Firebase so that we don't have to jump in and out so much. So great stuff. Now that you're in your Firebase project in here, let me go back in here. Let's just make sure it's the correct project. It says Bloc Photo Library, and I want to go to Bloc Photo Library course, which is the new project that we created. Okay, so it should look kind of like this for you. Then what you need to do now is to go into the authentication section of Firebase, and in here, what we need is to say get started. Okay. So in here, when you tap get started, then what you want is to go ahead and enable email and password authentication. Okay, so let's click on this and then say that this is enabled and press the save button. So now we have email authentication, and then we have this user section because we've enabled at least one authentication provider. Okay, so that's that part. What you need to also do is to go ahead and enable a Firebase storage. So let's go ahead and see if we can make this screen a little bit bigger, and perhaps if you could see the entirety of these. Okay, so what you need now, as you can see at the bottom of the screen, under build, you need to go to storage, and we're now going to go ahead and enable storage for our application. Okay, so let's go ahead and do that. Let's just say get started. And here it's going to ask you if you want to start in production mode or in test mode. In test mode, what it's going to do is just going to allow anyone to pretty much do anything. But we don't want to do that. We're just going to say start it in production mode. Okay. So let's go ahead and do that. Then it's asking where we want to create the, where we want to store the data. Since I'm in Sweden, I just kind of want to choose something like Europe Northeast or something. So depending on where you are located, you may be in India, Brazil, Africa, wherever, then you should hopefully choose some server that makes more sense for you. And to be honest with you, this is kind of like more a statement, as for instance, in Europe, you want to make sure that the server that stores your data is as close to you as possible because of like GDPR rules and etc. But Firebase is it's under Google's umbrella, and it's following GDPR rules as a whole. umbrella, so you don't have to worry about it so much. But this is more like, okay, which server is closest to me? It just feels better as well. So we have Europe West, and then I can see here we have Asia, and then we have Europe Central. And maybe I should actually choose Europe Central, because probably that's the closest to me at least. So I'm going to say Europe Central in here. Okay. And then press the done button. And this is going to go ahead and create a default bucket for us. And this bucket, just this default bucket is going to be free. And this bucket, as its name indicates, is just a storage place that you can put your files into, just like a normal bucket. Okay. So this is going to go ahead and do its work. And then at the same time, I'm actually going to go ahead and open the security rules for the other project that we have to kind of like imitate, basically. Great stuff. So let's have a look here now at the security rules in here. Great. So you can see now we have our storage, and then we have files, and then we have rules in here. Since I've increased the size of this, I can see that rendering isn't done so well, unfortunately, with CSS in here. So if I decrease the size, I can see it is actually rendered nicer on the screen. But if I increase the size, it kind of gets messed up. And that's okay, because really all we need right now, at least, is to, whenever we're changing something here, to be able to see the publish button. So you don't have to see what's on the left-hand side. All right. So that's completely okay. Okay, so now that is done, please go ahead inside your storage section. As you can see, it's on the left-hand side under Build Storage, and then go into the Rules tab, okay? So if you remember, I mentioned that in this default bucket, every logged in user is going to have their own folder. So let's say first user has the user ID of A, and the second user has the user ID of B. Now, this user ID of A is going to create a folder called A in our bucket, in our default bucket. And the second user, so in here, you see the first user is going to have a new folder called A, and the second user is going to have another folder called B. And these two users should not be able to access any other person's folder except for their own. So in the rules section, what we want to do is to define that role and say, given a user ID of A, that user should only have access to a folder at the root folder called A. And that is it, okay? So in here, we have this match all paths, but what we want to do is to say, after this first path, which is the root path, this slash, we are kind of like looking to target a user ID. Okay, so you can actually make that a pattern in here. Let's just say user ID. Okay. So after doing this user ID, we actually kind of want all paths after that as well. So let's just write it in here. We just say curly brackets, user ID, okay, like this. And then after that, then we want to have access to everything under that path. So really what this did is that now we're doing pattern matching against the root folder slash a given string, and then we're putting that given string inside a variable in here called user ID. Okay, so this is not just some magic identifier that I'm just finding. You could just name this anything, user identifier of my choice. So what happens is that it's doing pattern matching, and it's finding the root folder, and it's let's say a user comes in and says, I want to access this particular URL. Let's say user A says that I want to access this folder, a file PNG. Then what happens is that Firebase is going to say, okay, you want to access this file? All right, I'm going to put this A inside this variable user ID, and then I'm going to call this function in here to see if you have access to this particular file under that folder. Another user with the ID of B comes in and wants to do something malicious and says, I want to access ABC. However, my user ID is actually B. Okay, then this ABC is going to be placed in here, and it's going to be handed to us, and Firebase storage is going to say, okay, user B is trying to access a folder under the name ABC, and it's going to put that ABC inside this user ID variable. And then it's up to us to check, okay, the current user's ID is B, but you're trying to access a user ID that is ABC. So it's completely now up to us to do this pattern matching ourselves as well and say, okay, actually not the pattern matching, we're going to do the rule checking. The pattern matching is going to be done in here, okay? It's going to be up to us now to see whether that user has access to that folder or not. Okay, so now that we've matched that particular pattern of user ID and excuse me, all paths, it's up to us to go ahead and define some sort of a function in here. So we want to create a function that says is folder owner, for instance. So we want to check whether a given user ID is the owner of that folder that they're trying to access. So then we say user ID as a parameter. Okay, so this is going to be passed into this function. And then we're going to say, okay, we want to return something. And in this function and anywhere inside this match, you have access to something called request. You see there's a global variable available to you in here, and then you can say request. And then you have a property under that request that says auth, okay? And in here, what you want to make sure is that the user is actually authenticated, because this is an optional parameter in here. So what you want to say is to say, okay, it shouldn't be null, all right? And then what you want to do is to say, okay, after checking for null, I also want to make sure that this user's identifier, this authenticated user's identifier, is actually equal to this user ID, okay? So we're going to say and request auth UID should be equal to user ID, just like that, okay? So let's see what it's complaining about. It's probably complaining about the fact that we're not actually using this function. So, and that's okay. Let's just keep it like this for now, okay? Excuse me. So let's see, we're having this in there, and let's actually maybe put this function one level below in here before that particular match. Let's put it in here, okay? All right. So let's just keep it that way. Unused function, and then it's a invalid variable name request. But we do have requests though. So I think this is fine, to be honest with you. That issue is probably gonna soon go away. Okay, now that we have that, let's go in here. You see we have allow read write. So what we're gonna say, while you're in this folder that we've pattern matched again this variable and then slash anything in that folder, we're going to say allow create. There are so many rules in here that you have to specify the actual access for. So create, read, update, and write. If is folder owner, and then we're going to take the user ID in here, just like that. Okay, so now you see that our errors have gone away. So, and that was a little bit of a misleading second error that we had in here. So if we remove this in here, you can see we'll get 2 errors probably if you had it like the way we had before. Let's go ahead, and this is how it was before. You can see that there are 2 errors in here, and it's telling you like invalid variable name request, but that makes no sense because request is actually available. All right, so let's have a look at what's happening here. We're pattern matching against any folder, and then we're putting that folder inside a variable called user ID, and then slash anything that you're trying to access under that folder. And then we're saying allow creation of files, reading of files, updating the folder, and then writing or updating any files under it, and then writing into this folder, as long as this particular user ID has access to that folder. And then this function is being called, making sure that you're authenticated and that your user ID is actually equal to this user ID that you provided in here. Okay, so that's really good. Now that we're done with that, let's just publish this. And also there's really good like references of Firebase security rules that I think it's good for every developer who's working with Firebase to go ahead and read about, because there are really advantages of knowing all these security rules. I mean, maybe not all of them, but at least some of the stuff that makes it easier for you to be able to add your own security rules. Okay, so now that we're done, it's actually good to rebuild your application. And this is something that I did earlier because we'd set up all the pods and stuff. But if you haven't done that, please follow the instructions at the bottom of the screen. So first do Flutter clean, then do pod install, and then Flutter pub get and Flutter run in order to build and run your application afresh, just to make sure that you don't have anything that's cached or is inside the derived data of your iOS application that's caching old versions of your dependencies, for instance. Good. With that part done, with the all the security rules in place, it's actually time to go. It's time to start building our actual application. As you can see, I've mentioned here that we have a lot of things to do. This is going to be, I think, the biggest project that I've built and put on YouTube so far. And this is, for me, exciting that this is just a part of this Blotter. This is a part of this Flutter Bloc course. Maybe we should actually change it to Blotter, as in block for Flutter. And so it's, for me, it's very exciting, but I understand it's also could be quite challenging to go through everything and like keep a sane head. But I'm gonna walk you through all the steps, so don't worry about it, and we're gonna do them one step at a time. Okay. So as you saw in the application that we're going to develop, let me bring it up again. We have quite a lot of error handling in here. So if you go in here and then log the user out, and then go in here and write the wrong password and try to log in, then we have an authentication error, unknown authentication error. Okay. And then if you go to the register and then try to re-register the user that's already been registered, then we have this error. And we have quite a lot of things in here. Like, for instance, if I try to register with an invalid email, you can see then we say invalid email. So we've handled quite a lot of authentication, registration, and then uploading errors in our application. So the first part really is the authentication errors that we're going to go and define in our application. And we're going to do that by doing like a mapping between Firebase authentication errors and local error classes that we're going to create in our application to represent every error. Okay. So when we then get to our block is not going to like work with Firebase authentication errors. It's actually going to work with local authentication error objects that we can then switch, for instance, on and say, if the authentication error is this, then display this dialog, for instance. So it's because, Firebase authentication errors, they're all like string objects kind of. So they have their own classes, but the way to know what error was actually thrown is to go ahead and read their error string. And that's not what we want to do in our application. So we're going to map these authentication error strings into local class instances and use those instead. Okay. So with that said, let's go into Visual Studio Code in here. And let's go ahead and create our file in here for our auth errors. Okay. So I'm going to go in here. As you can see, we have our lib, and then let's leave alone these two files in here, Firebase options, generator plugins. And let's go ahead and create the auth. Actually, it should say auth slash auth error. So I'm gonna fix this before we get confused. So auth slash auth error. So lib, and let's go ahead and say a new file, and I'm gonna say auth slash auth error.dart. I believe that's how I've also done it. Exactly, auth error. Big stuff. What we're going to do in here is we're going to define an empty error mapping in here for now. And we're going to say this error mapping is just going to be a mapping of, as you can see at the bottom of the screen, a Firebase error description, which is of type string, and also a type that we're going to define, and we're going to call it auth error. We haven't done that yet, so we're going to get an error, but that's fine. We're going to define that auth error soon. Okay. So let's just go ahead and say a map of string and auth error. And we're going to say auth error mapping for now. And this is equal to this. Okay. So that's good. We're getting this error, but that's okay. Fantastic. So what we're going to do is to go ahead and define an abstract class for our auth error so that this error also goes away. So let's go ahead and say immutable, okay, and then say abstract class auth error, just like this. And we don't have access, excuse me, to immutable. So let's just go ahead and import foundation in here and say show immutable, just like that. All right. So now that we have auth error, this error also went away in here. So we can go ahead and implement what we need from our auth error. So what we're going to do in auth error is to actually have two very important properties for every auth error, because every auth error in our application is going to be translated into a dialog that's going to get displayed to the user. And this dialog needs two things from the auth error: the dialog title and the dialog text. And then the OK button is just going to be something that we're going to add to every auth error dialog that we're going to display to the user. So two important properties: the title, and then we also need the description or the text. So let's go ahead and define those. So let's say final string dialog title.
title. I'm going to copy this and let's just say dialog text. Okay. So now that we have those, let's go ahead and create a constructor for our abstract class. So create constructor, and I'm going to go ahead and say comma at the end, and let's make this guy a const. And let's go back to our application so that hot reload works as well. Great stuff. Now that that works, let's go and make these both properties required. So required like this, and then curly bracket in here and curly bracket closing right there. Okay. Good stuff. We have the auth error now, but from what we want to do is somehow be able to have like some sort of a factory constructor on this auth error that it can take in a Firebase auth exception, and for every Firebase auth exception, it should be able to create an instance of auth error for us. So if you're not familiar with class clusters, what we're going to do is to define our auth errors like one by one in here. So we're going to have quite a lot of classes in here that are going to extend this auth error. So for every specific error, we're actually going to extend this auth error and create its own class. And this auth error, then in turn, what it's going to do is to take in inside like a factory constructor, take in a Firebase auth exception and have a lookup of that auth exception using its description inside this map and say, okay, for that auth exception, which auth error class, concrete class do I need to create? So let's go ahead in here and say that we have a factory constructor in here, which is auth error from Firebase auth exception. Okay, and then we need to actually import Firebase auth exception in here, but we're going to figure that out soon. And then in here we say exception, just like this. Okay. So what we need now is to go ahead from this exception, somehow create an instance of auth error. Okay, we're getting this Firebase auth exception in here, and we kind of need to import Firebase. So I'm going to see if I can import that in here. Let's see here. We got package Firebase auth Dart show Firebase auth exception. And in here is telling us target of URI doesn't exist, package Firebase auth, try creating the file reference book. Okay, let's see if we can import this manually. Firebase. Oh, we're not even getting that. So we can't even import package Firebase. So I can see we have Firebase core and Firebase storage, but we haven't imported Firebase auth. So this is something probably that we've missed. Okay, so let's go ahead into pubdev. I'm going to open pubdev in here, and let's say Firebase auth because we need that. Maybe it was one of the steps that I just missed. So let's go ahead and import that. So we're going to say Firebase auth. Let's go into our pubspec YAML. Okay, and add Firebase auth in here as well. Okay, do a save. It's going to do a Flutter pub get. And now that is added in there, we should be able to close this. And let's go in here. Now that we have the Firebase auth exception, we should be able to import Firebase auth in here. Okay. I'm really not fond of importing a whole library or a whole package just because I need one of its symbols. As you can see in here, we just need Firebase auth exception where we're like importing the entire Firebase auth Dart file in here. So let's go ahead and say only show that particular symbol. Okay. Now that we have the exception, if you look at the exception, it has a property in here. You can see this has lots of properties actually, but there's one specific property that we're interested in, and that is the code for this guy. Okay, it's a string. And that is the code that we're going to use as the keys of our map in here. Okay, so let's say in here that we go into our map. Let's say that we say auth error mapping. Oops, auth error mapping. Okay, so we need to look that key up. So we say exception dot code, and then we're going to make it to lowercase in here. Okay, and just in case, we're also going to trim it. Otherwise, we're just going to use an empty string in here. Sorry, actually, we don't need that because it's not optional. Okay, so we're going to go ahead and take that particular auth error out of our dictionary in here. Otherwise, we're going to use an auth error unknown. So we're going to say if we can't find this guy in there, we're going to say use auth error unknown. Okay, and we're actually going to return a const instance of this. So. And we're getting this error right here because it says, okay, if I can't find this,
key inside the dictionary, then or inside the map, then I need another instance of auth error. And in here, we're just saying use auth error unknown. We're getting this error simply because we haven't really defined auth error unknown yet, and we're going to do that right now. So let's go ahead and basically say that we need to implement auth error unknown. Okay. So let's do that first. So we're going to say immutable. We're going to say class auth error unknown. Okay. And this guy extends auth error. And what we're going to do is to go and create a const constructor for this guy like this. And in here, we're going to call our super and pass a dialog title and a dialog text to it. I've already prepared those two properties, so I'm not going to type them by hand because they're not so relevant to this chapter, to be honest with you. So now you can see we have an auth error unknown and an auth error in here. And it says, okay, we're extending auth error. With that done, we have a very basic setup right now. So what we want to do is to actually go ahead and have a look at how this auth error unknown is going to be created, because you can see this guy isn't available in our mapping simply because what we want from our auth error unknown is to be returned if we are not handling that particular auth code. So what's happening in here is saying, okay, given this Firebase exception, get its code, lowercase it and trim it, and then try to extract that particular auth error from our mapping. If we haven't handled that particular auth error code, then return the auth error unknown. And that's exactly what we're doing in here, okay? Good stuff. Let's go ahead and have a look at auth error no current user. So let's have a look at no current user and see what this actually means. I'm going to copy and paste it right here because we don't have the time to type all of these. And because this is also using this exact same pattern as auth error unknown in here, as you can see. So it says no current user with this information was found. So if we try to log in, for instance, or mainly actually, if we try to delete a user, as you saw that we had this, let me show you actually before I try to explain it. So in the application, if we go to the login screen and log in here and then try to delete an account, this delete account call that we're going to make to Firebase is going to throw a specific error that says no current user, meaning that if you happen to make that API call to Firebase authentication to say, hey, I want to delete this particular user, and then that user is not a valid user, and for some reason, if that happens, it's a huge edge case, then Firebase is going to tell you auth error no current user. And that's what we're handling in here, okay? So now that is there, what we need to do is go ahead and move on to the next error that we have to handle. And this next error that we're going to handle is no error other than the requires recent login. And again, while we're implementing all these errors, these are not errors that I'm making up, but these are actually errors that Firebase, and especially Firebase authentication, is going to throw to us. There's documentation online that describes all these errors so that you can go and have a look at them. So you can see the mapping, like the error strings that are going to be thrown at us. For instance, at the moment we have this mapping here, and we're going to put the keys that Firebase throws at us. So let's just go ahead first and implement the classes that we know are going to be useful in defining this mapping in here from a Firebase authentication error to an auth error. And then when it comes to implementing this map, then I'm going to show you some of those keys and how we're going to map them to our classes. So let's go ahead and implement the next auth error. So I'm just going to copy this one from here, and let's go ahead and paste it one more time in here. And this time around, we're going to call it, as you can see at the bottom of the screen, auth error no current user. Actually, no, we've already done that. Sorry, we're going to go ahead and do auth error requires recent login, as I mentioned before. So auth error requires recent login, and then let's copy and paste it in here. So this author requires recent login. I'm also going to grab its text and the title and text, so I don't have to type it manually. As you can see in here, it says requires recent login, and you need to log out and log back in again in order to perform this operation. And what could happen in here is that if you, for instance, have a user's log into your app for like a year ago, and then they start your app again after a year, and then they're in the gallery. However, when they try to upload an image, then at that point, you may receive an authentication error from Firebase saying that this user hasn't logged into the application for so long that they have to log back in. So what you'll need to do in that case is to ask the user to log out and then log back in the application in order to receive a new authentication token. So that's what this error is for, okay? Then what we're going to do, there's another operation and another error that we have to handle, and that's called not allowed. I think operation not allowed, as you can see at the bottom of the screen. So since this process is quite tedious in that we're just literally copy pasting code, so I'm just going to chuck another one in here, and you can see it says author operation not allowed, and it's extending author again, and the only thing is changing in here is just the dialog title. Operation not allowed, you cannot register using this method at this moment, maybe we should just say, okay? So we could also have a look at this. For instance, if I bring up a Safari window in here, let's go ahead and search for some auth errors. So let's just say Firebase auth errors. And let's see if we can find some of those authentication errors in here. Okay, as you can see, here's a website that describes all these authentication errors that could happen. And let's go ahead and have a look at this particular error, operation not allowed here. Missing here, operation not allowed. As you can see, it says the provided sign-in provider, the provided sign-in provider is disabled for a Firebase project. Enable it from the sign-in method section of the Firebase console. So if you, for instance, if the user tries to log into your application and then you haven't enabled email and password sign-in method in your Firebase authentication on the Firebase console, then you will receive this particular error from Firebase authentication. So again, if you follow the steps that we have gone through in this chapter, you should have enabled sign-in method with email and password in your Firebase console. So if I go in here and say console.firebase.google.com and make sure that I'm logged in with my account. So in our Bloc photo library course, if you go inside authentication in here, sign-in method, then email and password should be enabled. However, it is very human to forget these things. And if you've forgotten to enable email and password authentication, and then you go into your Flutter application and try to log in, then it's going to tell you operation not allowed. So it is very important that you do a mapping of these errors, because if you don't do this, then you are risking yourself being confused by getting a very strange error from Firebase saying operation not allowed, and you'd be like, what happened here? But if you have like proper mapping for it, and especially if you have some comments on this, so you would say, for instance, email password sign in is not enabled. Remember to enable it before running the code. Okay, so if you add some comments in here and you tell yourself that, hey, if we get this error, then I should go ahead and enable email and password. Okay, however, it's also important to understand that this error is not going to be thrown only if you've disabled or if you have not enabled email and password provider. This error is going to be thrown if you try to sign into Firebase authentication with any sign-in method when that sign-in method is not enabled. So if you, for instance, go back to Firebase authentication in here and say, okay, let's see, users and sign-in methods, add new provider. Let's say that you want your users to log in with Facebook, okay? And then you go and enable that inside your Flutter application and add the Facebook authentication. And then when you try to actually authenticate, you will eventually receive the exact same error, operation not allowed, if you have not enabled Facebook provider inside your Firebase authentication settings on the Firebase console. So these are not things that we're making up. These are like valid errors that are going to be thrown by Firebase authentication. And it's very important that we have a good mapping between the errors thrown or the possible errors thrown, and also with proper classes that describe what's actually happening. If you look at this file in here, this is Firebase Google.com docs auth admin errors. There's lots and lots of errors in here, but just a disclaimer, we're not going to go and do the mapping of all these errors. So we're just gonna I've handpicked and kind of like made sure that we're only handling the most important errors and the most probable errors that are going to happen inside our application. Okay, so good. Now we're done with author operation allowed. Let's go ahead into the next one. And if you haven't done this, I mean, we've already done this author unknown. So let's go ahead in here. We have author unknown. So we've already implemented this, but if you haven't done the author unknown, it kind of probably also means that you haven't done this part. So if you haven't done that, please pause the video now and go ahead and implement author unknown and also the author from factory method of your author class, okay? So another error that could happen is if the user tries to log in with a credential that doesn't exist. So let's go ahead and implement that as well. I'm going to paste that code in here since this process is so tedious. So we have author user not found, and you can see it extends author again. And then it has a constant constructor with a user not found as the title of the dialog, and then the given user was not found on the server. So this could happen if you try to log in with a credential for a user that doesn't exist in the given provider. Okay, so let's say you try to log in with an email and password that doesn't exist in the system. We can actually test that. So if you go to our this application, I think we had did we say testing block? Yes. So let's log out of this. And if I try to log in with a user that doesn't exist, let's say .se, that's fine. And then I try to log in, and you can see it says user not found. The given user was not found on the server. And that's exactly the error that we're defining in here. Okay, so now you know the reasoning behind having this particular error, for instance. Now, if you go ahead and, for instance, try to register a user inside the register screen, and let's change this email to SE, and let's put a password in here, and let's say AA, and then try to register, you can see that we get an error message in here that says weak password. So this is simply, as its name indicates, it is a password that doesn't meet the standards of a normal password, a normal, well, relatively secure password in Firebase authentication. So let's go ahead and add that error in here as well. So I'm just going to go and check it. In here, it's an immutable class. Again, extending author, we don't have to explain that. The title says weak password, as you can see in here, and the content says, please choose a stronger password consisting of more characters. And that's exactly what we've written in here, as you can see. Okay. So that is author weak password. And what we're going to go ahead and do now is to implement author invalid email. So let's go in here and change this password, for instance, to something more secure. And then inside here, change this, remove this @ sign, and then try to register. You can see it says invalid email. Please double check your email and try again. So that's the next error that we have to implement. And I'm going to copy paste the code again, so no surprises here. Let's have a look. And it says author invalid email, extends author. And then we have a dialog title of invalid email, as you can see in here, and then a dialog text that says, please double check your email and try again here. Okay. And again, these are like suggestions, to be honest with you, as the title and the text of the dialog. These are not like guidelines. I'm not saying that you have to write these texts. These are just some texts that I've written. So if you have any suggestions on making these better, I hope that you can do that for the application that you're developing on your site by following this tutorial. Okay, now let's say that we try to log in with an email that already exists. Okay, so this email already exists and has been registered with Firebase authentication. If the user tries to register with the same email, then we will get this particular error. As you can see, it says email already in use. Please choose another email to register with. So let's go ahead and implement that particular error as well. Right here, and we're going to paste it. You can see it says email already in use, and the class is called author email already in use. Okay, and the dialog says please choose another email to register with. Fantastic. So what we need to do now, after we've done this, we need to go ahead and do our mapping. So for the mapping that we have in here, the goal is that we take these errors that are provided in here, and then we're going to go ahead and map them to these errors that we've defined in here. So let's have a look in here, how many errors we have. 1, 2, and then we have 3, 4, 5, 6, which is this one, and then 7. We have 8, but this one is something that we're actually only using here in the factory constructor. So we have to put 7 error mappings in here. So let's go ahead and add all those. So the first one, we probably should go ahead and do this user not found. Okay. So let's go to this user not found and find this authentication error that comes back from Firebase. So if you go user not found, okay, and this is the error. You can see it says auth/user not found, but the error codes that come back from Firebase, they're going to be embedded inside a specific authentication error. I think it's actually called Firebase authentication error. And since the class name actually says authentication error, then the actual code, which is a string in these authentication errors, is not going to include the part that says auth/. So the error codes that come back from Firebase authentication error are actually going to be these strings that are followed after the slash. So let's take user not found, and I actually suggest that we go ahead and add it here on top of the class name itself, so that we know in the future that this is user not found error. Okay, auth/user not found. Let's go in our mapping and add the first one. So let's just say for the key of user not found, then we have an auth error, user not found. So this is how we're going to define our authentication error. So we don't have to do a huge if statement later, for instance, and say, okay, if the string is this, then do that. If it's this, then do that. We're already doing that kind of stuff in this factory constructor without the if. So what we're making sure is that we have author mapping in here that goes into the key and looks for a specific author. Otherwise, it returns author unknown. Let me also put myself here in do not disturb, just to make sure I don't get any email noises, which I heard just a few seconds ago. So that's user not found. Let's go ahead and do the weak password part. So if you look in here, weak password, password, is it not defined? Invalid password, invalid. Interesting. It seems like the weak password is not actually defined in this table. So it is a little bit strange. However, it is actually a valid error. So let's go ahead and say Firebase authentication error. And then we're going to put this weak password in quotation marks. So let's have a look and see if that is documented somewhere. It is not documented in here. Strange. Let's go to the JavaScript SDK. Here it is, auth weak password. So it was a little bit strange that the link that I provided at the bottom of the screen, which is this official documentation here, doesn't actually include the weak password. But let's actually see why that could be. In here it says, here's a full list of error codes in the description, including recommended resolution sets that are thrown by the Firebase admin Node.js authentication API. So maybe, just maybe, the Node.js authentication API doesn't actually include all the errors. So, or they haven't just documented it. So what we could do just to send feedback maybe to them and just tell them that, yeah, you forgot to include the weak password error. But we know that their weak password is a possible error that can be thrown. So let's just go in here and just say auth/weak password. And let's go ahead inside our mapping in here and say we have a weak password in here and just say auth error weak password. So that's for the second error in our mapping. And after handling the weak password authentication error, we can go ahead and implement the next one, which is for invalid email. So let's go ahead in here and look for that particular authentication in here and look for invalid email. Okay, and I can see it is documented in here and it says invalid email. So let's copy this error exactly as it is. And then let's go to invalid email and then paste it in here just so that we have it documented. And remember, the auth/ part isn't going to be included in the actual error code. So let's just grab invalid email string And let's go back to our application. So hot reload is also going to work in here. Okay. So invalid email, let's go put that inside our error handling in here. So invalid email is going to create a new instance of auth error invalid email, just like that. Okay. So that's for our invalid email. And the other one that we have to handle is operation not allowed. So operation not allowed, which is right here. So I'm just going to copy this code from here and let's go back to not allowed here. Okay. And I'm just going to remove this comment that I added because that was just an example. I'm just going to add this operation not allowed code. Let's go in our error mapping and add operation not allowed and then create an instance of auth error operation not allowed. Okay. So it creates a new instance of operation not allowed right there. Then the next error that we're going to handle is going to be email already in use. So email already in use. Okay. So let's go and have a look in here and say email already in use, already exists. No, but we need actually email already in use. So let's see email already. Yes, it is documented in here in the Firebase references v8 Firebase auth for some reason for the JavaScript library. So let's have a look at Firebase auth, and this is under Firebase auth JavaScript version 8 documentation. So strange. It's not, I mean, their documentation is great. It's just there are so many things that they need to document that, yeah, we are humans, we can miss these things. So let's just copy this auth/email already in use. And let's go back to email already in use code right here and then paste it right there. Let's copy the text after auth/ and bring it up here to our error mapping. And then say for email already in use, we're going to say auth error email already in use, create a new instance of it right there. Okay, so that's great. We also need to do the requires recent login. So let's see if it's documented somewhere. Recent login, and I can see it is not actually documented in here. So let's see if we can find it in here. Nope, it's not documented there either. So it is a little bit strange because the error code is actually this error code. As I'm writing in here, requires recent login. So let's search for it. So let's just say Firebase auth error, and then put that requires recent login in here. Okay. Errors JavaScript SDK. Okay, maybe we can find it in here, and you can see it's right there. Auth requires recent login. I don't know why these errors are like in so many different places. And this one's like error JavaScript SDK Firebase, and this is auth JavaScript SDK Firebase. So maybe, I mean, these are auth errors, but I just don't understand why they're not documented all in the same place. However, let's just go and copy that. We're not here to judge. Let's go and say in our requires recent login, we're just going to paste that error right here and say in our mapping, then we're going to say for the key of requires recent login, we're going to say auth error requires recent login right there. Okay. And last but not least, we need to handle no current user. So let's see if that is documented here as well. Not there, not here. And it is not documented in here either, no current user. So that is a little bit strange that this error is not documented in any of these three documentations that we have up. So let's just say Firebase auth error, and then we search for no current user. And let's have a look in here. Is there any documentation that's official users in Firebase projects maybe? It is not documented there. Let's go ahead in here and see if there's anyone referring to no current user. Oh, and here is someone's maybe referring to it in GitHub, and here is the error. You can see Firebase auth no current user. However, I mean, I've tested this already. I know that Firebase authentication can throw this error, so I'm not making it up. It is a valid error that Firebase authentication can throw. So let's just go ahead and look for current user in our errors, and we're just going to say the error code is going to be auth/no current user. Let's copy the no current user part and then bring it here and say for that key or for that error code, we're going to say auth error no current user. So if we've done everything correctly, we should have 7 separate error codes in here, which are of type string, and they're going to be mapped to 7 auth error instances in here, so that our lookup in here inside auth error from factory constructor can actually go and get the exception code to lowercase and trim. And to be honest with you, we don't need it to lowercase and trim. This is just for safety and precautions. If we can't find that particular error, then we're going to go and say auth error unknown. Okay. And to be honest with you, what you could do is to go ahead and put a Firebase auth exception inside your auth error. For instance, if you set inner exception, okay, you could call it this, and then put inner exception inside the constant constructor in here, and then you can just remove that and put the exception in here. So this is also another way of doing the auth error unknown. What is happening in here is saying that if we can pick an actual error from our mapping of errors, of string to errors, then do that. Otherwise, create an auth error unknown with this dialog title and dialog text. However, also embed the original Firebase authentication exception inside it. We could do this. This is also fine. It would work. But for this example, I'm not going to do that. So let's just say auth error unknown. Okay. But for the curious, you could go ahead and do that so that you always have access to the inner exception if you cannot handle it by the traditional means of having this mapping up here. Okay. Wow, that was a lot of work that we had to do. So what we need to do now is to go ahead and do our app and implement the Bloc app events. So the different events that UI components, for instance, inside our application can dispatch to our Bloc. It's taken quite a lot of time for us to define all these errors, but let's go ahead and start defining the various events that we can send to our upcoming Bloc. I mean, we haven't really defined a Bloc yet, but one of the practices that I usually do also in this video, or even when I'm doing any type of professional Flutter application, is to go ahead and first think about the events that the application is going to send to the Bloc. And then I'm also going to think about the state of my application. And then I'm going to go ahead and create the Bloc. And it is always possible that you go ahead and do the events and the application state. And then when you come to the Bloc itself, then you realize that, oh, I missed something in the state, or I missed something in the event. But I always find it, I mean, this is also a preference. I always find it that it's always easier to go ahead and create the Bloc if I have all the events and I have all the states. So, or maybe the only state object inside the application. So let's go ahead and define our events. So this is going to be inside a file called, as you can see, inside a lib folder. Then we're going to create another folder called Bloc. And then inside that, we're going to go ahead and create a file called app event.dart. So I'm going to close all these authentication error in a main Dart file. So let's go in here, and we have lib folder, and we don't have any folder that's called Bloc. So I'm going to right click on lib and say new file. And then I'm going to say Bloc / app event.dart. And Visual Studio Code's nice enough to go ahead and create this intermediate Bloc folder for us as well. So now that we have our app event.dart file in here, let's go ahead and start defining. First of all, as you've seen in the other examples, I don't have to explain this again, but we are going to have an abstract class called app event, and all our events inside this application are going to be of the type app event. But the app event class itself is just going to be an abstract class, which is not constructible. Okay. So let's go ahead in here and say we have an immutable. Let me make the font a little bit bigger as well, since we have a lot of real estate. So let's say immutable, and then we're going to say abstract class, and we're going to define it here, abstract class app event. Okay, as you can see at the bottom of the screen, and we're going to import immutable from foundation. So let's say show immutable. Okay. So this is an abstract class, and let's go ahead and create a constant constructor for it as well. So const app event. So that's the overall app events. Any app event inside our application that's going to be sent to the app Bloc is going to be of this type app event. Okay. So the first event that we're going to implement in here is an event for uploading images, because if you remember, when the user presses the upload button, then we're going to bring up an image picker. And inside this image picker, we're going to pick the image, or not we, but the user is going to pick an image. And then when the user picks the image, then we're going to get a path to that image, which we're then going to send to our Bloc and say, hey, here's an image path, upload it to Firebase storage. Okay, so this particular app event, which is called app event upload image, as you can see at the bottom of the screen, is going to include just a file path to upload to Firebase storage. So let's go and implement this. So we're going to send immutable class, app event upload image, and this one implements app event because there's nothing to extend, okay? And let's go ahead and add a field in here, a property in here, the path of the file to upload. We're going to call it file path to upload. So final string file path to upload. And then I'm going to go ahead and create a constructor for this class. So it's going to be a const constructor. And let's make this guy a required named parameter. So required named parameter like this. And don't forget the trailing comma in here as well. So that's great. Now we have our app event upload image. It doesn't have to be more complicated than this. So if you remember from the other examples, our events are literally just signals that you send to your app block. Your events usually are immutable classes with constant constructors. So because they don't actually have any type of logic, they shouldn't be mutating. Like if you create an app event and you send it to your block should not be able to mutate that event. It's very important that you keep it immutable, because you don't want side effects happening from where the UI dispatches an event to where the block is processing that event, okay? Okay, now we have another event, which is for delete account. So if for instance, the dialog appears to the user, let's go in here. Let's go back to the application that fully implemented. So I can't register. Let's just log in with this user. So in here, when we say delete account, this dialog appears and says, are you sure you want to delete the account? And then if the user presses the delete account button in here, then we're going to send a delete account event to our block. So remember, this dialog is completely managed. This thing is managed by the UI. It is nothing that the block is telling the UI to display, except this component is managed by the UI. This button on top, the user taps on it, the delete account is pressed. Then we have a callback that says, okay, the user tapped on it, display this dialog. If the user presses the delete account, then send an event to the block. Okay, so let's just define that event right now. As you can see at the bottom of the screen, it's going to be called app event delete account. So I'm going to copy this class in here, okay, and I'm going to paste it in here. Let's remove the field in here and just call it app event delete account. And let's go ahead and create a constant constructor for it as well. Okay, great stuff. Now we have our app event delete account in there. Then what we need also is an event for logging the user out. So if you go back to the application here, we have log out. When the dialog is presented and the user taps on the logout button, then an event is sent to our block, which then in turn logs the user out. Okay. So let's go ahead and define that event. I'm just going to copy paste the delete account event, and instead in here, we're going to say app event log out, and with a constant constructor as you'd expect. All right. So we have the app event logout, and the next thing that we have to do is to create an app event for initialization. So this is a point that can be confusing a little bit in Bloc, because if you remember from the other examples in this chapter that we've created, when you create a block, you need to have an initial state. So it is completely okay to go ahead and say that my initial state is unknown. So when we go to our state definition, you could have an app state that, for instance, says unknown or empty. So you don't yet know the state of your application, because in this particular example, let's say, go in here in our simulator, okay, and then we're going to kill this application. All right, I also happen to kill this application, but that's okay. So if you go to this testing block, you can see as soon as we came into this application, the first thing that happened was that the application displayed the login screen. You probably saw it just momentarily. Let's open it again. See right there for just a second. And that is the application state not really being known. It's like an application that's unknown or empty. However, when the login screen appears on the screen to the user, or sorry, the login view appears on the screen for the user, then the login view can actually send a command or an event to the block and say, hey, block, initialize yourself. Go and find your state, okay? And that's what we're going to develop in here, an event that the UI or some component can send to our app block saying, hey, now that you're in place, go ahead and find the actual state of the user. And when we send that, our app block could communicate with Firebase authentication and realize that, well, the user was logged in previously, so I'm just going to log you in again. So if you log out, however, from here,
Okay, and if you completely remove the application from here and open it again, you can see then we stay on the login page, so we don't actually log the user in automatically. So log in and remove the application from running and start it again. It then goes into the photo gallery. So let's now go ahead and define this event, which, as you can see at the bottom of the screen, is going to be called app event initialize. And this task of defining these events by hand is tedious, so I'm just going to paste it right here, as you can see. It says app event initialize, and it has a constant constructor, so it's not more complicated than this. Okay. And then what we need is an app event for logging the user in. So if the user is logged out in here, let's just log out. And then when the user presses the login, if you look at this view that's on the screen, what should this login actually do? It should send two components or two pieces of information to the app block. One is the email address, and the other one is the password. So two pieces of information need to be sent to the app block with this login button, which then is going to be translated to an app event. Okay, so let's go ahead and define an app event in here, which we're going to call app event login. So immutable. Okay, class app event login, I believe, with a capital I in here, and this one also implements app event. Okay, let's go ahead then and define those two properties, which is email and then password. Okay, so final string email. Okay, like this. And we're going to also have a password. So let's make these two properties required named parameters like that and make this guy a constant constructor. And let's go and say these are required, just like that. So now we have an app event login with two pieces of information in here and an immutable class that cannot be mutated by our app block or anyone else during its transportation to the app block. Okay, what we also need to do is, if you have a look in here, if the user is logged out of the application, when we remove the application and run it again, we always end up on the login screen. However, this idea of which view to be displayed to the user is actually managed by a central component that we're going to develop soon. Okay, when we go into development of the actual app block. And what I'm trying to say in here is that we have three main screens in this application. One is the login view. The other one is the registration view, which is right here. And then the third is the photo gallery, which is right here. So there are three main views that we display to the user, and there's lots of other dialogues and stuff, but they're not actual views. Okay, so who decides which one of these views is going to be displayed to the user? Well, we're going to do this in a central place inside where we actually consume our app block. Okay, so it's just one function that is going to output each view based on the state of the application. So what happens then when the user wants to actually change the flow of the application? Because here the block has decided that you're not logged in. Okay, you're not logged in. Let's display the login view. However, what happens when the user presses this button? Not registered yet, register here. So now the UI wants to dictate to the block which view to show. And the view to show is something that the block is completely managing. So what is going to happen in here, it's going to say, by pressing this, the UI is going to say, when you press this particular button, I'm going to send an event to the block telling it that I want to go to the registration view. Okay, so let's go ahead and define an event for this button to be sent to the block to redirect the user to the register view. Okay. So let's define this, and it's going to be a simple constant class, immutable class with a constant constructor. It's going to be called app event go to registration. Fantastic. So that's the event that the UI is going to send to our app block. And similarly, when we're inside this register view, the user can still dictate to the block which view it should go to next by pressing this already registered login here. So this button needs to send you back to the login view. And that's what we need to define, and why we need to define an event for particularly that button as well. So pressing this sends you to the login button. So let's go ahead and define an event for it. So this being quite tedious, I'm just going to copy paste it. As you can see, it says app event go to login. All right. And that's this particular button right here. Okay, now let's say that you're in the register screen and you press this register button.
we need an event that gets sent to our app block, dictating to the app block that the user actually wants to register. So pressing it, as you can see, it's trying to communicate with Firebase authentication. It's trying to register you. So let's go ahead and define the register event. And the register event is almost exactly equal to this app events login. So let's copy paste it and then instead say app event register. Okay. Like this, and then copy paste it in here, and it contains the exact payload, an email, and a password. And you can see it has the app event register, class name, and a constant constructor in here. So no surprises in there. Okay. So we have our events. Now, what we need to do is to go ahead and implement. I mean, this is all the events that we had to do. So let's just save this file and close it. We need to do now is to go ahead and define our app state. So this is exciting. We're like getting closer to actually implementing the block itself. So we have all the events, we have like the error handling part, but we also need the application state. So let's go ahead and define that now. As you can see at the bottom of the screen, we're going to go ahead and create a file in here called inside the lib folder block, and then we're going to call this guy app state. Dart, okay. And this app state is going to be very interesting because we're only going to have like one app state as the general like umbrella kind of app state. However, it is also important to go ahead and define the various states of the application with their own concrete implementations. So we're going to have one app state that has a few base properties such as like is loading or any authentication errors. But we're also going to go ahead and define app states, for instance, for when you're logged out or when you're in the registration view or when you're trying to log in. So all these various screens that you saw in the application are going to have their own app state. And I mean concrete implementation, concrete implementations of this abstract app state class. So talking about abstract, I completely understand this idea could be a little bit abstract to start with because we haven't really developed it yet. But I promise you, as soon as we start developing this, writing the app state, you will get more and more you become more familiar with what I'm trying to develop in here together with you. So let's first go ahead and create this file, and we're going to go ahead and create the overall app state. So in here, I mentioned that we're going to have a few app states, but all of these app states have one thing in common in that they are going to have a class as their superclass, and this superclass is going to be app state. So let's go ahead and implement the app state first. So immutable abstract class app state in here. Okay, app state, if I can also spell it. That's going to have two properties. The first one's going to be a Boolean property that's going to dictate whether the application state is loading or not. So let's say final bool is loading. Okay. And then we're going to have another property in here, which is going to be an auth error, optional. And this guy's going to say auth error, just like that. Okay. Immutable needs to come from foundation. So let's import foundation. I'm just going to say show immutable. And then we have two properties in here for which we have to create a constructor. So let's go ahead and do that. Const. And let's put a trailing comma in there. Then I'm going to make sure that these are inside curly brackets and make both of these required parameters. Okay. So what is happening here? As you can see, any app state in our application, any one of them can have this particular property, for instance, is loading. Okay. Because if you look here, if I'm trying to register, you saw that little loading indicator. Did you see that? So this screen can have loading. In the login screen, we can have loading. And in here, we can have loading. So, I mean, it happens so fast that you didn't see it. But if you try to, for instance, say log in and then you try to delete this account, delete account. Did you see the loading? Okay, so all these three screens can have loading indications to the user, and that is why is loading is defined as an overall property. This is indicative of any app state in our application can have an is loading state. So you may be wondering, okay, but why is it in app state? Why don't like all these different states that we're going to implement have the same property? Well, that's for two reasons. One is that it is repetitive. So if we have an is loading property in app state, we don't have to define the same property in all the other subclasses. That's reason number one. Reason number two, which is the most important reason, is that as you'll soon see, when we go and handle the changes of our app state in where we're like creating a listener for our block state, we're going to just have one central place in the entire application that is going to take care of displaying that loading screen. Okay, so if you go in here and try to, for instance, delete an account, do you see this loading thing? Do you see that loading thing in the login screen? Do you see this loading thing in the register screen? These three loading commands to tell the application to display a loading screen is just one place. And that one place is just going to listen for changes in the app state. So if the app state changes, it's going to have a look at the property of is loading. If is loading is true, it's just going to display the loading overlay. So the reason is loading, the second reason is actually the most important reason, in that any app state that changes the is loading is going to trigger one place in the entire application that displays the loading overlay to the user. Okay, so that's for is loading. How about author? Why is this guy in app state? Well, we are going to go and define two separate app states, one for the register screen and the other one for the the login screen. So we're going to have two separate app states. However, this auth error is defined in the generic app state in here. And when I mean generic, I don't actually mean with generic properties in here. I just mean like the overall app state, the superclass. So both the login view, let's go in here, log out. Both the login view, you see it produces the author, both that and the register screen can actually have error handling. They can have errors and they need to have error handling. So the reason this author is defined inside app state as a superclass is that two other classes later that subclass, this particular class, are going to have the possibility of having an author embedded in them. So you could either remove this from here and then go ahead and implement author in both the login and the register app states, or you could just leave it in here so you don't have to go and re-implement the same property. Okay, so now you know the reason why we have these two properties inside the superclass app state, so that with that said, we can go ahead and implement the actual concrete implementations of various app states in our application. Having app state in place is then going to help us to create the actual concrete implementations of it. And we're going to start with the app state logged in. So let's go ahead and create our app state logged in here. I'm going to bring up the title for it, or the caption for it, at the bottom of the screen. So let's go ahead and say immutable class app state logged in. And this one is going to extend app state. Okay, so this is an immutable class which is extending app state. It's not implementing app state, which means that it actually is going to use the properties of app state without re-implementing those properties. Okay, so let's go ahead and create the constructor for this app state, and you can see that it is adding the required parameters for us exactly correctly in here as well. And let's make this a const constructor. So you can see it is saying that we need two properties in here, is loading and auth error as well. And it's making the required properties because app state itself requires those properties. Okay. So app state logged in has now two required properties that are being sent in its constructor. However, app state itself needs two properties. So, app state logged in. So when you're logged in, what does the user actually need? So if you go in here, let's say we go to the login screen. The first thing that we need to carry with this app state logged in is the user reference. So we need a reference to a logged in user. So let's go ahead and define that. So let's say we have a user, and you can see it is going to be auto imported from Firebase authentication. So let's say auto import that, and then we're just going to say user. So if the user is logged in, if the app state is in this state, app state logged in, then we have to have a user. Okay. The other thing that we need is a photo gallery. It's actually references to these images. So if I upload an image in here, then we have this loading state, and then we have the image in here, and then I can upload another image, and that image will also appear here. Okay, so when you're logged in and you're on this screen, you really just need two things: the user and a reference to all the, or an iterable of all these image references. Okay, now images, you'd expect that, okay, we're going to define these as actual images or something, but the way that Firebase storage does it, it defines those as an object called reference. Okay, so let's go ahead and here and say we have an iterable of reference. You can see it's going to be auto imported from Firebase storage. So let's just do that. And then in here, we're just going to say images. It is not so happy with what we've done in here, simply because we haven't gone and defined these two important properties as required. Okay, so let's go ahead and add them in here. I'm going to take these two properties and put them as like required parameters. So let's say we put in between is loading and auth error. Okay, so I'm going to make this required parameter like this, and I'm going to make this one as well a required parameter. Okay, so that's it, really. I mean, our app state logged in doesn't have to be any more complicated than this. It just has a user and an iterable of the image references. That's it. Okay. Let's go ahead now. Actually, before we go ahead and do the implementation of our app state logged out, let's go ahead and think a little bit about this app state logged in, because here the application state is in fact app state logged in. However, when I upload a new image, you can see things change on the screen somehow. Our view, this particular photo gallery view, is understanding even though we are in app state logged in, but something is changing, like the number of images is changing, or maybe the user is changing, something is changing. So we need to make sure that we actually implement equality for this app state logged in, because otherwise, if I try to upload an image in here, let's say this one, then this photo gallery won't understand that something has changed, because before uploading this image, the app state was in fact app state logged in, and after uploading that image, app state is still app state logged in. So how should this view know that, hey, something is changing, I have to update my content? So we're going to do that by implementing equality on this app state. So let's go ahead and override equality operator. So we're just going to say override and we're going to say a Boolean operator called equal with a covariance of app state logged in here. Okay, and we're going to call this guy, actually let's call this guy other, because to be honest with you, we don't know what this one is going to be. Our app state, this is a little bit strange. Let me just explain it. Usually in your equality, you would put covariant with the same app, with the same class name. However, here, what's going to happen is that, remember, our app block is going to manage various implementations of this app state. One is going to be logged in, the other one's going to be logged out, another one's maybe going to be registering or something. So when our app block emits these various states, all these states are going to be compared with each other in the block library, so that block knows whether to emit a state or not. So by doing the comparison of, for instance, app state logged in with an app state logged out, we need to be ready in here in the implementation of equality to be compared with any other object. Okay, so we're not only going to be compared with an app state logged in, but we're going to be compared with any other object, usually of type app state. Okay, so let's go in here and not type the data type for the other parameter. We're just going to leave it like this. All right, let's say final CLS is equal to other. So what we're going to say then, we're going to say if in here, if the class name, let's say other class name, okay, or other class, and then we're going to say if other class is app state logged in, and we're going to do some implementation. Otherwise, we're just going to say return false. So what we're doing in here is that we're saying that, okay, you're giving us another object, which is, as you can see in here, its type is just going to be a generic object. However, we're doing like a little bit of a type shadowing in here. We're saying, okay, put that object inside this variable, and then we're comparing other class with this particular class. And then inside this if statement,
this other class then is for sure going to be of type app state logged in. Okay, so if I say other class dot, you can see it has access to other properties inside app state logged in. So this is just type shadowing. If we didn't do this and we just said other, let's try that. And then in here, you would have access to images user auth as well. So you can decide in here what you want to do. So I prefer to create some sort of an intermediate variable in here that points to that other. Okay. So that is done at this point. So let's go in here and implement the equality between this instance and the other class. Okay. So we're going to say final, or we could just say return is loading should be equal to other class is loading. Okay. The other condition for equality in here should, if you have a look at the properties we have in here, you can see we have the user. So let's compare the user IDs. Then we're going to say user.uid should be other class user UID. And we're not going to do like a deep comparison between the image references in here. We're just going to check for the number of images. So if an image is deleted or if an image is added, then we're going to consider that new app state logged in to be a new instance of app state logged in and hence not equal to the current instance. Okay, then we're going to say images.length is not equal to other class images.length. Okay. These are the three requirements basically for, actually, sorry, they should be equal. So we're going to say, as long as these three properties on both sides are equal to each other, then chances are that these two instances are the same. Okay. Otherwise, they are not the same. Good, and you can see now we're getting a little warning about hash code not being implemented. I've explained this quite a lot in my Twitter account and on LinkedIn, what this equality and all this hash code business is all about, really. So I suggest that you, I mean, I don't think I can go into details about everything in this particular video. So if you're interested in that, go ahead and follow me on Twitter and LinkedIn so you can get these updates as well and go into the history of my posts. I posted this, I think, about 4 or 5 days ago about the equality hash code, okay? So now that we've implemented equality, let's go ahead and implement hash code as well. So let's say create method override for hash code. And for hash code, we're just going to use object hash in here. So let's say we're going to say object hash, and we have three properties to hash in here. Okay. So the first one is loading. The second one, I believe, is actually, maybe we shouldn't do is loading in here. Let's just say user.uid. And let's then go into images. We're going to hash them as well. Okay. And we could do is loading as well, to be honest with you, but it's just not a property that we contain. Remember, is loading and the author are in the app state. So the hash code of the implementation of this particular app state, which is app state logged in, should really just hash the properties that this particular class instance is actually implementing. Okay, so the user and the images. Good. Now we have the hash code. We can finally move on to the app state logged out. So app state logged out, to be honest with you, it has no properties of its own. So while we're here, let's say that you log out, there is no properties that this app state logged out actually contains. You may look at this screen and be like, well, it contains the email and the password, but that's not it really, because this is just a little bit of a trick that I've done that pre-populates these two text fields if I'm debugging the application. So if I'm not debugging this application, and this is, for instance, a release application, then these two text fields are going to be completely empty. So the app state logged out has literally no properties except for the properties that are already defined in app state. So let's go ahead and define that. So let's say immutable class app state logged out, and then this one extends app state, just like this. And let's go and define the constructor for this guy. Great stuff. A trailing comma to get the formatting done correctly in here. And let's make this guy a constant constructor as well. So let's go and then implement perhaps toString as well before we forget on our app state logged in and app state logged out. So let's go back to the app state logged in and implement toString in here. Okay. So for the toString of our app state logged in, we're just going to say app state logged in And in here, we're going to say images length is equal to $images length, like this, okay? And that's really it for app state logged in toString. And then we're going to go ahead and implement the toString for app state logged out as well. And this one is just going to have the auth error and is loading as its properties printed to the screen. So let's go in here and say toString. So here, and remember, the toString definition that I'm doing in here really is mainly used for two purposes. If you're doing poor man debugging and you're doing like and you're printing your app states to the screen just to ensure things are done correctly in your app block, that's useful for that. So that's reason one. And the other reason that this toString could be quite helpful is when you're doing block tests, because block tests are gonna take your app state objects and it's going to print it to the screen if things don't match up in your block test. And that's where you would find this toString quite useful. Okay, so two reasons mainly. For this toString property of our app state logged out, we're just going to say app state logged out, and then we're going to say is loading is equal to $is loading, and then auth error is equal to $auth error. Okay, so that's the toString for app state logged out. Great stuff. Now that we have that, let's go to our next state that we have to implement. So this next state, as you can see at the bottom of the screen, says app state is in registration view. So you saw that we have an event. So if we go to app event, we had an event that says go to registration. So that's the event that the UI sends to the block. However, by sending that event, the block should actually emit a new state telling the application that, hey, I'm now inside the registration screen. So let's go ahead and implement that particular app state in here. So we're going to say immutable class app state is in registration view, and this one extends app state as well. So let's go ahead and define the constant constructor for this guy. So let's say this is a const and a colon, the trailing colon at the end here. So, and I'm going to save it so you can pause the video and have a look at it. So here app state is in registration view right now, doesn't contain any properties of its own. You can see it's just delegating everything to the superclass. So, and it doesn't really have to have any properties, because while you're in the registration view, like while you're in here, what properties do you have? Nothing. You're just in the registration view. So this class really is just a statement. The definition of this class is a statement telling our app block that, hey, you can end up being in a situation where you have to be inside the registration view. And that's why we have this particular app state, okay? However, remember also that it can contain these two properties, is loading and auth error. So when I press the register button, you see it starts loading, and that's why we have app state is in registration with these two particular properties, okay? And it can have an error, which is this auth error, okay? So if you really think about it, this is coming together. You probably are understanding the role that app state plays in all of this. It's managing like the loading and the dialog parts. Managing maybe is not the right word. It's like it is containing the ability for any of these states to have a loading state and also have an authentication error. And this app state is in registration view is taking full advantage of that by saying first I'm loading and then I'm displaying a dialog in here, okay? Great stuff. So now that we're done with that, what we need to do is to go ahead and implement some helper functionality on our app state. So as we'll go on and create our app block, you will see that in some places when we, for instance, have an app state from before, and then we want to create a new app state sometime, or maybe not even creating a new app state, but sometimes we want to be able to say, regardless of what the app state is, I want to get the user identifier out of the current app state. So for instance, when you're trying to upload something to Firebase storage, at that point, you may need the user identifier to create a folder for that user, as you saw earlier when we defined the rules for Firebase storage. So in order to easily grab a user identifier out of any app state, because remember, we can have different app states. Is in registration view, we can have logged out, we can have logged in, and all of these guys are of type app state. However, only app state logged in has a user. So what we want to do in here is to be able to extract a user identifier out of any instance of app state. But in the actual implementation, we're going to check the app state's instance with app state logged in. And if that's the case, then we're going to return the user ID. Okay. So let's go ahead and do this extension in here. And I know it could be a little bit abstract for you right now, but you're going to get it as soon as we start implementing it. Okay. So let's just say extension get user ID on app state. Okay. And then in here, we're just going to say, actually this should probably be get user, to be honest. So let's just say, and at the bottom of the screen, I've written get user ID, but let's just change this, or maybe I should change this and then bring up the caption again. Let's just say extract user from app state like this, and then I'm going to bring up the caption again, so the caption matches the actual implementation in here. Okay. Then we're going to create a property in here of type optional user, and then we're going to say this is a getter, which is called user, and then we're going to say final CLS is CLS is this. If CLS is app state logged in, then CLS, then return CLS user. Otherwise, return null. Okay. And to be honest with you, some languages have the ability to, and let's see if we can actually compare it like this. This user property getter recursively returns itself. This is this.user. Oh, I understand, because that's interesting. We can't really do this, because if we're saying if this is app state logged in, then go to this user, but this user is then going to return this user property that we're defining right here. So we have to do something like this. All right. So that's great. We're shadowing this into CLS, and then we're comparing CLS with this, and then returning user. So yeah, this is going to work, because it's then going to go to the original implementation of user inside app state logged in. So it's a little bit strange, to be honest with you. We could call this like a function called get user just to avoid confusion, but I've tested this, I've tried this before, and it works. So we're just going to leave it like this. Okay. In the same fashion that we've done this extension of get user on app state, we're going to do something similar for grabbing images out of any app state. But we already know that grabbing images is only going to work on app state logged in. So we need something very similar to this extension. So I'm just going to copy this guy. All right. And then paste it here. Then we're going to call this extension gets images. And in here, we're just going to return an iterable optionally of reference. And we're going to say get, and then it's called images. And then in here, we're just going to return images. Okay, so this is also going to go into any app state as long as it's app state logged in, and grab its images. In some languages like Rust, you could easily grab these images by saying, for instance, this as like app state logged in, and then this would be an optional, and then you'd return it. So this would work a lot easier. This implementation would just be a one-liner if Dart had the ability for optional type checking with as question mark in here, but it doesn't yet. So maybe this will come in some other versions of Dart in the future, but for now we have to do something like this. Okay. Fantastic. I mean, that was really it. That's our app state. I mean, we don't have much more to do. It's just this app state, and then you could be logged in, or you could be logged out in here, and you could be in registration view, and that's it really. We don't have to implement much more than this. So great. We can say that we're done with the implementation of app state. With all of this done, it is actually time to go and start implementing our app block. So let's bring that card up, and we're going to go ahead and create the app block file first, because now we have the state or the various app states, and we also have our events. So it's time to put it together into the app block. And let's bring up the Explorer here in Visual Studio Code. I'm going to go into the block folder and create the file, as you can see at the bottom of the screen, called app-block.dart. So app block.dart. Okay.
And so now we've created that file, and let's go ahead and open also the app events. So we always have the event, the state, and the app block here in 3 separate tabs. Because when we're putting together the app block, it's always good to have the app event and the app state files open so that we can jump into them in order if there's any implementation that we're missing, or if, for instance, there's something that we've forgotten to how it was implemented. For instance, these special extensions in here, as you'll soon see. So let's go ahead and define the app block itself. So, the app block is going to be of type of block, and every block has an event and a state. So let's go ahead in here and say class app block. And this one extends block, okay? And you can see block needs to be auto imported. So let's just import that. And at the moment, it says it's importing it from block. But to be honest with you, I wish we could actually import it from Flutter Bloc. You can see in here the second suggestion is to import it from Flutter Bloc. And the reason that we want to bring it from Flutter Bloc is it's an umbrella package that includes all the necessary bits and pieces that a Flutter application needs to interact with Bloc. So I find it a little bit easier to just import Flutter Bloc, but maybe we could just go ahead and say import Bloc for now until we don't necessarily until we're not able to work with Bloc itself, and we have to use Flutter Bloc. Okay, so here we have Bloc, and it's imported automatically for us in here. As a refresher, let's have a look in here. As you can see in the documentation, this is a Bloc should have an event and a state. So for the event, we're going to say app event, which is going to be auto imported, and then we have for the state the app state, which is going to also be auto imported. Okay. So now that we have that, as you remember, every block should have an initial state. And what we're going to do at the initial state, which is the app state of our application, we're going to say the initial state's always logged out. So when you start the application, we're just going to say by default you're logged out. But then later, when the application actually starts, we're going to send an event to the app block and say initialize yourself. And upon that initialization, then the app block is going to be able to change its own state. Okay, so but know that by default, our app block is going to be in the logged out state. So let's go ahead and create the constructor for our app block, and we're going to say we don't need the initial state as a parameter. So what we're going to do in here is to say const app state logged out like this. Okay. And for is loading, we're just going to say false. And we don't have any auth errors. So let's go into this logged out. We can see in here for logged out, actually, the way we've defined it is that we said both of these properties are required, but ideally they shouldn't be required. And if we go back to our into how we've implemented app state, let's have a look in here. We can see the way we've implemented app state is that both the is loading and auth error are required. And having a look at this, it is a little bit strange in that auth error being optional, its property, like in the constructor, is actually required. So what we could do is to remove this required from here, saying that auth error isn't required. So if it's not passed, then it's going to be set to null. Okay. So having changed that, then we should go back to our have a look at this app state logged out. And in here, we're seeing that in its constructor is taking auth error as a required property, but it shouldn't. Now that it is optional inside app state, then this guy can also just say that, yeah, this property is optional. So let's remove the required part of this property from here as well. So now we have app state logged out. It is not taking in a required auth error, and then app state logged out. Sorry, app state itself doesn't have a required property for auth error either. Okay. Good stuff. So then let's go in here and say we're just not loading and we're not passing in any sort of auth error. Okay. So your code in app block should now look like this. Your code in app state logged out should look like this, and your code in app state should look like this. So if you want to go ahead and pause the video in order to make these changes, go ahead and do that, please. Okay, that was great. Now, what we need to do is just to define a few helper functions, kind of. As you know, when the user then tries to log into our application, we're going to go ahead and make a, a function call to Firebase storage in order to retrieve that particular user's stored images. So we need a helper function inside this app block that can return an iterable of file references to us. So we're going to pass it a user, and then for that user, we're going to retrieve hers or his file references. Okay, so let's go ahead and add the function in here. As you can see at the bottom of the screen, we said that we're going to have a function called get images. So let's go in here in our app block and write this function. So this guy is going to return a future of iterable of reference. Okay, and you can see it's going to be auto imported from Firebase storage. So let's just do that. And these references are like representing images. Okay, iterable. I can see I've written iterable like this. And we're going to call this guy get images. And then we're going to take a user ID in here. Okay, so let's say user ID. And it's going to be an arrow function. So what we're going to say is to say Firebase storage. And it's going to be, it is already imported because we started using reference, which in turn imports Firebase storage for us in here, as you can see. Okay, so let's say Firebase storage. And this is how you basically grab images or grab files out of a Firebase storage bucket. And I'll show you in here. So we're just going to say instance here, which is the singleton. And then we're just going to say reference here, ref. And this ref really is just going to go into a folder called user ID in here. And I don't mean the folder itself is actually called user ID. What I mean is that for every user ID, what we've been trying to do in here is in this application is that for every user ID, we're going to create a folder at the root of our default Firebase storage bucket. So what this guy is pretty much doing is say, go into the Firebase storage bucket, the default one, and grab a folder whose name is equal to the given user ID. Okay, so that kind of makes sense. So let's bring this down also to different lines so we can see it a little bit easier. And then what we're going to say is to say we're going to list its contents in here, as you can see, okay? And after doing this, if you have a look at the result of list, it will return a future of list result. And inside this list result, there's actually the contents, which are the items inside that folder. So we need to grab that. So we're going to say chain this. So let's just say list result. And then we're going to say list result dot items, which is actually the list of references. Okay, so that would be this function, to be honest with you. So it's not more complicated than this. It's just, yeah, as you can see, it goes into a given folder, lists its contents, and then grabs the items from that list. Okay, good. So that was the function to grab images. Okay. If you haven't already done that, go ahead and do this. Add the constructor to your app block. It should be logged out user by default, okay? Then what we're going to do is to start handling uploading images. So this is actually going to be the first event that is sent to our app block that we're going to go and handle. All right. So let's go ahead and do that. Let's go into the app block after the constructor. We're going to create an on block in here. So let's just say on, and we're going to say app event upload image. All right. So in here, we're going to get to, let's see, actually, sorry, this needs to be in the constructor, not after the constructor. So here we call the super, and let's create the constructor function in here. And then we're going to say on, and we're going to get two properties in here, which is the event and the emit. And let's close the brackets there like that. And let's make this guy an async function. So your code should look like this now, okay? And let's put a comment in here and say handle uploading images, just like that. All right. So the first thing that we need to do when someone asks us to upload an image is to first grab the current user. So, how do we do that? I mean, the app block doesn't have any users. No, it doesn't. We don't have any singleton in the entire application that says, here's the user. No, we don't have that. However, we have the current state. So let's say in the app block, you could just write in here, if I can spell, state, okay? And the state is an app state, but the state could be various states. It could be app state logged in. It could be app state logged out. It could be app state is in registration view. But how do we get the user? Yes, and that's why we needed this extension in here. As you can see, we have a get user extension on the entire app state, any app state. And then we're saying, okay, if this particular class, if this app state is app state logged in, then grab its user, otherwise return null. So now you know why we have this extension, because in our app block now we have a state and we want the user. So let's go ahead in here and say final user is state.user. And you can see this is an optional user, because dependent on which app state we have, we may or we may not have the user. Okay. So what we're going to say is if user is null, then just let's log the user out. So if you happen to be in any place that, for instance, inside the application, and you're not logged in, but then you try to send an app event upload image to your block, then your block is going to be, oops, yeah, you don't have a user. I'm just going to log you out, okay? Or I'm going to make sure that you're in the logout state at least. And then what we're going to say is we're going to emit now a constant app state logged out in here, as you can see. Now we're going to say you're not loading. Okay, emit like that, and then a comma in here. So then let's write a little comment as well here. Log user out if we don't have valid user, if you don't have an actual user in app state. Okay, something like that. The comment is completely up to you how you want to write and formulate that, okay? Great, now that we have that, let's go ahead to the next step. What we need to do in here is to make sure that we are basically telling the app state that we are all of a sudden starting to load. Okay, so we need to set the app state in a loading state. And if you remember, all our app states have this property is loading, and also the app state logged in also inherits that property from app state, because we're extending app state. So what we need to do in here is just to go and say that we're starting to load. All right, so how do we do that? Let's go ahead and emit app state logged in. Okay, because we've checked that you have a user, and that means that we can basically you are logged in. That's what it means if you have a user. So let's enforce that and say that you're logged in, but we want to set is loading to true. Okay, and let's put a comment here, and yeah, so let's format the code correctly. So how do we get the user? The user's right here. Okay, we actually said that here is the user. Okay, and we've checked it against null. And in here is now telling us that, yeah, you need to provide the user. And let's go ahead and just ignore that for now. We just say, okay, user is user. We know that. How do we do with images? Well, how do we grab the images? Because as you can see, app state logged in actually needs images. How do we get that? Well, we are, talking about it, I think you already know the answer to that. Talking about app state, we had one extension to get a user out of any app state, as long as that app state's actually app state logged in. And we have also another extension that we wrote, which is called images. It's a getter, and then it's also operating on app state logged in. As long as the class is app state logged in, it's returning its images, otherwise returning null. So what we need to do in here is just to go ahead and say, first of all, we're not interested in the auth error for app state logged in, so let's remove that. Okay, and I can see also auth error here. It seems like we've defined auth error in every app state as a required parameter, so let's go ahead and remove that. So let's make sure that auth error is not required anywhere. So let's remove the required auth error from app state logged in, and also let's search for, I can see in app state is in registration view, auth error is also defined as required. Let's remove that, and we haven't defined it as required anywhere else. So that's great. Now, author isn't required property. We can remove it from here. So for images, what we need to do in here is to say, okay, we have the state, and then we know that we can get its images. If we can't do that, let's just return an empty iterable. All right. Great. So in here, we're saying final user is the state user. And then here we're checking against that. Also, what we need to do, what we missed in here, to be honest with you, you would be a little bit surprised that, we are checking against null. If it's null, then we're doing this. But why is it complaining? Well, there's something very important that we're missing in here, and that is a return statement. So if you put a return statement in here, then Dart understands that, okay, you're checking against null. And if the user is null, you're not going forward. You're not going any further than this. Therefore, anything after this code means user is not null, okay? Either that, or we could put an else statement in here. But in my opinion, at least, since if the user is null, we should just log the user out and that's it, then it makes perfect sense to just have a return immediately after emitting app state logged out, because having an if and else in here is just going to complicate the code indentation a little bit more, okay? Okay, so in here, what we're going to say, let's put a comment in here and we're going to say start loading process. Okay, start the loading process. All right, then what we need to do after that is, let's put a comma in here as well. Good. After starting the loading process, which is this emit, what we need to do is to start basically uploading a photo. Now, if you look at this state, this app event upload image action, you can see it has file path to upload. What we need in here, oh, I closed the app event. Let's open app event as well, just to have it always open in here. What we need to do is to create a file reference to that path. So what we need is to say final file is file in here. As you can see, it's going to auto import it from Dart.io. And we need to say state dot, we need is from the event that is coming in, file path to upload. Okay, great stuff. Now that we have that, we need to go ahead and basically upload this file. So how do we do that? We don't have any utility at the moment that allows us to upload a file, and we're going to go ahead and create that utility. So let's go in libutils in here and create a new file. So we're going to say in lib, let's say new file, and we're going to say in the folder of utils slash upload image.dart. Okay, excuse me. In upload image.dart, what we want is just a simple function that can upload a given file, because as you see in our app block, we have a file reference. We just want to be able to upload it. Okay, so let's say that this guy creates a future of bool, and we're going to call it upload image. Okay, and then we're going to take a required file to upload, and then we're also going to take the user ID, because given the user ID, then we're going to know which folder to upload that file into. Okay, so let's just say required string user ID, like that. Put these in curly brackets so Dart is happy. And file needs to be imported from Dart.io, so I'm just going to go in here and say imported from Dart.io, like that. And then we're going to make this an arrow function. Let's say Firebase storage, which is going to be auto imported as well. And so instance, and then we're going to say get the folder referring to that user ID, like this. And then inside that, we're going to create a child. So we're going to create a file basically into which this file is going to be uploaded. So if you remember, I mean, if you look at the code that we have in here, there is no file name. Okay, but what we're going to do is for every file that the user tries to upload, we're going to upload that under a random UUID. Okay, like a random string basically. So let's go ahead and do that. So what we're going to do in here, we're going to say child, and then we're going to create a UUID version 4. So let's say const UUID in here, const UUID.v4. Okay. So that creates the file for us. And then we're going to say there's a function here, which is called put file, right? And then we're going to say file. And if this operation is successful, then we're going to say then, all right, and we ignore the value that comes in, then we're going to say the return is true. Catch error, we're going to say if there is an error, we ignore the error, we're going to return the value of false, just like that. So have a look at this function if you want to pause this video. It's very easy, to be honest with you. If you have a look at its signature, it's just taking a file reference in here and, sorry, a file and a user ID. It's grabbing that folder under the user ID. It's creating a child with a random name. A child means it just creates a file. after creating the file, is uploading our file into that file, and then it's producing the value of true if everything goes successfully. Otherwise, it's producing the value of false if there's an error. Okay, and hence that's why we have this future of bool, because the results either true, meaning that the uploading went successfully, or false if uploading actually failed. So now that we're done with this file, we could close it because we don't need it anymore. So what we could do then in here is to await the uploading of that image or that file. So let's just say await upload image, and it's going to auto import it from utils. You can see in here. File is file, and then the user ID is going to be user UID. Every Firebase user of type user has a property called UID of type string, as you can see in here, which is the user identifier. Okay. So now that we have that, we've uploaded the file. We're awaiting the result of uploading the file. What we need to do, let's just actually put a comment in here. Let's say upload the file. Okay. Then let's go ahead in here. Right after uploading the file, we want to grab all the latest files, because what's going to happen in here, Firebase isn't going to cache that for us. Like if you have a reference to a list of files in your bucket, and then you upload a new one locally, then Firebase isn't locally gonna store the new file that you just uploaded and like update the references to all the items and the lists. So what you need to do after uploading a file, you actually need to grab all the latest files as well. I mean, at least the list of files. And for that, we have this future of item of reference in here. So let's just say after upload is complete, grab the latest file references. Okay, so we're gonna say final images is get images, and here we need to pass the user ID, UID, like that. Okay, so this needs to be awaited on as well. This is a future. Okay, and then what we're gonna do is to emit an app state logged in right here. And let's go ahead and see if we can actually add the properties in here. So after grabbing all the images, is loading going to be false? User is user, and then images is images. So it just plugs and plays very nicely, as you can see in here. Okay. So let's say emits the new images and turn off loading. All right. So really, that was all we had to do for our app event upload image in order to upload an image to our default bucket. So let's go ahead and implement the next app event. So this one is going to be for account deletion. So if you remember, when you're deleting your account, it's not just that we should go to Firebase authentication and say delete the account. Before doing that, we actually need to delete that user's contents from Firebase storage, because I mean, you would be a little bit surprised that Firebase authentication, Firebase storage really don't have so much in common, and they don't really have like inter-product communication between them. So if you delete a user from Firebase authentication, it will not automatically go ahead and delete that particular user's contents. There are different ways of doing this. For instance, in this particular application, we're putting all that user's images inside a folder or a reference in our default bucket, and we're naming that folder with the user's identifier. So it makes it very easy for us, upon the user trying to delete their account, to go ahead inside our Firebase storage default bucket, find a reference with the exact same name. And when I say reference, I just mean a folder in this case, but in Firebase storage terms, it's called reference. And find that the reference with the exact same name as the user's identifier and delete that reference and all its contents. So that's our case. However, in your case, you may just have a bucket and then everyone's like uploading their contents in the same buckets with different names. So if you don't have that ability, then there's another way of associating content with given users, and that is by using metadata. Well, I'm not going to go into that at the moment in this chapter, to be honest with you, because we're not doing that particular method. But if you want to experiment with it, have a look at Firebase storage metadata and it may solve your issue. Okay. So let's go ahead and handle account deletion in here. So at the bottom of this, we can see that this, I believe that this is our constructor in here. No, It is not. So I'm going to go actually on top of app event upload image and start handling the account deletion. Okay, so let's go in here right there. I believe so. Okay, let's say handle account deletion. And in here, we're just going to say on app event delete account, as you can see in here. And then we have two properties that come in here, event and emit. All right, like that. And this guy is also going to be an asynchronous function. So what we need to do in here is to first grab the current user. Okay, so let's just say final user is Firebase authentication instance. And then we're going to say current user. So this gives us the user. Okay, and then we could say if user is null, then what we need to do is just to say if you have no user at the moment, then you can't delete that user. So let's just say that you are logged out. Okay, and we already have that code in here. You can see we're emitting this guy. So let's just copy that code from app events upload image when the user was null, and let's chuck it in here. Okay, and you can see in app event upload image, we're grabbing the user this way. So that's one way of doing it. And the other way of doing it is actually going directly to Firebase auth and saying that we're interested in the current user. Okay, so let's put a comment in here, log the user out if we don't have a current user. Okay, so that's gonna emit a logged out state to our application. And after that, what we need to do is just to start loading. So if you want to delete your account, what we need to do is just to say, okay, the first thing we need to do is to display a loading indicator to the user. So let's have a look at our state in here. We have a user and we made sure that user is not null. So in that case, it means you're logged in. So we need to just set a Boolean property on our logged in state. So let's go right after this and say start loading. Okay, and then we're going to emit a loading state right here. We have an emit. So let's just copy that guy, start loading. You can see it says app state logged in. It's saying true. The user is there, and then it's taking the state images exactly as we had before. Okay, after starting to load, what we need to do is to say delete the user folder. Let's put this guy inside a try and catch in here. Okay. So what we're going to do is to say on a catch statement, we're going to say on Firebase auth exception catch e, and then we're going to say on Firebase exception. So we're going to handle two basically exceptions in here. One is the Firebase auth exception, and the other one is the Firebase exception. So this is going to be thrown if, for instance, there is a problem with Firebase storage itself. So upon Firebase auth exception, what we're going to do is to actually throw an auth error in our app state logged in. So let's go ahead and emit that. So what I'm going to do is to go ahead and grab this emit from here that we had before and put it in Firebase auth exception. Let's have a look at it. So you can see in here, it says is loading true, but if we've received an auth exception, let's just say we're not loading anymore, we've actually received an error. The user is the user, the images are the same, but we're going to have an auth error in here. And we're going to say auth error, and it's going to be auto imported, as you can see in here. From, you can see it plugs in so nicely because we have this from factory. I actually think it was factory, but let's have a look whether it was a factory. Yeah, it was indeed. So in here, then we're going to put that exception in here. Okay, so have a look at this code, see what's happening. If we get an authentication exception while we're trying to delete that user's account, we're going to say we're not loading anymore. The user is as it was before. We're grabbing the current images that were in the current state before we even started. And then we're wrapping the error inside an author and putting it inside app state logged in here. Okay, so that is for Firebase auth exception. So what happens if you actually receive a Firebase exception in here? What we need to do is to actually log the user out completely. So let's just say we might not be able to delete the folder, and let's just log the user out. So since this is a tedious process, I'm just going to copy paste that code in here and say log the user out. And to be honest with you, you could argue to say, well, this is not right. You shouldn't log the user out. Yeah, I mean, we have no product specification, and these are the things that I've just planned for this example. But you could do anything in here. You could emit any state you want to do in here. You could emit an app state logged in with a specific error if you want to. But we're not doing that at the moment. So what we need to do is to just handle these in the easiest way so that we can focus more on the block itself. Okay, so we've handled Firebase auth exception, and we've also handled Firebase exception. Okay, so let's go ahead in here and continue with the try block, because in this try block, we have quite a few important things to do. The first thing that we need to do in this try block is actually get a reference to that folder and then delete all its contents. So let's say delete user folder. Okay, so let's say final folder is await Firebase storage instance. And then we're going to get a reference to that folder. So that reference is going to use the user's identifier, user UID, and then we're going to say list all, I believe. Okay. So this is the folder. If you have a look at it, its data type is actually a list result. So maybe we could just say folder contents or something. But I'm just going to call it folder. Okay. So this is going to give us the folder whose name is equal to the user's user identifier in here. Okay, and what we need to do is go through all the contents of this folder and delete those items one at a time. So let's say for final item in folder.items. Okay, and then we're going to say await, and we're going to say item.delete. Okay, and then we're just going to catch errors in here. So we're going to say if an error happens in here, we're not interested in the error. Let's just continue. Otherwise, if an error happens in here, then we're going to go into one of these exception blocks. Okay. And then if that error happens, then we're like literally just logging the user out, which may not be the perfect solution in here. And if you're like handling this, if you want to handle it in the absolute best possible way, upon trying to delete an item and not succeeding, you may want to inform the user about that to say, oops, an error happened. I couldn't delete your contents. Do you want to log out anyways? Or sorry, do you want to delete your account anyways? So we're not doing that just because that would make the application even more complex than it already is. So just have that in mind, that if the deletion of one of the contents or some of the contents that the users created didn't go through, you may want to inform the user about that before you actually delete their account. Because once their account is deleted, if they register with the exact same email and the exact same credentials, their user identifier will be completely random and they won't have access to the content that they had previously uploaded. So you would end up with a solution that, you would end up with a situation where the user's content is dormant and just sitting in your default Firebase storage or Firebase bucket, Firebase storage bucket to be correct. And then no one's touching that folder and no one's able to delete that folder. So it could be a little bit of a risky thing, like not being able to delete content that's on Firebase storage and then deleting the account. So I just want to make you aware that that is a little bit of a risk that we're basically taking by doing await and catch error and ignoring the error. Okay. So let's put a comment in here, say maybe handle the error. Okay. Good stuff. Now that we're done with that, so now we've deleted all the items in that folder, we actually want to delete the folder itself. So let's say await Firebase storage dot instance and get the reference to the user's folder with this. Okay. So let me bring this down into separate lines like that, like that. And then we're going to just delete that folder itself. And then we're going to say catch error in the same exact way that we did up there. So let's say ignore the error like that. And curly brackets. Okay. So we're going to say delete the folder itself. And in here, to be honest with you, we could just rename this to folder contents or user contents or files maybe. Okay. And then we're going into files items. Files items. Not sure. Let's just call it folder contents maybe. Okay. So in here, we're iterating through folder contents dot items. Makes a little bit more sense maybe. Okay. But this is just nitpicking, to be honest. All right, now that we've deleted the folder itself, we need to delete the user because that's what the user actually wanted. They wanted to delete the user. But up until this point, we've been busy just deleting the user-generated content. So let's go ahead in here and just say await user.delete. All right. And let's put a comment in here and say delete the user. And after deleting the user, we're going to sign the user out. So sign the user out, or log the user out as well, you could say. Then we're going to await on Firebase auth instance, and then we're going to say sign out. All right. So after doing all of this, we're actually going to sign the user out as well in the UI of the application. So let's go ahead and say we're emitting a new state, const app state logged out, and we're not loading anymore. And logged in, no, we want to have the logged out, and we're going to say we're not logged in anymore. Okay, so let's put a comment here as well. And that part is also done, as you can see in here. Let's just say this log the user out in the UI as well, right? That's great. That's really all we have to do for the app state, for this particular event where the user, which is called app event delete account. Okay, that was a big one. That was quite a lot of code. So what we need to do now as the next step is actually handle when the user wants to sign out. So signing out is very similar to this part. As you can see here, we should just say sign out and then emit a logged out state. So this particular event is going to go a lot smoother to implement. So let's go ahead in here and say handle logging out in here. Okay. So log out event. So we say on app event log out like this. Then we have two parameters as usual, emit and event and emit. And let's make this guy an async function like that. So the first thing that we need to do in here is to emit a loading state. So if the user says log me out, the first thing that we're going to do is to say, okay, we're going to log you out, but we're immediately going to send you to the login page. Okay, so even while we're logging you out, you shouldn't see your content. So let's go in here and say start loading. As you can see, we're emitting the logged out state immediately, and we're saying we're loading. Okay. Then we're going to take the code that we wrote in here, which is Firebase. Let's see here. You can see in here this particular code. So we just need to copy that Firebase auth instance sign out, and then we're saying logging out with loading false. So let's copy that and bring it here in here, app event log out. And right after this emit, I'm just going to chuck that code in. You can see it says log the user out with sign out, and then we're saying that we're not loading anymore. Okay. So that was for deleting an account. We've handled uploading image, and we've also handled logging out. And now we should go ahead and handle the app initialization itself. So let's go ahead and implement the next event. The next event is going to be for app initialization, because as you know, what we said before is that whenever a user lands in our application, that the user is going to end up being in the login page initially, because what we do in the beginning of our block, if you look in here, the initial state's always logged out. But the plan is that we're going to have a UI component, or someone at least, send an event to our app block asking the app block to initialize itself. And this initialization is going to be a very simple process. All we're going to do is to have a look at the current user. If we do have a current user, we're going to go get that user's images with that get images function that we have at the bottom of our block, as you can see in here, get images. And then we're going to say, we're going to emit a new app state telling the application that now you're logged in and here are your images. However, if the current user is null, so meaning that the user hasn't logged into the application, we're going to say that the user stays logged out. Okay. So let's go in here. As you can see at the bottom of the screen, we're going to go ahead and handle app event initializing here. So let's just say on app event initialize, and we have an event and an emit in here. Let's make this function an async function as well, and close the parentheses in here as well. So upon doing that, what we need to do first is to grab hold of the current user. So get the current. I can see my do not disturb for some reason was turned off. I'm just going to make sure that it is until this evening. Now let's go ahead in here and say we get the user. So let's just say final user is Firebase auth instance auth Firebase auth dot instance current user. Okay, and we're going to say if user is null, then we're going to just say that if there is no user, then you're logged out. So we're going to emit a const app state logged out, okay, like that. And we're going to say you're not loading anymore, okay? Or not anymore. It's just that you're not loading. Because, upon doing event initialize, in the beginning of this event, at least when we get the user, since this function is not an asynchronous function, we're not starting any loading process. Otherwise, you'd have to say, first of all, go ahead and emit loading true, then get the user, and then emit loading false. However, since this function particularly isn't an asynchronous function, it returns immediately. We don't have to actually put the user in some sort of a loading screen while all of this is happening, okay? So if the user is null, all we're going to do is to say, okay, emit this. However, if the user is not null, then we're going to say, go grab the user's uploaded images, okay? So let's say final images is get images, and we need the user ID. So we're going to say user.uid, okay? And this needs to be awaited on because it's an asynchronous function returning a future of iterable of references. After that, we're going to go ahead and emit an app state logged in. So if we have a user, we have to tell the application that you're logged in. So let's just say emit app state logged in. As you can see in here, we're not loading anymore. The user is user and image is images. Let's change this variable to images. Put our trailing commas in there. And really, that is it. We don't have to do much more for this particular event. It's just initializing the application, setting you to a logged out state if there's no user, and setting you in the logged in state if you are already logged in and if you have a user, okay? Great stuff. After that, we need to go ahead and handle registration. If you remember from the app event register, if I search for it in our app events, you can see in here, sorry, let's find register. You can see we have two properties in here, is the email and the password. So we're going to consume the email and password and actually register the user with Firebase authentication, okay? So let's go ahead and create a new block in here. So we're just going to say on app event register. We have the event and an emit, as you can see, okay? And let's make this guy an async function as well, as you can see in here, all right? Great stuff. In register, if you think about register, what event, what state do we want to emit while we are registering? If you think about it, if we go here to our application, to the simulator, in here, register screen, sorry, here. So this register button is going to send this event to us, app event register. So what state are we in if we are in the register screen? Well, if you look at the app state, we have a special app state that is called app state is in registration view, okay? And that guy also has a property of is loading an auth error. So let's go ahead and emit this, because we know that if you send the register event to us, you should be in the registration screen. So we're going to emit this state and say that you're now loading. Okay, so let's go back to our app block in here. And the first thing that we're going to do is to start loading. So let's say start loading, and we're going to say emit const app state is in registration view, and it is indeed loading. So the trailing commas to get the code formatted correctly. After doing that, we need to get the email and password from the event. So let's say final email is event.email and final password is event.password, okay? So we have the email and password in this event handling. We need to go ahead and register that user, okay? So let's put this whole thing inside a try and catch block. So let's say try, and then we're going to say on Firebase auth exception. If there's any authentication exception while we're trying to register the user, catch it as the parameter E in here. And then we're going to say we're going to emit the app state is in registration view. And we have two parameters in here is loading. So upon getting an error, we're not loading anymore. And having that error, we have to parse it as an auth error from E. Okay. So let me format this code a little bit better. So now you should be able to have a look at it. So upon us getting any authentication exceptions by trying to register a user, we're wrapping that authentication exception inside an auth error and passing into our app state is in registration view. Again, remember, all our app states, app state is a registration, app state logged in, app state logged out, they all come from app state as an abstract class. This app state has two important properties, is loading and auth error. So that's why in here in our app block, upon failing to register the user, we should be able to pass these same two parameters to our app state is in registration view, because app state is in registration view is delegating these two parameters to app state as an abstract class, which this class is itself is extending. If you have a look in here, extends app state. Okay. Good stuff. So now we're catching any possible authentication errors. What we need to do is to actually go ahead and register the user. Okay, so let's go in the try statement in here and say final credentials is await Firebase auth instance register, or actually it's called create user with email and password. We have the email and password here. Let's put the commas like this. Create user with email and password, and we're awaiting on it, and this returns a user credential object to us. All right. So having that, what we're going to do is we're going to get the user ID. Let's say final user ID is credentials.user, and then we're going to force unwrap it, and we're going to say UID. Okay. So now after getting the credentials, let's in here just say create the user. And then what we need is to get user images. So upon you basically registering your user, to be honest with you, you could in here argue that if you've just registered your user, you don't have any images. So that would also make sense. I mean, we don't have to go and grab your images. So let's just not do that. Let's just emit in here. And we're just going to say we're emitting an app state logged in. All right. So upon doing that, we're just going to say app state logged in. And we're going to say we're not loading anymore. Here's your user, credentials user, and there are no images. Okay. And then let's close this, close that, and this one as well in here. And then a const like this. All right. So we got your credentials. We know that you've registered successfully. If this statement goes through and we don't come into the Firebase auth exception error handling in here, or the catch statement, then we should be emitting a state of logged in. Okay. So just remember, when you create a user, that user is also logged in by default. Okay. So this logs you in as well. All right, now what we need to do is to handle this particular event in here. As you can see, the event is called app event go to login, and it is actually sent to our app block when the user taps this particular button in the register view. When you're in the register view, the user can ask to go into the login view. So by pressing this, all we're going to do is just to say that the app state is logged out, that the app state is no longer is in registration view. Okay, so let's go ahead and handle that. So let's just say on, as we can see at the bottom of the screen, app event go to login, and then we have our events and emits, and this function really doesn't necessarily have to be async. Okay, the only thing we're going to do in this function is just to emit a const app state logged out here, and we're not loading. That's really it. I mean, it's not more complicated than this. If the user says that I want to go to the login screen, boom, they're in the login screen. So no loading, nothing in here. Okay. Now, after registration and going to the login screen, we have to handle the next event, which is the actual logging in. So if a user comes in here and they're on the login screen and presses the login button, then we need to log that user in. All right. So let's go ahead and handle that. So we're going to say on app event login. All right. And then we have the event and the emit. Let's make this guy an async function. I don't know why we have so many parentheses in here, and like that. All right. So upon doing login, the first thing that we need to do is, I mean, if we log out in here, you'll see the first thing that happens when the user tries to log in is a loading screen. You see here? So what we need to do is just to say, okay, we know that you're trying to log in. That means that you're already logged out. So what we're going to do is we're going to emit an event of a state of logged out, but we're going to set is loading property to true. So let's just emit that, if I can spell. Emit const app state logged out like this, and we're loading in here.
okay, like this. After loading, we're going to go ahead and try to register you. So register, log the user in, final email. Let's grab the email and password out of the event itself. So we're going to say event email. Final password is event password. And then we're just trying to log you in. So let's say final user credential is await on Firebase Auth instance log, and we have to say sign in with email and password, and we have the email and password in here. Have a look at the code, please. We're awaiting on Firebase Auth instance sign in with email and password, and this gives us user credential. All right. So after that, let's grab the user. So we're just going to say user is user credential dot user, and we're going to force unwrap it. All right. And after doing that, what we need to do, actually, to be honest with you, now that we're working with like user credentials and stuff, let's put this whole thing in a try and catch statement. So because logging in is also going to have a lot of potential auth errors. So let's say try, and then we're going to say on Firebase auth exception catch E. Okay. And in here, let's just emit an app state logged out. And we're going to say, yes, your app state logged out here. Oops, one of these. Yes. So if you can't log the user in, we're just going to say, okay, we are not loading anymore. And then there's an auth error from E in here. Okay. So it's very simple. We want to, in this try statement, try to log the user in. But if that's not successful, we're going to say, okay, you're still logged out. We weren't able to log you in, but now all of a sudden we're not loading anymore. And then we we actually have an auth error in here for you that you have to handle in the user interface. Okay. Let's go back to our try statement and paste the code that we had caught from before. So we have the email and password in here, and then a user credential. Then we get the user in here. Then after getting the user, we need to get that user's images. So let's go and say final images is await on gets images with the user UID. Okay. So let's say gets images for user. And then we need to emit a state of logged in, because we've already logged you in here. You can see with the sign in. So, and we also got your images. So we now have to emit a logged in state. So let's say emit app state logged in. All right. We're not loading anymore. We have the user and we have the images. So if you name your properties, if you name these local variables right, they will just plug in like butter here. You can see I didn't even have to type any of these two parameters in here. They were just like placed in there for me. All I had to do was just to say is loading is false. All right. Great stuff. That was really it. I mean, we don't have to handle so much more here. Let's just put a trailing comment here to get the formatting right. And we've handled now app event logged in. That was it. So you just have to say sign in with email and password. And then if it's successful, we say app state logged in. If not, we just say app state logged out with that auth error. Okay. So let's now handle going to registration view, because if you're in the screen and then the user says not registered yet, register here, what this is going to do, all it's going to do is just to emit this particular state. App state is in registration view. Okay, so let's go ahead and handle that. So I'm going to go on top here above app event logged in. I'm going to say on app event go to registration. And then we have an event and an emit. As you can see in here, one extra parenthesis set in here. And in here, the only thing really we have to do is just to emit const app state is in registration view, and we're not loading. Okay, like that, and trailing commas in there as well. Wow, that was a lot of work. So to be honest with you, we're actually done now with our app block, I would say. So we've handled all the events that can come in, and we're emitting all the required states to the application. So if you want to have a look at your app block, I mean, it's a lot of code for me, at least in here. I can see there's a lot of code, but also this font is so big, so it could look a lot more than it actually is on the screen. Okay. Great stuff. We're now done with handling our app block, so we can move on to the next step.
And the next steps for this application are actually going to be us working on the UI part, because we've done quite a lot of work on the app state, the app events, and the app block itself. So it's time to put them together and bring the UI to life, because up until this point, we've just kind of been writing code in the dark and not really knowing if any of the code that we've written really works. So it's time to fix that and go ahead and start working with our UI. So if you remember from one of the examples before, I don't actually know which example it was, but we wrote a generic dialog that we could create buttons in that dialog using like a hash map. And we could also go ahead and change the title and the text. So we, as you know, we've been doing these examples all in the same project. And then after every example, we were like almost removing all the files and starting afresh. So now we need to bring one of those files back, and that specific file, as you can see at the bottom of the screen, is called generic dialog. So you need to go and have a look at all those examples and just find out which one it was. I don't unfortunately know which exactly, but once you see the code, you will know which one I'm talking about. So let's go ahead in here, and I have that generic dialog already in another project in here. So I'm just going to go ahead and bring it right here. So let's go ahead, as you can see at the bottom of the screen, and create the folder for that under lib. So we're just going to say new folder in here, and we're just going to say dialogs, okay? And in this dialogs, let's just expand dialogs, and I'm going to just drag and drop that file under dialogs in here and just add it. And this is just a refresher for you. Have a look at it. It was a generic dialog. As you remember, it has a title and a content, and it had a build context, of course, but it also had this options builder, which was a hash map whose keys were the titles of the buttons, and then these were the values of that button that were being returned from this generic dialog. So we're not going to write this code again. We've already done that in one of the examples before in this exact chapter. So if you can go ahead and find that file, which was just called generic dialog.dart, it could be example 3, 4, 5. I don't really remember, unfortunately. So, but we're not going to write it again. That's the point. So we need now a file for a dialog for account deletion. Let me bring that dialog up in here. So if you log in with this user, and then I say in here, delete account, here's that particular dialog that now we want to implement. And the implementation of this dialog is going to use show generic dialog, because if you have a look in here, the cancel button is going to send the value of false, and the delete account button is going to send the value of true. So we're going to use this dialog option builder to have the keys of cancel and delete account, and then values of false and true respectively. All right, let's go ahead and create that file. So inside our Explorer, inside dialog, let's go ahead and create delete account dialog, delete account dialog.dart. Okay. And inside this delete account dialog, we're going to go ahead and use our generic dialog. Okay, so let's just say we're using this dialog returns a future of bool, and we're going to say show delete account dialog, as you can see at the bottom of the screen. So show delete account dialog, and it has to have a few properties. And actually, sorry, it just has one property or one parameter, which is the build context on which it has to build and display itself. So let's say that the property is build context, and it's being auto imported from material in here, I can see. And let's just in here then say show build context, because that's the only symbol from material that we're interested in. Okay, so that's our context in here. And then this function itself is going to return our show generic dialog. Okay, and it needs to be imported, this show generic dialog. So be a little bit careful with show generic dialog, because you see, we have our own implementation of show generic dialog, but Flutter also has a show generic dialog, which doesn't work the way we want it to. So in here, you can see it says, oh, I have a show generic dialog for you that you can use, and it has a few required properties or parameters. However, there is no import in here, so we know that it's not importing anything in order to be able to use it. However, if we're using our own show generic dialog, we need to make sure that the specific file generic dialog.dart is imported. So make sure that you import the correct one. In here, we need to say show generic dialog. And as you can see, it imported generic dialog Dart in here for us, so we know it's the correct implementation of show generic dialog. Okay, the context is going to be there, as I said, and then for the title and the content, I'm just going to copy paste them from what I already have, so we don't have to type string in here, because otherwise this chapter could potentially be 20 hours long.
Now for the options builder, what we need to do is to create a map in here. So this guy is an actual function that returns a map. So a function that returns a map. For the first key, we're going to say cancel. Cancel, as you can see in here, we have cancel. And this key's value should be the value of false, meaning that it doesn't want to delete the user. Okay. However, for the delete account button, we need to return value of true in here. And let's say that our entire show generic dialog has a return value of bool in here. Okay. And remember, on Android, for instance, when you display a generic dialog or any dialog, even here on iOS, let's say in here, delete account, the user can always click or tap anywhere outside this dialog in order to dismiss that dialog. So if I tap in here, boom, you can see that the dialog is dismissed. So just because we're displaying a dialog doesn't necessarily mean that the user will indeed tap on any of these buttons. And that is the reason the result of this show generic dialog is actually an optional Boolean. So meaning that if the user cancels or dismisses that dialog, we're not going to get any Boolean in here. So we're actually going to get null. So let's go in here and chain this with a then, and then we're going to say we either get this value you can see as an optional Boolean, or we return false, meaning that if the dialog is canceled, we're simply saying that we have no value to return. Let's format this a little bit better as well. Let's put some colons, trailing colons, so that it is formatted nicely. And I think we're pretty much done with this, to be honest with you. Just like we have the delete account dialog, we also need a dialog for logging out, which is this guy in here. You can see it says log out. Are you sure you want to log out? And then cancel with a value of false and a log out with a value of true. So it's going to be very similar with the delete account dialog. Let's go ahead and create that dialog as well, which is going to be a logout dialog under our dialogs folder. So I'm just going to say here, dialogs, new file, and I'm going to say logout dialog.dart. Okay. So let's go ahead and implement this guy. It's going to be very similar to the delete account. So let's just copy the contents of delete account dialog and chuck it in logout dialog. Okay. And we're just going to call this guy show logout dialog. So show, let me just fix this here. Okay. Show a logout dialog. And then for the title and the content, I'm just going to copy paste them from another project in here. So it's just going to say logout as the title, as you can see in here. Let's bring it up. Logout. The title is going to be logout, and the text is going to be, are you sure you want to log out, which is right here. The buttons are going to be cancel and log out. So let's fix this one. Log out, as you can see, log out. All right. And it's going to do the exact same logic as the delete account dialog. So it has its own title and content and options. However, the rest is exactly the same. Okay, so let's save that file as well. Now for any authentication related errors, so excuse me, if I log out in here and I try to log in with the incorrect password, you can see we have this authentication error and unknown authentication error. So we just need a simple dialog similar to these, like show logout dialog and show delete account dialog. However, this particular dialog is not going to have any other options except for the OK button. So we need to go ahead and create a generic show auth error dialog. So let's go into our dialogs and just say show auth error. Okay, right click on it, a new file, show auth error, Dart. And in this show auth error, we're going to have a generic dialog, which just has, which it takes an auth error, and then it builds itself using that auth error. So let's go ahead and take our logout dialog. I'm just going to copy this guy, okay? And I'm going to bring it into show auth error. And we're going to call this function, as you can see at the bottom of the screen, show auth error, okay? So this function is called show auth error. However, if you want to display an auth error, you also need to know which auth error you need to display a dialog for. And that is why we're going to go in here and say, okay, you give us not only the build context, but also an auth error in here, which is going to be also important in here, okay? And we're going to say auth error, okay? And let's make both of these properties required name properties as well, like this, and then we just say both of them are required. Great stuff. Now that we have an auth error, if you look at this dialog that appears here, this has no true or false. It basically has no values. So it's just a dialog of void. All right. So let's go in here and just say future void, excuse me. And then in here we say show generic dialog of void. And we don't need this then statement right there. Okay, so it's just a void. All right. After that, let's have a look at the properties in here. So for the title, you may be asking, okay, but what title do we display? Because these errors, as you can see, it says authentication error and then unknown authentication error. Well, it's been a while that we wrote those auth errors, but let's go to the auth error file. And if you look, every auth error has a dialog title and a dialog text. Do you remember that? So like, for instance, error no current user, it has a title and it has a dialog text. And also even this one, unknown authentication error, let's find it. Unknown right here. Okay, you can see its title says authentication error and its text says unknown authentication error, and these two are the exact same two things that we're displaying in here. So if another error happened in here, for instance, if you went to registration screen and then tried to register with an invalid email and said register, we will get this dialog that says invalid email. So if you search for it, you'll see it right here. It says invalid email. Please double check your email and try again. So these things are already built into auth error. So the only thing we need to do in here is say, given this auth error, the title is going to be auth error dot, if I can spell, error dot dialog title, and then the content is going to be auth error dialog text. And for the button, we only have an OK button because these are just informative dialogues. They don't actually let the user take any action. Okay. So let's go in here and we just say we only have an OK button and its value is just true. Okay, because we don't care about the value. It's just a dialog of void anyways. Okay. All right. So now the next piece of code that we have to write is to help us achieve this particular functionality. If I kill this application and we go to this here, you can see as soon as I start the application, then these text fields are already pre-populated for us. So if I remove the text inside this text field, you can see that it has a hint, all right? But we never see these hints simply because while our app is being debugged, it is so much easier if we could just have email and password pre-populated in these text fields, so you can always try to log in and log out, register a new user without having to actually type all of these things, because it is quite cumbersome to go ahead and type the username and password, the email and password. So what we're going to do is to create a little utility that is going to allow us, as you can see at the bottom of the screen, is to pre-populate our text fields with some text, in this case an email and a password, if we're debugging our application. And while we release our application, that logic won't kick in. All right, so let's go. As you can see at the bottom of the screen, we're going to go create a new file under lib. So new file, and I'm going to say extensions, and it's going to be called /ifdebugging.dart. Okay. So in here, what we need to do is to create an extension on string. So we're going to say extension if debugging on string, if debugging on string. And then what we're going to say is to say string get if debugging is the actual property. Then we're going to say if k mode, k debug mode. You can see that this k debug mode is going to be also auto imported for us from Foundation. Let's say show k debug mode, and have a look at this. You can see it is a Boolean. Okay, so if we are debugging, then return the current string, otherwise return null. This allows us then later to write code like this. For instance, if you say your email, for instance, in here, and then you could just say if debugging, and then put this in your text field or text editing controller. What happens in here is that this property changes this whole string to null if you're not debugging, and it returns the exact same string if you are debugging. You can see in here. Okay. So this is a cool little trick that I like to use when I'm debugging my applications in order to make sure that I can, for instance, pre-populate some text fields with default values while debugging the app. Okay. So now you should have implemented the if debugging. I should have brought this card up a little bit earlier.
Okay, so what we need also in this project are our loading overlays. You see in here, we have a login. So if I press the login, then there's a little bit of a loading overlay on the screen. So if I go here, you see the loading thing. One more time, you see loading. So we've already written this overlay in one of the examples before. I think it was example 6, I believe, but it was in one of the examples. So if you go back to your Git logs and Git commits, you should be able to find, Git tags and Git commits, you should be able to find these two files that I mentioned now at the bottom of the screen. So let's go ahead and create a folder in here inside lib and call this folder loading. So loading in here, and we should bring those two files back, the loading screen controller and a loading screen. So we're not going to write the same files again, okay? So let me bring the loading screen and the loading screen controller under the loading folder and just chuck them in there. And we can see it's complaining about loading screen controller because loading screen controller at this moment is not linked into this file because the package name is changed. So let's go in here, remove this import, and then auto import loading screen controller at the right path. So if you've done this correctly, now loading screen and loading screen controller should be, the correct color, not red at least, okay? So they should have no errors in here. And I completely understand if you're sitting at home or anywhere and you're like following this course and you're not using Visual Studio Code, you may not have like the ability to see these files as red if you mess something up in them in the Explorer. So you may be using IntelliJ IDEA or Android Studio, and Android Studio may work differently. So I'm trying really hard not to say if this file is red, because in Android Studio it may not be red if you have any compile errors. Okay. So now we have the loading screen and we have the loading screen controller. So what we need now is to go ahead and create a login view. So this is very important, okay? So let's go ahead and start working with our login view, which is one of the first UI components that we're going to create inside our entire application. So let's create the file for it first. So it's going to be in lib views. Let's see if we have views already, and we don't. Let's right click on it and say new file, and I'm going to say views, if you can see it as well, views, login underscore view dot dart. Okay. And now we have our login view Dart in here. And what we're going to do is just to start implementing it now. Now that we have the file in place here, let's go ahead and start the implementation of our login view. Now, if you saw the how the application actually looks like, if you go here, you can see that our login screen is very simple. It's really just a column with two text fields in here and text editing controllers. And we have a login button and a register button in here. This register button actually doesn't register you. It only sends you to the register screen. We have an event for that, if you remember, that says go to register view or something like that. If you have a look at our app event, we had app event go to login, and then we have another event that says go to register, okay? Or go to registration rather. So let's go ahead and implement our login view. And for this, I've chosen to use Flutter hooks because we have two text editing controllers, and I don't want to go and create a stateful widget just so that we can have text editing controllers. So I have actually a video in my Flutter state management course on YouTube where I explain Flutter hooks in great details. But in this example, we're just going to use Flutter hooks for the sake of having text editing controllers without making our widget a stateful widget. So I'm not going to go into details about Flutter hooks, and I hope that even if you don't know Flutter hooks, then you're going to be able to at least understand what we're doing in this example, okay? So let's go ahead in here, and I'm just going to create a stateless widget for now, and let's call it login view. And let's go ahead and import material so that we don't have problem with stateless widget. And then what we're going to do in here, we're going to change this to a hook widget. And you can see that it's going to auto import it from Flutter hooks. And we've already imported, if you remember from before, we've already imported Flutter hooks into our application. So if you have a look at PopSpec YAML, we have Flutter hook somewhere in here. We have it here. And that is basically the reason we import Flutter hooks at the beginning of this example. So we imported quite a lot of stuff: Firebase core, Auth, storage, image picker, UID, and alongside all of that, we've also imported Flutter hooks, okay? So we have a hook widgets in here. And what we're going to do is inside the build function, let's go ahead and create two text editing controllers. Okay, so that now that we have a hook widget, we can go ahead and use all the available hooks and Flutter hooks in here, all the functions that start with use, as you can see in here. Okay, so let's go ahead and say final email controller is use. Use, and let me just move the Explorer out the way. So use text editing controller. Okay, and then you can provide a default text in here. And what I've done in here, as you can see, even if you remove this application from running and start it again, it is already pre-populated with some information. And the reason I do this in my applications is so that I don't have to type this over and over again as I'm testing the application. However, this information should only be populated inside your text editing controllers if we are debugging the application. So when you go and release the app, these texts shouldn't be present in there. And if you remember, we have this little property that said if debugging, I believe, here. And you can see it's an extension if debugging. And we're going to use this extension now. So in the text of this text editing controller, we're just going to say that we're going to use, for instance, my email address for now. But we want this text to be populated inside this text editing controller only if we're debugging the application. So let's say if debugging. Okay. Let's see if Flutter understands if debugging here, and it's going to import it for us in here in Visual Studio Code. Okay. So that's our first text editing controller. And we're going to do the same thing for password field. So let me just copy this and let's paste it in here. And let's call this one password controller. Make the text a little bit bigger as well. And in here, we're just going to add a password in here that says foo bar bass. So it's just a very simple password. Please don't use this in production at all. This is a horrible password, but for testing purposes is sufficient. Okay, now that we have that, let's go ahead in here and return a scaffold. So I'm going to go and say that we have a scaffold in here. Let's say return scaffold, okay? And we have an app bar. And for the app bar, we're just going to, on top of the screen, as you can see, we're just going to go and say we have an app bar that has a title of login. So let's say, excuse me, that we're going to create an app bar in here. And the title is going to be a const text that says login, like this. Okay, let's put all the trailing commas in here so we get the formatting correct. And depending on your style, you may want to go ahead and put a trailing comma in here as well. And so that if anybody wants to add some properties to this later on, they don't have to put the trailing comma themselves there. Okay, that's the app bar. For the body, let's just go ahead and create a column. As you saw in here, we have a column. So, and this column, to be honest with you, needs to be inside a padding, but padding is always easier to create when you already have a component, and then you can wrap it with padding. At least that's my opinion. Instead of having to say, here we have a body of padding, and then this has a child of a column. What I usually do is I say, well, the body is a column, and then I say children is like empty in here. Put a trailing comma in here, trailing comma in here, and then I go ahead in Visual Studio Code and right click on this and I say wrap it with padding. This, I find this to be a little bit easier because writes quite a lot of code for us. Okay. All right, now that we have that, let's leave this padding as 8 points in here. The first child of this needs to be a text field. As you can see in here, this is for the email, and then we have a text field for the password. So let's go ahead in here and say text field, okay? Text field like this. And its controller is going to be the email controller. All right, we've already created this. And let's go ahead and create another text field in here. And we're going to say the controller for this guy is the password controller because this is our password text field. Great, now we have two text fields in here. And now that we're working on the UI of the application, you may think that, well, let's go ahead and have a look at how this actually looks like on the screen. But what you need to also understand is that we are kind of like writing code in the dark. We don't really know how it's going to look on the screen simply because we don't have any routers in the application. We haven't actually instantiated our login view, so we don't really know how it's going to look like. And that's kind of okay. As you get more and more familiar with Flutter, you'll understand that, okay, you can just kind of visually in your head visualize, or you can in your head visualize how this is going to look like on the screen. So it's very simple. It's a stateless widget with text editing controllers and two text fields for now. Okay. So we're not gonna, that's what I mean. We're not gonna run the code at the moment, because at the end, when we put all these UI components into their own implementations, we're going to go and hook it up with our block. And until that point, we can't see how this actually is going to look like on the screen, okay? So we have our email controller, and we're going to go ahead and add a little decoration to it. So because if you remove this text in here, so if your user is running this application in release mode, when they land in here, this text in the controller is going to be empty, or this text field is going to be empty, and all they say is a hint that says enter your email in here, okay? So let's go ahead and create a decoration in here, and we're going to say const input decoration. And in here, we're going to say hint text is going to be enter your email here, okay, like this. So that's for our decoration. And it's also very important that when the user comes in here and they see the keyboard, that they see this @ sign in here as well. So we need to make sure that the host operating system understands that this is a text field whose value should match an email. And therefore, if you give this hint to the host operating system, then the host operating system is going to display the correct keyboard as well on the screen, okay? So let's go in here and say keyboard type. We want an input type, I believe it's called, or text input type. Text input type dot email address. And then we also want this keyboard. I mean, this is just nitpicking. We just want it to be dark, okay? So let's say keyboard appearance, and that is brightness dot dark, okay? So this is for our email text field, and it's so reusable that we're just going to copy this, except for the controller. So let's just copy all of this and then put it inside our password text field. Okay, so let's just chuck it in here, and then instead of enter your email here, what we're going to say is just to say enter your password here. So enter your password here. We're going to remove this keyboard type because it's not an email. Is there a password, visible password? No, we're just going to remove it. Okay, so no keyboard type for the password text field. Make sure it's password controller so that you haven't copied email controller in here as well. And it says enter your password in here. And what we also need to make sure that it is obscure text, because you see the characters in here shouldn't be displayed to the user. So let's go ahead and say obscure text is true. It's a Boolean property. And also there's another property here. It's called obscuring character. And I like to play with that a little bit because the default one isn't so pretty. In my opinion, it's kind of like asterisks. So I like to go ahead in here and bring up in this emoji view. And I'm going to use this bullet character in here, as you can see. Either that one, or we're going to use another bullet, which is a little bit bigger. It's this one. Okay, instead of that one, I'm going to use this one. And if you're at home and you're running this on Linux, or you're running, or what I mean is that if you're at home and trying to implement the same solution on Linux and Windows, you may not have the ability to bring up all the emojis and then pick from them. If that is the case, if you're at home and running Windows or Linux, just don't enter this. You don't have to. This is just nitpicking. This is just for style. Okay, so just completely ignore this. If you're on Mac, it's a little bit easier. You just have to press Control, Command, and Space, and it brings this up for you. And then you can just type circle, for instance, and you can find all these circular characters, or you could just say bullet, and you will see all these bullet characters in here, okay? So it's a little bit easier. I don't even know what this is really called. It is called, let's see, fisheye. So it's called fisheye. All right, so if you search for fisheye, you can find this character that I've entered here, okay? Great stuff. Now that we have these two text fields, we need to go ahead and implement this thing in here. This button that says login and the other button that says not registered yet, register here, okay? So let's go ahead and do those components. So what we need in here right after this is that register button. So let's say we need a, let me scroll this up as well. We need a text button, and text button has two important properties. One is onPressed. So let's just say onPressed is an empty function for now, and a child of const text. And in this text, if you look, we're just going to say login. Okay, login right there, and some commas to get the formatting correct. Excuse me. And then let's go ahead in here and implement our text button. So when you are here and you press the login button, all we're going to do is to extract the text in this text field and in this text field as well. So the email and password, and we're just going to send them as an event and dispatch them as an event to our app block. Okay, so what we're going to do later is to wrap our entire application with an app block provider. or a block provider actually. And that block provider is going to provide the entire view hierarchy of our application with an instance of our app block. So anywhere inside your application while working, like in this login view, you could just assume that you have an instance of app block. So you can read that instance from your build context, all right? So let's go ahead and grab our email and password. So let's just say final email is emailcontroller.txt, okay? And then we're going to say password is passwordcontroller.txt. And what we need to do is just to dispatch this to our app block. So let's go to the context, our build context, and say read. And then we're going to say app block. And let's just auto import app block. And remember, read isn't a part of our application yet because we haven't imported this Flutter block. So let's import Flutter block so we have access to the read function as well. And when you do that, then you can actually send an event to your app block. So let's just say add. So what is the block events that we want to dispatch now? And that is app event login. All right. And you can see we have email and password, and they just fit in very nicely, just like this. All right, that is really it. That is what we have to do for our text button login. So all it does is really goes to the build context and finds the app block and then dispatches an app event login to the app block. All right. So what we need to do is kind of like copy this text button, and we're going to use the same kind of logic, kind of the same thing for this button that says not registered yet, register here. So I'm just going to copy this text button all to the end, and then I'm then going to paste it in here right after that. The text for this guy is going to say not registered yet, and registered yet, question mark, registered here with the sign in here, okay? And then in here, we don't need an email and password, so let's remove the email and password. And then what we're going to say in here is that we're going to dispatch another event, which is called app event go to registration. And this can be a const, okay? So you can see in here, the second button is just going to tell the app block to go to the registration view. And you'd be surprised that that is really all you have to do in your login view. You can see there's no business logic in here. All the login view is doing is that it's dispatching events to your app block. So it doesn't have to be more complicated than this, okay? So after we've done the login view, we're going to go ahead and create the file, at least for our registration view. So let's go inside views in here. As you can see at the bottom of the screen, we're going to go ahead and create a file called registerview.dart. So I'm going to say registerview.dart in here. And this registerview.dart is very, very similar to our login view. So it makes complete sense because, I mean, before I say it makes complete sense, if you go and have a look at how they look like on the screen, so if I remove this application and then go in here, testing block, you can see this is the login view and this is the registry. Do you see how similar they are? It's just some text that are different and the actions of these buttons that are different, but the rest is exactly the same. You see? So let's go ahead and copy the entire contents of this login view and then paste it in the register view. All right, and I'm going to remove the Explorer, and I'm actually going to close the login view as well. So let's go ahead and change some stuff in here. This is not login view anymore. So let's call this guy register view. So I'm going to say F2 in Visual Studio Code. I'm going to say register view. So that changes the constant constructor in here as well. So let's have a look at the code. We have an email controller, and that's completely fine. We have a password controller. It's also fine. Instead of saying login, we're going to say register on top of the screen. You can see in here that says register. And then enter email here. This is exactly the same thing that we had in the other screen. So let's just leave it in here. Enter email, enter password. Now, when we come to this button should now say register instead of login. So let's change that to register. And the event that this button has to send is not app event login. It should be app event register. Okay, so you see it just plugs and plays very nicely. So just changing a few parameters and we're good to go. Then we go to the second button, which is this one. It says already registered, log in here. So let's say already registered, log in here, okay? And then in here, the event that we have to say is not app event go to registration. It should be app event go to login, all right? And just like that, we're done with the register view. So it's just changing a few parameters and we're good to go, as you can see in here. Okay, I don't think we've made any mistakes in here, but we'll know that when we go to putting all of this together and actually running our application. Okay, so what we need now is to go ahead and implement another important UI component in our application, which is this pop-up button. Let's go ahead to the login view and have a look at this. If you press this button in here, you can see that it displays this pop-up dialog. You can see it says log out and delete account. So we need to implement this as its own separate component. All right. So let's go ahead inside lib views in here and say new file. And let's go ahead and create main pop-up menu button .art. Okay, so let's go ahead and implement this component. So we need two actions in here. As you can see, one is logout and the other one is delete account. So these two actions are then going to be dispatched to a component that is then going to take care of displaying a dialog or whatever it is. Okay. So let's go ahead and define these two actions for now. So one action is going to be logout, the other one's going to be delete account. So it makes perfect sense for us to basically have these as an enumeration. So let's say enum menu action, and then we're going to say logout and delete account. All right, so we have two enum values in here. And our main pop-up menu button is going to be a stateless widget. So let's say STL and create a stateless widget in here. And I'm going to say main pop-up menu button. All right. We have lots of errors in here because stateless widget and other components aren't available. We don't have material in here. So let's import material. And that is that really. So what should be inside this guy? Actually, it should be a pop-up menu. So let's go ahead and instead of a container, return a pop-up menu button. All right. And this pop-up menu button is going to return an item of this type. So it's actually going to return the action that the user performs on it. So let's just go in here and say, because if you look at the source code for pop-up menu button, you'll see that it's actually a generic. You see it returns something, and that something is completely up to you. It's kind of like when you display a generic dialog. What you place in that dialog is completely up to you. The value of that dialog will then be decided by you as well when the user taps on any of the items. So let's go ahead in here and say this pop-up menu button returns an item of type menu action. And then we have quite a lot of code actually to do in here. We have item builder. So let's go ahead and first implement our item builder. And we get a context in here. And it's now up to us to display what this pop-up menu button should show the user. So in here, as you can see, if we have a look at the builder, have a look in here, it says pop-up menu item builder. And in here, you can see you should return a list of, you should return a list in here of your pop-up menu items. So let's go in here and say we return a list like this. All right. At the moment it's empty, but you see even putting that empty list in here makes this error go away. So if you didn't have this list, you can see that we're having this problem of the body might complete normally without returning a value. So let's put this list in here. And what we're going to do is to say we're creating a pop-up menu item. So let's say the first item is going to be pop-up menu item. All right. And this is going to have menu action value. Its value, its actual value, you can see it, Visual Studio Code is understanding that the value should be menu action because in here we specify the type. So in here, we're going to say the first item should be logout. If you look at the code, it says, if you look at the UI, it says logout. So let's say menu action logout. All right. And then its child, all it's going to do is just going to be a text. I think it's actually a button or a text. It's just a text. So let's go ahead in here and say that we have a text that says log out. All right, just like that. We're going to take this guy, copy its contents, this one. And for the second item, we're going to say that this one should say, let's see, delete account. And then the text for this guy should be delete account, just like that. All right. Now we have the items that need to be displayed inside this pop-up. What we need to do is also to have to handle the actions, because in here it's not enough that we just display these, but we also have to handle their actions. Okay. So in here, we have the item builder. So let's go ahead in here and define our actions. And that is going to be unselected in here. And let's see if Visual Studio Code can help us. And here we get the value. You can see, since we've already defined the generic types of the pop-up menu button, and the item builder is also returning pop-up menu items of type menu action, then it understands that the value that comes in here is also going to be of type menu action. All right. So let's switch this value. So let's say switch this value, and we get help from Visual Studio Code to complete the missing case clauses in here. So for logout, what we need is to display some sort of a logout dialog to the user. And if you remember, we have this show. Do we have the show? I wonder if we have show logout dialog. Let's have a look at our dialogs. Logout dialog we have in here, and you can see it's called show logout dialog. So that's really good. Let's go in here and say that we want to display that dialog now. So let's make this entire unselected function asynchronous, because we're going to display dialog. So let's say final should logout is show logout dialog, just like that. All right. And you saw that it was auto imported for us. In here, you can see dialogs, logout dialog. And this show logout dialog is now, if we wait on this, then this is a Boolean in here, as you can see. So if the user decides to log out, because you see that here they can say cancel or log out. If they say cancel, we shouldn't log out. But if the user says, yeah, I want to log out, then let's go ahead and do that. So we say if should log out, then we need to log the user out. If you have a look at your app events, then we had an event here that says app event logout, and this is handled inside our app block. If you go here, you can see what it does. It first puts the application in logout state immediately, and it starts loading. Then it signs the user out from Firebase Auth, and then it stops loading once this guy is done. So let's go ahead and send that event to our app block. So what we need in here is to say context.read. And remember, again, we don't have the read function in here until we import Flutter block, and we're going to do that soon. So let's in here say that we need the app block. It's auto imported. Okay, it's imported now here. And then let's close this function. And then I'm going to go ahead and import Flutter block in here to get that read function. Let's go ahead and add an event in here. And this event is going to be a const app event log out, just like that. All right, and put the trailing commas in here. That's for the logout event. It's not more complicated than that. Now for the delete account, we also have a dialog for that. So if you have a look at our dialogs, let's see where they are. In here, we have utils, extensions here, delete account dialog, and its function is called show delete account dialog. All right, and it only needs a build context, and it returns a future of bool. So very similar to this guy. So let's just copy it, okay? And let's go and paste it in here. So we're basically copying the code that we wrote for logout, and we're just going to chuck it in here for delete account as well. Going to get rid of the Explorer on the left-hand side. And let's call this one now should delete account. And we're going to await show delete account dialog. And you can see it's going to be auto imported for us as well. And if the user wants to delete their account, we're going to send an app event delete account. You see, it just plugs and play. It's so nice. It's just like butter. Take the code that we've written here, it's the same pattern, and just put it in here. Okay, good stuff. And for those of you who are like into generics, you could go ahead and make this case handling in a generic way. So you could like say, okay, for every menu action, I want to have a future that returns a future of bool. Should that future of bool be true, then I'm going to do some action on our app block. So you could actually make this generic if you want to. We're not going to do it now because it's just, I feel like that's not so relevant to the purpose of this course. But when I see code like this, I always think, looks really like each other. They're so much alike. And then maybe there's a way to make it generic. But you also have to always think of, like, when you're doing generic stuff, some programmers aren't so comfortable with generic stuff. So you always have to think about that and like the cost of making something generic, if it's actually worth it. Okay. Great stuff. We're also done now with our main pop-up menu button. So what we can do is to now focus on the rest of the application. The next component to implement now after our main pop-up menu button is the view that displays our images. So if we go back to the application, you can see in here, if I log out from this user and then I try to log back in, just have your attention on the images that are going to be displayed on the screen and see that they have their own loading indicator. So if you press the login button in here, you can see these 4 images started loading their content, so they somehow know what to load, and then they start some sort of a stream or a future, and then they ask for that image. While they're waiting for the image to be downloaded or provided to the application, then they display a circular progress indicator. And then when they get the data for the image, then they display that image. So let's go ahead and create a separate component for this, a separate view that we can populate inside of this grid view. We haven't done this grid view yet, but we're going to do that soon. So let's first go ahead and create this component that I'm talking about here. So we need to render the Firebase images. So we need to first create the file for it. So here, as you can see at the bottom of the screen, we have to create it inside views, and then the file itself is going to be called storage image view. So right click here and say storage image view.dart in here. Okay. And this guy's going to be stateless widget. So let's just say STL, and we're going to call it storage image view like this. And you already know this. We have to import material to get rid of all these errors in here. And what this, the build function of this guy needs to return is a future builder. So we're going to go and say we have a future builder. Okay. And what this future builder needs to actually provide to the application is the data for that image. So we're going to say it needs uint 8 list. And you can see it needs to be imported from Dart typed data. So let's do that. And that data is going to be optional. So we're not sure if we're going to get the data for every image in here. Okay. So now that we have that, we also need to basically, when we initialize the storage image view, we need to give it some sort of an image reference to download. So let's go in here and say we have a final reference, and this reference is going to be coming from Firebase storage. If you remember from before, every file that we store in Firebase storage is going to be referred to using a reference class. So we say this is a reference, and then we're going to call it image. So let's go ahead in here and say required this.image. Okay, just like that. And then put a comma in there, and then our builder here, it needs to work with that image. So the future of this future builder needs to grab the data of that reference first. So let's go in here and say the future of this future builder is going to be the image, and then we have a function here that says get data. If you have a look at the function's return value, you can see it's actually a future of uint8 list optional. Hence the reason we've created our future builder of the exact same type as you can see here. Okay. So after adding the future, and let me also bring up the card at the bottom because we're implementing this component. We're not just creating. So let's say the builder, let's get help from Visual Studio Code. It's not helping us, and say snapshot in here. So this snapshot is now going to be an async snapshot of uint8 list. So if you move your mouse over it, you can see since we provided the generic type in the future builder, now our snapshot knows exactly what data type it contains. But if you forget to do this, things still work, but your snapshot now will be an async snapshot of objects. So this is a trick a lot of Flutter developers actually don't use. If you give your future builder actual data type, since this is generic, then he will understand that his snapshot should be of the same data type. So if you have a look at future builder source code, you can see it needs T in here. And then in its builder, let's have a look in here. This builder is an async widget builder of the exact same type. And in here, it has a snapshot. You can see async snapshot of the exact same type. So it's a little trick. These little tricks make Flutter development a little bit more fun as well. Okay, now we have the snapshot. We need to go and switch on the snapshot's connection state. So let's say switch snapshots.connection state. Get help from Visual Studio Code to complete all these case clauses in here. So let's add that. For non-waiting and active, we're going to do the same thing. So let's remove these breaks in here. And while the state is in these enum values, like we either haven't yet connected to the stream, or we're waiting, or the stream is, or sorry, the future is active, then we're just going to say that return a const circular progress indicator in here. Okay. And Let's also put this in center because otherwise it's going to be displayed on top left. So let's say we wrap it with center in here, okay, and put a comma in here and move this const out behind the center in here because this whole thing is a const. When we get the now when we get this state, which it is done, meaning that we actually retrieved the data for our image, then we should go in here and say if, let's say if our snapshot has data, then we are gonna display the data. Otherwise, we're gonna display a loading progress still. However, I need to just warn you in here, and this is not actually warn you, but the correct way of implementing this is going in here and saying else if snapshot has error, and then maybe display the error to the user as well. Otherwise, do this. However, we're not actually going to go ahead and implement the error handling in this view because it makes it a lot more complicated as well. But I just want to make you aware of the fact that if you want to do things right, then you also have to handle errors. So let's say the user is sitting in a train and then they go in a tunnel and these images aren't being able to get loaded. So if that's the case, then you need to display some sort of maybe a button that says refresh or something like that. So keep that in mind while implementing this component. And if you want to pause this video and go ahead and implement that now, you're more than welcome to do that, but we're not going to do it here for the sake of simplicity. So if we have the data, let's go ahead and get the data. So we're going to say data is snapshot.data, and we're going to force on Rabbit. Then we're going to say return an image from memory with the data that coming from our future. And then we're going to say fit, box fit, and then we're going to say cover. Okay. And this ensures that our image basically is covering the entire available space for that part of the grid view. And as you know, this is a grid view. Okay. If you don't do this box fit, then your images, what they're going to do is that they're going to have their own aspect ratio. So some of your images may be like landscape, some of them may be portrait. So they're going to kind of get like each of these images is going to get its own height and width, which is going to make this whole grid view look a little bit funky. So if you say the fit is box fit cover, they all take the same space. All right. So it looks a little bit more gritty. Okay. It looks like a grid. Good. Now that we have this component in here, which can load references, image references, we need the gallery view that puts all of these together. So let's go ahead and create that file. We're going to, as you can see, call it photo gallery view. So let's remove these two, or let's close those tabs, and inside views, create a file called photo gallery view.dart. Okay. And this photo gallery view is what we're going to do in here. We're going to use some sort of an image picker, because you see in this gallery view here, we're going to put a lot of things together. So we're going to have a scaffold for this. We're going to have an upload button, which is going to bring up our photo picker. As you remember, in our pop spec, we have this image picker. Sorry. It's going to have this pop-up menu button. It's going to have instances of our images. So it's quite a big component. And since it's going to use an image picker, that image picker, it needs to kind of be like a property of our widget. And for that, we're going to use something in our in Flutter hooks called memoized. And this is actually a concept like memoized is quite important to understand how they work. And it's outside the scope of this chapter. I would say it's outside the scope of this particular chapter, because in the Flutter state management YouTube course that I've uploaded, there is a particular chapter where I talk about Redux. And in the Redux chapter, you can find an example of how we use memoized. And just to cut the long story short, memoized is a way to make your Flutter widgets remember a particular instance of an object, so that you don't have to create this object while your, for instance, build function or your init state is run, and then you have to dispose of it when dispose is called on your stateful widget. So what we're going to do in this example is to create a property for our this photo gallery view, and this property is going to be a memoized. It's going to hold on to a reference of our image picker. Okay, just remember that. So we're putting an image picker inside a Memoist so that we can get a reference to it and use it. So since we are using Flutter hooks, since Memoist is a Flutter hooks concept, we need to make our widget, this photo gallery widget, a hook widget. But let's start as a stateless widget. I'm going to bring up the caption for it as well. So let's start with a stateless widget. As you can see at the bottom of the screen, we're going to call it photo gallery view. Let's import curl in here to get rid of all these errors. And then we're going to make this guy a hook widget, which is going to auto import Flutter hooks. Okay. Goody. So that's our photo gallery view. Then what we're going to do in here in the build function, the first thing we're going to do is to create our image picker. So we're going to say final picker is use Memoist. All right. And this use Memoist is going to have a function then that returns our photo. Actually, it's called an image picker, I believe. So in here, it's going to also auto import it. So I don't have to do that importing in here. Okay. And it is hooked to the widget's key. So as long as key is the same, then this image picker is going to be the same instance. Otherwise, if the key of our widget changes, then there's going to be a new instance of image picker created for us. Okay. So that's our picker. And then what we're going to do is also go ahead and basically have a look at what we want in here is like the images that we have to display. But how do we display the images? No one's passing that images to us. But remember, if you look at our app state, we create a little extension at the bottom of this called get images on app state. And then it optionally returns an iterable of the image references to us. So if we have an app state, then we should be able to grab possibly images out of that. So if our app state changes, we also want to rebuild this. So if, for instance, you look in here, if I upload a new image in here, let's say this one, you can see this widget got rebuilt and it displays the images. All right, so this is a concept that we haven't used so far in this chapter with Bloc, but we want to watch the block now. Up until this point, we've been like reading the block and then we've been like sending events to the block, but we haven't been watching the block, meaning that we haven't been notified of changes in the block. This is the first time we're going to do that. So let's go ahead and get the app state out of our block by watching it, and then optionally grab the images out of that app state if the app state is logged in. So let's say final images is context.read our app block. It's going to be auto imported. And then let's import Flutter block to use read. And then now that we have that, let's change this actually to watch. I should have put watch from the beginning. It would have done the same thing. Okay. Let's grab the state out of our app block and then optional read the images. Actually, let's see, images. Don't we have access to it? That images. And then optionally we say this. And that's interesting that we don't have access to images. Let's see. App state. Let's import app state so we get access to images as well. Great. So if you look at images now, it is an iterable of reference. Since we put this operator in here, it's not optional anymore. But if you don't put that operator in there, then this will be an optional iterable of reference. Okay. Good. We have the images. Let's go ahead and create a scaffold in here. So let's say scaffold. And let me just actually copy paste the scaffold. To be honest with you, it is quite boring to implement this. So I'm just going to copy paste it. So you can see in here, we have a scaffold. Let's close the app bar like that, and then close the scaffold as well. All right. Now let's go ahead and create this and these, and you can see it says photo gallery as a title. Let's go ahead and create this little button in here. Okay. And that little button is going to be an icon button in our actions. So in our scaffold, let's say actions, in our app bar. Actions, and the first component in this actions is going to be an icon button. All right. Press. Let's do an async operation because we're going to bring up our image picker. All right. So let's leave the unpressed empty for now, but let's go for the title, or what is it actually? It is icon, since it's an icon button. So let's create an icon in here. So we're going to say const icon, and we're going to say icons.upload. As you can see in here. Okay. So now we have an icon button in there, and then puts a comma in there as well. Okay, so upon the user pressing this button, what we need to do is to bring up our image picker and allow the user to pick an image, just like that, okay? So let's say final image is a wait on our picker, because remember, picker is our
image picker in here, which is using use memoist. So we say picker.pick image, all right? And the source is going to then be an image source of gallery. So we say image source.gallery. There are different image sources. You can also bring up a camera, but we're going to say we just want to pick an image from the gallery like that. And you can see in here, this is going to be an X file optional because the user can always cancel this dialog like that. Then we get an optional in here. We get a null, basically, if the user cancels that dialog. Then we say, okay, if the image is null, then return. So we don't have to do any logic in there. But if the image isn't null, then we're going to tell our app block to upload that image to our Firebase storage. So let's say context.read. Let's grab our app block from the context. And then we're going to say add, and then we're going to send an app event upload image. And then it says file path to upload. And let's get our image.path in here, okay? And put some commas in here and have a look at the code. So we're basically just finding our app block in the context and then sending an app event upload image to our app block, which in turn is then going to upload this to Firebase storage, okay? Great stuff. So we have this button in there, but also remember, after this button, we have our pop-up button in here, which we have a separate component for. So right after this component, let's go ahead and add our const main pop-up menu button. And that's going to be auto imported as well. If you look here, main pop-up menu button. All right. So that also takes care of this thing in here. All right. Then what we need to do right after all of this, so here's our app bar. Let's go to the body of this component and create a grid view. So let's say grid view.count, all right? So this has a few properties, and it says cross-axis count, and this is going to be 2 because we have 2 components horizontally next to each other. Okay, let's put a trailing comma in here, trailing comma in here. And then we're going to add a little padding in here. So let me actually copy and paste some of these things so that we don't have to type them, because it's quite boring and tiresome, to be honest with you, to type out all of these. And they don't really give so much value to this particular chapter of this Flutter state management course. So we have a little bit of a padding around all of these. You can see 8 points to top, left, right, and bottom. The bottom one we can't see right now, but there is padding in there. I promise you that. And then we have a main axis spacing of 20. So there is vertically 20 points between each image in here. All right. And then there is a cross axis spacing of 20 as well. So there's a horizontal spacing of 20 between each item. And if you're like, want to do everything pixel perfect, you may want to change all of these to 8. So that like the spacing on top, left, right, and bottom is the exact same spacing between horizontal and vertical between the items, but I'm just using it as 20 for now. All right. Now, the children of this grid view, we need to go ahead and use our images in here. You can see this is an iterable of reference. So let's say in here that we go through images and we map them. So if I say IMG in here, then remember we have a component in here. So photo gallery we have in here, and then we have a storage image component. So let's go ahead in here and say for every reference, we have a storage image view, and it takes a property, I believe so. Let's import it like this. It had a property called image, and that is our IMG in here. So let me put some commas in there. And then since the result of images map is an iterable, we can't assign it to children in here because children requires a list. So let's turn this into a list, as you can see in here. Great stuff. That was really all we have to do for our photo gallery view. You see, it's doing a lot of stuff, but since we've made things into components, and since we're using Bloc, there's not much logic going on in here. Maybe it's like 30 lines of code, maybe. That's it. Even though it's a huge component on its own, you can see, I mean, at the beginning of this, I actually said this is going to be one of the biggest things we're going to develop in this chapter, but you can see since we've made things into components, we don't actually have to type so much code. So that's pretty nice. Good. We have our photo gallery view. What we need to do now is the most exciting part. Since we have all the components, we have the login view, the registry view, and the photo gallery view, and the image uploading, we need to put it together inside our application. So let's go ahead in our app. As you remember, we have, I believe we actually created an app in here, right? So let's go and separate this app inside our main Dart into its own file. So under views, let's go ahead and create a file, and we call it app.dart. Let's go and chuck this app in there. So here we have app, as we can see. All right. And I'm going to remove it. Oops. Take this app and then let's put it there inside app Dart and import material. Okay. Material here. And then let's also import our homepage. So, I mean, we kind of, I wonder if we actually need a homepage. So I'm looking at how I've like implemented it in here. I don't actually think that we need a homepage. So let's go to main Dart and remove this homepage in here. Okay. So we just have app. Let's import app so we can use it and close the main Dart file. So your main Dart file should kind of look like this, not much more. Okay. Let's close it. For the home, let's remove that. And now we have a simple app, which is a stateless widget, and it has a material app inside it. So very easy, okay? So what we need to do inside this app at the moment is to wrap this entire material app inside a block provider. Because if you remember earlier, I said that the entire application is going to be wrapped with a block provider, which provides our application with a block instance, because all the other components like the login view, the registry view, and the photo gallery view, and all the other subcomponents, they may need to work with our app block. And it's very important that we wrap the entire application with our app block, okay? So let's go in here and see if we can get help from Visual Studio Code and say we need a block provider in here, okay? And we say our block provider uses app block. So this is going to be auto imported like that. And in here, let's go ahead and create our app block. And to be honest with you, we don't actually need the context, so let's just ignore it. But what I like to do in here is to not just create the app block, but also, oh, it's saying it's not defined. So let's import Flutter block. Excuse me. And you see, this is where we're going to send the initialize event to our app block. So let's say after creating the app block, we're actually adding an event in here. We're going to say const app event initialize. Okay. So we're sending that event to our app block as soon as our provider is creating that app block. So create the app block. And you remember inside the initialization method, we said that it's by default logged out. So let's close that. And then right after it's the logged out state, the initial states provided, we're sending an app event initialized to our app block. Okay. So inside here, let's just change the title in here to photo library. Okay, it's not so important because this title isn't even going to be displayed. It's going to be the title of every individual view that's going to be displayed to the user. Good. Now, what we need as the, let's go in here, the material app, as the home, actually in here, I believe we have our material app, and here is the child, right? Here's the material app. So we have a home in here, which is a widget. What we need to do in here is to do some logic. Remember, we have like I told you in the beginning of this particular example that all these dialogues that are going to be displayed to the user, like any error, authentication error, these dialogues that say like, oh, are you sure you want to log out, blah, blah. These are going to be handled in one place, okay? So in here, inside home, we need a block consumer. A block consumer is the mixture of a block listener and also a block builder. So the listening part is going to do some side effects, and the builder part is actually going to return widgets to be displayed to the user. So let's go in here and say we have a block consumer of our app block, and also it has an app state in here. Okay. You can see then we have a property here, sorry, an argument for listener. So let's add that in here. Okay. And also we have an argument for its builder. So let's go ahead and say builder. Okay. And in here, we also get the same parameters. We get context and app state in here. Okay, let's change this also to app state, and let's auto import app state in here so that we can use it. All right, so we're going to keep the listener for now on hold, and let's go ahead and implement our builder. So dependent on our app state in here, which is of type app state, we need to return the correct component to be displayed to the user. Okay, so let's say if app state is app state logged out. Okay. If you're logged out, then we need to display the login screen to the user. So let's just say return const login view, and it's going to be auto imported. Else if app state is app state logged in, then we have to display the photo gallery. So let's say return const photo gallery view, which is going to be auto imported. Else if
app state is in registration view, then let's return a const register view like that. And otherwise, we're just going to say return container because we don't know really what app state you're in. And let's just say this should never happen. And one of my favorite things to do in this case is that if the cases that shouldn't happen actually happen, maybe you should do an assertion in here so that your application crashes. So in here, what you're saying is that I'm trying to handle all the available states that I know of. But if another developer or you go in the future and add another app state, then you don't want like just a black container to be rendered on the screen, because then you don't really know what's wrong. But if you crash your application in here with an assertion, then you know that, ooh, an app state's added, which I don't have any views for. Okay. So now we're handling our app states and displaying the correct UI components to the user. Let's go ahead and handle this listener. So the first thing we're going to do is, if you remember, every app state has this property of is loading. So let's go in here and say that if app state is loading, then let's go ahead and display a loading screen. So we're going to say loading screen here, instance, I believe. Did we auto import it? Yeah. And to be honest with you, here, we could go ahead and change the implementation of this loading screen in here. Let's put this on top. Let's put that in here. And let's say static, should we just say static final? Late final, perhaps, so it's lazy. And then in here, we say factory loading screen dot instance. Okay, and so it means that our default constructor is not always going to return the shared instance, but this time the user has to actually say instance. Okay. So we say loading screen.instance, and then we say show. All right. And with the show, it needs a context and a text. So in here, for the text, we just say loading. ... Otherwise, if the app state is not loading, let's just say loading screen.instance, and then we say hide, just like that. All right. So that's for the loading screen. And then we're going to handle all the auth errors in just one place. I mean, to me, this is beautiful. Any auth error that happens in the login screen, the register screen, the main gallery view if you're logging out, and if you don't have a token, etc., it's only handled in one place. So remember this. This is not at all like something that you should go ahead and implement in so many different views. Like, oh yeah, the register view should have its own error handling and the login view. No, we handle it just with this block consumer, which has a listener. Okay, and that's what listeners are for. So we say final auth error. We grab the app state's auth error, if any. You can see it's an optional. Then we say if auth error is not null, then we're going to go ahead and display an auth error. So we say show auth error. And because we have imported that, you see from, let's see, show auth error in here. We've implemented that using our generic dialog before. So we go to show auth error, and here we have all the necessary parameters to send to it. And you don't have to await on this, even though it returns a future. You see, it returns a future void, but there's no value to be returned from this dialog, so you don't have to await on it. All right. And really, to be honest with you, that was it. I mean, there is nothing more in here to do. So what we could do now is to go and run our application for the first time. So I'm going to go into our main Dart in here, and let's just select a device, and I'm going to say run it on iPhone 13 Pro simulator. And let's just run our application now. And I'm going to remove this old app in here. So once our app is running, then we should be sure that it is actually our application running, not the old application that I had prepared as a demo for us. I can see in here saying a running pod install, and sometimes you could run into issues with CocoaPods if you're running on iOS, for instance, or even if you're running on Android with Gradle. But that's also okay if you have some basic knowledge of how CocoaPods and Gradle work. You should be able to iron out all these errors if they pop up. So let's just wait here until this step is done. Okay, now our application is running in the iOS simulator. And here it is. You can see in here we have our login view with the text, and then we can also go to the register view. So all of these things are working. Now I'm just going to say login in here, and it's going to tell me the user not found because I haven't registered this user under this application. So let's go ahead and bring up Firebase actually in here. So let's say console firebase.google.com, and I'm going to switch to my main account, and let's see if we can
find that at the moment. Let's just 1 second. I'll bring up Safari window in here, and this is that Firebase instance, okay? So let's go in there and let's bring up authentication, and we can see that at the moment we don't have any users and the sign-in method of email and passwords enabled. So let's go in here and to the register view and register this user. You can see it's registering and then log me in. So if I refresh this screen, now we should have a user in here. Let's go to our storage in here, and we can see that there are no folders at the moment. And if I press this button, now we can see that our application actually crashed. So this is interesting. So you can see that, I mean, this is very important. And this is something that a lot of iOS developers would probably already know about. And when I see this, I immediately understand what the problem is. But the key in here is to reading this text in here that says the app's info plist must contain an NS photo library usage description. So what happens is that on iOS and actually on Android, when you're trying to ask to display a photo gallery to the user, this photo gallery is actually a system component, meaning that as iOS developers, we don't actually go ahead and create that entire photo gallery that the user sees. So that is a system component. However, for the app to be able to even display that system dialog or that system image picker, your application needs to tell the user why it's even trying to access their photos. So you do that by providing a very simple string in something called an info plist file in here, as you can see. So this info plist file is just it's kind of like a dictionary of or a hash map of various keys and values. So if you search for this NS photo library usage description on the internet, you actually find documentation from Apple developer. You'll see that it tells you why you need this, a message that tells the user why the app is requesting access to the user's photo library. So what we need to do in here is to go ahead and add that. To be honest with you, that is actually specified in this image picker. So if we search for image picker, you see in this plugin that's provided by Flutter Dev, the Flutter team themselves, it's specifically mentioned in here that for iOS, you need to go and add this property to your info plist. And that's just something that we forgot to do. And that's fine. Let's go in Visual Studio Code and find our info plist under iOS Runner. Okay, and you see there's a key in here. We're just going to add a key. And we say that's the key. And its value is a string. So let's just say, I'll see if I've already written this somewhere so that we can just paste that in here. I don't have to type that. So here is the string. It says this app needs to access your photos in order to upload your chosen pictures to the cloud. Okay, so you can just put any string you want in here. So let's then save that file and close it. And then we're going to run our application again. Hopefully this time the compilation is going to go faster since we've only changed one info plist file. And let's bring up our iOS simulator in here and just wait for the compilation to go through. Okay, now the compilation has gone through, and I can see when we ran the application from scratch, since we are sending that initialize event to our app block, it starts with a logged out state. However, as soon as the initialize event is received, it's understanding that we had previously logged into the application, so we should stay logged in. So let's do this one more time and see if this time we can actually upload some images. So pressing this button now displays this little dialog to the user. And since my iOS simulator is kind of like inside, it's actually a Swedish version. So let's go in here just to make this a little bit easier. And I just said, don't allow. So that's why this didn't go so well. Let's go and change my iOS simulator's language so we can all understand what it's saying in there. So here, let's change it to English. All right. And it's setting the language. It terminates all the applications. And unfortunately, this is something that is very iOS specific. Like on Android, if you change the language is just dynamically changed in the entire operating system. But iOS literally kills all the application. It kind of like does a soft restart of the entire OS just so it can change the language of the operating system. So it's just different ways that iOS and Android work. So now that is done, let's do this one more time. But we need to be a little bit careful this time because you see, I already said don't allow. So now I should go ahead inside privacy in iOS simulator into photos and make sure that our application has access to all photos, for instance. Let's say all photos. Okay, so let's run our app one more time and hope for the best that this time our application has access to all photos inside the photos gallery in here. As you can see, there are a few of them, 6 of them, I think. Yep. So let's just now wait for the build process to finish one more time. And I can see it finished now. Great. So now we have the photo gallery. And if I tap on this button, hopefully we should be able to see the photo gallery in here. And I'm going to press this button so we can see loading. And then that image is displayed in here. Okay, so I can load another image in here and we can see it loaded. Great. So now that these 3 images are loaded to Firebase storage, let's go ahead and do a refresh in here. And you can see now there's one folder whose name is equal to this user identifier who's logged into the application. And in here, there should be 3 objects. You can see them in here and they're images. So that's that image, this one. And then we have this image, which is the waterfall right here. And then we have the third image, which are these leaves right there. Great stuff. Now let's test the logout process. So log out. Yes, it displays the dialog and we should be able to log out. So, and let's test the register. If I try to register with the same user that's already registered, we should get an error telling email already in use. Great stuff. Let's go and register. Actually, we've already done the register, so we know the registration actually works. So let's go to the login and then mess up the password and then try to log in. We can see authentication error, unknown authentication error. Let's fix the password and say login. And then what we could also do is to test this delete account. So by deleting account, we expect all these images and the user's folder to be completely removed. So if we say delete account, we see this dialog and it says delete account and we should be logged out. Now, if I do a refresh in here, you can see the entire folder is gone and all the images, of course, in it as well. Great. It seems like our application is working as expected. It was a little bit up and down at the end, but that's kind of also expected since we wrote a lot of code without actually testing it. Okay. And to be honest with you, that's usually not how things work in reality. In reality, when you're developing this application, you would be doing a lot of trial and error. So you would go and write like some user components, you test it all the time. And to be honest with you, that's how I actually implement my applications. So the way I'm teaching you in here is to make teaching easier. But I never go ahead and like just write all my UI components without actually seeing how they look like on the screen. I have like a visual representation of all these UI components as I'm writing them, but I also feel a lot more confident in my applications if I'm constantly testing them on the screen. So just because we wrote our application this way in this course, it doesn't mean that you should go and do it for all your applications. You may have a different strategy of like creating your UI components first and then thinking about your block. And that's completely okay as well, whatever works for you. So now that is done, as is tradition, we're going to go ahead and commit and tag our code. So let's go to terminal and have a look at our status. We should have a lot of new stuff in here and lots of deleted stuff. So let's say git add all and git status. So everything is now in the staging environment. And let's say git commit, and we're going to say step 8, as you can see at the bottom of the screen. Okay. Now that is done, we also have tags up until tag number 7, step 7. Let's tag this as well as step 8, like that. And if you have our look at our tags now, we have all the tags 1, 2, 3, 4, 5, 6, 7, and 8. So this is basically going to conclude this chapter. And I really hope that you enjoyed this chapter. But what I want to say for now is that not everything is going to be absolutely crystal clear from the beginning. You need to practice. Just by watching this chapter, you can't be sure that you know how to use Bloc. So just go ahead and make up some applications to create. Just say, yeah, I want to create like an e-commerce application with Bloc. Oh, I want to create like a Facebook clone. I actually, to be honest with you, don't like clone applications, but whatever. You could say, oh, I want to create, for instance, an application that allows the user to back up their important files in Firebase storage. So go ahead and experiment a little bit and learn Bloc along the way. So I hope really that you enjoyed this chapter. I had a blast making it. It's actually a really fun chapter for me as well. I really looked forward to start planning it and also recording the material. It took a long time. I think this chapter totally planning and recording it took more than a month. So, but I felt like Bloc is so important as the library that I personally love as well. So I really wanted to put my heart into creating this chapter for you. So hope you enjoyed it. And if you have any questions or doubts, you can reach me on Twitter. And you can also find me on LinkedIn. And you could also add me and follow me on Twitter and LinkedIn if you want to. So I hope to see you in the next chapter.